Hello and welcome to Programming in C++. This is an introduction to the C++ language. I know you must be pretty excited about this. All the videos leading up to this point have kind of been preparing you to start jumping into the different languages.
Absolutely, yes.
So we've gone through the intro topics, we've gone through the object-oriented introduction topics.
Yeah, and a full course of C and all that stuff.
The entire C language. So now we're getting into the language that you want to know, which is C++.
Everything before this was a waste of your time, but you know what? That collective, like we said in the C video, that collective wisdom that we have now compiled is going to be applied to the C++ programming language. So once we master C++, everything else is wide open to us, because C++ is literally just a step away from getting into C# and Java and all the other higher level languages that all of you are more interested in understanding. But the thing is, if we don't understand it from this bottom level, then we're never going to understand it from the top level. You never fully know what you're doing unless you come from these roots.
Absolutely.
So that's why Brian and I have put such an emphasis on going back to C before even getting to C++.
Now, it doesn't mean we have to go back to assembly or Fortran necessarily, but at least we go back to C. I mean, it's, because C, we're not really losing a lot of time. Like, you don't lose any of the knowledge. It's applicable in C++. It's applicable in Java.
So let's get started on this journey on C++, Brian.
Right. Now that you know what you're talking about, now that this is like familiar territory, you have all the concepts down, you're basically an up and running developer now. We're going to talk to you like you are one.
Absolutely.
So just keep that in mind.
Yes, we're not going to baby you anymore. Yeah, okay, I got my take the trash out warning. What's up? You jealous?
Oh, I didn't even... I just saw it was like Redskins. Anyway, I was like, I don't think they've been playing for a while.
No, they've been out of the playoffs.
You're very much a fan.
For some
but
time.
now that I know, take out the papers and the trash. Anyway, so maybe start this one.
So what is C++, Brian? Well, let me just tell you, since you look dumbfounded. It is a general-purpose programming language considered by many professionals to be a mid-level language.
That's probably not how I would have answered the question.
No, I would love to have heard your answer, but I don't want to waste the audience's time with your 5-hour-long answer.
It was developed at Bell Labs in 1979.
Well, wait, before we even get there, Brian, what the hell is a mid-level language? What does that mean? Why do people call it that?
Because it's not really a low-level language. It's not really a high-level language. It's true. That's why you feel dumb, because that's true.
I guess that's the cheater's way of answering that question.
See, it's technically a high-level language, but C++ allows both a high-level and low-level functionality.
That's true.
So,
yes.
Technically, yes, that's fair.
So it was also intended just to be an add-on to the C language. So this is what Brian and I call a bolt-on object-oriented language. It is literally built on top of C, and the language was originally called C with classes. So it's just the C language with the ability to create objects. And then later in 1983, it was renamed to C++.
Pretty cool.
It's pretty awesome.
There's a lot of different compilers that you can get. They're both free and proprietary. So the ones that don't cost anything, the free and open ones, are like the GNU C++, which is generally what we're going to be using during this series.
Also known as G++, commonly called that.
And most of the free compilers are based on this.
Yeah. Why reinvent the wheel?
Yeah. And then we have Apple C++, IBM C++. We also have a number of proprietary ones. And like you might recognize like Borland C++, Microsoft C++, and Intel made a C++ compiler.
I don't know if anybody uses that but Intel, but the important thing to kind of understand from this is all the standards, unless they kind of derive from a single one, like for example, the ones that derive from G++, all have similar standards. The other ones tend to have different standards. Now we're going to be teaching G++, just because that is what we believe is the most easily accessible. It's also probably one of the easiest to use. It uses the textbook standard definition.
It's the widest net to cover all of the compilers.
Right, but you'll notice small things like in G++, when we include libraries, we don't have to put the .h extension, but Borland requires it, you know? So there's little weird things. So please, if you're going to follow this with us, use G++.
And it's free, so there's no reason not to.
Yeah.
Unless you're just being a dick.
Yeah.
The C++ syntax has inspired many popular languages today. Most, you have C and then C++, and after you get through C++, it just breaks open into all sorts of different languages. And the languages you're probably more interested in learning because they're more lucrative languages to know nowadays. Like C#, Java, Objective-C, Perl, JavaScript, like all the languages you've probably heard a lot of and know other people who can develop in those languages.
And you can't wait to get to those languages. Exactly. And we can't wait to get you to those languages. So Brian, fun little story about where the C++ term came from. Remember in C, when we were writing programs and we would say, I want to increment I, so I would do I++. Well, that's one better than the previous value. So C++ literally means one better than C.
Nice.
So C is one better than the C language.
That's awesome.
Yeah, it's pretty cool. It's pretty clever.
It makes sense.
Yeah. Some prerequisites that you guys are going to need in order to follow this is first the programming in C and the introduction to object-oriented programming. The reason why this is important is because we're not going to discuss any of the fundamentals of C++ because it's the same as C. So our assumption is you've already gone through that. When we get into objects and building classes, we're not going to explain the concept anymore because you should know that by now.
Also, if you haven't seen those videos, but you've been programming for a while and you are for some reason familiar with C# but not with C++ or Java, not C++, and you really just don't have the time to go through the intro, you know the concepts, you don't have time for programming in C, you should be able to jump from another language to these C videos. So don't worry too much about those. But if you're new to programming, like, they're fun videos. Absolutely watch Programming in C, Introduction to Object-Oriented Programming, or even just the intro to programming in general.
Mm-hmm.
Like they're they go pretty quick, and you won't regret having that structured walkthrough of programming. The fundamentals of C++ are the same as C, so we won't reiterate. We won't kind of like recover all the stuff we've already went through.
For loops, all that stuff, you know it. We're not going to touch it.
And the object-oriented concept as well has been explained.
So the environment that we're going to go through when we do our live videos are going to be a minimalist, just the same as our C video series. We're going to be using the minimalist GNU for Windows, but we're going to be installing G++ this time instead of GCC, and we'll be using the same text editor, so we'll just be using a simple Notepad++ editor.
Yep. And those are all free. Now we're going to take a look at the basic program structure of C++, and you'll probably recognize right away that it looks almost identical to C.
It looks suspiciously like C. We're going to start off first with, instead of including stdio, Brian, we're going to be including IOStream.
Nice.
Yeah. Ah. So IOStream is an object-oriented library that contains functionality for input and output to streams. And streams are a generic concept. A stream could be a file, it could be a device. It just contains the most common instances used for manipulating and using streams.
Right. It was kind of similar to how we have a handle. Well, we still have handle on this, but it's like when we saw a handle can attach to a file or to a console or to a printer
or to STD in or STD out, exactly. Right?
So just like in C, we have our main declaration, our main function declaration, and the code block below it.
Yeah, there's nothing. It works exactly like C.
We discussed namespaces before. This std : is a reference to the standard namespace.
Mm-hmm. So when we say std : cout, what we're saying is, go to the namespace std, and then the scope operator, which are the two colons, basically says that the following member or the following entity that I'm about to mention belongs to the previous namespace. Mm-hmm. So cout is an instance of a class called OSStream. So what I'm saying is go to the std namespace and use the instance of OSStream called cout, and then pipe it some information.
So this is similar. The way we described this before is you have a namespace like the universe, and then within the universe you have the galaxy or the Milky Way, and then the solar system. The namespaces,
and then David Bowie.
And then David Bowie. So this is really just a categorization of objects that are available to you, and classes that are available. So standard is just what cout belongs to, and you'll get familiar with this. Don't worry about it. Now this is the insertion operator. This is a little interesting. So this performs an output operation on a stream. So these are directional. So the arrows point to the left. So we're basically going to take that string to the right of them and pipe it through those arrows out to the object that we're referring to. Mm-hmm. So whenever we go to write something to the console, like, hey, buddy, we pipe it to cout, which takes it over to the monitor. Mm-hmm. You can think of it that way.
In this, we're using two to concatenate two strings together. And we're going to get into what the other one is here in just 1 second.
But just generally know that these are insertion operators.
So now, what are we doing here? Well, in between the insertion operators, we're sending text. So we're sending, hey, buddy, which we all recognize as a C string or as a string of text being piped or being inserted into cout. We're also sending a end line, which is part of the std namespace. An end line is basically a keyword that represents a new line character. Yep. By doing these two insertion operators, we're simply just concatenating these two strings together and piping it to cout.
So it looks suspiciously like C.
It looks very suspiciously like C.
So like we said, this is built on C, so what you're going to see is very similar. like Kevin had mentioned earlier, some of the compilers don't like the IO stream without the H.
Yep.
Some will force the .h at the end. So if you are using like, some other one that's complaining.
Just as a side note, the reason why I made a point to mention that is because Brian and I made a C++ video series in 2005 for the original website, and I got so many emails from people saying, when I run your code, it has a problem with IO stream, but if I have .h, it works. So since I got like 50 emails with that complaint, I figured if I just get this out of the way, and this time I won't have to hear that anymore.
You can avoid using namespace all throughout the program. Before, in the other basic program structure example we had like std : cout. You don't always have to designate that namespace. You can say that we're going to use it.
Mm-hmm.
So in the top of the program, above the main statement, you can say using namespace standard.
Mm-hmm.
So when we do that convention, all the code below it will assume that convention is in use. So we don't have to declare standard : cout,
Right.
or the new line, or a lot of other things. We can just use it.
Right.
So it's a very convenient thing, so you don't have to do std : 5 million times.
And when you use a namespace, it follows the same concept as variable scope, but we have an entire video dedicated to understanding namespaces later. So for now, if you just declare globally in your program like this, it'll prevent you from having to write excess lines of code or excess characters in your code.
It's pretty convenient.
How do we compile our C++ program?
I don't know.
I have absolutely no idea.
So
what we do is, like before, we were writing C programs, we were calling GCC and the input file and blah. Well, this is the exact same thing, except for instead of GCC, we're going to be calling G++.
That's awesome.
Very cool.
That's it. That's a fast, like grab you by the wrist and run you around the block. Whatever that means. I'm not really sure. Hey, buddies out there.
Hey! I did it again! Why is my instinct to make that sound?
Okay.
All right.
It's like the response to the phrasing that I'm saying. Hey, everybody out there. Welcome to Getting Started in C++.
Yes. Thank you for coming and following this programming journey that we've started from learning what programming is into the awesome language that C is into the next greatest program in the galaxy, C++.
We need to set up our environment. We have a text editor, as you remember from the C series, and we have a compiler for C, but we don't have a compiler for C++.
Yeah, what gives, man?
Yeah, so that's not going to do us any good. So we need to we've got a great text editor. We could probably use some other IDs if we feel like it, but we're cool, so we're not going to.
No, we're going to learn the low level because we're that awesome.
Yep. So we do want to install a C++ compiler. The one we're going to install is called GCC. It's under the GNU license. It's free. You can go out there and get it right now.
Yeah, and the GCC C++ compiler is widely known as G++.
If you've seen the C videos, you remember
which all of you have.
Of course you have. You remember when we went out and downloaded MinGW? If you haven't, just go out and search Google for MinGW.
Or just go back to the C videos. We do this already.
Yes.
Yes.
So we didn't install the C++ option the last time we ran this.
How dare we?
I know. So we're going to do it this time for you.
Thank you, user account control.
Yes. So we're basically just going to next our way through stuff.
Download latest repository.
Always want to download the latest, yeah.
We accept.
The latest repository.
Yes. Same path. That's perfect.
Path is fine.
And yes.
It already exists. We know. It's fine. We can create a folder.
This time, Brian.
So we got this one. We want this one. C++. Now, if you want to get saucy and get some Fortran action going or some Ada, some sexy Ada, go do your thing.
The Ada Countess of Lovelace.
Go get bad with your bad self. And we install it. You know how to install stuff on Windows.
I hope so. So, Brian, what do we want to try to get accomplished in this introductory video?
The only thing we really want to know is, did our compiler install?
Yep.
Is our compiler working?
Similar to what we did in C then.
Yeah.
Right. Okay. And then as you go through this C++ course, kind of like the same approach that we did before and that we will continue to do is you already know the basics of C. C++ has the same basics. It has the same for loop, if, decision structure. So we want to kind of get right into learning about objects. Since you've already also gone through the Introduction to Object-Oriented Programming series, you know what objects are and all that kind of stuff.
Now you get to use them.
Yes. So after Brian and I get through the introductory stuff, we're going to start talking about objects and how we interact with them and how objects are the basis of the C++ language.
This is going to blow your mind.
Blow your mind.
Okay, that was fast and easy and pleasant and delightful.
Yep. Now, we don't really need to show you how to install Notepad++
No.
because you know how to do that.
You know this.
Oh my goodness, Brian. We are about to write a C++ program from scratch for the first time. Now, just as a reminder, ladies and gentlemen, go back to the C videos and remember that we do set an environment variable to simplify running this from the command line.
Yes.
We're not going to do that now.
Because it's already done.
Yes, those of you that have been following have already done it, but if you're coming from scratch, go back to that first lab video and see what we did. So I guess we'll just make on the desktop kind of like we did in C.
Absolutely.
C++ something. Awesome. Nice. Very nice.
C++ awesomeness.
Yeah.
Okay. We'll call this testing.
No. It's got to be called Hey Buddy. HeyBuddy.cpp.
Fair enough.
We got to keep it awesome. If you're gonna put it in a folder called C++ awesomeness, it better be awesome. It should.
And
do
naturally,
that.
as you can see, C++
syntax
highlighting is ready to go. It knows that because we named the file .cpp. So if you're a little confused, if you're typing in a text document, you named it like some sort of check the language menu.
Yeah, and it's fairly common to have the CPP file extension.
We forgive you.
You'll also see some people that actually do C++ as the file extension. So the first thing that we have to do, Brian, is call the preprocessor directive to include, instead of stdio, Brian, what are we going to include now?
IOStream.
And we're going to do that, with the less than greater than, because
it
comes with the compiler.
Yeah, fine, right.
And we can also have the option to assume the standard namespace if we want to do that, right? Yeah, which we talked about this in the slide video. Initialize
a function to return an integer.
Yes, and that function is going to be called main.
And we're going to return
zippy.
There.
Now there's your basic structure of a wimpy little C++ program. Let's just go ahead and say, hey, buddy. Why not?
All right.
Now, since we have using namespace std, we can just call the cout instance just like this.
So, because we don't have to declare std in front of it, we can just jump straight to cout.
And we could get our little outsertion operator, whatever. Hey, buddy!
That's a very excited hey, buddy.
Yeah, it is. It is.
And then I'm going to go old school like that.
Yeah, nice.
Just for fun.
Nice. All right, Brian, let's compile and run this sucker.
All right. So we're going to go to start command prompt.
Yes.
And then we're going to go to, well, I guess it doesn't really matter. We're going to go to the path where we have this thing.
Yeah.
Because our environment variable refers to where the compiler is. So now we're going to go to our C++ awesomeness directory. We're going to list out what's in there. And what do you know? So we want to test our compiler. We're going to do just a basic. Run this.
Do a G++. That way we can distinguish the difference. Because a lot of people will use G++ to compile the C++ programs.
Sweet.
Although you can use GCC because it will recognize the .cpp extension as C++. Dash.
And we'll just give it we'll give it an output file name. Otherwise it'll give us a.out, which is perfectly fine, but
a.out in Unix, a.exe in Windows.
Oh yeah, whatever operating. Okay. Now we just want to see if this works and
hey,
boom! Hey, buddy! Hey! Buddy.
Now let's just do a quick run, Brian. Go back to the code, and let's take a look at the using namespace real fast.
All right.
And let's comment or remove that or whatever you want.
Okay, we'll comment it just so you can see the comments.
Yeah. Now go back.
Look, it's green.
Hold on one second.
Okay. Yeah.
It's gonna get us a little bit of viewing space here.
Ooh. Yeah. Oh, now I can see it. All right. Cool. Hey. Oh, this is C++. Weird.
So now, Brian, if we don't include the std : what does that? Well, by adding this, what are we doing?
So we're saying, you remember the RSO, the scope operator, the :
Yeah.
So that goes namespace, scope, function, basically.
Right. And that scope operator is also generic because it works in the context of classes too, which we'll discuss later.
Right. And these are, if you remember back to the intro to object-oriented, this is, when we say this, there's the solar system within the solar system, there's Earth within Earth, there's people. This is the STD or standard namespace bucket, so to speak, and within that bucket is the function cout. So if we don't have this,
the instance cout.
Yeah, sorry, the instance cout. Without declaring that, and without having this here, the compiler doesn't really know which cout are you talking about. Right. Where is it? I can't find it sitting out in the root there.
Because the cout instance is encapsulated inside the std namespace.
In a really freaky, weird sort of way, and don't think about this too much, you could almost look at it where std is kind of like a folder.
Right,
but it's not. Nobody kill me. I know. It's not. There's nothing like that at all, bro.
Well, but you know, I mean,
the idea.
Similar to a file structure, namespaces are used to categorize different entities that a program can use. So it's not much different than a file structure that we use all the time.
So what do you think? Do you think it's still going to work? You think we broke it?
I actually know for a fact it's not going to work. And I want you to compile it and let's see why.
Sweet.
Why Kevin's right.
I'm not saying you're wrong.
I am right, 100% right. I know it's not going to work. Because you forgot to do it for the end line. Oh!
See, and that's what happens. So you see where it says end line was not declared in the scope.
What the hell?
That's madness.
We have to scope in!
Yeah. Alright, so naturally we're going to add std :
Right, because we have
just
to
like the other
scope into the st namespace to then get the entity end line and cout.
And that's where end line sits.
Mm-hmm.
So after a while, you'll just kind of memorize where these are, or you won't, and you'll just get used to doing that.
Right.
Whatever. Now, if we were to comment this back in, this is still perfectly valid.
Mm-hmm. Yeah.
So that's fine if you do that.
Mm-hmm.
Anyway, we'll leave it out just for the fun of it.
Yep.
And what do you know? It compiled.
We have a program.
And we'll run it. Hey, buddy!
Beautiful.
Sweet.
Beautiful, Brian. Good job.
Done. Awesome. That's all you need to know.
Ladies and gentlemen, welcome to round 2 of programming in C++. We're going to be talking about basic input and output.
And you're probably thinking to yourself, like, okay, come on. Like,
yeah, let's move. Let's move.
We
are moving.
Right,
but you know what? The reason why we have to go over this is because the fundamentals of C++ don't handle files and stuff like that the same way. Files and streams are not handled the same way in C and C++. So we have to get this out of the way. We need to kind of do a quick review of the classes and libraries that C++ use to handle this.
So this is going to be like an orientation, just a walk around to kind of take a look at the basic I/O namespace, basically. Just look at the classes in the namespace.
If you're really getting that antsy, skip to the next video. Okay, just skip it. If you're really that antsy. But I'll tell you what, one day you're gonna be like, I really wish I watched that basic input output video. Fundamental difference between C and C++ and how they handle files is C uses pointers and C++ uses objects. So let's take a look at some of the classes that C++ uses to handle I/O.
These are all objects in C++. So just keep that in mind. Think of it in those terms. So the first one we're going to take a look at is IO base and iOS. So IO base is the base element, the base class for all of the stream classes, defines the most basic specifications, regardless of its input or output. This is like the core, we talked about inheritance.
Yep.
This is like the grandfather of all the stream objects that they all inherit from.
If we were going to make an analogy to the life analogy we had, this is life. So all streams inherit from life. And IO base and iOS is life.
So iOS inherits from iOS base, and that goes to the O stream and the I stream. So this is O stream. This contains the stream objects for output. It's mainly going to be writing and formatting output to all the streams. Mm-hmm. So you're going to use this a lot.
Yep. Every single output stream will inherit from this.
Yes.
And next we have the IS stream, and every single input stream is going to inherit from this. And this contains the objects for stream input. So it reads and interprets input from all streams. Mm-hmm. Now we have the mother of the streams.
Yes. So those two, the O stream and the I stream, combine to make the one that you will be using, that you'll be visibly using, which is the IO stream. And that's the one we included in that base program structure. So anytime you go to start using a program, to include this.
Yeah, so IO stream will create instances from OS stream and IS stream and also provide classes for, input and output. So it's considered the standard input and output library in C++.
So next, if you see, we kind of jump down on the left from iStream to ifstream, and iStream down to iStringstream. So ifstream provides the ability to read data from files as an input stream. So this is file handling.
So then on the other arm, we have the OF stream and the OF string stream, which inherit from OS string. And the OF stream provides the functionality to write to files as an output stream.
Right. So IStream and OF stream is just like we saw before, but this is file handling in and out.
Right. And where IO stream is more generically for input and output to like the terminal and the console and that sort of thing. These are specifically for file streams.
Mm-hmm. Then we have the string streams, which is this is the input one, the iString string.
That's a difficult one to get out.
Let me see if
iString
stream.
Yeah, the last one you messed up.
Anyway, this crazy thing provides functionality to manipulate strings as input strings.
So
just like we would do it through a file, we can kind of manage this through an object, a string object. It functions the same, but we're using strings as input streams, which is a very interesting concept. We'll get into that later.
And the other opposite of that is the O string stream, which provides functionality to manipulate strings as an output stream. So this is the opposite of iString.
If we kind of look back over it, we have the base, we have iOS, and those are kind of like it kind of like sets the foundation so they don't have to keep reinventing the wheel when they wrote this. And we have IOStream, iStream. The main three are IOStream, the F streams, and the string streams. So we basically have console, files, and strings.
Yes.
That's basically how it breaks down.
Look how beautifully designed that is, Brian. The inheritance structure here is phenomenal.
Yeah.
And that's how you should design all of your classes.
You just looked like a little girl, like, seeing the Beatles for the first time.
I did.
So, it was quick, painless. Thanks for watching. Welcome to Programming in C++, Console I/O.
Yes.
So we just had a review of the whole inheritance structure of using input and output. Now we're going to just get into using the console to input and output. I mean, this makes it a lot easier when you write a program and you can actually see it do something.
Yeah, absolutely, right.
Because if you start kind of screwing with C++ or some new language and you can't see what you're doing, you don't really know if you're doing it correct.
So we talked briefly about cout when we discussed the structure of a C++ program. So let's kind of just reiterate what cout is. It's a class instance from the input-output stream header that handles sending output to the standard output device. And in most cases, a standard output device is a monitor or a console screen or command prompt or whatever. It contains methods that also simplify formatting.
Is that a new element on the periodic table?
I guess so.
Sorry.
It also contains methods that simplify formatting. So basic data types work with no effort.
Right.
Like, remember how in printf we'd have to do, like, oh, this has to be a %d.
Right.
This has to be a %s. And in cout, it just assumes all that stuff, and it just works.
You'll see it soon. You'll be impressed.
And you could also use the concept of operating overloading, which we haven't shown you, but we've discussed the concept, to make this work for your own custom data type. So I can say, if I can make a my person object, create an instance of my person, cout the person instance, and it will write whatever I want.
Right, like their name or something.
Right, it's exciting.
Yeah,
this is
cool.
good stuff right here.
So now we're going to take a look at console output.
In C.
Yeah.
So this is what you already know.
So we have the standard IO header, which is similar to our IO stream now. We have our main function, and then we have, a couple variables. And when we do the printf, we have the %ds, and then we pass the variables. So you're all used to that print format function, and, it prints it out just like we say. So now let's take a look at C++.
Ooh, it looks so pretty. This is the same program, but it's so much nicer.
So now we have the IO stream header instead. And we're using namespace standard, so we don't have to, do the std : cout. And instead, we're just going to use those double arrow insertion operators to say cout x plus y equals, and you can kind of see as we go through that line. We're not saying there's no %ds, there's no anything. We're just taking that integer x and we're throwing it into the pipe, and that just comes out as text.
Yeah.
Like we didn't have to pass it through something to convert from an integer to string.
Right.
We didn't have to do anything. The X is in there, it writes it out to the console. It's
whatever you
cool.
are, show me your face. It's beautiful. cout follows the exact same standard of excessive white space that we talked about in C. So, for example, if you wanted to write this on multiple lines, you don't have to write it out in a single line. You could say cout and then your next one and the next line all the way down. It doesn't matter. So it follows the same excessive white space rules that we've discussed throughout.
Until it hits that semicolon.
Yep.
Cin is just like cout, but it's input.
It's the opposite.
Instead of output.
Yes.
It's just a class instance that handles getting the input from the standard input device or the console or from command prompts or whatever. So it's just like scanf and C was. Where we'd say scanf and you'd have the prompt and then you type something in, hit enter, it goes in. It's the same kind of thing. So Cin handles that. So now we're going to take a look at a console input in C. So we go back to C and, we see that standard IO header. Well, there's a dead giveaway that we're in C right off the bat, because otherwise it looks kind of similar. Then we use scanf, similar to how we use printf. So we pass in the %ds, and then we pass the reference to the variables that we want to store as. Now in C++, it looks like this.
So, in C++, gang, we don't have to say, this is going to be a %d, and there's going to be a thing here, and a %. No, Brian. Not anymore. We are free. All we have to do now is have the other operator pointing outward. I don't know. Is that the outsertion operator? I don't know what that's called. But
the pipe.
So in cin, guys, it's the opposite of cout. So in cout, we're pointing outward. In cin, we're pointing inward. So what I'm saying is when you have the standard input device, the first element is going to be stored as X. The second element, and it's going to be space separated, is going to be stored as Y. So it much simplifies gathering user input.
So let's look at cin and cout like they are the console.
Yeah.
So imagine that cin is console in. Imagine it is the console. So console 2, the arrows 2x, 2y. So you type 10, 20, then you're good. Cout is also the console. So x goes to the console, plus goes to x to the console, and so on. So just see those as the actual console object. We're now thinking in this object terms, and that's really what we're doing here in a very basic sense. So cin does have a limitation, though. It can't read an entire line of text. There's similar limitations, just like in C.
Yeah, we've been suffering with C, with gathering lines for a while now.
cin will kind of get stuck on spaces and things.
Yeah.
But we can get around this with the getLine function. And getLine is very cool. It can return an instance of the object string. We haven't talked about this yet, but we'll take a look at it here.
Yeah, we have a whole video designated as strings, but it can also use C strings, which we're already accustomed to. So in this case, we're going to declare a character array of just a buffer size of 128, and I'm going to ask the user, using cout, write a bunch of text. Then I'm going to use the cin instance, and then remember how before in structures and unions, how we were accessing members? Well, now we're accessing a function inside. Now don't get hung up on this. We're actually going to talk about classes more in depth, but what I'm saying here is the instance of cin access the function called getLine. The first parameter I'm passing is the character array that I want to fill, and then the second parameter is the size, so the maximum number that I can input. Then I can see out to the user, you typed, and then here's the text. Now if we look at this next example, we're going to be using a string. Now again, don't get hung up on this because, like I said, we have a whole video dedicated to strings.
But strings just like an integer. So just like the way we've been using a char, int, float, whatever else. String's just another data type instead of saying a char star.
Right, yeah. In a technical sense, that's not true, but in a functional sense, that is true.
Just so you understand.
Yes. So you can just call getLine, which comes from the iostream.h header. We can pass cin as the first parameter, so we're going to suck out of cin, and whatever cin has, we're going to throw it into string
awesome.
s.
That's very cool.
Yeah, it's beautiful.
That's smooth.
That's gorgeous.
So now we can go all the way out until the user hits enter. It's great. It's awesome.
So like what Brian was saying about you have to start thinking in terms of objects, what we're literally doing is when you have a command prompt terminal and you're typing something, we're passing the whole prompt as a parameter to a function.
It's awesome.
It's so cool.
We just took the console and just jammed it into the function.
Just jammed it in there.
It's pretty cool.
Beautiful.
So I hope you enjoyed that. We'll have some exercises, some sample code. We'll kind of, we'll walk through this some more. This is the concept, and now you're kind of up and running. You kind of see how it works, and we're kind of just starting to get that flavor of what it's like to program an object oriented.
I can taste it. It's so good. Hey gang, welcome back to the Programming in C tutorial series from WiBit.net, and we're going to be discussing file input-output. So continuing on our rampage of learning I.O. streams, we went from what are they, how to communicate with the console, and now we're talking about how to communicate with files.
Very exciting.
Awesome.
We're cruising. C++ uses OF stream to send data to files. Like we saw before in the other video about
the hierarchy and stuff. Yeah.
We have console, files, and strings. So there's IF stream, OF stream, so in and out. So this is the output file stream. And you can learn more about it here. Here's a link to cplus.com. It's a great site.
Yeah, it's amazing.
So, and it's a good reference of, IO stream as a whole, but OF stream in particular. We can open a file handle, close a file handle. We can check to see if a file handle is open with is open. There's put, kind of similar like we've seen before. So this would be OF stream put, and it would put a character to that file stream.
Kind of like the put chart function in C, yeah.
So we can just open a file handle and put or write, like to write a whole block of data, and then close the file handle. Now we've written to a file. Yeah. Basically, I mean that's essentially it. Then we got tell p, which gets the current file position.
Kind of like seek in C.
Yeah, exactly. And then there's seek p, which sets.
Right.
So, and then flushes the stream out, which we'll talk about that later. Basically, the workflow through writing data to a file is you open the file, write to the file, close the file. If you do certain types of conditions, you check to see if it's open. If it's not, you can't open it, and so on. So it gives you a lot of flexibility in these few functions.
So what we're going to basically do in this example is we're going to take in text and write it to a file.
Yep.
Simple as that. So let's start from the top, Brian. We're going to include the IO stream, which we're all familiar with. But we're also going to be including this fstream. Now, what is this? Fstream is the file stream. It provides us the O stream and the fstream class. And of course, we're going to be using namespace standard to standardize or import the STD namespace.
After a while, you'll be amazed to find out how fast you can type using namespace standard.
Yeah.
Because it becomes like, you type it so often, it becomes like muscle memory. So you just like include stream, standard. In main,
Very nice. Very nice. So inside of our main function, we're going to create an instance of OFStream called outFile. Then we're going to create 2 character arrays. And they're going to be out file name and out file data, and they're just going to be of a buffer size of 256. Then we're going to run cout. So we're going to ask the user to set the output file name, and then we're going to use the cin instance and call the getLine function, passing it the out file name and 256, which is the buffer size. Then after that, we're going to ask the user, give us the text that you want to print to the file, and we're going to be using the same mechanism to grab this data by doing the cin.getLine. Now, Brian, of course, this means if you have spaces, it will capture the spaces.
Yes.
So if you want to put a whole sentence to a file, this will get the whole sentence.
Yep.
So the next one that we're going to do is we're going to call against the instance of OFStream, which is outFile. We're going to call that open function that Brian was talking about before. So outFile.open, and then the path to the file that we're going to open. So now we've created a file handle. Is that cool or what?
That's awesome.
Then next we're going to, wait a second, this looks just like cout! Oh my goodness, that's because all of the streams inherit from the same class! Woo! So we're going to send data out to outFile the same way that we send data out to cout.
It's really cool. It's cool looking.
If you don't, I don't know, if you don't get excited about this, you're watching the wrong thing. I don't know, this just makes us so excited.
Go watch reruns of Friends.
Yeah. Oh God. So then after we send this data out to the file, we're going to close the file by calling the close method that is inside of the OFStream instance. So if you take a look at with the frog, he is pointing out to us the glory of the output of this program. So we're saying set the output file name, myfile.txt, text to write, hey there buddy. And if you look on the bottom right, we have a little file that says, hey there buddy.
So it's really pretty straightforward. I mean, you create an instance of an OFStream object.
Yeah.
And that object we're going to name outFile. And then once we have that object instance, we can then call methods contained within that object, like outFile instance.open.close, so we can open and close it, and between that, pipe data out to the file. It's very smooth, very straightforward, very clean.
And the beauty of C++ is since they all inherit from the same stream class.
So when we have a stream instance, like in our last example, we had outFile, but in any case, an object instance of the stream, we can say the .open. And we can pass it a file path, but we can also pass it an open mode. Mm-hmm. So we have a couple different options. We can say app to append file data. So we write some data to the file, we close the file, we open it back up, data's already existing there, that file has already been used. And whatever we send to it just gets appended onto the end of it. Mm-hmm. We can switch it into a binary mode. So instead of sending ASCII data, we're sending just whatever we're dumping into that stream. It's just digit, binary digit for binary digit. We're just jamming everything in there in its binary form.
8-bit chunks to a file, right.
And then we can trunk, which means that we're going to truncate and remove any data in the file. Now this is the default method of opening. So if you don't specify the mode, if you don't specify to append file data, and you close the file, open it back up, and write to it again, or not even if you close it, if you just write to it again, you will you're going to lose what you have.
Yeah, so keep that in mind when you're writing your programs.
So let's take a look at using the open mode in file output. So this is similar to the example we had before, but we're going to be setting the mode of opening the file stream. When we run the program, we'll be asking the user a couple questions. Set the output file name, and the user will enter in the file name. It's yes or no, do you want to append data? And that's going to dictate how we set the mode and runtime, and what text do you want to write to the file. And it'll produce our file. Very smooth. So we call the cin object instance and its method getLine to get the text like we've been doing. And then we ask the user whether or not we want to append data. So we call cin get and pass it append data, which is where we're going to store the character. And then we call cin.ignore, which will basically just ignore the new line character. Because anytime we call C and get and we hit enter to complete our input, it will take that in as a character.
That's not the same in all systems and all compilers, so keep that in mind as well.
So it just kind of takes it out of the buffer, so to speak. Then we get the text that we want to write to the file, and in this case, we say, did we want to append data, yes or no? Since this example we said no, we go to the else condition, and we go to our open file object, .open, and pass it the file name, and then the IO base namespace, and within that, we call the keyword trunk for truncate. And that's the one where it will wipe out the file, and it will just write what you want it to. So now that we have that file stream open, we pipe the data out to the file, we write what we piped out to the console just so we can kind of take a look at it. We close our file, and we're done.
Let's take a look at another example where we do the exact same program, but in this case, we're going to actually overwrite the file. As you know before, if you go back here, we wrote, hey there buddy to the file. Then we run it again and we asked, do you want to append the data? What we're doing here is we're running the exact same code again. So we're doing the IO base : trunk. And when we do that, the new text that we write is going to overwrite the data.
So the file doesn't say, hey there buddy, and then on the next line, write this to the file. It just wipes the file out, and the only thing contained in it is write this to the file.
And that's where this changes everything. So if we want to say append data, yes, well now we're going to go down the path of passing it the iOS base : append or app. So in this case, the output to the file is going to say, write this to the file, write this to the file, appended right up against it.
So now we're going to take a look at ifstream. It's the same thing as ofstream, which is writing out to the file, but this is reading in from the file. So this is the class that C++ uses to read in from a file. There's more information, as always, at cplus.com to kind of get a more just textbook walkthrough of ifstream and everything in it. But we'll take a look at some of the common functions. And you'll notice a lot of these will be similar to taking in from the console and the ofstream object that we've already looked at. To open a file handle, we just call the open method, just like we did in ofstream.
Yeah.
And close to close it. And is open to check. So that's all exactly the same as ofstream.
I think we've seen this little deja vu.
Yeah. And now if we want to get data from the file, instead of writing to it, we just call get, or getLine. And it's kind of like cin. We've seen something sort of like this. So get will just read raw file data. GetLine will read a single data item, and what it considers to be a data item. And read will read in a block of data, and that block being a size that we dictate. And seekp will set the current file position of where we want to read from. And that can be very useful and very time consuming with larger files.
Oh, yeah.
And flush will flush the stream.
Well, you said time consuming. I think seekp is very time saving with gigantic files.
Yes.
Yeah. Here's an example of using file inputs. We're going to do this program here. We're going to run this and compile it, and then we have this little file on the bottom right. And this is a file that already exists. So if you want to open up a notepad and write, this is line 1, line 2 through line 5. We're just going to compile this program as a.out or a.exe, and we're going to read file lines.txt. What we're going to do now is in the first argument parameter, we're going to send that to the infile.open method. That's going to create a file handle to this output file. While, look at this, while the infile.eof is not true. So while we're not at the end of the file,
nice.
Look how freaking convenient this is.
Yeah, it's awesome.
So while this, like the infile, you start thinking about objects, that text infile represents a file sitting on the file system. So while we're not at the end of the file, read it. And what are we going to do, Brian? We're going to call that instance and we're going to say getLine. And we're going to store that as a character array or a C string. So we're going to say we'll read up to 256 characters and store it in file lines. Print that out to the screen. As we go through this, we got line 1, line 2, 3, 4, 5. How beautiful is that? And then we come through, we close the handle, program is over. Now, Brian, we can also do this using the string getLine.
Right. So this where it starts kind of getting nice and sexy. So instead of a character array, we just say string file line. And then when we go down to that while loop, we can just call getLine because we're using the namespace standard, I guess. That's in the...
It's an IOStream.
And pass in the infile object itself. So getLine has that and has access to it. And then we pass it file line, which is the string that we want to set this to. So this is the same example, but using string. So we'll declare a string file line instead of the character array, and that's going to temporarily store the string as we go through the while loop. And if you look below in the while loop, every time we move through this and check to see whether we're at the end of the file or not, we're going to call getLine. And that's going to get all the way over to a new line character. And we pass it in file, which is the object that is the file stream to our file, that actual instance.
Yeah.
And then we're going to pass it file line, which is the string that we want to store it into. And then on the next line, we just write it out to the console like we did before.
Yeah.
It's very, very clean.
Very beautiful. And again, don't get intimidated. Strings are coming up. Oh my goodness, Brian. We're going to talk about binary files
Nice.
now. Oh, baby. You're up, dude. Show me what you got.
So when we run this program, we will be reading in the executable that's currently running and prints it out the screen byte for byte. We create an IF stream. I know. We create an IF stream object instance in binary file. In binary file will open up, and that file name is going to be argument vector 0. And if you remember right, argv1 is our first argument that we pass, and 2 and so on. Yeah. argv0 is the name of the file that we're currently executing. So we pass that in to in-binary file and open that up, and we pass it in as a binary because we don't really want to read this as a text file.
Because it's not a text file.
Right.
If you read it as a text file, you're not going to actually get the real data in the file.
So then we create a current byte integer, and then we get. And while that current byte is greater than or equal to 0, we just continue to go through this and get the next one, get the next one, get the next one, and print it out.
Right.
And when we print it out, we can use printf just like we've seen in C, which is very cool because this is built on C. So we can call printf and pass the %d and %x to show it as decimal and a hexadecimal.
And that is really cool, Brian, because pretty much any code that you've written in C will port to C++ without a problem.
Yeah.
Now, also, another thing to keep in mind is when you're reading from a binary file byte for byte by calling the get method, what C++ will do is it will return a negative number once you've reached the end of the file. So, as you guys know, a byte can only be a positive number. It's a positive integer. So that's why we have that current byte is greater than or equal to 0, because a byte can be 0. It just can't be less than 0. Here's another example, just to kind of just pound this into your brain of doing file input. So we're going to do this example here. We have a file on the bottom right, and this file is called myfile.txt. And if you guys remember, this came from the few examples before where we wrote, write this file, write this file. So what we're going to do is write a program that will do stuff. So we're going to create an IF stream instance called inFile, and then we're going to make a character pointer called file data and just start pointing it at null. It's pointing at no memory. Create a file pointer. So open the first argument, which is going to be myfile.txt. So this is, again, assuming that myfile.txt is in the current directory that a.exe is in. This function right here, which functions in C++ work exactly the same as in C, is going to get the size of the file. So we pass it the memory address to the file stream, and it's going to, just like we did in the C example before, we go to the end of the file, we get that byte count, and we send the seek point back to the beginning of the file, and send back that length that we had, that we received from that.
And you notice the use of the keywords end and beginning, or beg.
Yeah.
Which is nice. So those are things that you can use with seek to jump from the beginning to the end of the file.
So yeah, it's like rewind the file to the beginning. Right.
Be kind, rewind.
Yeah, there you go. And then get the, yeah, beautiful. And also, just like we did in the unions and structures that we did in C, as we're passing IF stream as a pointer, so we have that star file, we're using the arrow to access the members within it. Next, we're going to set file data equal to a character pointer or character char star typecast from C-Alex. So we're going to create little 8-bit chunks of however many, bytes the file ends up being. So we've created our dynamic memory to fit the entire file in it. Now we're going to do the .read method, Brian. So what the .read method is going to do is we're going to do the file instance .read file data, which is what we're going to store, and file size, which is how far into the file we want to read. So I want to go all the way to the end of the file and store all of that into the dynamic memory that we just created called file data. Then I'm going to write that to the screen. So this is like, instead of doing reading line at a time, now I can read an entire file and store everything in memory at one time.
Consuming the whole thing at once and dumping the whole thing at once.
Exactly.
So if this file was very large, it might be
Yes.
it'll take a while.
Well, that's why we have a one-liner here.
That's true.
So now we're
But it's a lot. There's no loops involved in this.
That's true. Now we'll close the file handle, And remember free? We're going to free the memory and bloom, we're done.
Nice.
Now Brian's going to tell you about this next fun example.
So here's another example of file input where we're going to be making an exact copy of a binary file.
Yeah.
Now, if you were to if you were to read in a file using text or like an ASCII read of the file, you'd get like a lot of garbage and you write it out to another file. The file's not actually going to execute properly. It doesn't really work the same way. So in this case, we're going to make a copy of an executable and make it just identical down to the last bit. So the structure of the program is kind of similar to the last program that we just ran. But in this case, when we've declared both in-file and out-file as an object instance of the OF stream and the IF stream. So we open the in-file in a binary mode and we open the out-file in a binary mode. And the in file is going to be argument vector 0, and the out file is argument vector 1. So the AEXE is the input file, and B.exe will be the copy of the file that we'll write. So we're going to store the size of the file, the size of the input file, by using getFileSize and pass in a reference to infile, the infile object. We'll store that as file size. Then the file data is going to be stored as an allocation of memory to the size of the input file size. So now we've blocked out enough memory to store the input file. Now we're going to run through a for loop and we're going to increment from 0 up until the size of the file, because an integer is the same size as a byte of the file that we read. So this will move us through the entire file. And every time we iterate through this for loop, we're going to store into a file data array in position I what we get from the in file, which will be a character at a time until we're at the end of the file size. And we run through another for loop exactly the opposite. So as we increment I, we write out to the file. So we have outFile.put instead of get this time, and we pass it the next value as we iterate through from the file data array. Then we close our file handles, free the file data from memory, and return the program. And now we have a binary copy of the executable.
Now some of you guys may be looking at this and saying, wow, that's terribly inefficient, because if you're doing a binary copy of like an 8 gigabyte program, you're going to run out of memory. And you know what? Those naysayers are absolutely right. This program wasn't written to be efficient. It was written to show this as an example, because what you could do, Brian, is you could just have a loop that says that instead of storing it as an array in memory, you can say outFile.put and then infile.get.
Right. So as you're getting, you're putting.
Exactly. So for those of you guys that were thinking, wow, these guys are idiots when you were looking at that, just understand we knew what we were doing. Okay, we're smarter than you. Who has the video tutorial? Me or you? No, I'm just kidding.
Crazy.
I'm crazy.
Files.
So that's just basically a great summary of file I/O. It just kind of wrapped up how the input and output work and how get, puts, read, all that stuff happens.
So we've gone through the layout of the environment of using input-output objects. We've done to the console, out to the console, from the console input, and we've now done input and output from files, which is pretty awesome. So now you're up and running. You can write to the console, you can write to a file, you can read in from, like, you can do anything. You're pretty much golden at this point. Awesome. You're like a professional.
Sort of. You knew it was coming, ladies and gentlemen. Our first string video series. Video lesson. This isn't really a series. It's a part of a series.
A series of slides.
Yes, a series of slides. So
ladies, it's a string of slides.
High five, yeah. So we're going to talk about the object string. Now, the string object is used, it integrates so well with C++ that it's really difficult to really understand that it is an object. And I know that when I first learned C++ when I was, a little tyke, I really did not understand this concept at all. String was just the same thing to me as an integer, as a character. I didn't know that there was a difference. But there actually is a strong difference, and this video will kind of outline what those differences are.
Couldn't have said it better myself, and I didn't. C++ has a class, and just like you're saying, it's not a data type, it's a class called string. And so this handles, like, instead of using a char star or a character array like we've seen before, this just has a class that handles that for us. I mean, obviously it's frequent that we use strings. So why not have something that really handles it well? And they did a pretty good job at it. So this string class basically contains methods that are a convenience to make it easy to manipulate data and manipulate string data, all from within this instance. It's very cool. So we'll see it. We'll see it here in a second.
So let's take a look at string versus what we already know from C programming, the C string. Well, let's take a look at the C string first on the right-hand side. Well, as you guys remember, a C string is nothing more than a character array that ends with a null character. So when I have the sequence string, string, it's that plus 1, because the null character represents end of string. On the left-hand side, this is what a real string looks like. Now these little oval bubble things, those represent methods, and the little square things, they represent fields, and all of these support a character array that's hidden deep inside and that contains string null character. So it's just that hidden inside there with a lot of support around it to manage it, like to manipulate. You want to remove something, you want to search for something, you want to turn it to uppercase, lowercase, whatever. All that stuff is encased within that instance of string.
Well, and if you remember when we were going over C strings before, we would often say like, oh, and take a look at this. We can do this with the character array, a C string. And here's a convenient function to know, to use, and blah, 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 blah. You probably find yourself writing those convenient functions to handle C strings over and over and over. So have they. So they just wrote some really mean ones and packed them all inside of a class. It's very cool.
Yes. So a string is always contained within double quotes, like we've seen before in all of our other programming extravaganzas. So when we look at a sentence like, the quick brown fox jumped over the lazy dog, this is going to be encased within double quotation marks.
And another string that we might use, for example, is, duh, we know this, man.
Yeah, man. We already know this.
Come on, moving on. Let's get to the point.
Let's get to the point. Seriously?
God.
Here is an example of using a string, which we actually have already seen this before, Brian. We're just going to create a basic C++ program, string my string equals, hey there, buddy. And we're just going to see out that by doing see out, insertion operator, my string end line, and it just writes, hey there, buddy, to the screen.
So that my string object instance that we declared is just kind of like when we had the OF stream type or the IF stream type, and then we'd say out file. So OF stream instance out file. So this is actually the string class.
Right.
So that string object instance is my string.
Right.
So it functions very similar. It ends up functioning identical to the way a data type declaration functions.
Yeah, just because C++ has done all the operator overloading to make it work that way. Yeah.
So here's some basic string operators. The plus concatenates two strings to make a new string. A nice convenience to just say, A plus B is equal to AB. Plus equals is a compound assignment that appends to a string. So in this case, you don't have to say, if you've already declared S1 as A on the example on the right, you don't have to then say S1 is equal to S1 plus B. It'll just be plus equals B, and it'll just append it onto the string S1. This is a C string, essentially. So this is still a character array. So we're still working with an array. So when we call S1, string 1, for example, and we pass in a number between these two square braces, that will return the character in that particular location, because that character at that particular location is that location in the character array, because this is a C string. So you can use it just like it was one, which is very convenient. The double equal sign is the comparison operator. So if you want to see if two strings are the same, you just do, if this equal that. That's not like C.
You guys remember the example we did in C with the char stars?
Yeah.
And how they failed because we were comparing memory addresses and not the data within those memory addresses.
So this will compare the data within those.
So the string class, Brian, contains a lot of functionality that we're just not going to go over. I mean, for the explicit interest of time. If you want to learn more, we've referenced C++.com probably like 10 times already. It's a magnificent resource. We're just going to go over some of the methods and some of the functions and some of their uses, because a lot of these have a lot of overloads. So they have multiple uses. Brian and I are going to basically go over the ones that we believe are the more common ways that these are used. But again, don't take this as gospel. There are tons of ways that these can be used. So please do your research and learn them.
Yeah. So here's a couple of the core ones. The length method.
And this is dealing with sizing.
We'll take a look at some of the common methods in the string class. Here's a series of sizing methods. So these are all related to the string size. The first one is length. This will return an integer that represents how many characters are stored in the string, or the length of the string. We have max size. This is how large a string can be. Mm-hmm. So you do, that your string instance dot max size, and it would return that back to you.
And that varies from system to system.
Mm-hmm. We also have capacity. So that's the size of memory that has been allocated for this string. Clear will clear out the data in the string. It'll just give you basically a null character. It'll just wipe it out. And empty is whether or not the string is empty. Mm-hmm. So this returns a Boolean value. So you can say if string.empty, and it's pretty convenient to use. It's nice. Or if not empty, if not string.empty. We also have at, and we pass it an integer like @3, and it will get the character at that index. And it's functionally the same as using the brackets, like getting into a position in a character. So let's quickly use a couple of these sizing methods in an example. We'll declare my string which will be a string object, and we'll put in there, hey there, buddy. And we'll write out to the console, my string empty is equal to my string empty, and we'll call that, just for fun. We'll put out
you know exactly what we're outputting,
Yeah.
There's no mistaking what's happening here.
We'll put out to the console my string max size, and we'll pass it max size and capacity. And then we'll go through and that will show us, the empty, the max size, and capacity. And we'll go through a for loop, and we'll increment I until we hit the string dot length.
Oh,
awesome.
baby,
It's
look
very
how
cool.
cool this is.
So, and every time we go through that, we'll pass it the character at that array index of I. So my string bracket I bracket, just like we do in arrays in C. And then we'll use the concatenation of the two strings, saying my string is equal to my string plus how are you? But then we'll also say the plus equals question mark. So now we're kind of using the concatenation, and then we're using the concatenation without, the explicit concatenation. And then we'll put that out to the console.
All right, this is too much of a tease. What is this going to look like? Oh, baby,
So
look at that.
empty will return 0.
Because it is not empty.
Right.
Is it empty? No.
It returns a Boolean, but when the Boolean gets passed to cout, when it gets piped to cout, it will reinterpret that data type into a string.
Because a Boolean is either a 2 or 4 bits integer. Yeah.
So it will represent a Boolean as 1 or 0 to the output console naturally. The max size, so we can print that out as an integer form.
That's a pretty big string.
Yeah, it is. It's actually quite large. And then the capacity that we have allocated in memory, which is 17.
Yeah, so that 17 bytes have been allocated to this particular instance of my string.
And then you see we kept putting the end lines after each character, and that's why we have the HEY space all the way down the array. And then in our concatenation example at the end, we have, hey there, buddy, how are you?
Nice, Brian.
So pretty
well
smooth.
said.
Yeah.
Well said.
All right, Kevin, maybe you can take a look at the manipulating.
I'll try, but this isn't as fun because you had more than me.
That's
Why
true.
do you always get all the cool slides,
I don't know,
man? I don't know.
I'm cooler than
I
you.
guess so. So here's some usages of some of the manipulation methods that come along with the string class. So we have append, and we pass a string as a parameter, and what this will do is it will append to the current instance of a string, whatever string you pass to it. Then we do an insert. Here's an insert example. So this will insert into a string at a specific location. So when I have my instance of string, I call the insert method. Int is where I'm going to put this, and the string is going to be what I'm going to put there.
Convenient.
Erase. This is going to take in 2 integers. The first integer is going to be the start position, and then the second one's going to be the count. So what I'm saying here is I'm going to remove the character starting here all the way up until I count 1, 2, 3. So if I'm going to remove the first 2 characters, I do 0, and then my count is going to be 2. So it's going to be 1, 2. Pretty cool,
Nice.
huh? So now replace. Here's a way we can use replace. So what this is going to take is 2 integers and a string. Now this is going to kind of functionally work like erase in the beginning, because I'm going to go in at a start position, and I'm going to count, and I'm going to remove those, and in its place, I'm going to put in the string parameter that I pass in here. Now let's take a look at an example of how we can just kind of jam these into a very useless program. We're going to start by saying, my string equals hey. And then I'm going to append to it, buddy, exclamation point. So you see the first line, hey buddy, exclamation point. Then I'm going to insert into position 3 a comma and a space. So now it says, hey, comma, space, buddy. Nice, huh? Then we're going to erase. We're going to go into the 10th position and remove 1. So we're going to remove that exclamation point. And then we're going to replace that position 3. And we're going to go in position 3. We're going to count 1. We're going to erase that comma. And then we're going to write space there, comma. So now we have hey there, buddy. So we've gone through a nice, fun little maze of getting hey there, buddy.
But that's a pretty fast showing of append, insert, erase, and replace, which are all very convenient functions. Very nice.
Pretty awesome. Now, Brian, tell us a little bit more about some of the operations that come along with the C class.
So if we have C code in our program, and for some reason we want to get we just want to get the character C string out of our object, we can call .c_str, and it will just return back to us just that C string that's contained in that object.
Hmm?
So sometimes that's useful if you just need to get that and use that somewhere.
Yeah, like sometimes you'll be writing a program and you only have access to a function designed for C
Exactly.
that does not know what a string is. So you pull out the C string equivalent and send that to the function.
And we call the copy method, and we can use that to copy a section of our string into a character array. So we're going to pass it a reference to a character array and 2 integer values, a start position and a count position. And that could be 0 to length, or it could be 1 to 3, or whatever you want it to be. And that will take between the start position and the length, the character array, and store it into the character array that we passed in reference. And we also find, which will search our string for a string that we pass it. So if we have a hey there buddy and we pass it there, it will search for the word there. And it will
first occurrence.
The first occurrence,
yes.
Right. And it will return back an integer that represents the positional value of where it found that first occurrence. Our find is similar, but it will instead find the last occurrence in the string. Now let's take a look at an example that uses some of these. This is way more useful than the last example, seriously.
You jackass.
So here we have a string. Hey there, buddy. How's your day, buddy?
Buddy!
I'm not your buddy, guy.
I ain't your guy, buddy.
Well, we can call printf just like we did in C, and we can say %s new line, and we'll pass it my string dot C string. So
Nice.
It's like if we really get nostalgic and we really want to go, call it like in C, we can do that, and we'll do that. And then we'll write out to the console. So we'll pipe to C out. MyString.findBuddy, and that will print out it will search the string for the position of the first occurrence of buddy and write that out to the console. Our find, which will go to the last occurrence, which will go up to the string and look for the positional value of the last occurrence of the string. And then we'll also call find string not there. And obviously string not there is not in our string, so we'll find out what it's going to put out to the console.
I'm so terrified to know what's about. Oh my goodness! Oh. Okay, that was a bit over dramatic, I'll admit.
So as we see, find returns position 11, our find returns position 36. But then if we just call find and the string's not there, interesting. What is that?
Wait a second. WiBit is kind of reminding us of something.
Oh yeah, remember when sometimes it's like,
WiBit remembers that if you have a bunch, what's happening here? Wait a second. That equals that 4 million. That is the highest number in the 32-bit range.
Interesting.
WiBit really just saved our asses right there. So that's kind of like the out of range number that it's returning.
So that's the last possible position it could ever possibly be, which is not going to be there.
Yes.
Because it's always the start position. So that number does mean not found.
And like some more modern languages, they use like negative numbers to represent not found.
Right, exactly.
But you can also, if you're doing, if you don't want to remember what that number is, you can call the string class, and the end position is a static member inside of the string class that contains whatever that number that it's going to return is going to be.
Okay.
Now, even if that varies from system to system, it's always good to use this method, because that number may not be the same in Unix. It may not be the same on a 64-bit system, on a different compiler. So string : end position, which is the null position, I think, will return whatever that is. So if I do seek string does not equal this, that means that the string was found. If it does equal that, the string was not found.
That's fun. So this one is crucial. This is one that you're gonna love. This is the substring. You're gonna get very, very used to this.
Oh yeah, and not only in C, but in a plethora of other languages.
The substring method will return to us a subset of the string that we're calling this from. We pass in the start position and the length, the number of characters, and it'll return us what's in that range. So where this becomes very useful is if we search a string for the first position of something. Let's say we want to get like whatever follows hey, and we search a string for hey, and we say substring start at the next character after that, and then the length of 10, we'll get back there and some other stuff. So it's very nice to get substrings if we need to chop up a string, if we need to chop it in half, just trim off the last character, take only the first character, whatever we need to do. Substring can basically do it all. It's like a very minimized, simple form of just a lot of string manipulation. Compare will do a proper comparison on two strings. So we pass it in the string object of another string, and we compare it onto the object that we're calling this method from, and it'll compare those two strings. Now here's another example where we use these. So we call we create a string instance myString, and it's hey there buddy, how's your day buddy?
Hey buddy.
And we now define two more strings. So we have two string instances, string 1 and string 2. The first one we call myString.substring, start at position 11, and go the length of 5. And as you see in the yellow highlighting, this will get the beginning of buddy and to the end.
With the capital B.
With a capital
yeah.
B, right? And then in string 2, we'll call mystring.substring start at 36 and move 5, which is also buddy.
Hey!
With a capital B.
Capital B.
Interesting. We'll compare these two strings and write the result out to the output if they compare. So if you look at the two if conditions we have one that uses the double equals and one that uses the .compare method. To use the .compare method, we say string1 .compare and we pass in string 2 as an argument. And if this is equivalent to 0, so if that means that there is 0 differences in the comparison resulting from the comparison, then we're going to say to the output string 1 compares to string 2 using the comparison method. And then the second evaluation will be with the equal operator. If string 1 equals string 2 just by using that comparison operator, then we're going to say buddy equals buddy. And as you see on the console on the top upper right, that these are equivalent in both cases. So buddy compares to buddy with an uppercase B, and buddy equals buddy with an uppercase B.
Keep in mind, Brian, that this is kind of a cool thing. You know, before we were using the insertion operator to concat strings together?
Yeah.
Now we are using the plus operator to do it.
But it's very nice. So instead of the double arrow, double arrow.
It functionally does the same, although technically doesn't do the same thing, it functionally does the same thing.
But it looks a lot nicer.
It looks very pretty.
Yeah.
I mean, it's so intuitive, too. I mean, this string plus this string equals the concatenation of these two. I mean, it's
it makes sense.
so beautiful. I love C++. Let's take a look at the constructors. Finally, I get a good one. Yes. Okay. So, constructors. Now, we have not actually gone over constructors yet in C++. We have discussed them in the introduction to
Object-oriented programming.
Object-oriented programming. Thank you, Brian. So the string class contains three major methods or three major constructors. The first one just creates an empty string. Okay. That's kind of boring. Cool. The second one, we can pass it a string, and it creates a new instance of a string from the data contained in another string. And similarly, we can send it a char star or a character array or a C string. That way we'll cover both of them as a parameter to create an instance of a string from that. So we take a look at this code example. When I do mystring1 equals init with this string, I'm functionally calling the constructor like I am in the second one here. I'm saying mystring2 in parentheses, quote, init with this string.
That's awesome.
This performs the exact same thing.
That's very nice.
It's so beautiful. Now let's take a look at this. Let's create a char star. So we'll do char star. This is a C string. Now I do string, and then the instance will be called with C string, and then I call the constructor by just putting the parentheses there and saying my C string. How beautiful is that?
That's nice. And so that constructor is just going to take that char star C string and just put it inside the object.
Yep, absolutely.
It's very cool.
Now we're going to get more into constructors when we get into classes. So if you're scared at this point, this intimidates you, don't let it intimidate you. This is just kind of, since we're talking about working with an object here, we might as well go over the constructors that it contains.
And since you went over the object-oriented programming videos, you kind of have a visual sense of what this is looking like.
So, Brian, strings can also be treated as streams, like C in, C out, files, and all that kind of stuff. So this means that we can treat literally a string as if it was C in, C out, or a file. Isn't that ridiculous?
That's awesome.
And the beautiful thing is you can use the insertion operators to concatenate the strings into another, which we'll see here in a moment. Yes.
So all of the flexibility and all the robustness of having our streams go to different handles, we can just do this to another string, and we get a lot of flexibility to how we construct that. So we'll see some examples of this.
Yeah, and down here we have some documentation for the iString stream, which is obviously for input, and then OString stream for output. Try to say that 150 times. OString stream. Hey, remember this? We talked about this.
Oh, yeah.
Yeah. We talked about the inheritance structure of streams for C++, but we never actually talked about these two at the bottom. The little outliers, the one that nobody likes. Nobody cares about them. But we're going to show you today. Brian?
So this is iString stream. This is the input side of it. We include SStream. That kind of covers our bases. And we'll instantiate an object. We'll call it iStream. And this is going to be an iString stream. Object type. Nice. iString stream.
You sound drunk when you say that.
The iStream object, then we'll have a .str method, and we can pass that a string. That's one way of taking a string and putting it into the private string of a iString string object.
Now you know what's really f***ed up, Brian?
What's that?
When we're parsing this, we're doing .eof. So we're looking for the end
That's
of file.
hilarious.
So
It works the same.
we're treating it as if it was a file because the files inherit from the same, iStream that this inherits from as well.
So while we haven't reached that character, let's say, while we haven't watched the end of file terminator, we're going to just kind of keep moving through it a word at a time. So since this is on the input side, we can say, we'll declare a word just so we have some temporary holding place for where a string is going to be stored. And we'll have, just like we do with the cin, we'll have iStream, which was the connection, our string stream connection itself, at that handle, and then it'll be a greater than, which is the kind of insert.
We've been calling it outsertion.
Yeah,
Why not
outsertion and insertion. I don't
Why
know.
not just keep following that trend?
So that will pipe it to word.
Word.
The word string. So this will stream it to the word. It'll take kind of like an input, just like reading an input.
Yeah, just like we did with files when we were reading a word at a time.
Yep.
Same exact thing.
So since it's pulling from that stream, we keep pulling from the stream, and they'll keep moving just like you'd pass it parameters. Because we have spaces in the string, it would be just like when we do it from a command line or a console or a terminal or whatever, what have you. And every time you do a space, that's kind of going to be like added to, the next in queue. So this works the same way. So as we move through this while loop, we just keep going to the next, and then we see out and kind of pipe word out to the console.
Yeah, so everywhere you see a space, you see a line break in the console window on the right-hand side.
So just know our inputs are going to work just like they do from a handle, like we've seen with cin, just like they do from a console.
Now here's another example, Brian, where we get to do other fun stuff. So look at this string above. We have a little comment here that says that the first one's going to be the account number, the second one's last name, then first name, then gender, then account balance. So this is going to be Brian's checking account. And that's actually a lot of money for Brian's
Yes,
checking
it is.
account.
I think you're forgetting a minus.
So what we're going to do here is we're going to take the iStream instance and call the str method, passing it a string that has Brian's. So if you want to know Brian's account number, that's what it is. And Brian's alias is .NET WiBit, his last name and first name.
Of course.
And Brian's gender is M, I think. The facial hair is a dead giveaway. And then 147.5 is the account balance. So look below, Brian. We have an unsigned integer, which is the account number.
Nice.
Then we have two strings for last name first, and then a character for gender.
Nice.
And then a double that will store the account balance since we're dealing with a decimal number.
I like it.
I like it a lot. Now check this out. We do the iStream, and then we do the
That's
pipe
cool.
account number, and that's going to be an integer. The next one's going to be a string. The next one's going to be a string. Next one's going to be a character. The last one's going to be a double. And we print this out. On the upper right, you can see Brian's account number, Brian's alias, his gender, and his account balance.
So that's a fun way of using this as a way of parsing strings very quickly.
Yeah, and also
just inputting into different data types. That's going from a string to integer to character to double.
Right, so if you wanted to do something on the fly, like if you wanted to say convert a string to a float and you don't want to ask you to float by pulling out the C string or whatever, you can just pipe it out to an integer or pipe it out to a float.
Yep.
Or whatever, because you can override that whatever freaky operator outsertion that is. So you can have your own custom data types and weird kind of things like that. So good things. Now, O strings.
Now the evil twin of I is O. This is O string stream.
String, our home in NATO.
In NATO? What about NATO? It's America.
That's America.
We don't have some.
So Brian, one of the more common ways that you'll see O string stream is from converting integers and stuff to string.
Yes.
So this is kind of a classic example of how to use it.
A lot of objects and data types have already implemented ways of handling that, just like we've seen when we write stuff out to a console. When you print a number, there's already written in the idea of the number in the language, how to convert that to a string. This is kind of baked in the streaming process. In this case, we're going to have a function called convert integer to string. It'll take in an integer, and all it does is, you see where we declare an O string stream, and we pipe number to that O string stream. Just like we would pipe it to the terminal, we're just piping it to an O string object, and we're returning that object's string.
Yeah, so if we had multiple ones, they would concatenate to the string.
So it's very cool.
It's pretty awesome.
So this is a very, very easy way to write your own kind of integer to string converter.
Now here's a little bit more of an exciting example, Brian. Maybe you can help us understand how this one works.
This is basically the opposite of the example we saw before. We start with the unsigned integer, the string, the character, the double. That's where we start off. Now, just like in the other example, when we had all of those different variables coming from the iStream, in this case, we're going to pipe them all to the O stream. Now, since they need to be space separated to denote that there's multiple arguments going into the stream, and because it concatenates all these values, we want to also concatenate into them spaces between the account number and the last name, first name, and so on. So that will do exactly the opposite, and it will just pipe these all into O stream, and when we print that out, we just get it as one nice long line of text.
Beautiful. And it concatenates to one line of text, I think. That concludes our string video for the programming in C++ section. Yes. We went over pretty much the basics of using strings.
Everything but the color blue.
The important thing to keep in mind is the methods that Brian and I discussed, as we mentioned before as a disclaimer, are used in many different ways. So don't say that, whoa, Kevin and Brian said this is the only way. That's not the truth at all.
It's also not a conclusive list of all of the methods.
All right.
See you guys. Bye-bye.
Bye-bye.
Welcome to our video on programming in the language that is one better than C.
I love it. Oh, yeah.
So now we're going to talk about dynamic memory allocation, and we're also going to talk about exception handling.
Ooh.
So we're getting into some pretty cool topics.
Ooh, baby.
They're not difficult to get. You know, you're gonna have an easy time with them, but they are a lot of fun.
I'm terrified, Brian.
So we're really going to be using a very large aggregate of a lot of the other concepts that we've been learning.
These are two concepts that have me. I'm sweating. I'm so scared right now. I'm so scared. Let's talk about dynamic memory allocation. Now, remember in C, Brian, we used malloc and we used calloc.
Mm-hmm.
Well, in C++, we use an operator called new.
Oh, I like it.
And in C, we destroyed memory or freed memory by calling the free function. And in C++, we're going to be calling the operator delete.
We had, do you remember when we had a teacher once that would always want us to, he would always say this, like when you go to name something, if it's like a project or whatever it is, he'd say, you need to call it something sexy.
Something sexy.
Something very sexy. Yes, nice.
Yes.
So when the guys who in 79 were writing, C++ and they had their big mustaches, their Tom Selleck mustaches.
You better believe they did.
Polyester on.
They're 2 unbuttoned top shirts with the chest hair sticking out.
Yeah, some gold necklace, some gold chain. They were like, hey man, we need to like name this something sexy. So they called it, instead of like malloc and cialic, like what is that? I mean, seriously. Like,
how about new and delete?
Yeah, that's awesome. That's way easier.
So in a basic sense, here is how we can use the new operator. Now, it kind of looks like a keyword, but functions as an operator. And the reason why, Brian, is this can be overloaded or overwritten. So you can actually, when you make your classes, you can say, I want new to do this. So you can, so you can create your own memory the way you want. So that's why it is an operator. In this case, we're creating a dynamic array by saying int star integer array equals new int and then the size of the int. And then on the bottom, we're going to destroy this memory by calling delete, and then it has brackets since we're deleting an array in an integer array. When we create this dynamic array, what we're doing is this size, I want you to fill up with whatever the parameter is that comes in from the user that we're going to use stdlib.h because we can still use our C headers in this as well. So we're going to use std.h to do the ASCII to integer conversion. So when I have a code file here or executable file called dinmem.exe space 3, I create 3 little blocks of memory that are integers. Then I'm going to fill them with 0, 1, and 2, and then I'm going to print 0, 1, and 2 to the user, and then I'm going to go to those memory spaces and I'm going to clear them out.
Nice. That was pretty hot.
That was very sexy.
So in this example, we'll take a look at using the new and delete operator, but we'll use a string pointer. So we call new string. We store that into our string pointer. This is going to point to a particular location in memory. And in that particular location in memory, we will store, this is my new string. And then we will delete the pointer. Very straightforward.
Gone.
Done. It's gone. We've just dynamically allocated memory.
Now the pointer still exists, but the memory that it was pointed to is now deallocated. Mm-hmm. So if on the next line you wanted to say star str equals something else, you can do that. So here's an example of us doing the same thing with dynamic memory allocation, but calling a constructor, which we technically did in the last example. We just called the base constructor, which sets it to an equal to an empty string. So in this case, we're going to do string star str equals new string, and then in parentheses, we're calling the constructor method and passing it, this is my string, and in the following line, we're deleting it. So functionally, it's the same as the previous example.
We just allocate and get rid of it. New and delete act like keywords, but they're actually operators. It's kind of like Kevin was saying earlier. Mm-hmm. And when new is called, memory is allocated from the free store memory pool.
It's like Freebird, but FreeStore.
Yes. So it's just a pre-allocated larger chunk that we have access to. And this is different because from malloc and calloc, because they use heap.
Let's look at the basic comparisons between the FreeStore and heap. So Brian, why don't you be the FreeStore and I'll be heap?
All right.
We can have like a little back and forth
Sounds
argument. Kind of like...
I allocate with new.
Yeah,
I'm sexy and from the 70s.
Yeah, well, I use malloc and calloc. I'm from the 50s. You like 50s women. Hey, Marilyn Monroe, she was hot. What's up?
Yeah, but I had Suzanne Summers.
So?
Okay, so you won that one. I deallocate with delete, and I got a big mustache.
Yeah, well, I came from the 60s where we had free love, baby, so I use free.
Okay, you win that one.
Oh, baby!
Man, come on, I'm not arguing a good case for C++. It's way better, I swear. I have type identification that returns a pointer with a designated type already in hand.
Okay, well, you kind of got me there because I just returned a void pointer and forced you to typecast it.
That's what I thought. I will survive because I automatically handle allocation size.
And I require you to pass the block size as a parameter.
You're lame. And I can be overridden with method overriding. So when I call new or delete, I can make new do whatever I want. I can make delete however I want it to.
But malloc, alloc, free are all static.
So disco rules.
That was very good, Brian. Generally, it's good practice to use heap for primitive data types in the same way that we were using it in C. Mm-hmm. And it's typically best to use the FreeStore for objects.
Yes.
Now this is not something that's written in stone. Many developers will even say, really, there is absolutely no difference. And to a large degree, they're correct. But it's more of like, it's more of like an organization of things, I guess. Exception handling allows us to work with a potentially dangerous situation, or an exceptional situation, as it would be. We can run we can run Plan A code. I'm doing quotation marks with my fingers. And if something in Plan A, we can send control to Plan B code. And we do this by creating try blocks. So the try block will allow us to run this code, and if something exceptional happens, run this code.
So it's kind of a safety container. And if anything goes wrong in that container, we'll say, like, oh, that's fine. We're just going to clean up, go over here, jump out of the scope, do something else. Mm-hmm. It's very nice. You're going to like this. These exceptions allow us as programmers the ability to kind of react to things that we don't anticipate. So in one of these blocks, these safe blocks of code, we won't necessarily be able to, it's not like an if-then, we won't be able to consider all of the circumstances that can cause a problem to happen. So this gives us a chance to say like, okay, hey, just kidding, I was just trying it, and we can react to that. And when an exception is caught, it's called throwing an exception. So we will throw that exception up into the code, and that will transfer the control to another section of the code and kind of just break out of that safe container. It's like a fuse that breaks in your house and the light bulbs go off. You blew a fuse. You can just kind of throw that fuse.
Mm-hmm. Right.
And to catch this exception, that safe container is considered to be the try block. So we'll see an example of that here.
There are types of exceptions that occur naturally. For example, when you do dynamic memory allocation and you extend beyond some capability, that is a natural exception. Although many exceptions are controlled by the developer, where there are checks and balances that if something doesn't match, there will actually be code that says throw this exception. And we'll take a look at that in this example here. Now in this case, our program has no choice but to have an exception because we're not actually testing anything. We're actually literally just throwing an exception to show you how this works.
So with that throw operator, we can actually just force it to throw an error. Instead of having the program blow up, we can test for a condition. And if that condition arises, we just will force a throw.
Mm-hmm. So when we execute this program, this throw keyword will then create a new instance of a string, and we're calling the constructor and saying, I'm throwing an exception. Now, it's important to kind of understand what's actually happening here, because when I throw an exception, I can actually have this be anything. This can be an integer, this can be a character, it can be a char star, it can be a string. There's also an exception class, which we'll get to in a second, that contains what I was saying, the predefined exceptions. But in this case, I'm throwing a custom exception, and it's coming back as a string. So in my catch code, when this exception is thrown, the catch code will take in that, whatever the exception is, as a parameter. So think of this as like a little function block inside of your code. So when the exception E comes in, cout, an exception has occurred, and then I can just print the value, just like we with pointer star E, we'll print the value contained inside of that. So it just says an exception occurred, and the exception is, I'm throwing an exception.
That's exceptional.
That's very exceptional. Now this is a little bit more practical, and
So we have an integer pointer that points to null, and we have a function up above that says do something, pass in that integer pointer as a parameter. If that parameter is null, then throw it. When we call the main function, we'll go down and we have our null pointer, and we'll try to do something. And that do something is effectively passing in a null pointer. If we go up to do something, when that parameter is null, equivalent to null, and we're going to throw the new string param cannot be null. That will bubble back up. It'll throw up back into the catch. So it'll catch what was thrown, and it'll catch it as a string pointer E. And we'll take that E, that pointer to E, and we'll write it out to the console. So we'll say an exception occurred, just like in the last one, and that exception is param cannot be null.
now this is a lot more practical than the last one we saw, because this code is actually testing something. When this person wrote do something, deep buried inside the code, they wrote exceptions. If you're passing me a null pointer, I want to throw an exception because this won't work under this circumstance. So this is a programmer-defined exception that is caught by the try block.
It's very nice.
Very beautiful.
So you can already see right away where this can actually have a significant effect on your style of programming.
Absolutely.
And the way that you've pre-visualized out that workflow. And, we go back to the flowcharts and the pseudocode, even all the way back. This exceptional programming style can be thrown all the way back to the flowcharts, where we would actually change the way we design the flow of the program around the ability to do this. It's very cool.
It's generally good practice to put any type of dynamic memory allocation in try blocks. And the reason why is because the new operator does have exceptions built into it, and they do have predefined exceptions. So it actually will return you an exception instance of predefined exceptions. So if a memory can't be allocated for some reason, you can catch it so that your program doesn't continue running as if it had been allocated. Now that is potentially dangerous, because you can run into a situation where your program either crashes or infringes on another executing program. Remember, this isn't Java. This is C++. It's on top of C. If you have direct memory access like that, you can really things up if you're not really careful, So if we take a look at the next...
haywire on
You can, absolutely. So if we take a look at this next guy here, we're going to make a integer array of a big size. We're going to create this dynamic memory through a try block. So let's try to make this big array before we actually assume that this array has been built. And we're going to, here's our little memory. This is 1925, okay? We have like 5 bytes of memory. We allocate this one, this one, this one, this one, this one. Oh goodness, we can't allocate any more memory. We're out! Throw the exception! And now if you look down here, we have, instead of a string, we have an exception type. Now the exception type, and if you want to look this up, it's a standard class in C++. It contains a method called what. So if you do e.what, it will tell you what happened. When I say caught exception e.what, it says bad alloc, which means it was unable to allocate the memory.
It's awesome.
Yeah.
Now you can kind of see where you can throw exceptions on your own. Like you can look for cases where you want to throw an exception. But also, if you don't throw an exception, and as you can see, there's a couple different ways that try-catch will work. So these try-catch blocks can be thrown when you decide to throw them, when you create a condition and you throw an exception. And that exception is thrown back up to the catch block, and we do something about it. We print it to the console, whatever. If it's not something that we explicitly throw, but if we're using objects in C++ that have dynamic memory allocation and a lot of other ones that are in there, they usually have within them the use of this exception throwing built in into these classes. So if anything goes wrong when we're using these C++ objects, they will throw exceptions up. So without us explicitly calling to throw these, they will bubble up to the catch block. And as we saw, there was that exception class type, and that can kind of figure out what type of exception it is and tell us what's going on. And that really gives us a lot of flexibility of how to deal with these things that can get out of hand. Things that especially get out of hand when we're dealing with dynamic memory allocation.
Oh yeah, absolutely. That's a very good point, Brian. Dynamic memory allocation is not only something that you have to account for, but it's something that's very important to use. And Brian and I are going to go over some what we think are really great examples, like, for example, the dynamic array, the linked list,
Nice.
which is going to be using these operators because you're going to be dynamically creating lists of data during runtime. So creating dynamic memory during runtime flow is used in software engineering so much, you get to a certain point that it just becomes like breathing. How fluently you use dynamic memory allocation, because nothing is static anymore.
Right.
Everything is just little bubbles that are just popping out of programs all over the place.
How does that go again?
Blah.
Nice.
Yes.
See you guys.
Hey, Brian.
Yeah.
Do you remember that movie Basketball?
Yes.
Do you really know that?
No, I remember the movie. I hadn't seen the movie.
Well, the creators of South Park made that movie, right? And they had, I think, Al Michaels and Bob Costas.
What country did it take place in? Was it
America?
Sorry.
And there was one part where the Bears, which was their basketball team, was winning some championship game, and Bob Costas said to Al Michaels, "You're excited? Feel these nipples." And that's how I feel when I see Introduction to Classes on my computer screen right now.
So after all that talk about classes and objects that we kind of led up to, like we're there.
This is the moment that you grow up from a little pansy into a strong bear. Yeah, that's right. I said bear. Maybe I watched The Office too much. So, ladies and gentlemen, this is what you've been waiting for. Once you conquer classes, you are a true software developer.
Yeah, not a fake poser.
Yeah.
You hoser.
Yeah. This is what separates the women from the girls and the men from the boys.
You're like real now, right?
This is it.
Oh, yeah.
This is it. It's the most important programming concept that you must understand if you're going to excel in this skill.
Yes.
Now, of course, you do have to understand all the other stuff that we've discussed, but you probably already have a firm understanding of that. And, to be honest, that stuff is easy, I think, to kind of get. Object-oriented programming is where I think a lot of developers struggle. And this video is going to kind of make you understand that object-oriented programming is not a complicated concept at all. The introduction series kind of gave you the Saturday morning cartoon feel. This is the real deal.
Right. Don't think of it as being complicated. Just think of it as being sexy.
It's very sexy.
Yes.
Very sexy. Now, as we've discussed before, the classes are a part of the object-oriented concept. Duh. Classes are templates for objects. And remember, Brian, objects are the potential or the blueprint.
Right.
And from the objects, we create instances, and instances are entities of objects.
So this is how we're going to be creating those blueprints in C++.
Absolutely. Whew. Okay, Brian. Let's get started with how classes work in C++.
So classes are constructed with two files and are used in a third file. So we have our header file, and that contains the template for the class. Then the implementation file, which is usually a CPP file for C++, and that's the file that contains the class implementation, the actual definition of all of the actions of the methods, like the code that makes up the methods. And then there's the driver file, which is also a .cpp file. And this is the file that uses both the header and the implementation file. So this will be the file that probably contains your main function, maybe.
Mm-hmm, yeah.
Something like that. It's the driver. Technically speaking, you only need one code file to do all of this. But it's not sexy. You need to keep it sexy, yes?
Well, there are a lot of programmers do stick to the standard of the header, the implementation. So we're gonna promote that way, but show you the other way.
Yeah, because it's up to you.
When you also switch from language to language, that same concept is kept. It's pretty static. So by default, C++ members are private.
Unless you have a friend.
Unless you have a friend that can access your privates, but we'll have that's coming later. So we can use access specifiers to allow the proper access outside of our code. And the access specifiers in C++ are public, which is accessible from everywhere that the object is available. Private, which is accessible by members in the class or by
friendly functions.
Your friendly functions have access to your private members. And protected, which is accessible by other members in the class and
friend functions
and other
but
classes.
Also anything that inherits it too. Yes. So any children of that.
Yes, exactly. Now this looks suspiciously like what we talked about in the introduction to programming.
Yeah,
introduction to object-oriented programming, huh? Oh my god.
So this
is really happening.
Yeah. So we're looking at the header template, the declaration of the class. And then the name of the class.
Oh, wow.
Yeah, it's pretty smooth.
It's coming.
Like everything
together.
in C++, really, when you start looking at it, is It's pretty smooth. It's nice.
basic.
So then we have our code block, and in that code block, we can have members that are private, protected, and public. And you just call, private colon, kind of like a label, and then what those members are going to be. And that's the general construction of the header template.
Members are private by default. So if you specify like this, where you just have members that you declare, and then you have protected and public declared after that, everything declared above that will just default be private.
Smooth.
So my goodness, this is a real f***ing class. This is happening, folks.
So here's a blown out header. So you have the class and then the name. We'll just call this one name. Why not?
For your name or whatever, yeah.
And then the private variables are going to be a character pointer first name, and then character pointer last name.
And these are private.
Yes,
Nice.
so nothing else can get to them.
And we're using underscores.
Yes.
Because they're global and they're private, so that's just the naming convention that we've struck to separate the difference.
Yeah, methods and attributes and things is a get first name method, which returns a character pointer, and the get last name method that returns a character pointer. And this is similar to where we saw before we have our sets and gets to access our private members. So the gets will return back a char star, and then we have other methods, set first name and set last name, that take in char star, and they're void, so they don't really return anything at all. They just execute.
Accept. Right. Now here is the template for an implementation file. And an implementation file is going to include the header file. Now this may remind you guys of the DLL program that we wrote in C, because it was kind of similar to this. We had a header and an implementation file. Same concept. And in this case, what we're going to do is declare the return type. So we had the other ones that were char stars and void. And then the class name. Now remember we had the scope operator? This will come in handy here. Now the scope resolution operator, which is its full legal name, if you were to go to the courthouse.
Yes. All right. Look at me. I'm calling it a scope resolution operator. I'm cool.
What this is saying is the class name here is where this method resides. So method name, whatever that method is, belongs to this class. And then we can pass it parameters just like we would to any other function, and then we have our code inside just like any other function. And except for it's not a function, it's a
method.
Yeah.
Let's assume that the template that we had is we called the class name. We're going to call the file name.h just to keep it all consistent. So in our implementation file, name.cpp, we're going to include that header file. So we start off right out the bat. It's just as if we were to take the code out of the header file and paste it where we said to include it.
Absolutely.
So it's really just to kind of keep it all clean. But functionally, that's what we're doing. So we're going to just include that header file. So we have all of our declarations out ahead, our prototype, and then we say void name, which is the class.
The name of the class.
And then
the scope resolution operator. Yeah.
And then set first name, which is the method that we want to declare here.
And set first name belongs to what? The colon tells you that.
Yes.
Yes.
Belongs to the name class.
Yes.
If you remember, set first name was declared, it was prototyped, so to speak, in the header file. And we're going to pass it the argument char star first name. And first name is what we'll use inside of this method. We're really just going to say that underscore first name, which we now have access to because it's private, is equal to first name, and that'll set that first name.
How beautiful is that?
It's
now
awesome.
Let's take a look at the rest of the file. Wow.
Ooh.
This has defined the setters and getters for first and last name. So we have the scope resolution operator separating the method names from the class name, and then the return type in the beginning. Wow!
It's almost intuitive. Like it's almost like you see it and you're like, well, of course that's how it would work.
Exactly.
Now that you see it.
If you were to build the language, that's what you would do.
Yeah.
So you have, just like Brian said, the set first name. We have the set last name below that, which does the exact same thing, but it just sets the last name. Then we have the character pointer or char star. That's going to return the first name. That's just going to return underscore first name, which was that private member or private field that we set before. And then get last name, same thing. It's just that we're returning the private underscore last name field.
Now, this is very similar to how we've seen functions declared and defined. Yeah. I mean, it's really no different. So you're kind of used to that structure.
So these together, Brian, my header file and my implementation file create the potential for an object.
Look how pretty it is.
Literally right now have an object in our hands. Now we got to do something with it, Brian.
All right.
Let's use it.
Okay.
What do we do?
So if we want to use this is kind of like, this is the template of our driver file. So this is the file that's actually going to do the executing that uses our class that we've defined. So we're going to include the implementation file, and not the header file, the implementation file. And then in our main function, we will declare a new variable by calling the class name, and then the variable name we want it to be. And then to access the members, the public members and the public attributes, we say variable name dot, and then the member.
Yeah.
And that's how we get access to it. So that's the main kind of template of how this works and how this looks. So here's an example of the same thing, but now using dynamic memory. So in this case, since we're referring to a pointer, so we have class name and then the star variable name or the pointer, and then new, we use the new operator, class name. So that's going to create a new instance of, to a pointer variable name, to a space of memory. And because we're talking about a pointer to variable name, whatever that is, we're going to use the arrow instead of the dot to access the members and attributes within it.
Yeah, and since we use the new operator, it is our obligation to delete. Otherwise, we have memory leaks.
Yeah, it's like being a Boy Scout. Like, you always leave the forest cleaner than when you walked in, kind of a thing.
Oh, yeah, that's good. I mean? Yeah.
So like, if you see trash, you take it. If you drop trash, make sure it goes with you.
Like Smokey the Bear says this. Yeah, in America. Protect the American forests. Take a look at this, ladies and gentlemen. This is... I'm shaking. I'm so excited right now. In this code example, we're going to include the IO stream, and we're going to include our implementation file.
Nice.
So if we take a look on the right-hand side, those are our two files. The top file is the name.h. The bottom one is the name.cpp. So you can see this little cascading hierarchy where when we include the CPP file, the H file
comes with it.
It's sucked in along with it.
It's awesome.
Yeah. Next we have the potential for name.
Right.
So when I say include name CPP, I'm saying there is a potential to create an instance of name.
So now our program kind of has the knowledge of how to create a name object.
Yeah. Oh, baby.
It's cool.
Nice. So now let's create an instance of name. Hit it again, Brian. We're going to go out. So when we call name, we're going out to that template. And we're saying,
blueprint.
Hey, name, I'm going to need to go ahead and get you to write that TPS report. No, give me an instance. So when we call the name class, it will give us an instance, and it will say, here you go. So now we have an instance in memory. So now we want to access the members inside that instance. So we call the instance, which goes out to that memory space, dot the method, and we're going to send the first name method WiBit. So WiBit goes back into that code file, basically, and it says, okay, name, the scope resolution operator has to find a method called setFirstName because the driver code says you have it. And it goes, okay, setFirstName. Here it is. Here's the parameter, and then it just says, okay, now we're going to set underscore first name to WiBit, and, oh my goodness.
Nice.
WiBit is set as first name. Now, Brian, take us through this wonderful last name.
So just like in the set first name example, we're going to call my name dot set last name. And so you can see how this kind of reads pretty natural. You just say my name set last name.
Yeah.
My name would do something. It's very nice. We're going to pass it, in this case, the last name, which is .NET. So .NET goes down to our implementation file, which makes a reference up to the template and, finds where to do the things and store the thing. So now, my name has, within it, a first name and a last name set, and they're private. You can only access them through the get functions.
And if we want to receive the first name, we say, hey, my name, which is in memory. We say, hey, buddy. Hey buddy, I'm gonna ask you to go ahead and call the get first name method. So then the my name instance goes into its methods and says, okay, get first name is going to return you a char star called first name, and it sends WiBit back. And then it does the same thing for the last name. And that's going to send .NET back. This person has the greatest name in the entire world right now.
And then it'll concat both of those and throw it out to the console.
This person is a walking advertisement for our website.
Yes, exactly. So, what do you think is better?
I don't know, Brian. I'm kind of confused. I mean, it sounds like the first one is better because it's easier to implement, but the second one does kind of have more freedom associated with it.
It's true. It's very true.
Well, let's see. What do you think, Brian?
Well, the first one is easier to declare.
Oh, isn't that what I just said?
Yeah.
Oh, I must have seen this before.
There is less work on your part because it's simpler to declare.
Yeah, it's true. Yeah.
And it's good for smaller applications that don't run for an extensive period of time.
Mm-hmm. Yeah, because it relies on garbage collection, the operating system memory cleaning in order to manage itself.
But if you're hardcore like Ripshaw McGraw, then you'd say name star my name and just do it as a pointer reference and call the new operator and then name. So you create a new instance in memory, dynamically allocated, put it over there. It's a little more effort to implement, I guess. You got to be a little little sexier to use it. You have to remember to delete it.
You have to remember to use arrows to access members. Yeah,
instead of dots.
Yeah.
It's more efficient if it's used properly.
Absolutely.
So it's good for larger applications, things that run for longer spans of time.
Yeah.
Just remember that it's a pointer. So if you start kind of treating this like it's not, you might have multiple things that point to the same memory space and all that kind of problem. So make sure that you treat it like it's a pointer.
Right. Like, for example, if you set something equal to that value and then delete, whoops, you deleted the memory space that something else was pointing to.
Right.
So when we say that's more work to implement, it does require more thought. But if you have a program that has like a long, like what they call a run loop, you know, like a service has a run loop, something that is like, it runs and it stays running. Well, in that instance, if you don't want to rely on the operating system garbage collection to handle your objects, you should do it this way. But again, you have to know what you're doing. It's not something that you can just pick up in one day and be an expert at.
But in any event, whatever you do, you can do it with style, you can do it because you can use classes. So congratulations.
Yeah! It finally happened.
You are now from a baby to an adult.
Yes. Believe it or not, ladies and gentlemen, you have learned something amazing.
Yes. So don't waste any time. Try it out. Make some programs. Rewrite a program that you've already written.
Yep.
Just for fun.
Write your own string class.
Yes, exactly. So pick up your skirt, Betsy, and get to work.
Yep, let's do it.
Oh, yeah. Also.
Oh, yeah, there's more.
Yeah. Now, if you've been watching this the whole time and saying like, well, I've been dying to know how to do this without the header file and all that other crap, you know, I just want to like jam it all into one file. Skip ahead if you don't really care. But if you've been dying to know how to do this, we're going to show it to you anyway. It's not a best practice, but who cares?
I don't care. So this is an alternative name.h, Brian. Now this does not need a .cpp file. We're going to create a name class. You know, so our prototype, our class declaration looks exactly the same, except for, our method implementations are not in a different file.
Right.
So it's in the same file. So you could, instead of saying include name.cpp, now you could say include name.h.
Nice.
So
that's cool.
Yeah. Now there's also another example, Brian. Now this just is even shorter. This is actually throwing code inside the class declaration.
That's crazy. It's
you
madness.
You can do that.
It's madness.
You can do that.
Yeah. So if you're writing a program and you don't feel like all this whole, we don't need separation, I just need like a small little class, do a couple little things, whatever. Just throw this in there. Done. You're good to go.
I will tell you that this might get unmanageable after a while, though.
Yes, absolutely. Absolutely. But so, yeah.
But you can do it. And you know what?
If you need to.
We don't hate. We're not haters. If you like this.
Unless you try to do something like this in Visual Basic, then we're haters. So which class declaration is the best?
Well, it's generally considered acceptable
to
do the header plus the implementation.
But really, you know, like we keep hashing on, it's whatever works for you. Like the important thing as a developer is to really, and it's important with anything, is to come up with your own sense of style. It's your own way of doing stuff. It's what you like. Because having a whole bunch of programmers that do everything always exactly the same won't have that diverse strength. You know, the weakness of one will be the weakness of all. And so really just kind of like focus on your own style within reason. I mean, you don't want it so stylistically different that people can't manage your code after you've written something, but you really want your own kind of, you know, so whatever works for how you've learned.
Right, and there are pros and cons to doing these different methods, and whatever process or program you're working on, from situation to situation, it would be different. Like, for example, this, if you're just setting a name and getting a name, why have two files?
Right.
Why have 50 lines of code when you can have 12?
But if you have a bit beefier of a class and you have a bunch of classes and the program's longer, you don't want one like 500 megabyte code file or something. That'd be ridiculous.
Or the class declaration just like we said, gets unmanageable.
Yep.
So that's it, guys. I mean, this is it.
You just knocked through something nasty.
Yes. And we're just going to continue building on this and building on this.
I know, we're not even half of the way through C++.
You're going to be the baddest software engineer this planet has ever seen. Thank you, WiBit.net. You are the greatest. That was a shameless plug.
Oh, who cares? Like that giant WiBit.net TM isn't.
Welcome back, everyone.
Oh, except that guy.
Oh, yeah, that guy's kind of
that guy, you can just go off.
He's a VB.
What are you doing
here?
He's
a VB programmer.
Yeah. Stop spying and hating. Get lost. All right, is he gone? Okay. All right. So everybody else, now that face is out of here.
Come closer to the screen.
Okay.
Closer.
I'm fine with that.
No, okay, too close. Back up, just, okay, right there. Okay. Hey, everybody, welcome back to the WiBit.net lab series for C++. What we're going to be doing in this video is, Brian, we're going to be writing our very first object. And there's been a lot of build up to this. We have discussed objects in the abstract, and we've been using them. We've been using the string class, and a few others like for OF, input and output, OS stream, all that kind of stuff. But we want to build a class with you guys, and we want to try to do it in a way that doesn't scare you guys.
And I guess we're gonna do this in between us cutting out you farting on my leg? Is that?
No, we're gonna keep the farts live.
A lot of build up. You
Yep.
might be anxious.
Yep.
You might be kind of like, I don't think I'm going to get this like class idea.
Yes.
Like objects, right? Whatever, but
Yeah.
like a class versus an object, an inheritance, instantiation. Like, what the hell is going on?
Because
Okay.
Brian and I kind of believe, at least I do, that the thing that really separates a good programmer from a bad programmer is one that really fully understands object-oriented programming. Because yes, you can be a programmer and just use it and never actually know what you're doing, but you're never going to be a programmer. You're going to be a copy and paste coder the rest of your life.
Absolutely. And a good and not just object-oriented, but a good programmer versus a bad programmer is you actually know what you're doing versus assimilating the people around you.
Yes.
Yeah, if you're just kind of like, oh, I saw this guy do this thing, and you don't really know, but it kind of works.
Right. Yeah.
That sucks.
Yes.
So let's break it down. Let's understand what we're doing. It's no big deal. So we're gonna, in the simplest form possible, not because you're stupid, but just because I guess maybe we're stupid. I don't know.
Yeah. Well.
The simplest form possible. We're gonna define out a class so that we can use that definition to create an object. Do something with it, and then end the program. Really simple. You're going to like this.
Yes, and what we're going to be doing is we're just going to, kind of like in the lesson that we just went through, we made a name class. Well, we're going to kind of take that same approach here, and we're going to make a person class. Now, you guys are going to see this person class later on, so kind of keep this in mind, because when we start talking about object inheritance, Brian, we're going to be using this example in object inheritance.
It'll be cool.
It's going to be awesome.
Okay, so let's call this, person class CPP. Actually, .h.
Person.h.
Perfect.
So it's standard in C++ code to have your code file, the name of the class, and then we're going to do the .h file, that's going to be the class definition, and the .c file, which is going to be the implementation, .cpp file, which would be the implementation.
Okay, so the first thing that we want to say is that we're declaring a class.
Okay, now
which is the blueprint for an object.
How would I do something so complicated, Brian?
You'd probably say class.
No, no.
Class.
Oh.
There you go.
It's col and then s.
Right.
Kind of like, yes. Right. Ooh.
And then the name of the class.
Oh, okay, wait, hold on.
Person, right? Okay, so this
No, it's gotta be more complicated. There's gotta be some like code right here that does this.
No. Just add some curly braces and,
what?
and then a semicolon and that's it.
No way.
We're done.
Okay. Woo!
So this is setting up within these walls, within these curly braces, will be all of the rules and regulations and restrictions for how to blueprint out what it means to be a person.
Yes. At least our concept of a person, which is pretty lame, I might add.
Yeah. So we're going to have all public members for now.
Okay.
Just to keep it simple.
Okay. But you guys, as we spoke in the video, we can declare different types using access specifiers.
So we have protected, we have public, whatever. All this is going to be exposed just for this example.
Okay.
Just to kind of like get you used to this.
Okay.
We're basically just going to have two things in our person.
Yeah, we're going to have
just
two,
for this
two
idea.
fields.
Two fields.
Right, and these fields, and maybe we could mess around with this, but these fields right now are going to be publicly accessible. And our person is going to have two attributes or two fields. It's going to be a first name and a last name.
And that's it. So we're just going to keep it simple. All we're going to have, and they're both going to be a string of text, just a first name and a last name.
And remember the syntax we spoke of before. I'm going to keep these underscore because they are global to our class. And these are actually supposed to be hidden, even though we're not doing that in this particular example. That way, later on in your code, you know that these, what these are just by how it's named. All right, so the first thing that we want to do, Brian, is we want to create setters, right?
Yep.
And a setter is nothing more than a method that interacts with a variable and sets its value.
So inside of this class, it's really cool. Just like we explained, inside of this class, not only can we have the fields and the attributes, but we can write functions that get attached inside of this class definition.
Actually,
that's called a method.
If you guys want to see something really cool, let's leave the class like this, right? Okay? I'm going to make a new text file, and we'll just call this person driver.cpp, right? So let's use include
person.h
iostream.
Oh yeah, that'd be cool.
And then using namespace
std
sexually
transmitted.
And now let's include person.h, right?
Yep.
So if we do int main, and inside the main function here, we return zippy to the operating system. We create a person like this.
Let's call the person, instead of calling it P, let's call it like
now I gotta get all nitpicky.
Yeah, let's call it like Beverly.
I have no idea how to spell Beverly.
David.
David?
I don't know.
All right, we'll call you David. Now, before we do anything, Brian, let's compile this and let's interact with these variables. Since they're public,
let's do it.
We can actually touch these variables from this scope.
We can do whatever we want with those.
Yeah. We can be friendly with this class.
Yes, we can.
Yes, we could. All right, so
we're not creepers. You'll understand that joke later.
Actually.
Oh, we are creepers.
Those of you guys that have been following us for a while. Whoa, what is that? I have no idea what I did. Plus. Okay, so we go to G++. Let's compile person driver. Whoops, person.
Yeah, there you go. Tab.
Driver.cpp-o. We'll just call it person driver.exe. If we run this program, of course it does nothing. But what actually is happening, Brian, is once we get to this line of code, we are instantiating an instance of person called David.
So let's set David's first and last name.
Okay, let's do that. All right, I like this guy. Although
let's call him Davy, because that's what he goes by.
So you want the instance to be called Davy?
No. We want his first name to be called Davy.
Okay, so remember, it's going to be underscore first name equals, what is it? D-A-V-I-E? Like
I guess, I don't know.
Or D-A-V-Y? How do you like Davy Jones?
I didn't even know a Davy. There you go, try that.
Davy? That's Davy, isn't it?
That's close enough. That's what
I like this one. Okay. I like this one.
Done.
All right, so now David's going to have a last name. Right? So now we're going to set Davy's last name to Wavy? Davy Wavy?
There you go. Sweet. Awesome.
W-A-V-I-E. Davy Wavy. Now, and we're not going to really, this program's not going to do anything, but if we compile it.
Not do anything visibly anyway.
And run it, right. What we're doing is we're instantiating an instance of person. The instance is called David. And what we're doing is we're scoping in by using the dot. So go into the instance of person, dot, access the member first name, which, as you guys recall, is this member right here. And we're going to set it as if it was a regular string inside of a program.
That's awesome.
Yes!
Yes.
Yes. Okay, so that's the basic concept.
And then after this, you can make a person Bill, a person whatever, a person...
Right.
It doesn't matter.
And if you were to design this class properly, what you would most likely do is make this private or protected. Now, you guys remember the difference between private and protected, right? A private member is only accessible to itself in any subclassing or any sub-members, but protected is inheritable. So when I inherit this class later, which is, don't worry about that, I will be able to access these. But if I set this to protected, Brian,
it's not gonna work.
What's gonna happen here?
We don't have access.
We don't have access. It's protected. So we can't. So in this situation, Brian, which is a very common class setup, we're gonna actually have to have a setter and getter to interact with these.
Absolutely. So we want to write a method. Like we were talking about, we can embed the functions inside the class. We're gonna write a method that's publicly accessible, so we can control how the person using this class sets, they don't get like sloppy with the T's with. If we feel like it, we can kind of like not allow like non-alpha characters in the name.
Right, and if you
you can't be like Davy $9er as your first name. Like that's ridiculous.
And we could also
Davy
do
SQL injection 9er.
We could also do other dumb stuff like if you send in a blank value, we can throw an exception.
Yeah, or so just chomp in the blank. Yeah,
we have complete control over that. Now, but we're going to need to be able to implement this because this is actually going to be doing some actions. So, Brian, explain the next methods that we need to interact with these.
So just like we would prototype a function, we're just going to kind of lay out what we have available. So this is kind of our table of contents.
Yeah.
So we're just going to say void set first name, and we're going to want to pass it a string because, well, that's how we know what to store it as.
So we're doing a function prototype inside of a class that's called a method.
Yep.
Method prototype.
Let's do another one for the last name the same way. And then it's all well and good that we can store these things. We want to be able to get them so we can use them.
Absolutely.
So let's, perfect. Let's call that the setters. Now we'll get through the getters.
And keep this terminology in mind, ladies and gentlemen, because this will be a very common thing that we say. And as we progress through our languages, this is going to be used an awful lot.
Okay, so now we want to make a couple more prototype definitions, and we'll just do the getters. We know they're going to return a string.
Right.
So right off the bat, we can just say string, get first name. Easy.
Okay.
We don't pass any parameters.
This will take no parameters.
So we just get the first name, whatever that is.
Mm-hmm.
We do the same thing for last name. So now we have one that doesn't return anything because it sets, and it takes a string as an argument.
Okay.
And the other one gets it, returns a string. Done. Easy.
So we've just defined a prototype. Now, Brian.
Now we just have to implement this class.
Well, before we do that, what happens if I try to compile it?
Well, it's still protected.
Oh, well, okay. Well, let me take set these out.
Just comment.
We'll just.
yeah, that's fine. We're not going to use them anymore.
So let's try to compile this again. Let me do a little CLS here. Okay, that actually compiled.
Yeah.
But there's actually no guts to this program.
Yeah. So nothing will happen.
Right. So nothing will happen. What we have to do is we have to make it so that these do something.
Yeah. So let's create our implementation file.
Our what?
Our
implementation file. And it's pretty common to give it the same name as your .h file, but have it as a .cp.
Yeah, so now you can clearly see that these two files are paired up. You got person and person.
And this little fella here...
It's like sibling files.
Is going to be including person.h.
Yep.
So you see that this code file here absorbs this code file.
So that we have the table of contents of our class.
Yep. All right, Brian.
Okay, so we're going to have basically just implement our functions. So the first one is void function.
Uh-huh.
And we have to do the scope operation now in the class. So it's going to be person, : and then our method name, which is set first name.
Okay, set first name.
Yep. And then we've taken an argument string, and we want to have a name for that variable that we come in as first name. Perfect.
Okay. And so, as we had discussed before with, we were kind of talking about namespaces and stuff, this method belongs to this class. So it's read from right to left. Or, this class contains this method.
Right.
But I like to read it backwards.
I like to read it forward because I'm not. I don't.
Because you're stupid.
I'm awesome. Okay. And so the only thing this is going to do is it's going to take that parameter and it's going to store it into our protected member.
Okay, so this will be...
So the protected one is the underscore one. So that's the underscore first name. And that's going to be equal to first name.
Okay.
So we just basically pass it right along into our protected, hidden little protected insides.
Because these protected members are not available to this code here, but they are available to this code here.
Makes sense, right?
Yep, absolutely.
It's cool.
All right, what's next?
The next, same thing, just the last name.
Okay,
so we're going to void person for the class name and scope in to set last name. We're going to pass it a string, and we'll call that a string last name. Why not? Makes sense. And then the protected last name is going to be equal to. So we can access that last name here. We can't access that last name in the driver.
Oh,
in our main function.
Okay, so before we go any further, Brian, let's try to set Davy Wavy's name.
Sweet.
All right?
So David dot set first name. That's it. You've accessed it. And we pass in Davy. Isn't that awesome?
Oh, that's really cool. Oh, man. It's that last name, W-A-V-I-E.
Right. So now I'm going to see this when we run it because we haven't done the getter yet. So we have nothing to give you.
And we're going to be changing this, Brian, to CPP. Yep. So
we have kind of a chain of command.
This little fella gets absorbed here.
Then the declaration of the methods and the implementation of them.
And then the driver code.
Yep.
So if we execute this
program... It's kind of a waterfall. You can kind of see how that's going.
We can compile and execute this sucker.
And it's happy.
It didn't visually do anything. But what it did, Brian...
is not blow up.
The instance of David calls set first name. Yep. Set first name is this method here. Set first name takes in a string. So this string right here is passed here. Our protected value underscore first name, which is here, gets set from this expression right here.
Let's throw our getters in there now.
Let's do it. Let's do it.
Just like the rest of them, we return a string, and then we got the scope operator backwards there, buddy guy.
That's true. I do.
Got a little freaky with your cheese whiz.
I did.
Okay, so person : Then
what about
scope
your
in. Colon blow in the morning. Return a protected one.
Oh.
So we're kind of granting access to that protected one, but in a very controlled way.
Oh.
And then we do the same thing for last name.
Get last name. Last name.
Cool.
Not bad, huh?
Let's go back to our driver, our main.
For those of you guys that are screaming at your computer screen, let me
raving mad like it's the 1 minute of hate.
Yeah, let me fix that. Okay.
Okay.
Cool, huh?
Now let's go to the main function. And we'll get these. So we can just dump this right out. Yeah, let's do it. So we'll just see out some M&Ms, no, some left arrows, some hungry alligators going to the right. So now we're gonna get the last name, and then a comma. So we're just gonna kind of keep piping it down the line.
Yep.
First name and line.
Brian. Cool. What is this gonna do?
I don't know.
Let's find out.
It's pretty cryptic code.
That's craziness. Oh,
nice.
Wavy Davy.
Awesome. All right, good job, guys. You've now successfully gone through and to find out the blueprints of a class, instantiated the class, even though it's all crazy. You know, you've made a person, named the person, used the name, whatever. So now you can have employee IDs, you can have arrays of people, you can do whatever you feel like it.
You can treat this like you would a string. You can make an array, like Brian said, if you want.
Array of people.
Yeah, right.
You can call the array people of persons. It's nuts.
You could also create a class to embed this class. So you could have like, I don't know, something where there's a person instance inside of that class.
Right, like an employee contains a person.
Yeah,
and then an employee has like an employee ID. It's crazy.
Gorgeous.
Anyway, see you guys. Thanks. Welcome to method overloading. This is an awesome concept.
Oh my goodness.
When you declare a method or a function, you'll have a function that takes in an argument. Well, if you also want to have that same function, but it takes in a different type of argument or different number of arguments, you don't want to have to keep declaring another function, another function, another function.
With like
slightly different names.
Yeah, like we've seen this where people will do like, you know, function 1, function 2, right, exactly. Function 3, but there's what? Method overloading prevents this from having to exist.
Yeah, so once we declare a method, we can overload that method and use it differently. This is very convenient. It really gives a lot of flexibility to how we design and stylize our class blueprints, because we really want to say append something. And that something can be an integer, it can be a character, it can be a string, and we want to handle all those different conditions. Mm-hmm. We want to, whatever. So
now that we know everything about classes, let's expand on some of the exciting concepts that surround them, Brian. Let's take a look at this header file. So we have created a new class for this tutorial, Brian. We're creating a class called number. Now this is going to store a private member or a private field called _number, and it's just going to be a double because it's kind of like a middle point for all numbers.
Yeah.
You know? And we're going to have a void method that sets an integer value, a void method that sets a double value, and a void method that sets a character value. All right? So these are all three different methods. They have different names and they perform different things. So those are our setters. Now we have getters. So we have integer value, which returns an integer, obviously, a double value, which returns a double, and a character value, which returns a character. Now, you can see that, this is cool that we have these three set, but what if we just had, like, one method that overloaded to do all this?
Yeah, why don't we just make it sexy?
Yeah, so take this code and we can apply it to this concept. Now, like we said before, members are private by default, so these two code files on left and right functionally are the exact same.
Just one declares private, one uses it by default.
Yeah, so if we go to the next slide here, we are taking a look at the implementation file. So this is what makes that header file work. So when we set the integer value, we're typecasting the integer that comes in as a parameter to a double. The same thing is when we set the double value, we don't have to typecast it because it is of that type. But when we send in a character, which is synonymous with an integer, it's just a positive integer. We just have a double typecast, and the same thing in return. When I return an integer, I typecast the double to an int. When I return a double, I return its native value. When I return a character, I typecast it to a char.
Pretty straightforward.
Very straightforward. Oh my goodness, haven't we seen this once before?
Know.
Wow, we're really driving it home. Yeah.
As we know, the number class is constructed out of a header file and an implementation file. Now we're going to look at the driver file that uses those. So we include number.cpp, so that makes a reference to the implementation file, and now our program contains the concept of the number. We will instantiate a number n Here it is in memory. Now we're just going to call n dot set integer value, and we'll pass it in 67, and we can print it out to the screen as a character. So we'll say cout, and then pipe to cout n dot char value, and that will return the character value of 67, which I think is lowercase a.
No, because 65 is capital A, so this is
C?
60. This will be capital C.
Or lowercase c.
No, it's capital.
Oh, yeah.
Yeah, because remember, capital is higher on the hierarchy
That's
than
right,
lowercase.
yeah.
So this is taking it an integer and returning it as a character. That's
cool.
kind of cool.
Yeah.
So let's take a look at using operator overloading. We're going to have 3 methods that have the exact same name. They could have multiple return types, and they could have multiple parameters. So we have method that has a param1 set, which could be the same, number but a different type, and then param2 and then param3. So let's take a look at how this is implemented within our code. Brian, how does this happen?
So we can have set value, set value, set value. They're all the same method names. And so long as we have differences in how we prototype this out. So, obviously we can't say set value int because there's no differentiation.
Absolutely.
But so long as there's at least some differentiation, we can do this many times over. So we can have a void set value int, a double, a char, or whatever we want to pass as the parameters. So this will really start collapsing the concept. So before we had set integer value, set double value. So now we're just going to set value. So it's really going to kind of streamline and make this blueprint nice. And here's how the implementation looks. We have number, : set value, integer, locally we use as value, and then this refers back to this object.
Yes, that is the open recursion that we discussed.
So that's the current instance of the object in which we're operating on.
Which is a pointer. That's
Yes.
why we're using the arrow.
And set integer value is called and passed in the value. The same thing with the double and the char, and that will then call and access those functions that have already implemented that functionality. So this kind of wraps on top of it.
Now, as we discussed just now, we are actually using open recursion. So this arrows are all the open recursion. Now, you may be wondering, we haven't discussed this. Why did we just throw this in here? Well, the main reason is a lot of languages require open recursion. C++ is not one of those languages, but it can use open recursion. In this case, if I want to call the set integer method within the current instance of my class, I can say this arrow and then the method name. But I can also just simply say the method name, and it does the exact same thing.
Yep.
So just be aware of this keyword, because we're going to be coming across that in other languages and even later on in C++ for certain things.
Here's an example of writing an actual program to use these concepts. And we're going to use the set value and the integer value, and doubles and the gets and the sets and whatever. So we've included number.cpp just like before. We've declared number n.
Ooh.
So now number n is in memory, and it will say n.setValue. And now this time we're not saying set integer value. We're just saying set value, just generically speaking. And we're passing in just an integer. And our program now is smart enough to know what to do with that integer and set it properly into that number double value. So this will go to the allocated instance. Calling set value will go to the implementation file by way of the header file. So you'll see it will look to the prototype void set value integer because it knows that we've passed it in an integer. That will jump it over to the implementation file where we have the number : set value, pass it integer. That will then call, in turn, set integer value, now that we know what type we're dealing with. That goes up to the top, calls set integer value, passes in integer, and it will store that into our private member _number, and typecast it as a double. So that's functionally what we're walking through when this happens, when we call set value. So behind the scenes, it takes a lot of work to be lazy. It's a lot of effort being lazy. But we want to be a nice, lazy, sexy programmer. So we want to have that generic set value, and this is how we go about doing it. It's really not bad. So now that double _number, that private member, is now set to 1.
Ooh.
Printed this out to the screen, and we can use the n.integer value and print it out as an integer value.
Yeah, but of course, if we did n.double, we would get the
double value of it.
And
right,
the
exactly.
.char, we would get a non-printable control character.
Exactly.
Yeah.
We'll do the same thing, and we'll pass it. We'll call set value again, or we're going to pass it 5.9201. And because of the decimal point, it will understand. The program will understand. The language understands that that's a double. So that will then get passed to the header. It realizes that we're passing a double as the parameter. That will go down, call set double value, jump up and store that in its native format to the underscore number private member. We print that out to the screen, and you see it prints out as 5.9201.
But if you did .integer, you would only get 5.
Yes.
And if you did .char value, you would only get another non-printable control character.
Exactly.
That's valued at 5. So in this case, we're going to set it using a character. Now in this case, C++ knows that when I send it a quote, that I'm sending it a character. So this will then naturally go to my overloaded method, set value, that's a character, and it will go to the set value overloaded method, which we'll call the set value that comes from the implementation code. And when we go back to the set character value, remember that when we look at our ASCII chart, the capital A is the integer 65.
Yeah, whatever.
So when we store the value as typecasted as a double, 65 is the actual value that's going to be stored.
Nice.
Yeah. So when we print the integer value, surprise, surprise, we get 65.
Very cool.
Wow.
And now when you think about blueprinting out a concept of a class, the concept of an object and how you want it to be designed and how you want it to be stylized, you can really start thinking also in terms of how you really want to streamline it, how you want to, any time that you create an object, you want to have a dot value, or you want to have a dot something, or a dot set value, or whatever that style is that you want, you can really streamline it and make it out to just be functionally the names of the methods only being the functions of which you need to operate on, which is a very cool concept.
Yeah, method overloading is used everywhere in software engineering, so get familiar and get very comfortable with this concept.
Yeah, get with the program, right?
Yeah.
Hey, buddy.
Hey, buddy.
Welcome to Programming in C++. In this video, we're going to talk about constructors and destructors.
Yes.
Yeah.
Constructors and destructors are an extremely important part of object-oriented development. So just to kind of recap, I know that we've already gone through this in the Introduction to OOP series, but just to kind of recap everything, the constructor is basically just a method that executes when an instance of an object is created.
Mm-hmm.
So when Brian is born, there is a constructor in his brain that does things like sets your birth date, sets your gender. I guess it happens when you're conceived, but gender, all that kind of stuff.
And sometimes that part of the program crashes.
Yes, as it did in your case.
Constructors can be overloaded so that you can pass in parameters, and you can, we'll get into it later. But it's basically a method with the same name of the class that executes when the class is instantiated.
It has no return type, but it must be publicly accessible.
Yeah, but we'll see. So
yes.
let's take a look.
Here's an example of a header template in C++.
So if you remember, we have the header and the implementation file.
Yes.
For the two halves of the class, just as a reminder.
Yeah.
And so this is the header template that kind of says we have a class called this, and then in the other file we have our implementation of that class.
There you go, Brian. Thank you for putting it in context.
Uh-huh.
So inside of our class declaration, we will have a method that has the same name as the class. And it can also be declared in the first line here as having no input parameters, and as the second one here shows, you can have one or more input parameters. So when you create an object or an instance of an object, you can have it create with these pieces of criteria that will give you a custom object in return.
It's pretty cool.
Yeah, it's pretty awesome. And here's an implementation template.
Yeah, so this is where we actually do the code to implement the method. So this is just like we would normally do a method in a class where we'd say that the get value, whatever. And just like we're used to, usually we have the class name and then the RSO and then the method name. In this case, because the constructor's method name is the same as the class name, it's really just class name : class name for that scope operator. So it's class name, and then your implementation. And if you want to pass parameters into it, you just do it just like you normally would define a method. So it's a method just like any other. The only difference is that this gets kicked off when you initialize an object, or when you instantiate an object, really, and it has the same name as the class. It has to have the same name as the class. That's how C++ knows that it's the constructor.
And the only one other thing that you didn't mention that's different is that there is no return type. So you don't see void class name, you don't see whatever class. It's just class name and then the scope operator and then the class name again.
Yep.
Here's an example of a real header file. So we're going back and we're grabbing that number.h, that number class that we've been building, and number.h we're going to create a constructor. Now this is just one constructor that has, 3 different overloads. There's a default constructor, which is the one that has no input parameters. Then we're also going to have other ones, one that accepts an integer, a double, and a character.
So you can see the class name is number, and the public method is also named number.
Yes.
And when you look at the implementation on the left, and this is the implementation file on the left, it would be, you see number, : number. So it's the class name, : class name again, which is the constructor method name. And so we'd have different implementations for different overloads of this method. So we have one where we pass in an integer value, and then we set that value, a double value, set that, and so on.
I mentioned this, but I didn't really kind of explain it, but there is, in most objects, when you do have a constructor that does not take parameters, that's kind of known as the default constructor.
Mm-hmm.
So in no other case, this is what will happen. In many classes, most classes will have a default instance within other overloads.
So now that we have our number class with a constructor, and it's all, flexible and awesome, and we can pass it like floats and numbers and whatever we want to instantiate it with, let's take a look at an example. So first we declare n1 is a number of type number, and we pass it into our constructor parameter 12.5. So what that basically is it's basically calling the constructor with the double value overload.
Right.
So this goes out and it defines the object number, and that goes down and calls the constructor of this type. And 12.5 kind of forces the type double. The system will know when you see a decimal in numbers, it will know to do it to a double value. And that calls set value. Set value is overloaded with all of the different types, integer, double, char, nothing. And that sets the value. So right off the bat, n1 without any other line of code starts off as 12.5.
Yep.
So now we're going to create another object, n2, but this is going to be a reference to. So this will be a pointer n2.
Right. So we're using dynamic memory methods here, but we're still calling the constructor in a similar way as we do in the first one.
And since it's dynamic memory, we say new number, just like we talked about before. And in this case, instead of using a double overload, we're going to overload it with a character value. So we're going to say new number, and then in our constructor parameter, we're going to say single quote A, single quote for character uppercase A. So this goes out and it calls number, class, number method, and passes the character value. So now we have two of them. So we have n1 and n2. Now, because our actual number that's stored in the number class is a double, 12.5 is stored as 12.5, but character A is stored as 65.0.
Yes.
Because A in an ASCII chart, uppercase A, is integer value 65 and stored as a double is 65.0. And that gives us the most flexibility. So when we want to go get a value, we can choose to get it as a character, as an integer, a float, whatever, and kind of down convert it back out. And also just as a side note to keep reminding you guys of this as often as possible, because n2 is a pointer, that's why we have the arrow referring to getting the double value to print it out. And also, because it's dynamic memory allocation, we have to delete n2.
Don't forget to delete your dynamic memory.
Yep.
I feel like my mother is like nagging me every time I do that when I write code.
Really?
Yeah.
I just think of Mr. T saying, "Wipe your ass, fool."
Nice. C++ constructors.
I'm done.
All right. Now, C++ constructors are not directly inherited. I mean, in a technical sense, they are. But if you want to call a specific constructor, you have to do some special coding to do it. And later on, we'll kind of go over this in depth, but I just wanted to mention to it at this point. When you do inherit from a class, the class constructor that is from the inheriting class does execute. But if you have multiple ones and you want to specify which one to execute, you have to pull it in a special way.
So, just an FYI.
Right. It's coming up. Destructors.
Yeah, so now let's look at the polar opposite of the constructor, which is the destructor. So if constructors are good, destructors are evil.
But they're not evil.
But they're both necessary.
They're not evil.
For the balance of the universe.
Because it cleans everything up. It's like nature. The destructors, like the constructor is man, making these big buildings, and then nature is making rain, wind, fire, and cleaning it out and making the earth pretty again.
Like Shiva?
Yes. Wait, you're talking about Shiva the goddess or Shiva our computer science professor?
Aren't they the same thing? She was kind of hot.
She was beautiful, yes.
Destructors, so destructor will execute when we destroy an instance.
Yes.
And it's it cleans up, and we can call the destructor, we can define the destructor method so that when we destroy our object, it kind of does some house cleaning and, whatever we want it to do. We decide how to implement a destructor, if we choose to. The difference with the constructor and a destructor in the way we name it is it's the same thing. It says it has a class name. It just begins with a tilde.
And there can only be one destructor.
See, I told you they're evil. They abide by the laws of the Sith.
It's funny, but if you read that sentence, you can only say that with an evil voice.
Yeah, exactly.
You can't say that with a nice voice.
I swear, Destructors are like Decepticons, and Constructors are like Autobots.
The class that we've been working on this lesson, the number class, doesn't use any dynamic memory. So the only variable that it stores behind the scenes is that double variable. And that's actually going to be naturally cleaned up by the garbage collector because it's not a dynamically allocated memory. It's actually created when the program first executes.
Right, it's just a primitive data type.
Right, but although primitive data types still can be dynamic memory executes during runtime, whereas the way that we define this, when the program first executes, it sets aside memory for that.
Sweet.
So there's really no point of us building a destructor for this class because it's not going to do anything.
But we'll do it anyway just to show you.
Well, we'll do it with a different class. Let's do this.
All right.
Watch this. Oh, sucker. We have now pulled in the name class that we worked with before, but this time we're going to change the constructor so that it does a malloc of 256 just to kind of create memory just there when you create the object instance.
So the name class basically just gets and sets a first and last name.
Yes.
And that's all it really does,
Yes.
just in essence.
But now we've also modified this to not only have the constructor create dynamic memory, but each time that I set the first name, I have to free it. Then I have to malloc it again with the size +1 that you sent, because you remember there has to be space for the null character, and then do a string copy, and that happens for both the first and the last name. So, you can see this is going to require a destructor because we're using dynamic memory. This code needs a destructor because we're requiring dynamic memory.
Just like you just said. Anyway, so when that instance is destroyed, the data... It's like you're psychic.
No, it's
like you've read this before.
It's like I've seen these slides before. I don't know. I'm crazy.
Deja vu. So when the instance is destroyed, we have to destroy the data too. Otherwise, we'll have memory leaks. If we keep constructing this class and we never destroy that memory allocation, then we're just going to have runaway and just keep allocating and allocating memory and never letting it go. We'll have memory leak. Who wants that?
So now let's add the destructor.
Nice. So as you can see, it has the same name as, class name. The constructor is just name, paren. Now in the destructor's case, we have the tilde name.
Yes.
And that's the only difference.
And we're calling the freebird function to allow the bird to flutter free.
Exactly.
Here's a full code example that makes use of the class that we just looked at. We're going to create a instance of name called myname using dynamic memory. And of course, at the end, we're going to delete it. We're also going to set these values, which you remember is going to be using alloc or malloc and free to do this. So let's say I execute this program and just pass Bill Mill, who we all remember from the C programming videos, right?
Of course.
We were talking about C strings and...
Bill Mill.
Okay, I guess nobody cares. So we're going to take the H file, the CPP file, and that gives us the little bubble that represents the name object. We're going to go out and we're going to say name, give me an instance, and the instance is going to have two char stars, and at first they equal nothing, but when the constructor is called, they're going to just equal something. It's going to have 256 bytes set aside for each value, and they just equal something, and now we assign it a value name, so that's how we can refer to this. When we want to set the first name, and this is coming in from the char star argument list, the first thing that happens is the first name pointer is freed. Then we reset the value. Then we do the same thing here. We free it and we reset it. And that's just because we're working with dynamic memory and we're trying to avoid having a memory leak. Then we come down here and we get the value. So we pull the value in and we print it. We pull the value in, we print it. Now we call delete, and this will actually also execute the destructor. But this is just a way for me to manually force the execution of the destructor. And what delete's going to do is it's going to free those two char stars, and it's going to remove those from memory. Then it's going to then start destroying our object, which is what the default portion of the constructor does by nature. It destroys the current instance itself, and then it's gone, and it's like nothing ever happened.
And there's balance in the universe once more.
Yes, the destructor has done its job.
So I hope you enjoyed that. It's extremely useful to be able to overload the constructors and deconstructors and just to be able to define what they do.
Yep.
So I'm sure before you know it, as you get into programming in C++, you're going to inevitably run into, sooner than you think, a situation where you're like, oh, I can overload the constructor and do that.
Absolutely.
It's pretty cool.
All right, cool. I don't know how this happened, but I'm right next to you. Why did I slide all the way over here during that?
I put cologne on this
You
morning.
must have. You must smell really good. I'm like...
Welcome to virtual and friendly functions. So we're going to talk about how to really. This is a strange concept. It's a concept that we had some struggle explaining, but we're gonna make it real here, just like we are in this C++ run of things. We'll see that it's pretty straightforward and and a practical example of why you would use a friendly function, what virtual methods are for.
Yep,
It'll be good.
absolutely.
Let's take a look.
Polymorphism.
That's the word of the day.
That's the word that there are many things that C++ uses to create the ecosystem of polymorphism, which is kind of like gravity in our universe. It's a thing that binds everything together. Mm-hmm. And virtual functions and friendly functions are very important in creating that environment. Now, let's just kind of recap. Now, we've spoken about virtual functions already. So if we have a little class here that has a function, and the function is called red, and let's just say I don't want the function to be red, I want it to be gray, I can actually go, you are now this function and you've been overridden. That's kind of what a virtual function is. It allows itself to be changed. Now, let's really quick just kind of clarify, Brian, what is method overloading and compared to method overriding?
When we have a method and it can take in an argument, a string, and then an integer, and we want to be able to pass it a string and a double, we can overload the method and make a definition where we take in a string and a double this time. So overloading gives us the ability to have a whole series of options of different types of sets of input parameters that in which we could deal with our method. Method overriding, on the other hand, is actually swapping out a method and its parameter setup with another one. So if the method is defined that takes in an integer, and we want to change the way that method handles taking in the integer, we define another one that also takes an integer, and we override that method.
Now, this functionality sounds suspiciously like another concept we talked about before, and we want to just kind of throw it out right now that virtual functions and delegates are not the same thing at all. As you guys recall from the remote control car example, we had a person that was inflicting its will on another object, which was the remote control car, using a delegate of a remote controller. In this case, a virtual function would be as if the engine in the remote control car was pulled out and replaced with another engine. So it's not like I'm running code from the person in the car. I'm actually swapping something out in the car.
Right.
Ooh. Remember this one, Brian?
Yeah.
Doesn't this bring back warm fuzzies?
So this is just to recap on virtual functions and polymorphism. We had the concept of WiBit friend, and that WiBit friend could become a frog, a fly, or a chick, but they're all still essentially WiBit friends.
Yep. They're all inheriting from the WiBit friend.
Yep. And the make noise is the virtual function.
Right. It's the method that all of them inherit. But all of them must be different because a frog is not going to say the same thing as a fly. A fly is not going to say the same thing as a chick.
That would be ridiculous.
Yes. Wouldn't that be weird if flies are going bzz, wabbit and flying away? Wouldn't that just freak you out? No?
Yeah, maybe.
That would dude, if a frog was talking, that would freak me out. Here's a WiBit friend. That bubble WiBit friend that we were just looking at, this is it. This is what we've been talking about this whole time. We have a private member, which is going to be the name. We have a constructor that takes in a string. And we have a destructor. Now, the name is a pointer, so obviously the destructor is going to be used to destroy that dynamic memory. We have a getter for get first name. We can't set the first name, if you notice that.
Yeah.
That has to be set during instantiation. Now we have a virtual string make noise method.
Interesting.
So when I want to make a virtual function or a virtual method, I just use the word virtual in front of it. That means that this can be replaced.
Very cool. And in the implementation, we see that the make noise method, by default, with nothing overloading, just the WiBit friend definition.
Yep.
Before it's defined as a frog or a chick or anything else, just as a WiBit friend, returns blah.
Yep. So a regular, boring WiBit friend.
It's just blah.
Like Brian. He just wakes up and he goes, blah.
Today's going to be just like any other day.
You can also see that we have a constructor that creates a new instance of a string, the destructor that deletes that, and then the get name, which returns the value of the string.
Yep.
Let's take a look at this driver, Brian. The driver! We're going to create an instance of WiBit friend, and we're going to call it my friend. And we're going to create this using dynamic memory management, and we're going to send it the constructor, my friend. So the WiBit friend's name is my friend. Now, when this code executes, it will just say, my friend says, and then in quotes, it will say, blah. Kind of boring, huh?
Yep, and then we delete my friend.
And we just delete it. Gone.
So simple.
Like it never even happened. But wait a minute now. Now we're going to create a frog.
This is another example of class inheritance. We have class frog that inherits from, that colon, the public WiBit friend.
Ooh.
So now we're turning WiBit friend into a frog, and the frog has a constructor that takes a string, and we have a make noise method. Now that's interesting.
Very interesting. Very interesting.
Now we already have make noise with no parameter
when we
declared.
Inherit WiBit friend, we have
interesting.
Wait a second. Could this possibly be overriding the make noise method? I don't know. Let's find out. Okay, yes it is. As you recall in the first line here, we're explicitly calling the WiBit friend constructor. So we're saying when we create a frog and we pass it a name, call the WiBit friend constructor, so we don't have to rewrite that. And we override the make noise method.
That's awesome.
So now instead of saying blah, the frog is going to say WiBit.
And if you'll notice, since in the WiBit friend class, we already defined that method as being virtual.
Yes.
We don't really have to make any other denotation in this implementation here. We just simply define the method.
Yep.
And because it's virtual, it allows us to do that. We don't have to say we're overloading anything else, we're overriding anything else, I'm sorry. We just do it. So now the frog will say WiBit.
Perfect. Perfect. Here's an example where we created a WiBit friend and a frog. So here we're going to create my friend as WiBit friend and WiBit the frog as frog. And when we call this, or when we execute this program, it will say my friend, and then in quotes, or says in quotes, blah. And then it will say my friend WiBit the frog says WiBit. And as you can see, we're calling the same method, but it's producing two completely different outcomes.
Right. Polymorphism, as we keep pushing on, is simply the language's ability to allow different data types to be used as another type and kind of be interchangeably interactive with each other. Virtual functions are a huge part of this ability for C++ to implement polymorphism. Mm-hmm. In this example, we have two different instances that respond to the same method and perform different tasks. So the frog makes noise, WiBit friend makes noise. They perform different tasks, but they're the same methods.
Now, even though we did showcase that polymorphism, a really big part of polymorphism is dynamic binding, which is determining data types during runtime. Now, you saw we specifically made a frog, and we specifically made a WiBit friend.
So to make use of inheritance and virtual functions, so that we can build an environment that's not restricted to data types, we'll use dynamic binding. Let's take a look at an example.
Oh my goodness. What do we have here, Brian?
This is very similar to the other example where we create a my friend that's a WiBit friend. But in this case, when we create a new frog, we still include frog. We still have the definition of a frog, but that's being stored. That frog is being constructed and stored as a WiBit friend.
Oh my goodness.
Object.
Now, why is that possible?
Because the frog inherited from WiBit friend. So everything that a frog contains is at least equal to a WiBit friend.
Beautiful. So the dynamic binding in this case is the print friend function. So Brian, explain how dynamic binding applies in this situation.
Right. So at the top we have void print friend, and we pass in a WiBit friend, my buddy. All this effectively does is just print out the name and the noise it makes, just like in our other example. Mm-hmm. This just takes a WiBit friend. When we create my frog, it's considered to be a WiBit friend. And when that gets passed to print friend will call make noise. But make noise was overridden in the frog so that it would make a noise WiBit instead of blah. So calling exactly the same function, interacting with it just like we would using WiBit friend in the function definition print friend, when we say my buddy, arrow, make noise, one is implemented in a frog definition, one is implemented in a WiBit friend definition, but the function doesn't know the difference.
The function doesn't care.
No, it doesn't.
Beautiful.
It's great, because that instance has still effectively been constructed with the functionality of the frog.
And that is a real live case of dynamic binding. How beautiful is that?
It's great.
Yes. Friendly function, Brian, tonight on Dateline.
Friendly function, just as a recap, is an external function. It's somebody that you declare to be a friend of yours that can have access to your privates. And that's specifically defined within a class.
Yep.
Let's take a look at the header for defining a class.
So is this your neighbor right here?
This class definition has a public declaration of a function, and out in front it says that this function is a friend function.
Oh, cute.
Yes. Let's take a look at an actual class header. Here is class real number. Real number has a numerator and a denominator as private variables. There's a constructor that takes no arguments. There's a constructor that takes two integers, the numerator and the denominator. And then we have a friend real number copy, and it takes in a real number. So that's declared as a friend function. And we have a double
So it just
method that
it
just
returns
takes
a real
nothing,
number.
right.
Because remember, a real number is two integers, a numerator and denominator, and the value of a real number is not necessarily
So stick
a
them
whole
together,
number. Yeah.
send them back out to you.
In the implementation, we don't really have to specify anything for that friend function at all, because it's just a function that we're allowing access to our privates, which is our numerator and our denominator. So all we're doing in the implementation is just proceed as if we never did that.
Right.
We make the constructor, the default constructor, which makes 0 over 0, which is actually bad because if we divide 0 over 0, we get a... But, let's just pretend like we have a better example and we check for that. But
And now we'll take a look at the driver. In the beginning of the driver, we declare real number copy as a function, and it returns a real number. And all that effectively does is return a new and construct real number, passing it in the numerator and the denominator of the number that we took in.
Now, remember the numerator and denominator were private.
Right.
But this function can access it as if it was just a regular member.
If we tried to access the underscore numerator or the underscore denominator just in the main function, we wouldn't have access to it. The main function wouldn't even understand that those exist.
Mm-hmm.
But since we're doing it in copy, and we declared copy to be a friend function, it allows us to have access to those.
Now, you can also embed friendly functions inside other classes.
Mm-hmm.
But just to kind of save you the lecture of us having 9 more slides of us building another class, we just figured this is a simpler example to showcase. And just to kind of show you, there is no way for us to extract just the numerator and the denominator. So in order for us to make a direct copy, the only way I can pull that information out is through some way of accessing the private members. So this is actually a somewhat practical way of using a friendly function.
Yeah, very to the point.
Now you remember this, Brian. What did we say before?
That you can overload cout and cin, but it's a little trickier than
little tricks.
Yeah, it's a little strange.
You have to have your creepy neighbor friend help you out with overloading these operators. If we were to use the real number class that we're using in this lesson, and we tried to do coutn, what would happen? Boom! No match for operator blah. Oh, man. Okay. Well, when I coutn, I want it to print out that real number value.
That would be awesome.
That would be so cool.
Yeah.
I mean, that would... Wow.
When cout calls something, it needs something to be implemented to tell it, I want to return this. Just like we talked about before when we compare a cookie with a cupcake and it compares on sugar, or if we go to print cookie, it prints out the sugar value. We have to decide when we create these types of objects, we have to decide what gets printed and why and when.
Now, as we discussed before in one of the first videos when we were talking about basic I.O., we said that cout was an instance that was created from the OStream class, right? So in this case, what we're doing is we're going to be sending out an OStream and passing that to cout. How cool is that?
That's awesome.
Yeah, it's beautiful. So if I want to overload cout, I created an OStream and then a pointer operator and then my 2 less than signs. When we're creating this function, we're going to be returning an OStream type. Then we're going to be declaring AND operator and then our operator that we're overloading, which in this case, we're overloading the 2 less than symbols. We're going to be pulling in an OStream and then pulling in an instance of the class that we're using. Now, the instance of the class in this case that we're going to be using is going to be that instance of N that we had in that last example. And the stream that we're pulling in is the cout stream that we're currently using. And then when we want to pipe to that stream, we just call stream. In this case, down here we have stream and then the operator out, less than, and then what we want to go out to that stream. How slick is that?
That's awesome.
So now if we want to just implant that code, Brian, if we want to overload cout, we need to create a friend function.
Oh.
Yes. So this friendly function here is going to, we're just using std because we're not using namespace std. So that way we have access to OStream and operator, less than, std OStream, which is the actual cout instance. How cool is that? And then a real number instance.
That's awesome.
Yeah. So hit the next one, Brian. Boom. We just throw that right into the header.
Nice. So now we're effectively taking real number in and being able to work on that against the OStream.
Yes, and remember, this is being declared as a friend function. You'll see why in just a second.
When we define the implementation, we call the standard namespace OStream just like we did in the header, the operator that we're overloading, the parameters we're passing, and it's just what we want to print to cout and pipe it to the stream. And in this case, we want to show, anytime we print it out, we want to show the numerator over the denominator. So we literally take n dot numerator, and because it's of an integer type, that will already convert itself to a string of that integer representation. Less and less than, in a string format, the /, and then the n denominator. It'll concatenate all those and push them all out to stream.
Yes.
And that's our implementation of this operator. So that's what actually makes it function. That's what that we can decide we want these things to be printed out. We can be evil genius about it and show numerator +5 and confuse everybody. We can, so you have to be really careful how you show this and why you want to show what you show.
Now, the reason why we have to declare this as a friendly function is because we are not able to declare this as part of our class. This has to be declared globally. As you can see, there is no real number : blah, blah, blah. That syntactically will not work here. So by defining this as global, and this is why it's a little tricky because the other operators were able to build inside of our class, by declaring this as global and having it called friendly, I can then access whatever private members inside of the instance of the class that I'm working with as I want.
That's awesome.
So that's the reason why we saved this for friendly functions and did not discuss this during operator overloading, because in order to really make best use of this, it's best to have an understanding of friend functions. Now, Brian! Now what's gonna happen?
It will actually run.
Will it? Let's see.
Yeah.
Oh, baby! And remember, the 12 and the other number are private. So we're pulling it privately.
Why is the implementation outside the scope of our real number class? Well, it takes place not in our class, but it takes place really in the OStream class. And that's why it's declared globally, because we want to declare this and implement this so that it's overloading something from std : OStream. It's not something we're overloading in our class. Our class is simply declaring it, making a friend reference to it. But when we implement it, we're not implementing it within the scope of our class. We're implementing it within the scope of something that has access to, std and that whole namespace and anything else that we would want.
It's not necessary to declare this with a friend function, but when you see this code, you're most likely going to see it implemented this way. And it also gives you a lot more power, a lot more freedom.
Yeah. A lot more freedom to...
Because freedom isn't free.
Unless it's free.
Yes.
Now let's overload CN.
Oh, this looks so different.
Yeah, right. Oh, my God. So this is essentially the same, but instead of OStream, it's iStream. And operator greater than, and the stream goes to greater than. So it's exactly the same way we did it before, but now we're doing CN. It's great. Here's an example of it. We already have our friend function definition where we say friend std stream, the operator, and so on. And now in this case, we're going to do just the same. We're going to say friend std stream and the greater.
Ah.
And in the implementation down below, as you see, we use stream just in the same way, but in this case, we do the pipes away from stream into. So stream is feeding into n.numerator, n.denominator. So when we call driver.exe, it'll execute and it'll prompt for CN. We say 10 and 50.
10 space 50.
And I'll pipe those in, and then we'll print those out, and that's what we get.
How gorgeous is that?
Yeah, that's smooth.
And by overloading these operators, you guys, this doesn't only count for CN and Cout. This is for any stream you can do this to. How beautiful is that?
Just whatever you do, make sure that your friend functions don't cross the streams.
Yes.
That's extremely important.
So now we can actually see how polymorphism in C++ works. So that scary word that computer science professors didn't want you to know is now coming to life right before your very eyes.
And it's these types of things that make the difference from your class being useful to being sexy.
Oh, yeah.
It takes your class to a whole other level.
Absolutely. Beautiful.
Make it sexy.
Make it sexy. Hey guys, welcome to the String Lab.
Yeah.
What we're going to be doing in this lab is, you guys are familiar with the string class. We've discussed that at length in the string video, and we've also been using them in some examples. Well, what we're going to do in this lab is we're going to make our own string class so that you can kind of learn, why the string class came about, why it's so useful, how it was built, and ways that you can improve on that concept for your own programs.
Exactly. A lot of the functionality in the string class that you use, which is just it seems like a data type.
Right.
But it's really a string class,
right?
Not exactly a data type.
Right. And I know that when I first first started writing code, I really didn't understand that concept.
Right.
That it was its own class.
And all of the functionality, like the string length and things like that, those are just methods in the class that give you that functionality. And some people in the 70s, when they were working on C++, some big mustache Burt Reynolds fellas, wrote all of those functions and methods.
Do you think they had a Suzanne Summers poster when they wrote this?
Probably. Holding a machine gun with an American flag bathing suit.
Nice.
A lot of blush.
Yes, a lot of blush. Curly, frilly, fluffy hair. And like the man perms that the guys had.
Just shooting that machine gun in slow motion with the
boobs all jiggling. Yeah. Nice.
That's how it goes.
Very cool.
While smoking a cigar.
Yes.
So we're going to be exploring kind of our own version of the string class, just for the sake of kind of getting into the mentality of we can get this language to do whatever we want.
Right. Now, we're not going to be doing everything. We're not going to do stuff like substring. We're just going to do what we think are kind of like a basic framework for a string class, and then you can kind of build on that for your own knowledge and your own purposes to just use your own imagination. What do I want my string class to do?
And so if like speed and efficiency is important to you, take this as a springboard and improve on the algorithms and make it faster, make it lighter weight, make it more robust for what you want to do it.
Make it sexier.
Yeah.
All right.
Absolutely.
So when designing our string class, Brian, obviously, since we've been writing objects already, we're going to be starting with the header file, right?
Yep.
So we're going to define our class before we write our class. So let's go ahead and let's save onto our desktop C++ awesomeness. We'll call this wstring.h, and we'll just kind of define class wstring.
Nice.
And that's for WiBit string, for those of you guys that are wondering at home.
Or way better string than anything you've ever seen before.
Way better string. Okay, so now we're going to define our private and our pubic, our public members. So let's get a quick overview, Brian, of a few of the private members, starting with some fields.
The C++ comes with the character data type as a primitive.
Or C does, right. And C++ piggybacks on it,
exactly.
Right?
So our core data type, our primitive that this will be built on, is going to be a char star.
Right.
And that's going to be our internal string.
Right. So it's a character array, but we're going to be using dynamic memory to mimic this.
Yes.
So the W string is basically encapsulating a char star. Simple, right?
Yep.
So this is going to be the actual string we're going to be storing. And since the naming convention that we've been discussing this whole time that we're going to stick to is the underscore, means it's just going to be globally accessible. Okay, Brian, what else do we got?
We also want to know if this value's been set or not.
Right, like if the constructor's been executed.
Exactly.
Yeah. Because there are going to be situations where we're going to be setting the value of the string where the constructor is not necessarily called. And we want to protect our program from crashing in that circumstance. So you're going to see how we use this in a little bit. So we'll just call this value set.
And you might be asking yourself, well, why wouldn't we just have a Boolean set to true or false? We'll discuss this later. Where it's going to be an integer data type for a couple of reasons.
Well, we can discuss it right now. I mean, what's going to happen, Brian, when we first execute this program? What is value set going to equal?
Whatever it happens to be pointing to.
Right, just some numerical value, whatever that memory space is valued as. And this won't equal null because by default, we're just going to be pointing at memory space, right?
Some memory space.
So what we want to do is we want to protect the situation where we don't have control over what the string value is set as. And the way that we can do that is we're going to be setting this value to a very specific value in the integer number range that the probability of it being randomly that number is
not going to happen.
Probable enough that we can uniquely identify when the constructors have been ran.
If this was set to a Boolean true or false, and that Boolean variable is just pointing at some memory space, that memory space may be accidentally interpreted as true or false. We don't know.
Yeah, we have less control. It's a 1 in 2 chance.
Yeah, and this is all assuming that the constructor fails for some freaky reason.
Right.
So,
it's circumvented, which we'll see how that works in a little bit. So we have a pair of methods that we're going to be defining. What are those?
We want to be able to copy the string so that it's not just another reference to the same memory space.
Okay.
We want to be able to actually make a copy of it, establish a new memory space, and create a new
So we're going to be taking in a character pointer or a character array, whatever.
Right. So that'll be the destination, and then we'll be reading in constants, or basically read only char star.
Source and destination.
Yep.
Excellent. Just like the string strcpy and string.h kind of, but this is just our own flavor of it.
So we want to be able to copy. We also want to be able to delete the string. So basic copy delete functionality.
Right.
That's also a void data type.
Good call.
Doesn't return anything.
All right, Brian, let's start defining our public members, starting with the constructors.
Okay. So we're going to have some constructors and some deconstructors.
Okay.
And the first is going to be our default constructor, which takes no parameters.
Okay.
Then we have our constructor that takes in a constant character pointer.
That way we can do from C++, we can say, you know, this create the string W string quote something end quote.
Right.
Like
double quotes.
Right.
Yep. And we also want to be able to create one with the passing another W string in the constructor.
Right. Now this is a special circumstance, Brian. What is this specific circumstance called? Because
we're passing our own data type as a parameter into the constructor. We're actually going to be using something called the copy constructor. And we'll just make a note of that. And you'll see that the implementation looks a little different.
Did I spell constructor right?
Yeah. That's
okay. Yeah, and we'll get to that in a little bit. So
we also have a deconstructor.
Deconstructor, which
also known as a wobbly constructor.
Which for those of you guys that may be thinking ahead, you can see that we're going to be using this character pointer array or character array char star. This is going to be dynamic, so our constructor is basically going to destruct this memory when the class is being killed.
Absolutely.
Yeah.
Okay, so we're going to march through some setters real quick.
Okay. So what kind of setters are we going to do, Brian?
Just set string, append, and clear.
Okay.
So the first is set string.
Okay.
And there's going to be two overloads for it.
Okay.
The first one is constant char star.
Right.
And the other one is a W string.
Okay, great. So void set string, and this is going to be a W string reference, right?
Absolutely.
Okay.
Yep. And then the next one is going to be append.
Okay.
And
Vody? Wow.
Voidenoid. The first one's going to be just a character, so we can append just a character if we want to.
Yeah.
Then we're going to have a constant char star.
Okay.
And then we'll have a W string reference.
Okay, great.
Lastly, for the setters, will be clear. And clear doesn't seem like it would be a setter, but we're actually setting the string to nothing. So it is a setter. Yeah, so in the context that we're using for setters, they're all going to be returning void because these are affecting the current value of the encapsulated string. Right. Yep. So we also have other types of setters, but they're not really in the same class as these types of setters. So what do we got next? All right. So logically, the next thing we would do are getters. Okay. Now there's also a few different types of getters that we're going to be getting, right? So first we'll do the getters that are on the class level, the static getters first. Right. Now these getters are for getting information about the string. No, so we're not actually getting the string itself, but information about the string. Or about a string, not necessarily the string. So these are going to be static getters first. All right. Static getters. Okay, static getters. What do we got, Brian? The first one is going to be the static. Actually, they're both just going to be the same thing, the length. Okay. Static int length. Okay. We could do some other ones, but we'll just let you do that on your own. Okay. It's going to be constant char star and a W string reference. Okay. Now, what this is basically saying we could do WiBit string : : length and then pass it a string. Right. And then it will return us the length of that string. Very nice. Exactly. Just to kind of show an example of that class level functionality. Right. And when you get into Java, you're going to see this kind of stuff an awful lot. Yep. So some of you guys may think this is dumb, but you know what? You're dumb. Right. All right, Brian. Now, I think that we also want to do an instance level length, right? Yes. To get the length of this specific string. So let's do instance getters. Okay. So this is going to be instance getters. Okay. And the first one is string just length, and the next one will be get at, and this will take in an index integer, and it will return a character. Okay. Get at. And this is going to take in an index. Yep. Right. So this is like if you're treating the string as if it's an array. Yep. Get at this value. Excellent. Get at position blah and return the character. Cool. The next one will be equals evaluative. Okay. So it returns a boolean equals, and then we're going to do a comparison to a constant char star first. Okay. And then we'll do a comparison to equals W string. Nice. Our normal, So you can see we have this overload here, and a little bit of foreshadowing, Brian. What else can we use these methods for? Probably the equal symbol. Yeah, a little operator overloading action going on here, huh? The last one is going to be isSet, and that also returns a boolean. Okay, what is isSet going to do? Well, it's going to determine whether or not our internal primitive data is set or not. And we're going to be basing that on this value, which we'll be discussing in a little while. So this if it is set, that means the constructor had succeeded successfully.
Right.
Completed successfully.
So the next class of getters that we're going to be getting are ones that are going to be returning a string of some kind. Right.
So we'll call these string getters.
Okay. So let's talk about these, Brian. What do we got?
So the first one is going to return a constant char star.
Okay.
And that's going to be C string. So this is going to return just the char star. It's going to get you access to a copy of that basically.
Right, but it's going to return it as a constant, so you can't with it.
Right. Exactly. The next thing is going to be copy, and it's going to return a W string.
Okay.
And that just returns a copy of the string.
The copy of this instance.
Correct. Right. Yeah. So you're not pointing at the same memory space. The next one will return. The rest of them from here on out are all going to return the W string, and this is going to be concat.
Okay.
It'll take in a constant char star. Okay. And then we also have an overload for that for the W string as well. And that basically just takes in a string and it'll apply it to our internal string.
Right.
It'll just concat to the end.
But this, no. This is going to return. A pen does what you said.
Oh, yeah, sorry.
This is going to it's going to do the same thing as a pen, but it's going to return you a new instance.
Exactly.
Right? So concat is kind of like, I don't know, the plus operator maybe? I don't know. Yep. We'll kind of have to see how that shakes out later. What do we got next, Brian?
2 upper and 2 lower.
Ah, excellent.
So this will return a W string version of our current one in an uppercase format or a lowercase format.
And I'm assuming that we're going to have a lower as well. Right.
The next one is chomp.
Cool.
You all know what chomp is. Chomp is where it will return the same version of the W string minus any type of like new line characters at the end.
All excessive new lines from the end are removed. Correct.
Then the next we have trim right. One that takes a character, and the other that takes no parameters, assuming space to be the default trim character.
Yes, which is pretty common. Pretty common. So obviously, if we're going to have a trim right, we're going to have a trim left.
And we're also going to have just a trim.
All right, so this is going to be an overload that doesn't take anything. Yep. And then we're going to have a trim left that doesn't take anything. And then I guess, Brian,
we'll just have a trim
that does left and right.
Oh, yeah.
Not too shabby.
And one that takes a character as well.
You are correct, sir. That's what I get for falling asleep.
You're correct for $500. Okay, cool. All right, so that is all of the getters and setters that we wanted to do, at least to kind of get a string class started. Now we want to get into the fun part, which is the operator overloads. This is where we will take advantage of the methods that we've just declared above and implement them in more integrated ways with the language.
And we're going to start by implementing some friendly things, correct?
Yeah, we're gonna set up some friends.
So we're going to have some ability to touch our privates. And Brian, what is the first operator that you want to overload?
Insertion and then outsertion.
Nice.
So the insertion this is the outsertion. We'll do OStream first.
So this is going to be OStream.
Yep.
And this is going to be a reference, right?
Reference to operator left arrow, left arrow. Standard OStream is the first parameter, and the next one will be a W string.
Okay. So.
Okay. And then basically the same thing, but for iStream and a different operator.
Okay. So
this will be our insertion.
iStream and iStream. Ice cream, what? And then that. Okay.
Awesome, perfect.
Nice.
Cool. So that gives us, C out, arrow, and then just put in our W string, and it's good to go.
All right. Now we can also pipe the files.
Oh yeah, anything we want.
All that kind of, because that's going to be, that comes from the IO stream header. So we're just going to be leveraging that functionality in our class.
Now the next one we want to do is, when you have an array and you can do the bracket, and then inside the bracket there's the number. Let's overload those brackets. So that's going to return a character, because inside the brackets we're going to pass an integer. So operator is bracket, and it takes an integer. Right,
awesome. so we can just reference that index.
Yep.
Cool.
And then we want to do the equals. So this will be the setter. Returns void. It's equal, constant char star, and W string. Okay, so we're going to have one equal, so we can set our string equal to that. Nice. We can also set our string equal to this. That way we can say this equals that, and it's done. Yeah. Next we want equality. Equal, and not equal. Now, I'm going to make an assumption here, Brian, that triple equal is going to be the same, right? Yep, it's just that it returns a bool instead. Right. It's so cool that returns a bool. And then it's going to be the same thing, but not equals. Cool. We're cruising. I see what you got going here. All right, so then we got our not equal happening here. Yep. Excellent. Okay, now let's do the plus operator. So the plus operator will return a W string. Of course. And it will take in either a W string or a char star. Right, so we got the operator plus constant char star. And then we also want to overload this to accept a W string. Absolutely. Nice. Easy.
W
Easy
string
peasy,
reference.
1, 2, 3, easy.
Okay, cool. What
Okay,
else?
and then the last one is we want to append with the plus equals.
Right.
So this will be a void because it's a setter. Operator plus equal.
Yep, operator plus equal.
And we'll take in a constant char star, and then we can do just a character.
Right. So we can do, because we have the character append, right?
Yep.
So why not leverage?
Absolutely.
Why not leverage the functionality there?
And then let's do W string.
Okay. I keep hitting funky keys, man. After we make our sticky keys website, we got to make funky keys. There we go. All right, got a little lag going here. All right,
W string.
like this.
All right. And
So-
that
I was gonna say, finish. You're probably gonna say exactly what I'm gonna say.
that concludes our header. So now that basically lays out the blueprint of how we want to structure this class.
Right.
Now all we have to do is make our implementation file, our .cpp file.
Let's just make sure first, Brian, before we cut this video out, that we don't have any syntax errors in the header file.
Okay.
So one way we can do that is we can make a W string driver.
Absolutely.
And I'll just kind of do a preliminary outline here where we do an if not defined WiBit
W
string class, whatever.
That's fine.
Make it more unique.
Yeah, that's cool. Less likely to be.
Yeah. If not defined, then we'll go ahead and define this. And if that should be that.
Yep. So we'll include WiBit.h. WString.h, I mean.
Okay, so then we'll just go over here and we'll do include iostream.h, include wstring.cpp.
And then use namespace standard.
There we go. And we can do a good old-fashioned int main, return 0 w string. Well, actually, I don't know if we can create an instance.
No,
we should,
but at least we can include it.
we should be able to compile.
Check
Syntax errors. Okay, so let's go to here. We have our desktop, C++ awesomeness, G++, and it's going to be w string driver -o wstring driver.exe iostream.a. Oh, I'm stupid. Let me get rid of the .h. G++ doesn't like that.
Cool.
And so far, syntactically, we're in good shape.
Nice.
All right, guys. Now we're going to start taking a look at creating the driver code. So while I start
And
setting
the implementation.
yes, implementation. What?
Hey, implementation.
All right, I'm going to start by just kind of coming to my .h file and selecting everything. I guess first I'll kind of do these, the public, and in between these two, I'm going to just paste everything, and
then also those two private.
yeah, we'll get to them. So with these. With the constructors, we're going to be doing, we're going to be scoping in by doing it this way.
So everything will be scoped in, basically.
Right. So we're going to scope that in. We're going to scope that in. We're going to scope that in. It's a little different with the setters because with the setters, I need to have my return type. So it's going to be return type W string. Actually, I think I could just paste what I have on the clipboard. So void, I can scope that in. Here we go. We can scope that in. We can scope that in. Not twice, of course.
Okay, so right now Kevin just got into a time warp booth, and he is typing this at hyperspeed, and just basically reconfiguring the how we set up and laid out the header, but as the infrastructure for our implementation. That way we don't forget any methods that we may have declared, and just didn't implement one. So this kind of also gives us a to-do checklist to make sure that we finish everything.
Mm-hmm.
So at this point, until all of these things are addressed, this program won't compile.
I got to be breaking some kind of a speed record here. I mean, for crying out loud, I mean, what do you think that the human words per minute record is?
Not this many.
Not this many. That's for damn sure. Now, you may wonder, Brian, after we went through that whole fun deal, we still have our little semicolons and stuff, but you know what? We're just going to leave it like that. The ones that have the semicolons are the ones that we know we haven't worked on yet. So, okay.
Exactly.
So let's kind of start, actually, you know what, Brian? I forgot I have Dos Mas up here.
Yep.
What we're going to do, guys, is Brian's going to start popping through some of this code, and what we're going to do is a lot of these are going to be calling other methods inside of the class. So what we're going to do is we're going to try to define all of the methods that I guess what I would call the lowest common denominator.
Have no
methods.
other dependent functions.
Yep, no dependencies, correct. So, where do we start?
The default constructor.
Okay. Default constructor, which is this fella right here.
Yep. The default constructor is going to do 3 simple things. First, it will establish a new memory space for string.
Okay.
So string is going to be equal to a new, basically, character array of 1 size.
Right, so we're going to use the new operator, and it's going to be of data type, character of size 1.
And that 1 character is going to be set to be the null character.
Okay, so Sub-Zero is going to equal \x
Sub-Zero.
Sub-Zero wins. Flawless victory. Fatality. Sorry.
Okay, nice. Good job.
Did you ever use the friendship moves? I thought they were stupid.
I thought they were...
Yeah.
I mean, you did them just to say that you could,
But
because you had that list, and you just go each one of the lists,
Yeah.
and, Anyway, now we're going to do a value set.
Okay.
So we're going to set value to our magic number.
All right, and
the magic number is...
the size of the int in bytes.
Cool.
So there's our default constructor.
Okie dokie. Next, we can do the length.
The static lengths?
Not the static lengths, but the...
Well, the static lengths are going to be the underlying lengths, right? So we're going to want to define the constant char star length.
Yes, absolutely.
Right,
Totally
so
agree.
let's kind of scope in here. Look at this. Look at, I got my little own scope in thing going here.
Nice.
So if we're going to get the length, let's see. Let's just call this, what, STR? Is that good?
Yeah, it's perfect.
All right.
Okay, let's make a comment in here.
Okay, let's do that. After I select all and delete that.
Just like the... Okay.
What was that from? Was it like the Microsoft?
It was the Windows Vista demo. The first public Vista demo.
Didn't the Windows 98 public demo crash?
Probably.
Blue screened? Anyways, yeah. So you said a comment. What are we doing?
Okay, so let's just say to do for... We want you to make some of these better. So these... Yeah, exactly. So these algorithms aren't going to necessarily be perfect. They won't even necessarily be good. But we understand that this is kind of an beginner, intermediate level C++, so we don't... we're not going to get anything crazy. So these are... You can make these better. So we want you to take this and make it better, improve on it in the way that you like to. So, that said, all we're going to do is basically traverse the string as if it's an array until we hit a null character, count how many positions that is, and return the length. So we want an I.
Okay.
And then we want a for loop. And we don't want to redeclare I as a data type, but...
Oh, yeah, right. Because
I know it's muscle memory to do that.
Because we also want to make sure that I stays outside of the exclusive scope of the for statement, right?
That's what we're going to be returning.
Right.
So long as, not I less than, but that
like this?
String sub I is not equal to a null character.
Okay.
Then we increment I. Yep.
And then we can just do one of these.
Oh, yeah, we're not doing anything in there. We're just incrementing.
I would imagine that would be it, right? So we're just going to traverse character by character until we see one of these fellas, and that's that.
We can do the length function.
The instance level length.
Instance level length function.
Okay.
And all the instance level length function is going to do is it's going to return the result of the function we just wrote, or the method we just wrote. And that's going to pass the internal underscore string.
Right. Okay, cool.
The length of our internal string, that's what it's going to return.
Nice. Cool.
Okay. Then the next one we can do is equals.
Okay, so equals with the constant char star here?
Yep. So let's do that one next.
Let's talk.
Okay. We know right away if the length is different, then we want to return false. So we can say if, and we can use the one we just made, if the internal length with no parameter is not equal to the length of the constant char star that we just took in.
And we're gonna, what do you want to call this?
STR.
STR. So while the instance length is not the same length
as the parameter,
as the past length,
then return false.
Return false. Okay, because then
Don't match. Okay. And now, otherwise, we'll go through a for loop, and we'll traverse from 0 so long as I is less than the length of our internal string.
Okay, like this?
Absolutely. Increment I. And if, at any time, the character at the position I is not equal to the parameter's character at position I.
Like this, right?
Absolutely flawless.
Return false.
Outside of this loop, if we still survive and haven't kicked out, then we want to return true.
Right. Because in any other circumstance, once we get to this point of the code, we know for a fact we have a complete match.
Yep.
Excellent. Oh, yeah, and let me just kind of tab this to...
Perfect. Awesome.
Syntactically, what I did was correct, but
whatever.
Practice-wise, it's terrible.
Now we can implement the equals W string parameter, the equals overload for W string.
All right, what's next, Brian?
And now we can do the overloaded equals that takes in the W string, because that's basically going to piggyback off the one we just did.
Right, but I think that they're... Oh, no.
Yep, because we're just going to pass the internal... Oh, yeah,
But we're going to need to have another method defined to do that.
Right, okay, well, then let's... Because it'll need the C string. So let's do C string
Let's do
next.
C string, which is this little fella right here.
Yep.
The C string should be a simple one. What is the C string going to be doing?
Return underscore string.
Oh,
tricky.
That's crazy.
Okay, so now we'll go back up to the equals,
All
overloaded
right.
equals.
This fella here.
Yeah.
All right.
Okay, and that's just going to return.
It's going to return or return?
It's going to return. Turn around.
Nice.
I don't know. It's going to return the equals method that we already declared, which takes in the C string dot the string dot C string. Thank you.
Right. So this is what I like to call writing from like the lowest common denominator up, or the dependencies up. So we're building on top of this, and that also kind of helps further abstract. So if you want to build one method that facilitates all cases, then you could build other methods around it that will then support that. So if there's a problem, Brian, if there's a problem with our equals method, all we have to do is focus on one method as opposed to finding problems all over the place. Because when we write code, it is best practice, at least in my opinion, to keep all your failure points localized as opposed to having them everywhere.
Right, but also if you improve on an algorithm, you should only improve on it in one spot.
Yes, exactly. Right.
If
you have a better way to do equals, then you don't have to change it in 10 different places.
Right.
Exactly. All right, cool. So what do we got now?
Now we can do the isSet.
IsSet. We can do that, right?
And all that's basically going to say is if the value set is equal to the size of an integer, because we know that's our magic number.
Size of integer, right? Okay.
Return true.
Nice.
And then return false.
Right. So this is, even though we're not saying else return false, you know that if this doesn't happen, the code is going to continue here. So syntactically speaking, we can say this, but it has the same outcome as not doing this. So just to kind of expose you to something a little different, we'll do it this way.
Okay, so the next one we want to do is copy. We'll just keep on trucking right along.
All right, and copy, from what I understand, Brian, is really difficult to do.
I know.
So maybe we can talk slow.
Okay, we want to return.
Oh, hold on.
Turn.
Oh, damn it.
Oh,
okay.
So difficult.
Okay, that one was not on purpose.
We want to return a pointer
Okay.
to this.
Right, so we're not returning a pointer. Well, since this is a pointer, we're returning
the value of
this.
We're doing exactly the opposite of what I said.
Yeah.
What I mean to say, not what I actually say. It's like computers would be great if they just did what I meant to do instead of what I told them to do.
Yeah, I often tell newbie developers, first thing I usually say to them is, the greatest thing about writing software is it does exactly what you say. The worst thing about writing software is it does exactly what you say. Okay, what's next?
Okay, so now we'll go to the constructors.
All right, constructors.
We already have the default constructor.
We do.
Now we can do, you know what? I'm a big fat dirty liar.
Okay, let me scope back out.
Yep. Okay, now we can go to the copy string. We can implement the copy string method.
We can do that. All right, now if I was a copy string method, how would I work?
Okay, so the copy string is going to take in two parameters. The first is the destination and then the source.
So deststr and src_str. Is that cool?
That's fine.
Nice.
Let's put like a T in that dest one. That looks a little funny.
Yeah.
Looks a little okay. We're basically going to go through character by character and traverse the string and insert that into a new character array. Okay. And then append a null on the end of it. So we do want to know kind of the length at a certain point in time. So we'll do a for loop through the string, but we'll keep I outside the scope.
Okay, so you're saying we do an I equals zippy kind of like this? Okay.
So I's 0, I's less than the length of the source string.
Okay, so SCR, STR.
Yep.
Okay.
And we increment I.
Okay.
And then as we traverse through that, we're going to say that the destination string sub I is equal to the source string sub I. So it's just copying each character over.
So that equals this sub I.
Sub I.
All right. And I think, if I understand you correctly, we're going to be taking this value, and since this is not inside the exclusive scope, I is not inside the exclusive scope of 4, I can say now dest I equals x0.
Right, and terminate that character string. Right.
Yep, there we go. Cool.
Very cool. Very cool. Very cool.
Let's
now do the delete string.
Okay, delete string, which just so happens to be right underneath the copy string. What do we got?
Okay, if this is set.
Okay, so we're going to call the is set.
Yep. So if is set, then delete array.
Okay, so delete
underscore string.
Nice.
So just wipes it out.
That's it?
Yep.
Oh, man. That was boring.
Yeah, I know.
Got all excited.
Okay, now we can go back to the constructor.
Okay, which one?
That takes the... No, we can't. I'm still lying.
Man.
Cut that out. Okay, let's keep moving.
Can we write set string yet? So
okay,
set string.
So next we'll do is set string.
Okay.
And we'll just keep on moving through this.
All right, so set string is going to be taken in a string.
Constant char star, right, string.
Mm-hmm.
And that will be... the first thing we want to do is delete the string that we have, so delete string, which we just wrote.
Mm-hmm.
And then we want to set the underscore string, our internal string, to be a new memory position, which is going to be a character array, and the size is length of the string that's coming in.
Okay,
plus
length
1
of str plus 1 for the null character.
Yep.
Okay.
And then we want to copy the string to our internal string from the string coming in.
Okay.
Yep. And then we want to set the value set, so
okay.
we know that this is successful. That's going to be equal to the size of an integer. Okay, now let's do the. That's it.
That's it?
That's it.
Holy
right?
That sucks. I was hoping to do something crazy.
Yeah,
all right.
Keeping it simple.
All right. But I think, Brian, can't we do the overload, too?
Yeah, let's do the overload.
Nice.
And that's just going to be calling that, because now we have C string.
Right. So, again, I'll kind of zoom in with both of these. Now, remember, we're working from this requires a dependency, so we're scoping down or we're abstracting downward.
Right.
Just like we did with the, was it the equals that we did a moment ago.
And all this is going to do is call the other set string and pass it the parameter dot set string.
Right. So str.cstring, right?
Yep.
Like a this.
Like a that.
And that's it.
That's it.
Very nice.
Okay. Moving right along. Let's go to, well, let's just do append. We'll just keep on marching.
Right.
Okay, so first one where it's going to be a character is the parameter.
Okay.
So we'll call it C. I don't know.
Okay,
That's
C.
Fine. And we just want to attach that character onto our internal string.
All
so the length is going to change. So let's just store off our new length as int new length.
New length?
Yep.
Okay, new length equals
length
method.
Yeah. Plus 2.
Plus 2. One for the new character, one for the null character.
Exactly. Now we want to create a new C string, so char star new C string.
Okay.
And that's going to be equal to character of size new length. Character array of size new length.
Right, new length.
Yep.
Okay.
Okay. And now we're going to call copy string and copy into this new C string from our internal string.
Right, like this, right?
Yep, so that we have kind of a new working string. Okay, so now that new C, so we want to add the character, then add the null character. So the new C string at position.
Okay. New C string. So new C string at position.
New length minus 2.
New length minus 2 equals
the C.
C. Okay.
And then the same one. And then this. So then we're going to do the same thing, but at position minus 1, it's going to be equal to a null character. And again, we can't iterate enough. These are not exemplary method implementations.
Yes, they are, Brian. This is the gold standard. The gold standard here.
I tell you.
Yeah, the gold standard. I've been doing this for 40 years, Brian. I know what I'm talking about here.
40 years. I ain't seen a method like this. 40 years. Okay, then after that, we want to delete the string that we currently have.
Yes, good call.
And
so that's going to be delete string.
Yep. Our internal string is then going to be equal to the new string.
Okay. String is going to equal new C string. Now, the reason why we can do this, Brian, is because since we're allocating this dynamic memory space, it is in the global allocation scope. So once we pump out of this, this isn't going to be deleted. Now, recall, this is actually setting a pointer. So once we set the pointer, build the pointer, delete our old pointer, all that we're doing is now we're saying label underscore string, point to this new memory that we just allocated.
Exactly.
That's all that we're doing.
And that's why we don't actually delete that here.
Right. And that's why this is, even though this is being declared locally, it's in the global scope.
Right. Okay, so now let's do the overload for append for constant char star now.
I bet you this is going to be hard as hell.
Yeah. Yep, it's going to take in a string, and all we're going to do is we're basically going to traverse the string that we take in. So for I, 0, I is less than the length of the string coming in.
Okay.
And so for each iteration of this traversion, we're just going to say append, and then the character, which is exactly.
Okay.
Yep.
Now, this is not the most efficient algorithm, but this does kind of demonstrate what Brian and I were kind of preaching before about this is our lowest function or method.
Right.
And then this guy is going to be using this guy. So even though we believe that this is a good practice, maybe you should try to figure out how to make this more effective.
Exactly.
So that you can still keep this approach. Because this
Right.
is not the greatest, but it certainly isn't the worst either.
Yep.
So
okay, and then the last one, which is the overload for the W string.
this is going to be hard.
Yeah.
Oh, man. I'm not looking forward to this one.
So that's just going to call the other append, but pass the C string value of the parameter coming in.
Man, this is crazy.
I know.
So
Perfect.
like
Look at that. Just like that. Nice.
Very cool.
Yep. And then we just keep moving and we go right to clear.
Clear, which is right below
Clear.
these guys. Clear!
So the first thing we're going to do is delete the string
Why would you do that?
because we're clearing it.
Oh.
Duh.
Stupid. That's kind of a dumb question. I'm sorry about that.
Like Dolce Gabbana. Yeah. Duh. Okay. And then our internal string is going to be equal to new char1.
Right,
and then
like
that's
that?
going to be set to null. Yep.
So then this is going to be that sub-0 is going
Sub-zero.
to equal \x0. So it's kind of the same thing as the default constructor, sort of, except we're actually deleting the string.
Yep.
Cool.
Okay. So now let's see what else we have. What do we got going on here?
What do we not have defined?
Yeah, let's just go back
see
up
here.
to the top to our
Can
constructors.
we have some constructors here that need work?
Okie dokie, let's do
the
it.
constant char star in the W string.
All right, so the constant char star for the constructor.
Talk to me, Brian.
Okay, so that's going to call we managed set string well, so all we have to do is just call set string and pass it the string.
Oh, beautiful.
Because set string will delete it, it'll set
Right.
the value set, it handles it all.
So we're leveraging the work that we've already done. Remember, guys, when you
Right.
write your code, please try to follow this philosophy as closely as you can, because when you start writing gargantuan programs that get to be like 10 to 50 code files, and each code file is 500 or more lines, you definitely want to try to keep this approach to save yourself time down the line.
Absolutely. Okay, now we get into the tricky dicky part.
Okay. Thank you for using the word dicky in a way that we don't have to bleep it out. Of course, we don't have to bleep out.
Yeah, I know,
dick
because
if
we can
don't
say
want to.
schlong if we want. It doesn't really matter. We
Yeah.
can say
All Beavis and Butthead style schlong. I haven't heard that since like 1996.
wanger, whatever.
Okay.
Okay, so we mentioned this before.
Uh-huh.
When this is a little different. The implementation of this constructor uses the copy constructor.
Correct.
In the case where you have a constructor of a class that is taking in its own data type, it gets a little chicken eggy.
Okay.
So C++'s way of handling this is by using what it calls the copy constructor.
Okay. And there's many ways that we can use this.
Yes.
And we're just going to kind of use it in a very basic, very generic way.
Right.
So Brian, kind of let's see how we can do this.
So
First by starting with I'm sorry. I'm going to shut up.
So we just want to kind of establish a wire of what we want to copy into our scope, because we can't really access that string in this method. So that string str, we don't really have access to it. So we have to pull things that we can understand out of it. So we do that by saying a single colon, and then this is basically the copy operation. So we're going to copy to underscore string.
Okay.
And we will copy from str.underscore string.
Right.
That's a private member.
Right.
That we, in this case, have access to.
Right. Now, there are several implementations that you'll see. Like, for example, we can set multiple parameters by doing a comma-separated list. So if we wanted to do, like, the value set that we have, like, value set equals str dot value
Right.
set.
We can do other things like that.
And you'll see this kind of stuff in C++ code a lot, but we're just going to use just this. But there is a functional problem with this, Brian, a fundamental problem with this. And that is that these are both pointers.
Right.
So in order to alleviate a potential problem, which would be having two different strings equaling pointing at the exact same memory space by mistake, how can we fix that?
We're basically going to make a copy of the string.
Okay.
So we want to first block out the string we want to copy into.
Okay.
So a char star, some new string or temp string or whatever you want to call it. That's going to be a new character array of length +1.
Like this? Is it going to be this length, or is it going to be input length? So it should be... Oh, no. That's right, because at this particular moment, we have set this equal to this.
Yes, exactly.
So that is legal.
Yep.
That is legal.
Yep.
That's good.
Because we don't really have access to it that way.
Right. Let's go.
And then we want to call copy string. So what we're going to do is we're going to copy string into the temp string.
All right, so new string here.
From underscore string.
Underscore string,
yep.
Okay.
And then we're going to set the underscore string to be equal to the temp string.
Gotcha. Now, in this case, it's kind of like what we saw before, except we're not going to be destroying this memory. Why? Well, because this instance right here is pointing at that memory.
Right.
So all that we're doing right now is we're pointing at the same string that the incoming string is pointing at, or the same char star, making a localized copy of it, and then pointing to that new copy.
Right. Exactly. So.
And then I think we also want to do the is set, right?
Yep. So we make value set equal to the size of an integer.
Right. Okay.
And that completes the constructor.
Okay. Cool.
So not too bad, but it is a little strange.
Now I do know that this one's going to be easy.
Yep. Delete string.
Yeah. So might as well just kind of blow that one out while we're staring at it.
Okay.
What have we not done? Okay. Let's kind of do a one over here.
All right. So we did the
constructor 1, 2, 3.
Nice.
We got the destructor,
Yep.
we got copy string, we got delete string,
Yep.
we got set string, we got set string, we got append, clear, length. We don't have get at.
Okay, let's do get at.
Okay, so we're going to do get at.
Yep, so let's do get at. So we're going to take in an integer index as a parameter. And here's how we can do this. We can say if index is less than 0.
If index, so if we pass in a negative number, what are we going to do?
Then we're going to say index is equal to the length of our internal string plus the index, which will be a negative number.
Right, so if we do like plus... mathematically, if you were to do 1 minus 2, it's mathematically the same as 1 plus negative 2.
Exactly.
And that's what we're doing here. So we're subtracting by addition.
Right, so if you say get at negative 3, it'll get at the third position from the end.
Right, or negative 1 will get the very last character in the string.
Yep. Okay, so then, so now we want to test to see if the index is out of bounds.
Right.
So we say if, and there's two conditions in this if.
Okay.
If the index is less than 0.
If it's less than 0, it's negative, which means it's out of bounds.
Well, I should say if, so that means we've already set the index to be the length plus the negative number.
Right.
So that means that the negative number was so negative, it was beyond even the length.
Right. Like you have the word Brian, but you pass a negative 5 billion.
Exactly. Right. So if the index is still less than 0, then we're outside of the bounds. Or if the index is greater than the length.
So index is greater than length, like this, right?
Yep.
Okay.
So if either of those conditions are the case, we want to return null.
Right. Yeah, we could throw an exception if we want, but we're going to be cool and just send you back a null character.
Just to keep this simple for now.
Yeah.
And then we return underscore string at that index position because we know it's safe.
My. Nice. Cool.
Safe-ish.
Safe. Okay, cool.
Okay.
All right. If we just keep cruising down, we got C string. Okay, now we got some of the fun, sexy things, right? So let's start rocking some concat.
Okay. Concat.
Sounds like the name of a band, sort of.
Concat?
No, maybe not.
Like, what kind of
kitty
cat rock bands? They just, like, rock out with tights and meow at you or
something? Probably. All right, Brian, let's do it.
Okay.
We have one and then an overload. And I'm guessing the overload is just going to call this, right?
So we're basically gonna effectively the same way we did the copy string, where we traverse each character and add each of those characters into a new string. We're gonna do for the current string as well as the input string. So we're gonna just traverse the first one, then traverse the next one.
what we're gonna do is we're gonna create a new string. We're gonna fill it with all the data that the current string has, and then from that point on, we're gonna be adding on the new characters that we're gonna be appending to the string, and then returning a new W string instance of that. So we're gonna be managing two loops, right?
Yep, so we'll do an
I and J. We're having two indexes because we're traversing one and the other one in different spots.
Right. So so let's make a new variable called total length.
Total length.
And that's going to be equal to our internal length, which is just the length method, plus the length of our input parameter, just string, plus 1.
Nice.
Okay. Then we're going to say we want to make a new char star, or just char star. Yeah, whatever.
I was like typing literally what you were saying.
And that's going to be a new character of size total length.
Okay.
Okay. And then we're going to start getting into our two for loops.
Nice.
So for I starts at 0, goes to our internal length.
Okay, so that's going to be length.
I plus plus. Okay, and then the new string at position I is equal to our internal string at position I. Okay. So we're copying all of the characters from our internal string into this new string first.
Right, and now we're going to
And that new string is the length of both of these, so we got plenty of space for everybody.
Right.
Now we're going to do the same thing with using J, and J is less than the length of the... Yep, exactly. And J plus plus.
So J is going to be less than that, and increment J. Yep. So here we're kind of traversing a different loop just to have like a different index.
Exactly. And so now we're going to insert into new string, but in position I plus J.
Right. And what are we going to be inserting?
And that's equal to our input parameter position J.
Right.
Yep. So that's we're basically just using those two numbers as our offset to keep on entering into that new string.
Right.
Okay, and then the new string at position total length minus 1.
Okay, so at the new string,
which is the last position,
total length minus 1
is going to be the null character.
Nice. Very come on,
smooth.
Kevin. We can do that. Okay.
So not too bad.
Not too bad. There's probably better ways to do it, but this is a simple way to do it.
Yep. And then we're going to make a new W string.
Right.
And we'll call it our result string or return string.
Return string.
And that's going to be, we'll pass the new string into the constructor.
Right. So we're going to be constructing a new W string because, as you can see, we're going to be returning a new instance here because that's what the return type is.
So the constructor establishes a new memory space, makes a new instance, and then we want to delete the new string, so we don't need that anymore.
Right. Delete the temporary memory that we were just working with. Okay.
And then we want to return our return string.
Right. So we're going to be doing return this with a semicolon, right?
Cool. Perfect.
Not bad, huh?
All right. Let's do the next concat.
Now, this is going to be super hard, okay? I mean, prepare yourself, guys.
Yep. So this is just going to return.
Hold on. Whoa, 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 whoa.
It's going to return the result of the one we just wrote. So concat string C string. Easy.
Brian, these complicated programs are driving me crazy.
I know. See, we could rewrite C++ today. No, we can't.
No, we can't.
Okay.
So right now is a good opportunity, just because it just happens to be next in line, to write the two lowercase method.
All right.
All right, Brianna.
Brianna Beasley.
What are we doing?
Brianna. Okay. We're just going to basically copy this into a new string, but shift the characters if they're lowercase to an uppercase value. So,
right. So we're going to be scanning the ASCII range for the specific numbers that are the lowercase numbers, and then we'll be basically subtracting a value to put them in that other range.
Yep. Okay, so let's just march right through it.
Let's do it.
So we're going to make a new string, so new char star. Yep.
Okay, so new string. Okay.
And that's going to be...
new char of size what?
Length plus 1. Our internal length plus 1.
Length plus uno.
Okay. Okie dokie. Okay. Now for int I is 0, I is less than length increment, so we're just going to traverse our internal string, basically. Okay.
Okay, now we have a fun, interesting little if condition here, right, Brian?
Yep. So we want to say if the typecast to an integer value of the character in string at position I.
Okay.
So as we traverse through the string, we look at the character, but we look at the integer value of the character and its ASCII value.
Mm-hmm.
And so if that ASCII value is greater than or equal to 97, because this is 2 uppercase,
right?
I'm thinking it's a lowercase.
That's coming up.
Yeah. Then, and, same thing, but is less than 122, that means that it's in the lowercase range.
Okay.
And so if it's in the lowercase range, if this condition is true, and one more parentheses, I think. No, I'm alive.
I think we're clean.
No, you're good. So then we want to set the new string sub I.
Okay.
Nope, just the new string, not the internal one.
Oh, yeah, you're right.
Yep,
You're right.
it's okay.
New string sub I.
Equal to, and because we're in a number, we need to typecast it back to a character.
Okay.
The string at position I minus 32.
Nice.
And that will offset the ASCII chart back down to an uppercase value.
Yes, exactly, right. And if you guys are confused about that, go to ASCIItables.com. I think they have it there. Or
It's
just
an awesome website.
reference back to the Introduction to Computer Programming where we discuss the ASCII table.
And then we want to just say else. We just want to copy the string as is.
Okay, so then else it's just going to be this will equal string sub I.
Exactly.
Like that.
Yep. Okay, so outside of the for loop now, we want to say the new length, new string at position length.
Okay, so a new string at position. You said length.
Yep, at position length.
Like this, length,
Like that.
like that.
Yep.
Okay,
Equals
like that.
null.
Okay.
Yep.
And we're going to be probably copy and pasting these lines here, right?
Oh yeah. Mm-hmm.
Because we're going to be doing the same thing where we're going to be creating a new instance and returning that new instance.
Exactly.
So here we're going to do the W string, return string, and this is new
Exactly
string,
it, yep.
return string.
Okay, now we're going to do to uppercase, and we can basically copy this code, but we do have to modify it.
Oh, man.
I know.
All right. Okay, so let's just, hopefully there's no...
We hate copying code. We probably could make a third func method, an internal method.
Yeah, that facilitates both?
Facilitate both. That takes in like the range parameters and the offset, but whatever.
Yeah, we're going to be lazy.
Yep. Okay, so instead of 97, it's going to be 65 to 90.
Okay, 65 to 90.
Yep.
Got it.
And that's going to add 32 and not minus 32.
Okay, cool. Was that it?
That's it.
Holy monkey!
Yeah, I know. Okay.
That's awesome.
And the next one we got is chomp.
All right, so let's
So we
chop.
might be going fast, but one of the things that we wanted to, the reason why we want to just go through these and not just give you the code is we just kind of want to get you to walk through the thought process with us. You know, kind
Right.
of like, okay, this makes sense, and we just talk through it, basically.
Right, and a lot of times, if you're not too familiar with reading code is a horrible exercise. I mean, a lot of times, if someone doesn't kind of go over it with you, you may not really understand what you're looking at.
Yeah.
I know. Brian and I were like that. You know, when we first started, we couldn't read any code, and our college professors were so lazy that they would just give us code to read, and we would say we don't know what's happening
Yeah,
here.
and we'd be like, we don't understand that, and they'd say, okay, we'll just type it and execute it.
Right,
And be like,
yeah.
okay, thanks. buddy,"
Right.
You
Yep.
know?
Yeah. And
So-
at WiBit.net, we're going to try really hard to not make those types of assumptions.
So we do want to explain everything
Yeah.
that's happening, why we're typecasting, why we're calling
Right.
something, why it's whatever.
And our goal is to make you the most badass software engineer on the freaking planet.
Exactly.
So, all right, chomp me, baby. Let's do this.
Okay, so this is basically going to iterate through a string backwards until and so long as we're hitting new lines or return carriages, and then we stop. So
Well, while we're
gonna
saying
null them out.
while we're saying return a new line, we'll null them out. And once we don't find one, we've hit the first character that is not a new line or return carriage. Boom, we're done.
So let's walk through this one.
Let's do
so because we're creating a new version of the string, we want to create a temp string, and that's going to be of the same size as our internal string,
Right,
just for
so-
convenience.
Equals new char.
Char
New.
size len.
Right, because it's going to be at most the size
Of
of
our
our
current
internal
string.
string. Correct.
Either the same length or smaller.
Mhm.
So we're going to copy into the new string from our existing string.
Do we have to do a +1? I think we should do a +1 just to be safe. So copy into new string underscore string, right?
Yes.
All right.
Now let's traverse backwards through our internal string. So we're going to say for int I is equal to length minus 1.
Okay.
So long as I is greater than or equal to 0.
I is greater than or equal to 0.
I minus minus.
I minus minus. Okay.
So this walks us backwards.
Right. So we're starting at the end of the string, going to the first from back to front.
So if our internal string at position I,
if string sub I
is a new line character,
okay, it's \n,
or
okay,
if that is a return carriage,
if it's a return carriage,
then we want to set the temp string sub I,
okay, sub I,
to be a null character.
A null character. Got it?
Otherwise, we break.
Right.
So this condition will keep setting null values until we work our way backwards and hit a character that's not /n or r, and then we break out of this loop and leave it alone.
Right.
Because we've already copied it. And then, yep, exactly.
And we could just kind of reuse this. We could have probably subfunctioned that out, but we didn't. So whatever.
Yep.
You can do it when you modify this for your own exercises or your own purposes. So we're just going to be, again, making a new instance of WString, deleting the temporary memory, and returning the new instance.
Exactly.
Trim right, Brian.
Okay.
So when we do the trim right, we're going to be taking that same philosophy where we have a lowest method that serves as a base method for other methods.
Absolutely. So our parameter that we're going to take in is a character. We'll just call it C.
Okay.
Okay. So trim right. We're going to move through the internal string backwards.
Okay.
And we're basically going to... It's kind of the same as the way we did chomp, but instead of looking at a new line or return carriage, we're basically going to be looking at the character that we took in. Basically.
Cool. So it's a very similar type of algorithm.
Yeah, so we can actually copy the internals of chomp.
Okay, let's do that.
And just modify it to fit our purpose.
Okay, so we got that. We got that, and we'll stick that DARS.
Yep.
Okay.
All right, so we have our new string that's equal to the length. And then we copy the string into a temporary string, and then we traverse backwards. And then, exactly. Yep.
Is that it?
Yep, that's
it. Oh, cool, baby. Nice.
Yeah, it's easy.
Okay, so I would imagine trim right is going to be leveraging that, right?
So by calling the default trim right, all that it's basically going to do is it's going to trim using the space character.
Right. Right. Like it is.
So it's just going to trim a white space.
Right.
Yep.
Okay, so trim left.
Okay.
Same philosophy as trim right. This is going to serve as the base method.
Yep.
So we'll just do a char C, right? All right. Let's go, Brian. What do we do?
Okay, so we're going to... that's true. This will be a little different. The first thing is we need to know a couple things. We need to know basically the index of position. So we're going to be doing a couple traversions. So we want a couple variables. We want an I and a J, and we want actually that's it. So let's declare I and J outside of the scope.
So we're going to be managing two loops here at two different indexes. The first thing we're going to do is we're going to scan through the string, and we're going to find the first character starting from the left that is not the value of C. And once we find that value, then we're going to start from that point, and we're going to fill up a new string. So, you know, like if we have...
With the remains.
Right, so if we have like space, space, Brian, and we're trimming space, at 0, 1, 2, the character B starts, but at 0 in the new string, the character B will start.
Right.
So we're going to be traversing two arrays in two different positions, which is why Brian says that we have to have two different indexes here.
Okay, cool. So for I is 0, and so long as string in position I is equal to C.
Right.
And we don't exceed the string length.
Oh, right. Yeah. Okay, cool. And
I is less than length.
Well, I is less than length like this, right?
Yep. And
I
then
plus.
Exactly. Okay.
And that's just going to be traversing until we find that end condition.
So that basically gives us the first index of character C that's not character C.
Right. And if you have all spaces and you're trimming spaces, this will make it all the way to the end of the string.
Yeah. Because you'll have nothing left. Okay. So now I is the first index of not character C. So now we want to make a new string.
Okay.
And we want to make it of size. So new character array of size. Our internal length.
Okay. Like this?
Right. Minus I. So minus all of the characters before that.
Right.
Plus 1 for the null.
For the null character. Exactly. Cool. Okay.
Okay. So we want to initialize J to be 0.
Okay. So
now we're going to use J.
J equals zippy.
Yep.
And then...
And we're going to traverse, and we're going to say for Yep, it's for nothing initially.
Yeah, because the first compare, we don't have to run the first expression.
So long as I is less than this internal length.
Like that?
Yep.
Okay.
And this is going back to I. So we're, again, we're not starting again at 0. We're starting at the position we left off and going to the end.
J is starting at 0.
Exactly.
And if we want, Brian, I actually don't want to look at it that way.
Okay,
I want to look at it this way. Now, don't be confused that we have J here and I here. Remember, we're going to be traversing through 2 different strings. I is going to be indexing underscore string. J is going to be indexing the new string.
Exactly.
Okay? And you'll see how that works right now.
All right, so now we're going to continue to increment I.
Okay, so I plus plus.
To the end of the length.
Right. Okay.
So now we're traversing the remains.
Okay. Traversing the remains. Now that's the name of a band.
Nice. Oh, that sounds nasty.
It's a death metal. It's a heavy metal band. Traversing the remains.
Nice. Is that the 2 kick?
That's the
drum pedals. Nice.
As long as you growl over it, it works.
Nice.
All right. Cool. Anyways.
Okay. So while we traverse this, we just want to set the new string sub j,
right,
which starts at 0, to be equal to underscore string sub I.
Okay, so underscore string sub I.
So that's copying from our internal string, starting at where we want to start, and then just offsetting it into our new string. And in visualizing this is part of the skill set that you definitely want to grow. And we want to increment j since we're sort of using I as the incrementer inside here.
So I is going to be incrementing into the next position here, and j will be incrementing into the next position here.
Exactly.
Beautiful. All right. And once we do that, I think, Brian, all we need to do is just kind of
terminate it.
Or pinch it off.
Yep.
Just shake it real quick.
Shake the tip.
Yeah, shake the tip.
Shake that last little drip out.
Yeah, okay. So we got that. And then I think we can just kind of steal that same code that we've been kind of wrestling with. And that's just making the new instance using the constructor and deleting the temporary memory space for the new instance. Yeah. All right, so here we go. And I think the variable names are all the same, so we should be in good shape.
Cool.
So now that we got the trim left base done, let's talk about the trim left.
So trim left, again, we'll just call the trim left we just implemented, but pass it the blank space character.
Like it is.
Like that.
All right.
Okay, and now lastly we're going to implement trim.
Okay.
So trim is really just a combination of the 2 we just did.
Interesting, Brian.
Yeah.
Interesting.
So we will create a return string of type W string, because that's our return type.
All right, so it's going to be W string, right?
Right, and we'll call it return string or result string, whatever you want to call it.
Right, okay.
And that's going to be equal to the result of trim right, passing it parameter C.
Nice.
So we're going to do a right trim of our existing string.
Mm-hmm.
That comes back as a W string. We save that W string as return string, and then we basically just return the result then.
Like that?
Of return string dot trim left, passing parameter C. So we trim the right with character C, and we trim the left with character C.
Very, very neat, Brian.
Yep.
Very neat. I like it. Now with the trim, I mean, at this point, guys, I mean,
you know what's going on.
I can't even have fun like being enthusiastic about this because it's like now you're starting to see the repetitiveness that we got going on here.
All right, so now let's do a once over and kind of see where we're at, and then we'll finish off the rest. I think the only things we have remaining is the operator overloads.
All right, let's just do a quick scan, Brian. So we got a fair amount of code here. We got the constructors here. We got the copy string has been defined. We have
delete set string,
append, and then append, and then append, and then clear length, get at equals is set C
string copy
concat,
nice, good,
to upper,
I like it,
to lower,
nice.
And then chomp,
trim right,
trim right,
that whole
left.
Family.
And then trim left again, trim. Okay, Brian, let's talk about operator overloading. Now, Brian, when we start doing these operator overloads, one of these we're going to be kind of stealing and leveraging some stuff from the string class to simplify it, but that certainly is not this one. So let's gotta mess around here, Brian. What do I do?
Okay, so yep. So we'll call it stream. We'll call it string.
Okay. What do we got?
Okay. We want to pipe the C string to the stream.
Ah, because
that's really it. So we have access to a data type that the OStream class knows how to handle.
Right.
And so we just pass it right along.
Exactly. Why reinvent the wheel?
Yep.
And that's also the philosophy that we're going to take here. And Brian, maybe you can kind of explain what we're going to be doing.
Okay, so now this is for the insertion operator. And all we're going to do is create a temp string as a space with which to insert this into.
Right, but we're going to be using
the std string.
Yeah, and some of you guys might think that this is lazy. We look at it as it's
time efficient.
Yeah, it's saving time, and we're not writing anything too terribly complex. We're still staying at the intermediate level.
Now, if you guys want to swap this out,
do it and post it on the forums. We would love to see what you guys come up with.
So just for the sake of time, we'll just use this for now. Temp string.
Yeah, and the string class is already designed to work with the stream. So again, we're not reinventing the wheel here.
And we're just going to have the stream pipe to that temporary string.
Okay.
And that's going to perform the insertion.
Okay.
And then we're going to clear our internal string.
Okay, so that's going to be str.clear.
I'm sorry, our parameter string. We're going to clear it, and then we're going to set it. So str.setString, because it's a public function, public method. SetString, tempString dot cstring.
C_str, which is what the constant char star is for the string class in C++. Yep. And then return string.
So that dot C_str. That's exactly the same as our C
string. Yeah. Very nice.
Yep.
Is that it? Return stream and then we're done?
That's it.
Cool. All right, so the beauty of all this, guys, and the reason why we built the methods out the way that we did was so now that we get to operator overloading, it's literally just calling a method that we've already written.
Right.
So when you start to think, Brian, about what index, well, what am I actually going to be performing when I return something at an index?
Right, so we're going to be taking in an index value and we're going to be returning the character at a position. So our get at method is perfect fit.
Yep, done. That's it.
Yep.
Okay, now equals.
So this is basically just connecting all the wires, just wiring it up.
Yep.
We built the harness, now we just wire it up.
Now you guys remember we did write a method called equals, so what do you think we're going to be doing here?
Not calling the equals method.
Okay, so let's not do that.
Yeah, because this is the setter, not the...
Well, okay, I'm sorry. I'm thinking down here. Shut up, Brian. Nobody likes you.
Well, you smell. I don't know.
You know what?
Oh,
that was kind of sad.
Okay, so we want to set the char star. So we're gonna do a set string, and we're gonna pass in the string. Before we do that, we just want to clear it.
Okay, like that.
Yeah, just like
clerk.
That. So we clear our internal string, and then we call set string on it.
Cool. So now we do the same thing here for a W string.
Right. So we actually, this is a little funny. We actually can just call the operator
equals
like it's accessible. Yeah.
And it's important for you guys to kind of see that operator equals, although it looks all weird and crazy, it's just a method that belongs to the instance of my class. It's freaking crazy.
It is.
So then this is going to be str.cstring, right?
Yep, exactly.
Because we've already built one to handle that.
Piece of cake.
Now we're where I was talking earlier.
Now we can use the equals.
Okay, so now let's do it.
Okay, so all that's going to do is just return whether or not it equals the parameter.
Okay, so equals str.
That's it.
And then this guy, what are we going to do with this guy?
The same thing, but the parameter is just going to be the so the parameter is going to be a C string, just like the other one was.
All right. So do you want to call this, or do you want to call the equals?
We'll just call it equals. Yeah.
The equals overload.
We'll call it equals overload.
Okay, we'll do that. That way we can kind of have a nice little sampling.
But it's actually not an overload. We'll just call it equals str.cstring.
Oh.
We
do have an overload, right?
Perfect.
Yeah.
Done.
We should be able to do that.
Moving on.
Yeah.
Awesome.
Okay. Not equals. This is crazy.
Yep. So it's going to be the same thing. It's going to be returning the equals operator.
You want to do operator equal? Like this?
Yeah, so that way we kind of like declare it in one spot. So we're going to just return the result of, and then double equal instead of single equal.
Okay.
And the only difference is it's going to be a not that
Right.
case. Whatever the opposite is of what that
Right.
returns.
Opposite of equals.
Yep. And that's going to be the same implementation for the W string as well.
Nice. So we got a nice variety of different ways that we can pull off this functionality.
Yep.
So then we'll do this as an str, and I guess you want to do .c.
We don't have to. We have an overload.
For equal?
Don't we?
You are correct. Yeah. You are correct, sir.
Utilize that overload.
Absolutely. Okay, great.
Moving on.
Operator plus, Brian. This is going to be
plus is basically,
stuff.
yeah, exactly. It's exactly the same as concatenating. So what that's going to do is it's going to first create a new W string, and we'll call it like the return string. And then that will be equal to calling copy.
Okay, so we're making a copy of this current instance.
Yep.
There we go.
So we block out some new memory space. And then we return string.append. The string that we're passing in.
Like that?
Like that. Perfect. And then we return that return string.
Like that?
That's it.
Not too shabby.
And then for the overload.
Oh, man, hold on. This is going to be hard. All right.
So the overload, we just call what we just implemented, but we pass it the C string.
All right, so you want to do this?
So, yep,
like that?
return.
So it's going to be operator plus.
Uh-huh.
And then we're going to do str.cstring.
Yep, exactly.
Yep, there we go. Nice. Now does now plus equal,
okay, so now
which
like
is the
append.
concatenation?
So that's like append, because it's like a set.
Okay, cool.
So char C. Okay, and all that's going to do is call. I'm trying to think. I think it's a little more complicated than it's not. It's just append C. That's it.
Append C.
It's so easy it hurts the brain. And then the next one is append. We'll call it string.
Okay. What is this one?
Append string.
Oh man.
And that's the same thing for the last one too.
What?
It's a little anticlimactic.
I know. It's like once you get all the hard work done, it starts to get boring.
Okay, so now so that concludes our implementation.
Right.
And now we get to the part we don't really want to.
Yeah, which is going to be debugging and testing.
So now let's see if that actually works.
So the first thing that we're going to do to see if this works is to see if we can get a compilation to happen. And we do have a failure.
Hey, we got a failure.
On
we got
line,
a debugging opportunity.
Line 94. Looks like I forgot to take the word static out.
Oh, yeah.
So on line 94 on CPP, let's just do a search for the word static. Well, no, that's not exactly... Well, I don't... That doesn't see it. It says line 94, right? wstring.cpp line 94.
Oh, no, it's column 94.
Oh, look.
Oh, yeah, look at that.
We never defined this.
That's funny.
Holy okay.
How did we miss that?
I have no idea, but that's what debugging is for. Okay, so in defining this string, I mean, this is a no-brainer. It's going to be return length
passing
of str.cstring.
Exactly.
So sorry about that, folks. string.
Okay, whatever.
Yeah, let's see what happens now.
Let's try it again.
Okay.
That was it, really?
Yeah.
Oh wow.
All right. So now
Man,
we don't really know if we have any logical errors.
Right.
So let's just kind of start. Let's just first go through systematically the constructors and make sure that this works.
Okay, so let's use you want to use fruit as an example?
Yeah, we can do fruit. So you want to do maybe apple, right?
Yeah.
Apple equals.
Actually, let's just call it. Yeah, that's fine.
Well, all right.
Doesn't matter.
But all right, here we go. Hold on. This is calling the default constructor.
Yes.
Now let's do something called banana. And banana is going to be calling the constant char star. So this is going to be banana, B-A-N-A-N-A, banana. And then this one's going to be banana also. Why not? Because this one's going to be taking in a W string. So what we should get is nothing, banana, banana. And since we overrode the the I stream and O stream, we can do stuff like cout, and we can cout fruit. So let's do something like quote fruit equals, and then fruits.
Yep.
And line. And we'll kind of replicate this for
Each of the ones we want to test.
Yep. That way we can kind of see where we're at. So that goes there, that goes there, that goes there, and that goes there.
Okay, let's see if this actually works.
Yeah, hopefully. All right, we got a compilation. So let's do what did we call this? This was a W string.
Driver. Nope. That exe.
Son of a B.
Oh.
This is dot exe. Exe.
We got exe.
And we got fruit equals blank, which is correct. Banana equals that. Banana also equals that.
Cool. Awesome.
All right. Now, since we've tested that, made sure that the constructors are functioning, let's also kind of make sure that we can use the equal operator.
Okay.
So, fruit, and then banana is going to equal.
Actually, let's instead of doing banana, do prompt.
Prompt, okay.
Yes, and then because that way we can test insertion. We can ask the user for to enter a fruit type.
And is there another equal? Well, all right. Before we do that, Brian, let's do a little more primitive, okay? So I want to make sure that I can equal a constant char star and I can equal a W string, right?
Okay.
So I just want to test this.
Okay, perfect.
And for right now, we'll comment that out. So at this point, we should get the word fruit and fruit, right? So if we get once I get past my stupid little mistakes there, okay, expected on line 8 a semicolon. What did I not do?
Oh, yeah. There it is.
Yeah. Lame. All right, and we run this, we get fruit and fruit, which is what we expected. Now, let's also, just to see, if we set then fruit equal to banana, hopefully we will see that banana equals fruit and fruit equals banana, right? If we hope, unless there's a logic error where the pointers are pointing in the wrong space, let's hope that's not the case. So fruit equals banana and banana equals fruit.
That's
fantastic. Awesome. So, Brian, you wanted to do an insertion, right? Yep. You wanted to do a CN.
So let's set fruit to be let's make fruit as like a holding place. So we'll just set fruit to be the default constructor.
All right.
That word looks weird when you stare at it for a while.
It does. It probably is another word that looks weird. For me, anyways.
Okay, so that'll be the prompt, and the prompt will just set as a please enter a fruit :
Okay.
Okay, and then let's do like.
How about see out prompt? Let me just kind of kill this. This stuff is let me just kill that and kill that because we're going to be using.
So we'll do see out prompt, and then
see out prompt. And then we can just cut that off there. Now we can see in
fruit
to our fruit, and this to our fruit. Brian's a bit of a fruit, so we can see in there, and then let's just say fruit equals. Is that cool?
That's fine.
All right. So now we come back to our code here. One of these days it'll load. There we go. Oh, I just opened up a new prompt. That's not what I was hoping for. Okay, so now we'll come back to our code. Come on, Kevin. All right. Run that. Okay, now that that's ran, we can then execute it. Please enter a fruit. Brian, what kind of fruit do you like? You want an apple?
Yeah, let's do an apple. Perfect.
Fruit equals apple.
All right.
Let's also kind of test some of the other methods, Brian.
Like plus equals. And
Right. So I guess, you're right. Operators are fun. So let's just start looking at some of the operators. So we've done these two. Let's start the brackets.
Okay.
Why not? And this will be kind of fun. Let's just do.
So we can get rid of the prompt, and we can say, we don't need to go through all that every time, and we can just say fruit equals apple.
I got a pretty good one for this, if you don't mind that I take over.
That's cool.
So check it out. Watch this.
Do it.
So that we can do a for int I equals 0 while I is less than. What am I going to do?
Print out.
Fruit.length. Oh, shit. See out. fruit sub I and line. So now you can see, now we're getting a whole abstract thing built in here because we're going to the length of the string.
It's really about integrating our class into common language functionality.
Yep. So now we should be able to run this and execute this, and apple prints out.
Very cool.
Yeah.
Awesome.
All right, Brian. Now it's your turn.
Okay.
How would you in the Brian world test the double equal operator?
I would say if the character at the first position is equal to.
Well, that's not. That's using a character. We have to do the equal for the W string. If you do character at first position,
it's not going to actually test that. Okay, how about this? If fruit to lower is equal to quote apple quote.
All right, we can try that. If fruits dots to lower case equals fruit.
No, equals, in quotes, apple, all lowercase.
Okay. And we should have the constant char star overload, right?
Yep. So if that's the case, if that is apple to lowercase, then we'll say fruit. No, before we output. Fruit plus equals.
Like that?
Yep. And then we'll see out fruit and line.
Or yummy.
Yeah.
Like that?
Yes. Perfect. Let's try that.
Hey! Apples are yummy.
Very cool. Alright, so far so good.
Okay, now, let's see. We did like length and get at and equals. We tested
Oh, we
equals.
do trims.
We can do trims.
I think trim's the last one. And a plus equals.
We did a plus equals right here.
Oh yeah, I knew that.
So we got. So we can try. We can.
Let's do chomp and trim.
Let's do these babies.
Yep.
So concat, we've already used that with the operators.
Yep, copy's used kind of throughout.
Yeah, we just demonstrated the two lowercase and also just to kind of make sure that, you know, two uppercase. Right?
Yep.
Just to make sure that that's functioning.
Cool.
Apples are yummy. You said chomp, or is that what you wanted to do?
Yeah, so we'll do chomp and then the trims.
All right. So a way to, let's see here. So one way that we can kind of demonstrate the chomp is WiBit.net is awesome. Bakery? What is that crap? So we're going to put several end-line characters.
And let's also say WiBit.net is new line awesome.
Alrighty.
Just so we can show that the new lines are protected inside the string as well.
Alright, so
just do, yep.
Then what?
We'll just put a couple before awesome.
Okay. Just backslash ends this time.
Okay.
We're going to get all Unix style on you. So run that and that. Okay, so you can see, as Brian demonstrated, there's a line break here, or a pair. There's one there, then a second one here, and then awesome, and then all these line spaces. Now, what we can do, is we can make a new instance of W string just to kind of demonstrate this, and do a W string, my new string equals my string dot chomp. And then we should be able to then put this here, and then
Perfect.
The output should be, run that, and the output should be, if I can find my, there we go. So
Nice.
those they're all gone.
Very cool.
Now, if we're going to do the trims, let's first demonstrate each individual trim and then a,
Combine.
right. So let's say I have right padded and left padded zeros. And then we'll do another example with
White space.
Yeah. So this one is going to be then trim right. And when I trim right, I want to remove everything on the right-hand side that is a 0.
Perfect.
So if we run this guy, we should get all the zeros are
nice.
gone.
Okay,
Now,
now we do left.
And the same we can do left. And all the left ones are gone.
Cool.
Now we can do
Just
just the trim. And that'll take care of both of them.
And then we know that the...
Hey!
Perfect. Awesome.
Now, let's do some white space, Brian.
Okay.
So we got a bunch of spaces there. We got a bunch of spaces there. Now, if we just call trim and we
should
pull
clean
that
it right
out,
up.
we should have no white space on the sides. And we don't.
Nice. Okay,
Now,
cool.
Let's just do real quick. I'm sorry. I'm one of these guys. I'm sorry. It won't take me long. All right. That works. Although we really can't see
Yeah,
it.
it's fine. It's good.
And then,
very cool.
okay, whatever. That's cool. That's fine.
So, keep on testing it. Keep on making it better.
Yeah, like this
you
is
like with it?
this is by no means perfect. There are problems with this code, but again, we're still not we're not trying to get all computer sciencey on you. We still want to make it practical.
Yeah, and the big thing we want you to walk away with is when you're using C++, and you're using the string class, to be aware that it's not a data type; it's actually a class, and that it was implemented by somebody just like you.
Right. Well, it is a data type, but it's a composite. It
Yes.
isn't a primitive.
Right.
Right. So it's a man-made data
Yes.
type. Although, I guess the primitives are too, but it's a
Right.
user-made
Yes.
data type.
Anyway.
That's it. Have fun.
Welcome to Programming in C++. This is our video on class inheritance.
Yes.
This is very cool.
Oh, yeah.
If you remember, class inheritance is when, we were talking about how the order of life is kind of like class inheritance, and you have, a horse, and then you inherit the horse and extend the neck,
Mhm.
and you have a giraffe.
Yeah.
So as things evolved, they kind of got like extended and extended and extended by way of class inheritance.
Yeah.
And as things, simple things became more specific or more complex, it was just a process of inheriting that parent, defining the child, inheriting the parent, defining the child. So now we're actually going to see that in action in C++.
Yeah, so now we're not going to talk about it as some weird, fuzzy, abstract concept. This is where it becomes rock solid. Now, just to review, as Brian was saying, now here's an example of us having two classes. A person class that just contains a first and last name, because as you know, Brian, people only have first and last names. There's nothing else
that identifies you as a person.
That identifies you as a person. And now we're creating a brand new object called an employee. An employee is a person. So why would I just make these new person attributes? I would just suck in the person class to inherit the person functionality into my employee class. So an employee is a person. An employee has every attribute that a person has plus. So it has everything and then some.
Because an employee is a person, that doesn't mean that a person is an employee.
Not necessarily.
So a person does not have all the attributes an employee has. It doesn't go both ways.
Right. A person doesn't have a job code at birth. Well, at some point we will, but at this point we don't.
Well, I guess it also depends on the country you
Yeah,
come from,
that's true. Textile factory.
Oh. Here's the class definition of a person. The person we were talking about has a first name and a last name.
And that's it.
And we're going to also put in the methods to set and get the first and last name. Now, we've seen this person before. There's two constructors, one that takes no parameters, and one that takes two string values and last two string values to construct the person and initialize it with those values.
Yep, and then we just have our setters and getters, our first, get first,
Easy.
set first.
Yep.
Now here is the implementation file for person. Now in here we have our default constructor, which does nothing except for just create the instance. Then we have our other constructor that takes in a last name first and then a first name, and they will just be calling the set last and set first name methods that belong to this instance of the object. And then of course the remainder are the setters and getters, which we've talked this to death at this point. Now let's take a look at the driver file, Brian. Now this is just basically creating three people. I'm going to create P1 Bill Mill, P2 Bill Mill, and then P3 Bill Mill, using three different methods. The first one is we're just creating the person, and then we're using the setters. The second one we're calling the constructor. The third one we're doing the same thing, but we're using dynamic memory. So this is just how we're implementing our person class. Now, if our goal is to inherit this to make something else, we're going to have to create an employee class, right?
Mm-hmm.
And inherit from this class. So Brian, why don't you tell us how we can possibly do this?
It's pretty easy. Here's our class template. Class, our class name, just like we normally would have. And then in the code block, we have our class code to define our definition of the class, basically the blueprint of the class.
There's something oddly different about this. What is
so
that?
now we also have colon, public, and then the inheriting class name. So this is telling it we're going to define this class, and it's going to be an extension of. So that colon is like saying extension of public class name.
Yes.
So the way we would implement this is to say, class employee, colon, public person. Let's take a look.
Yeah, so when we inherit this, what we're doing is we're directly inheriting all the public and protected methods, and behind the scene, we're inheriting the private methods. Because the inheriting class can't access the private methods directly, but it can access protected methods directly and public methods directly.
Right.
So here's the code that Brian was talking about.
Here you can see class employee, colon, public person. So class employee is a new class that we're defining, and we're laying out the blueprints of what an employee is, but also saying that inherits the parent class, public person. So person is the parent class, employee is the child class that's being extended out. Right away, we have the employee class, and it already, right off the bat, has all of the methods in person class. And so now we'll extend this, saying we also have a couple private members, a string employee ID and another string job title, and some public things. Employee constructor with a person overload, another employee constructor with string, a set employee ID, set job title, get employee ID, get title, just like we normally have with our setters and getters, our constructors. So this is really basic stuff. The class definition, just like we always see, but in this case, we also have extends from public person.
You know what's cool though?
What's that?
On the constructor, we can pass it a person instance. And this employee will become that person.
Yeah, it's pretty cool.
Awesome?
So here we can see when we call the extend from public person, that will literally go out to the person header file and make reference to that person code. So that header file still has to exist. It can't just exist in theory.
Right.
We're still functionally referring to that code.
Right, so the person class must be defined before we get to this point. So it kind of looks like this, Brian. We have protected methods that go right here. So it's like the bubble and the bubble absorbing into another bubble. The setters and getters for the person absorbing here as well.
Here's the implementation file of how we're going to define out the employee class. Right off the bat, you can see something strange. We've already defined the fact that this is inheriting from the person class. And we have a constructor that doesn't do anything if there's no parameters passed, just like we see at the top. Right, and then we have employee first last name and then employee person. But on that employee string constructor, that third line in this, you can also see the colon person last name first name. So instead of reinventing the wheel, we've already, in the person class, we've already made a constructor that will pass it the last and first name and generate a person.
Right.
So we're really just going to say, we want to not have to rewrite this one because that's just a waste of lines of code. Why bother? We're just going to say, extend this from the person constructor. So this is like Kevin was saying in the other video earlier, to just be mindful that FYI, he lets you know.
Yeah.
When you inherit a class, and you want to take in the constructor from that parent class, you have to explicitly take in that parent class's constructor.
If it's not the default constructor, you have to, that Brian's exactly right. So in this case, let's just say the person class had something more spectacular happening during the construction part, and you wanted to make sure that you directly called that because first off, you may not know what it's doing, and secondly, you may not want to replicate what it's doing. And this is just an example of how you can just pull in the person constructor that takes the last name and the first name directly in the employee class and use it as if it's native to the person class.
It's awesome.
Spectacular.
It's very cool. So now we can really start seeing the nuts and bolts of how we can take some, you can think of it like it's a piece of clay sculpted into something, and we take it and we start resculpting it into something else. It's very cool.
If this doesn't excite you, I don't know what could possibly excite you.
So this will directly make reference to that particular constructor overload in the person class.
Now there is a constructor that is native to the employee class that is accepting a person instance. In this case, what we're going to do is we're going to take in the person instance that is sent. We're going to call the getters first and last name, and we're going to set underscore first name and underscore last name to those values. Now, Brian, as you recall, when we looked at the employee header, those did not exist in the employee header.
Right.
Those are directly inherited as protected members from the person class.
Right. So now that we have these, we can use them.
Yes.
With no declaration of anything, no overdone, retype everything from the person class. We just have them just like that.
And it's important to know here that since these are protected in the person class, I know I've said this already, but I'm going to say this so that you know this and that you know this like you know breathing. I can say underscore first name directly and directly communicate with that value. If it was private, I would have to use the setter to communicate with that value.
Right.
So if you don't want that relationship to occur, you would make those private. Anything that you want to have direct access to in inheriting, make it a protected field or a protected method or something. Property, whatever. Member is the general term, I guess. Okay. Brian, let's take a look at the driver file.
Right off the bat, we declare employee E. So we create object E, which is of type employee. So employees are a special extended object type that we pulled in from person.
So we've included person before we included employee.
Exactly. We have to include person first and then employee, because employee makes reference to the person class.
Yes.
So we have to do it in that order. Parents have to be loaded first, and then the children. We create an instance of employee E, and that calls the employee header and
creates the instance.
Then we set the first name, and we set the last name.
And we do that in the person class.
Right.
Yeah.
So when we say set first name, that's a method defined in the person class that was inherited, just like the last name. We never had to redefine how to do set last name, but that functionality is just implicitly available on E. Beautiful. It's very interesting. So now we get into calling set employee ID, which we did define in our extended employee class. We pass it in a string, just like it's expecting. Same thing with set job title. You know, when we declare ourselves as being a super awesome software engineer adventurer. And then we call our getters. You can see right away that we're alternating between the person header and the employee header, the person and employee class definitions, interchangeably.
Yeah, it's just like it's native.
Yeah, e.getFirstName and e.getLastName, when we print these out, are calling from the person class. And here we print getFirstName and getLastName, which are calling from the person class. And then right off the next step in the line, we say getEmployeeID, getJobTitle, and that comes from the employee class. With no obvious difference, we're using this object just like we would expect to, and having seamless interchange between the parent and child class definitions.
The user is none the wiser.
Right.
Just like you're none the wiser when you use file streams and when you use strings, because that's all inherited from the IO base.
Yep.
You know, it all just kind of flutters in and you have no idea what's happening. All that you care about is this beauty right here.
Yep.
Look at that. That's fantastic, Brian. Wonderful explanation. That last example, we called the set first name and set last name getters that exist in the person class. As you recall, Brian and I made a big deal about us inheriting the constructor from the person class that we wanted to use natively in our employee class.
Right.
So here's an example of us calling that. So we have employee, and then we're calling the constructor that takes the two strings. This will be last name and first name, so WiBit the frog. And as you can see on the right here, we're going into our employee class because we had to specifically state that we're using this. But when it comes here, the implementation says, by the way, when you come in here, just go to the person class and call that constructor instead of calling the code here. So it just kind of like...
It starts looking like law in Congress, pursuant to Article 6 of Clause 5, refer to the manual.
Right, there you go, exactly. As we come up here, we actually then call the code in the person class, and that's what this notation to the right here says. So when I say person, last name, first name, go up here and do this.
But at the end of the day, and what's important is this is where you start seeing saved lines of code.
Oh, yeah.
And especially in cases where this becomes a little more complicated. But if we generate 3 employees, that's already saved us right away 6 lines of code.
Yeah, right.
And it's always about reducing your numbers of lines of code.
Yep, absolutely.
Here we dynamically create 2 objects, a person object and an employee object.
Oh, goodness gracious me.
So now we have one of each. When we make a new person, this is dynamically allocated, so we're using the pointer and the new, just like we're all used to now. We're going to pass it the last name, first name constructor overload with WiBit the frog as the full name. That will go off and create person P. Then we create employee E,
my goodness.
and we pass it P, point it to P. And this is where it gets interesting. So our new extended, newly implemented method to overload the constructor of employee by taking in type person,
right,
of the type that we're extending, which is really cool. That will get employee up and running with all of the things that it's able to inherit from, and then we have it to use its extended functionality off of.
And one thing to keep in mind here is the reason why we're passing star P instead of P is because the constructor that we wrote in the employee class does not take a pointer. So remember, the notation star P says pass the value of P, not pass the memory address of P. So if that wasn't a pointer, you wouldn't have to do that.
Yep. And that goes off and refers to the instance of P we have.
You're right.
And we'll call the employee constructor of type person. And that effectively goes out and calls the getters on the person object and stores it back into our inherited first and last name values that we took from the person class.
Yep. So now
we just drop those down. So it really shows, how crazy and how inventive and how free you are to do whatever you want with these class definitions and inheritance. It gets really interesting.
That's so beautiful.
Yeah.
So now our employee has absorbed the person that we passed it. How beautiful is that?
So I hope you enjoyed this.
Wow, yeah.
It's a lot of fun. And now you can, basically you're the master of the universe now. Now you know how to make the whole order of evolution of life of your own development ecosystem, whatever. You're Charles Darwin, up and running. Hello and welcome to Programming in C++. Now we're going to talk about namespaces.
Let's do it, dude.
You've now officially gone over the hump.
You've done it, my friend. Congratulations.
Yeah. We're past all the crazy stuff, even though polymorphism wasn't really that difficult, but it's still the end of the meat and potatoes of C++. Now we're kind of onto the easy stuff. So from here on out, it's just smooth sailing. So just as a recollection, in C++, namespaces are a collection or a container of entities, just like we talked about before when we said, the universe can be a namespace, and within the universe is a solar system, and that's a namespace. So if we want to refer to Earth, we could say universe
Galaxy.
Galaxy, solar system, Earth, person,
Right.
colon.
Fingernail, cell, skin cell.
These entities within a namespace can be variables, it can be objects, functions, classes, other namespaces. So we'll see how to actually implement a namespace in C++.
My goodness.
I know, I love this transition from the concept to the actual. It's so much fun to see it really come to life.
Yes.
All of the different concepts.
I feel like Zach Moore is sitting on a hot chick at the max right now. I'm just in heaven.
I feel like his scheming scenes.
Nice.
Really? Anyway. We declare namespace, the word namespace, and then the namespace's name.
It's got to be more complicated than this, Brian.
Right.
Something so abstract and so scary sounding as namespaces has to be more difficult.
So all of our classes, all of our methods of the classes, all of our variables, our object definitions, or whatever, all get jammed inside of this code block, and that code block just has the namespace, solar system, whatever.
I still don't get it. It has to be more complicated than this. I got to see an example.
It's really just a way of labeling, your code.
I still don't believe you.
There's two methods to access this.
How do we do this?
I don't know. You tell me.
I don't know. That's what I'm asking. I'm the student. I'm the pupil.
You either evoke or you use.
Oh, what does evoking mean? Am I bothering you?
Why every day? Evoking a namespace calls a namespace directly, so we call it out by name. We say namespace name, function within the namespace. So we directly say solar system, Earth, person. And if we say using, we can say we're using this namespace. From here on out, I don't have to say I'm using this namespace. I've already declared that globally. That's what we're doing now. So if I say using solar system, I don't have to say solar system, Earth.
Yeah.
We just say Earth.
Your code has swum into the solar system.
Exactly.
So it just assumes when I say Earth, it's, oh yeah, Earth is already in the bubble that I'm in. Let me just go swim over there real quick.
Basically.
Here's an example. Oh my goodness, it is that easy!
Wow.
This doesn't make any sense, Brian. I'm so scared. So inside of this namespace, instead of having a class definition or whatever, we have an instance definition. So an integer of whatever, 100. In this case, if I want to access this integer, now I'm evoking it. I'm not assuming it. I'm saying, namespace? Yes. Can I please have access to your members? Sure. Which member do you want? I would like to have N. Here you go. How beautiful is that? That's exciting. And a little scary.
Namespaces are really dopey, aren't they? Of course I can.
You know why they're dopey? Because functionally they do nothing.
Hello, little sparrow. You can rest on my branch for the evening.
Well, but functionally, what does a namespace do other than deliver you something that you ask,
It's great. It's awesome.
It's beautiful.
It's very straightforward.
Beautiful.
See, we told you got over the hump.
Yes. And it's so funny. Namespaces sound scary, but look how simple this is. Now, Brian, this is actually embedding a function inside of a namespace.
Nice.
And an instance of an integer inside of a namespace.
So now my namespace has not only the integer of 100, it now also has the function getNumber that returns an integer. So in this case, we just say my namespace getNumber. We call it just like we called then, and we pass it the parentheses and say no parameters, just like we would anything, just intuitive, just like you'd expect it to be. You also notice we're saying std : cout in the same way.
Right.
So that's the namespace call that we've already seen before.
Right.
We use it exactly the same, but now we're defining it as we go.
Right, and cout is just an instance of a class inside of the std namespace, just like the n is an instance of an integer inside of the my namespace.
Absolutely.
Beautiful. Now here's a really ridiculously awesome example. This is embedding a full class inside of a namespace.
Yep. So we have my namespace, the namespace, and inside of that we have the person class.
Yeah.
The whole definition
the
of
whole
the class.
thing is just jammed
all
in there.
thrown up inside namespace. But this is where it really starts getting great for organization.
Right.
Because now we can have a whole series of classes and other types of functions in a namespace. Now we really can start orchestrating our kind of ecosystem of classes.
So beautiful.
And as you see down below, when we call to instantiate P, we just call my namespace : person.
Right. Gorgeous. Now, what if we had an external code file that contained the person class?
Interesting.
We can actually use a preprocessor directive to suck in the code and
awesome.
just jam it inside of the namespace.
I didn't know that. That's really cool.
So awesome.
Learn something new every day.
Yeah, it's so beautiful. And that means you don't have to have like the jarbled mess that is pulling full class code inside of a namespace. You declare a namespace and just include external code. It can't get any more beautiful than that.
That's great.
Now here's an example of having a namespace inside of a namespace.
It's like one of those Russian dolls.
Yes, you open the doll, there's another
Smaller
doll.
one,
Yeah, and then on the inside, there's like a note that says, why the hell did you open up all these dolls?
That's a good idea.
I know, because I have Russian heritage, so when growing up, my grandparents had like 50 of those Russian dolls, so when my brother and I were little kids, we would always put a note for each other in the smallest
That's
one.
awesome.
And it was always something like really gross, you know. I'm not even gonna say, we've said some bad things here, but I'm gonna keep that private. You got a friend function. You don't get access to my privates. I'm going to call the my namespace by my namespace. Then I'm going to use the scope operator to get access to the person class, which is defined inside of this CPP file. So now I have access to a person. Now, in the next one here, I'm going to call my namespace scope into the other namespace inside of it, which is called my other namespace. And inside of here, I'm going to access the get number function.
And the advantage that this has is if we, for some reason, need two different get number functions, and we want them to be in different namespaces, but they're still all within the realm of my namespace, we can actually do that so long as they're declared in separate sub namespaces.
Right.
Now we'll take a look at using namespaces. And using namespaces is very similar to evoking namespaces. It's just sort of like a lazy way of doing it. We sort of globally evoke a namespace.
Yep.
So let's take a look.
Now, we're all very familiar with this code right here. We've seen it a billion times. You don't really need us to go in depth. We've explained it 1,000 times. But this is an example of evoking. And now, when we use the namespace, we call using std, and we don't have to call the namespace anymore.
Right. So before we had std : cout, and now that we say using namespace std, that's just a given. Now from there on out, all the way through or in main and any functions that come below this, we never have to say std : again. It's just assumed to be the case. And that includes this entire main function. So anything below when you declare using namespace, it's defined just like anything else, just like you define a variable, it's within the scope that you declare. And since this is in the global space, the most global scope you can have, it's anything beyond that.
Now, one thing to keep in mind is if you write a class that assumes, like cout and that kind of thing, you have to declare it after using namespace. Because this is within context for everything south but nothing north.
Right.
Just throwing it out there.
And here's where we're using namespace standard inside of the main function. So that's not globally accessible. That's only accessible within main.
Yep.
So only cout, hey buddy, and return 0 have access to it. If we have some other function definition outside of the main function, that won't assume to be using namespace standard.
Never heard of it. Who's STD? I have no idea who this is. So here's kind of that example of what Brian just said. In the bottom one, when we had the using namespace, we can access this, so we can just call cout, just like we did in the last example. But when we call the print line function and says, aren't namespaces awesome? It doesn't have access to that, so I actually have to use std : to evoke the string class and the cout and inline instances.
Exactly. Now here's locally using namespaces, but this time an arbitrary code block.
We haven't discussed, Brian, what is an arbitrary code block?
An arbitrary code block is just a code block for no reason.
Yeah.
Really.
It belongs to nothing.
You can use code blocks just because you feel like using code blocks. Some people use it for stylistic reasons. We always say you should really focus on developing your own style of doing things because that's what makes you unique. That's what makes you your own uniquely valuable programmer. Even though you have standards and naming convention, you still want to have a lot of people with like a nice, versatile, diverse range of having styles of programming. And those styles might help you to solve problems differently. And one of those stylistic elements that don't really have impact on the function is the arbitrary code block.
Yeah.
And so, not to declare anything, but just to stick things in a code block, as you see on the right, where we have int main, and then we just create a namespace person p, WiBit the frog. And then after that, for no reason at all, we just start using a code block. But inside of these code blocks, that's still a scope definition.
You're defining scope when you define a code block.
And so when we look in here and we say using namespace standard, within only this start and end of code block, we're using namespace standard.
Yes, it's only assumed right there.
Yep.
Oh my God, C++ is so gorgeous.
And in this other code block, we're not assuming to be using namespace standard, but we are saying using namespace, my other namespace.
Yes.
And so when we say cout inside of this code block, we do have to see std : cout.
Now, when we do this one too, when we do my namespace : my other namespace, my namespace is not also assumed. It's only the specific namespace that you're calling.
Yep.
Wow.
And that's effectively namespaces.
That's it.
It's pretty straightforward. It's just a label. You can use it however you want. It's for convenience. If you really want to say std : every time you say cout or do anything in the standard, you can.
Yeah.
If you really want to be explicit and you're kind of anal and that's your style, that's your style.
Well, that's
cool.
fine, because you'll see probably equal amounts of code that do either or.
Yep.
There are some people that don't even know how using namespaces work. And this is a very powerful tool that you can use in C++ to not only assume namespaces within the particular scope that it's relevant, but also creating your own namespaces to categorize your classes, your functions, like all the things that we said during this presentation.
And now go out there and use namespaces for fun. Do stuff like, I don't know, maybe make something that's like 300 namespaces deep and see if it has any performance implications. So do very rapid calculations, 300 layers deep in namespaces and one that's using the namespace, and see if there's any performance difference.
Yeah,
I don't know. Maybe not.
You really, really have to have no life to do that.
Yes.
Yes.
But if you find that fun, go for it.
So why don't we have a social networking website called My Namespace?
I think we will.
Yes, that's the next project.
Yep.
With this live video, Brian and I want to demonstrate a basic example of using a namespace and the reasons why you would use a namespace and how to access a namespace.
I completely with Kevin.statement.
Or I believe with Brian :
I just didn't want to say Kevin : That was just too weird.
and Brian, you were saying a little bit ago why this is important, so maybe we should hear what Brian has to say.
When you get to Java, when you get to C#, a lot of stuff that you'll take for granted as language functionality will actually just be functions in a namespace. So
more so C# than Java, because Java has the whole package thing.
Yeah.
But C# definitely.
Yeah. So in C# you might say something like console.writeline over and over and over, and you'll think console.writeline is just there. But it's not just there. The only reason that works is because you're saying use system IO. And so that says to use the namespace system subnamespace IO and give you that.
So we're going to kind of demonstrate one reason why you would want to use namespaces, and the first reason we're going to demonstrate is method or function conflicts. So we're going to just do a quick, let's save this one as, should we just have it in its own code file?
Yeah, sure. Namespace
test.cpp. We'll just do this in one code file.
That's fine.
Let's do something crazy, Brian.
Okay.
Let's even though we're in C++, let's use some C code for this example. stdio.h and string.h.
Okay. Cool.
It main and return zippy. And what we're going to do is, wow, that looks a lot bigger. C++ awesomeness.
That's
G
what she said.
Plus,
I don't care if the timing wasn't good.
Namespace. Tacho. Namespace.exd.
Oh.
Exe. There's no main. What is that all about? Oh, I didn't save it.
Oh, yeah. I was like, that looks...
Okay. So, as you can see, Bri, we have pulled in string.h. So if I want to do something like this.
And it knows exactly what to do.
Yes. So then we'll do
D, that's right.
String length, length. So hopefully...
You'll print the number in a new line.
Yeah, if my typing was correct, it's depreciated. All right. So we've got the length of the string. Cool. Now, let's just say that I have a series of functions that I wrote.
Okay.
And
one of them maybe accidentally being in string length.
Exactly. And if I do something like, I should have a conflict. Right? So we have a conflict. Because
It's saying, why are you declaring this? We already have this declared.
Exactly.
What the deal is, man. What the deal is.
So one thing that I can do is encapsulate this inside of a namespace. Because Brian is the only person that I know stupid enough to write a function called strlen.
That just returns 0.
It just returns 0. So at this point, we can run this functionally, and it works.
Yep.
Now, if I wanted to then evoke this fella, I need to scope into Brian's namespace.
Yes.
And how do I do that, Brian?
With my namespace, and then colon.
I like to put spaces here, but
Yeah.
not everybody does.
No.
So I'll just kind of.
I like it that way.
So now when we run this, we're going to get 0. And we do.
Cool.
So that's one really good example, because Brian and I, in our time as developers, have actually been in this situation
Found it, yeah.
where we pulled in APIs that have overridden other methods and classes that we've written.
So what do you do?
Scope in. All right, and Brian had another example that he wanted to do, and I'll just kind of slide the keyboard to him, and he'll make it ha-ha.
So this is so that if you see this down the road, you'll be sure to know that it's a namespace.
Mm-hmm.
I'm going to call the namespace system, and then inside of that namespace, I'm going to have another namespace called IO.
Mm-hmm.
And then inside of this, I'm going to have a class called console. Inside of that class, I'm going to have a function, which I'm not really going to prototype or anything. I'm just going to define.
Make sure you make it public first. Now, remember when we talked in the class video, we mentioned that there are multiple ways to define a class. The standard way that Brian and I advocate is to prototype and then implement. Brian's doing it the quicker way, I guess you can say. You have to include that within the namespace. So pull that in. That would be above class.
Yeah, thank you. My bad.
But you don't even have to do that. We already have C, because you can do it. Printf.
Okay, yeah, I'll just do that. Why not?
Yeah.
Ooh,
But what Brian was trying to do is, if you want to include, you can include it within the scope
just within a
of the
scope,
namespace by defining it
Just
inside
so you
the
know.
IO namespace.
Okay, so we'll call this right line, and this will take in.
Right. And again, Brian's not defining this. He's implementing it in the definition, which is
Right.
perfectly legal syntax, but not best
Not-
practice.
yes,
Yeah.
no. But we're just demonstrating the point.
Mm-hmm.
Chill out, people. Chill out.
I think we've had a little too much of that today.
Let's see. So I want to say printf, and then this is going to be.
Close.
Where am I?
Yeah.
This.
Mm-hmm.
Okay, so this will take in the string, the char star, and it'll print it, and we're going to call that
Mhm.
static method right line.
Cool. Let's save it, and let's do a quick compile to make sure that
Okay.
we're syntactically adequate here. Okay, that's fine. All right, Brian, let's implement this code.
Okay, so now all we're going to say is, oh, come on, Ted, come on. We're going to say system.
All right.
Dot,
Oh,
yes.
What language do you think this
God.
is?
Console. Right.
At that point, it's no. You're right. It's a colon. But the thing is, that has to be a static method.
Right line. Hey, buddy.
Yeah.
And I don't put a new line at the end of this.
Mm-hmm.
So that should be legal.
Let's see.
Unqualified identifier before right curly token. Am I missing a right curly? Doesn't look like it.
Line 23.
Oh.
Oh yeah, good catch. Why didn't it catch that before?
I don't know.
That's weird.
Whatever. Sometimes when you think about something, it makes your brain hurt. Now, I should be able to say now. Once we get to this point, what we should be able to say,
Mhm.
unless I'm crazy,
Mhm.
should be able to say using
Mhm.
system
Mhm.
IO,
Right.
and then down here I can just say console right line. Error. Console has not been declared. Yes, it has.
Do colon console maybe at the top.
Okay, I'll try it.
There we go.
Weird. Oh well, whatever. So what I was hoping to show is that in C#, what you will often see all the time is looks like this. You're
Right.
going to see that all the time in C#,
Mhm.
and that's the same thing as this.
Right.
Make
And
no mistake about it.
And in Java, you're going to see import. So they do type
Yes.
import java.io.star.
Right.
Same concept, although technically they're very different.
Yes.
But the concept is the same.
Yep.
Yeah.
Welcome to Programming in C++.
Yes.
We're talking about templates.
Templates! That's what I'm talking about, Brian. So let's talk about templates. Now, we've already spoken about templates in the intro to OOP. So maybe you could help refresh my memory since I'm having a hard time remembering what a template is.
You have different data types. One can be an integer, one can be a string, one can be whatever you want it to be.
Yes.
If we had a generic data type that just says, this is of some data type, that's a template. So if we have a function that returns a data type, we can say this function returns some sort of data type. We're not actually going to explicitly define it. Or this variable is of some data type.
Yeah, or this class can make use of some generic data type. It can be used in many contexts.
It's the not explicitly defined data type. It's a template.
Gorgeous.
Yeah.
Gorgeous. I love this language. Here's an example of a function that uses a template. Now, the way that we define this is we say template, and then inside of these greater than, less than symbols, we have the word class, and then the following thing is the data type. Now, in this case, it just equals DT. Now, for any of you guys that may be a little confused about DT, that's just arbitrary text. As long as it's not a keyword like for or if or class or union or any other reserved word, that can be there. So DT just represents whatever data type this is going to end up being. So in any other place within the scope of this function, including the return type and the input parameters, wherever we see DT, that's just swapped out with that data type.
The data type that we passed in.
Exactly. So this param is not, it can be anything that has a cout or insertion operator overload can be used in this function. Now the important part of the previous example that we looked at, Brian, was a template parameter. So how does the template parameter thing work?
The template parameter just means that the parameter that you pass in isn't explicitly defined. Normally when we define a method or a function or something, we say that the parameter is going to be an integer and it's a string. And we can overload it and have a whole bunch of them, a whole bunch of different types of configurations. In this case, we're just saying this particular parameter is of some undefined data type. It's just a placeholder. But this can only mimic one data type at a time, so you can't say, I want to pass in 3 data types of different types generically.
Right.
You can only use it once. Because, it's abstract. You can't go too abstract that the program doesn't know how to handle all the circumstances, but there's a way around it, so we'll take a look.
Okay, now here is that template example that we were showcasing before in action.
Here we have template to declare that this is a template, class DT, and then DT, which is also the general abstract data type parameter for the parameter as well. When we declare integer and set it to 50, we say printline n. Now printline is the function we defined at the top. That function we defined at the top doesn't have a data type. It's just some undefined data type class. And for the sake of defining the function, we just say DT. When we pass in printline n, we pass in integer n. What if that effectively does is pass in as data type integer, comes down, and says standard cout param, and cout will take in it as an integer, not as a generic data type. It'll actually take it in as an integer because what you define that to be is driving what that abstract data type is going to be temporarily defining itself as. Similarly speaking, we can say printline double, printline char. And in all these different cases, we keep saying printline. We didn't define any different functions. We didn't overload it. We didn't have it with different types of parameters because cout can handle a parameter being an integer, a double, a character. It's fine with that. You can pass it whatever you want. And we pass it into that template function, that template data type in the printline function. It'll take whatever we give it, it'll just move it right onto cout, and it'll handle it.
And it will even take a string.
Yeah.
Now, in these examples, we didn't actually use a template parameter. We just used the power of C++, of its ability to figure out what the data types are on the fly. But we can specify these. And when we take a look at this next example, these are a few different ways that we can use this template. And this is a different function altogether. In this case, instead of DT, just to show you how arbitrary this text is, we now have underscore UDT. So it's just our little fun way of saying this is a user data type. Yeah? So when we have class UDT, the return type is going to be UDT. So we're actually going to be expecting a return, a result. And then the input parameters, X and Y, are going to be UDT, whatever that data type is.
And because the return type is of the same data type that we pass the parameters as, whatever we pass those parameters in as is what it will be returned as. And the two parameters, because it's abstract like this, whatever we pass one of those parameters in as, it has to be the other two.
And for those of you that recall our recursion video, this is the GCD, which is a recursive function. You like that?
Nice.
Fun stuff. In this case, when I say int GCD1 equals GCD 100, 90, because the C++ is able to recognize the input as an integer, UDT will be an integer during this execution. Now this is an example of using the template parameter where I specifically say, I don't care what the parameter is, this is an integer. So UDT is going to be explicitly set as a integer in this case. Here I'm just going to use this pretty much the same example as before, but the output is going to be typecast. So this is another way that I could just make it into a double if I want to. And then lastly here, just another example where I use long as the template parameter.
And as you see, because long is used as the template parameter, GCD4 is of type long.
Yes. Precisely.
It's cool. And in this case, you just saw, we can either pass in an integer, or a long, but you didn't see us pass in an integer and a long. Because it's generic like that, because it's abstract that way, just like whatever we took in is what we returned, we can't take multiple data types when we define a template. It's just one at a time. There is a way around this. If we can mimic one data type, then we should be able to mimic two, right?
Yeah, at least two. Oh my goodness, Brian, look at this mess.
This is getting crazy.
Oh my goodness.
So really, when we break this down and highlight it and segment it off, it doesn't look quite so bad.
Not scary at all.
Here we have a template, class return data type, and then class data type 1, class data type 2, or DT1, DT2, call it whatever we want. And this is for the function getMin. And we can pass in the parameters here. We say that the return data type is return DT. And that's whatever we want it to be. And that works because integers can impersonate longs.
In this example here.
Right.
So our return data type on the bottom, our first parameter is long. So our return data type is long. Data type 1 will be an integer. And then data type 2 will also be a long. And these are all comparable data types.
So you have to really be mindful when you're doing this, so that you don't kind of convert or imply something incorrectly. So you do have to be a little delicate in how you use this. Then the parameters we pass is DT1N1 and DT2N2. Now in this case, we are calling this down below. You'll see longmin equals getmin. The long is the return type. Then the integer, which is DT1. It's in the order that we define these data type definitions. This is an integer. So now that's how we're going to be using it that one time down below.
And also the parameter passed in the function below, where we have getMin, that has to be an integer.
Right.
Because if you look at the template for the function up top, the function that says DT1 is this. So that has to be an integer because the template parameter specifies that it's an integer.
And then we do the same thing with the long, which is n2. So we're passing in an integer and a long value. And that will return us back the long value.
Wow.
It's pretty cool.
That's beautiful.
Yeah. Just as a reminder, when you're using objects with templates, and you're doing operator overloading, anything like the plus, the minus, the multiply, divide, whatever, those operator overloads must be defined.
Yes.
And if you're calling the same method, then that method overloading must be defined as well when dealing with generic templates.
So recall the person class that we've used a few times throughout these tutorials. We just have the person.h that has the first name, the last name, the setters and getters and constructors. Now when I want to run this templated code right here, where I have a function that's called add to objects. My template, my class DT is going to be whatever, and these data types must have a plus overload. How do I know this? Because I'm using the plus operator. In the code below, where we have integer n1 equals 50, integer n2 equals 250, and integer n3 equals add two objects, and my template's parameter is an integer, so dt in this execution is going to be an integer. 50 plus 250 equals 300. Now we know we can do this with integers because we've done it a billion times before. But if we try to do this with that person class that we just looked at, it's going to fail because there's no plus operators.
And it's the same kind of failure we've seen before.
Yeah.
When we tried to add two persons together without overloading the operator.
Yeah, we haven't defined what adding two people actually means. Yep. So in this case, even though this is nice and generic and it's cool and whatnot, it doesn't function for this purpose. So this is something that you have to be aware of when declaring generic functions. Oh boy, that was a good one, huh?
Yeah. Generic functions are one of those things where you just have to keep abusing them, but it really cuts down on the number of lines of code. which is really what you want to always be after. It's coding elegantly, not coding in these weird ways. You don't want to use templates in unnecessary circumstances just because you can.
Right.
You don't want to make it unnecessarily complicated, but if you're really breaking out the same method 10 different times, you can handle a string and a something and a something and a something, and it's effectively doing the same thing every time.
Right.
Or you're handling all these different cases of extended classes that you made. Just make a template, just keep it generic, keep it at a high level. It really starts letting you use these objects in a more of like an orchestration sort of a way.
Right, like a really good example of a template that you can use on a function would be, remember how in C we wrote those sorting algorithms?
Mm-hmm.
Well, in the sorting algorithms, what operators do we need? We need the greater than and less than operators to exist. Well, let's just say that you had a class of some, or an array of some class that you've made that has those two operators that overloaded and defined. Well, I can send it to a bubble sort and it will just work. Yeah. I can send an integer and it will work. Yeah. I can send anything I want to the bubble sort, the selection sort, the insertion sort, the shell sort, and it will work flawlessly.
You won't have to re-implement the entire sort functionality for every different type of object.
And that's a really good example of
awesome.
using that.
So have fun with that. Welcome to Programming in C++, our video on static members. Everything we've been talking about so far has been very polymorphic and flexible and dynamic and fluid and stuff.
Yeah, man. It's crazy.
Then we're getting into generics and templates kind of all over the place. Now we're going to talk about static members.
Oh, this sounds very corporate.
Yes. Static members are great. It's not something that comes with your objects. When you declare a class, you have static members in your class, but it doesn't come with your object instantiation. It's not a member that's accessible on your object.
So a review, Brian. What is a static member?
Like I just told you. Weren't you paying attention?
Well, I know, but I want to hear it right now. I didn't want to hear it then. My brain is ready to accept the information right now.
A static member is part of a class, just like anything else is, but it's not part of the class instance.
Yes.
So
class level access.
Yes. So you could probably immediately, light bulbs are going off in your head and you can see why it's valuable. So the example that we always harp on with this, just to give some sort of visual with it, is you can have a person class, a class of type person. And when a person is born, there's a population. A person won't have a population.
Because a population of people is not a property of a single person.
Right. So population is something that's on the class level, not on the object instance level.
Right.
Now when somebody is instantiated or when somebody is destructed, it does, though, have an effect on the population.
Mm-hmm.
Just like when somebody's born or when somebody dies. So the human population is a property of humans, not of a single human.
Exactly, right. So Brian's name is not a property of all people. Brian's first name is a property of the instance of Brian, but it's not a property of all people. His first name has absolutely nothing to do with me. I don't give a about his name. I don't care. But when we declare a static field inside of a class, we call it static.
So everything in C++ always seems like it's going to be so crazy and so convoluted until you actually see how it's done. It's all, how do you declare a friend function? Friend. How do you declare a static variable? Static. How do you declare if it's public? Public.
Well, yeah, but here's where it gets complicated. When you want to make a static method,
it's easy.
You call it static as well.
It's like intuitive. If you want something to not come down with the object instance, you want to stay at that class level, just say static.
Why can't this be hard? I want to pretend like I'm smarter than people. Okay, this is making me look stupid.
Well, that's what Visual Basic's for. It's for pretending that you're smarter than people, but have it dim. Like, what the hell's dim mean? I don't know. I'm going to dimension a variable. I'm cool.
Now, you remember the person class that we've been talking about a few times, yeah? Just ding, ding, ring some bells.
So we have our setters and getters or whatever. You've seen this before.
Yeah, now, Brian, the person class needs to have a population.
Yeah.
So let's go ahead and let's throw a static population in there.
Okay.
Boom. That simple. Right here in the private section of our class declaration, we're calling a static, unsigned, long, and we're calling it population.
Because we could have 41 billion people, 0.5.
Yes. We could have 0.5 of a person.
Yes.
Yes.
They're called midgets.
Yes. Okay.
Yes, I said midget.
I'm just going to wait for you to get it all out.
Static unsigned long is going to be a population.
Yes.
A population can be huge, so we leave it unsigned.
And it has to be a whole number.
We can't have negative population. That would be ridiculous.
You can't have a negative population, and you can't have a fraction of a person, because if you're a fraction, you're probably dead. Now, at this point, we have a static method. Wow, this is so hard. Static unsigned long. Oh, wait, never mind. No, it's not hard. So now we're just declaring an unsigned long method as static. So now these, when we create an instance of a person, these just hang behind. And they're able to be manipulated by the instances, but they aren't part of the instances. So every time that an instance touches one of these values, it's affecting every other instance that have access to these values. Beautiful.
So is it different looking when we implement them, or does it look exactly the same? Let's find out.
Let's see what's happening here. And the implementation, let's see here.
No.
Oh, okay. Here in the constructor, when a person is born, we increment the population by 1, whether we give them a name at birth or not. Or it's going to get hard here. Ready? Oh, damn it. When a person expires, or when the destructor takes care of the person, think of the person as the destructor here as death, we take the population down by 1.
And that will affect everything in that class. It's affecting it globally. So static things are really globally defined when we call the class, when we include the class. So that population is going to be affected from every object instance, but stored globally.
Right. Now, this is the method that gives us the value, and we don't have to do anything special here. This is just an unsigned long...
We've already declared it static. We just, say the data type that's returned and the name of the function.
I really thought I was going to outsmart people when I saw this one come up, but apparently not.
No.
Now, down here, this actually is important. When we create our person class template, we have to set that value as 0. Because inside of the template, it's set as nothing. So if we do nothing plus plus, you may end up with a number that you don't want. Because remember now, it's just going to pick some random memory space and occupy it. So when we create our program that will be using this, the population is 0 and nulled out, nice and clean. And pretty.
That static unsigned long definition in the header file can't start with an initial value. And because the constructor is being set every time an instance is set, we don't really want to wipe this value out every time with a constructor. So normally we would initialize the value to like 0 in the constructor. But this time we don't want to do that because every time we create an instance, we'd set it to 0 and then increment. That'd be dumb.
Yeah, it would be stupid.
So we declare this, we initialize this to 0, kind of like we would when we globally define something in like a main function or above the main function. We just kind of globally declare it like that. So we say in our implementation, just by itself, it is an unsigned long person, : just the population, just that variable name, equals 0. We just do it just like that.
Right, and this works the same exact way that we access methods inside of a class. The data type is unsigned long, and then the person is the object it belongs to, and then : we're setting the scope, so we're saying inside of the person class, there is this static property, or this static field, or whatever.
Every time we call the constructor, whether we call it with no parameters or with parameters, we just simply increase the population by calling the underscore population, and that refers back to our static attribute or static field. And similarly with the destructor, we decrement it with the population minus minus. Because when somebody dies, the population decreases, and when somebody's born, the population increases. And when we get the population, we access it just like that, the same way. We just return underscore population. It has access to that class level.
When does this get complicated? It has to be complicated. Here it is.
I don't know. There's a lot of things going on.
This is where this is the trick. This is why nobody knows all this stuff. This is why we're the only ones privileged with this information. Yes. Let's take a look at a program that actually makes use of this, and I think it's Brian's turn.
All right.
So let's see how smart Brian is.
Right off the bat, just like we were talking about, population starts off with 0.
Yes, before anything happens.
Right. So when we say just the concept of include person, that starts it off, population is 0.
Yep.
We'll print out person, not an instance of a person, just the name of the class, : get population. So now that's a class level access, just like we would do it when we do our implementation file and get access to things in the person. We do it here. We just say we've included a person, we know what the person class is by definition. Before we've ever instantiated anything, we just say person, get population, and it's 0. That's the initial value. We have access to that global value.
Absolutely gorgeous.
So now let's create an instance of a person and see what happens to population.
And this uses the default constructor, gang.
Right.
And it just does population plus plus. Look at
Yep.
the upper right. You can see.
Yeah, it's great. And now when we
man.
say person get population, now it gives us 1.
Beautiful.
It's awesome.
I'm so excited.
Now let's do another one of a new person instance. So person P2, we do P3, the population just keeps increasing every time. That global population, that static population attribute keeps increasing. So now it's up to 4. Now we call print the persons get population. Now we get 4.
Beautiful.
And so now we're really interacting with that static class level attribute. Easy. It's
now,
awesome.
now people are going to start dying.
Uh-oh. Now the plague comes. The bubonic comes.
Oh, no.
Oh, population decreased. Oh, population decreased. Now we get the population. Now we have 2. So now we can kind of keep track on a class level.
Mm-hmm.
That static attribute, no matter what we instantiate and destruct. A couple more, and now we're back down to 0.
Oh, goodness. That was a bad plague.
Yeah, it wiped everybody out.
Wow, Brian. I mean, you could probably start just thinking about how many times you would use a static method or a static field. They're all over the place in software development. I'm pretty sure that you've even probably heard the term static class. And a lot of times all that a static class is it's a class that contains static methods.
Mm-hmm. And sometimes you want to declare a lot of functionality that you want to include in your program, and you put it in a class, but the class isn't something that you necessarily want to instantiate. Like a logger class sometimes is something you don't want to have an instance of the logger class.
But you still want to have the same flexibility of having a class, right?
So you might want to say something like log : info, pass a parameter, pass the string, and now you've just sent an info message to the log. Mm-hmm. Something like that. Welcome to Programming in C++. This is our video on threads.
Yes, threads!
How exciting.
How very exciting. So just like many of the other concepts that we went over, threads can be something extremely easy, but they can also be something that is very complicated. Mm-hmm. So how you define a thread depends on the situation that you're using the thread. So if you're doing something simple, why do it the hard way? You can just do it the simple, easy using the C macros, which we'll show. But if you're doing something that requires a little more, you want to create multiple threads and all kinds of crazy things, then you could use the other method that we're going to discuss.
In this video, we're only going to show Windows threading.
Yeah, so sorry, Mac and Linux people.
Yes, you can just...
Hey now, everybody. Calm yourselves.
What the is this? What are you guys, Fox News? MSNBC?
The truth is, guys, for us to go through every operating system and show you all that, I mean, do you want a 9-hour threading video? I don't want to record a 9-hour threading video. We'll just kind of go over the basis. Since this is kind of a Windows-based, video series anyway, we'll just use the Windows.h header to create our threads. So sorry for anyone that's disappointed that we're not teaching Mac and Linux for this.
There are a lot of ways to implement multi-threading. Just like any robust language, C++ has a ton of ways to do this. The simplest way is to just use the _begin thread function, just like in C, provided by the process.h header file.
Yes. So Brian, here's an example where we call that. So maybe you can kind of walk us through this.
So first we define the function that our thread is going to be, which is just going to be called myThreadFunction.
Ooh, how clever.
I know. And we're going to pass it a pointer, which is always going to be typecast as void. All our function is going to do is basically just start with an integer and sleep for some span of time based on the parameter that we pass it. Typecast as an integer, and then print out when the thread ends. So we'll just take the current time when the thread ends, print out that time.
Yeah, and that int_ptr type is defined in Windows.h. Now, there are multiple of those. Basically, what that's doing is that's taking a void pointer and taking its value and converting it to an integer.
Awesome.
Very awesome.
So in the main function, we print out the start time of when the program starts to execute, and then we create a handle of our thread, a handle instance.
Wait, is his friend handling the thread?
It might be, I don't know. So a handle can be of any type of object, any type of resource.
Yeah, why not? That sounds about right.
In this case, it's going to be we're going to attach it to a thread. So we're going to typecast the result of begin thread, passing it our function name.
Ooh.
Now, because this isn't a method, because it's not in a class, because it's just kind of within the same scope, we don't really have to pass it by a pointer, by reference. We just pass it the function name.
Right, because the function acts as a pointer when it's within the current scope here. So,
and then we pass it 0, and we pass it the void pointer, and then the parameter that we want to pass it. We always pass it with that void pointer.
Mm-hmm. That way we can pass any data type.
Yep, and just typecast it to what a thread needs to take.
And then basically what we're going to do is wait for the thread to run. And my thread is the thread that we're monitoring. And then the second parameter there, which is, I don't know, 100,000. I think that's either seconds or milliseconds to wait to time out. So the thread, if the thread's taking longer than this to run, just go ahead and shoot it down. And when you look on the right-hand side, we compile the program. When we execute it, you can see that there's the start time. And then you'll see that 5 seconds later, the thread ends.
Nice.
How cool is that?
That's awesome.
Yeah. You want to hear something really up? This also works in standard C.
That's awesome.
So as you can see in this example, all that we did is we just basically converted, we took out IOStream, made it std IO, and then converted the couts to printfs. But it does conform to the C standard, and it will compile and run as a regular C program. So you don't need C++ to have threads. But you do need C++ to have more complex threads, which we'll discuss in a moment. Because right now, what we're going to do is we're going to take the same concept of that thread handle that we just did, but we're going to make an array of threads. So instead of just having one thread associated with my process, in this case, we're going to have 5 threads. We can see that we have a constant integer of thread size, which we're going to just set to 5, just a constant. And then we're going to create a list of my threads with the type of handle passing it the thread size. Then we're going to go through a for loop from 0 to thread size, setting each one of those independent array elements as a new thread to start executing. How cool is that? So now we have an array of threads that are just off floating around, like blah, 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 doing all the consecrated stuff. But these threads aren't that exciting because if you look at the thread function, it's the same thread function that we had before. It's just that instead of passing it a static count of 5, this will stay alive between 1 and 10 seconds, depending on what the random number is in the mood to give us at that particular moment. So as you look at the top, if you were to compile and execute this program, you would just start seeing these randomly flashing, ending, like it wouldn't happen all at once. When one ends, it reports that it's over. And then once that for loop at the bottom completes, then the program executes, because that's just scanning through the threads, and as long as a thread is still alive, it will keep the program running.
So when that for loop goes, if a later thread ends before the thread you're on, as soon as you go to the next iteration of that for loop, it'll just kind of jump through it because it'll see that it's finished. Yeah. So it'll only wait when a later thread is longer. That's awesome. Isn't there a more radical way to do this?
There should be.
A more bodacious way to do this?
There should be. What a lot of developers do in Windows, if you were to run through and read production code or find documentation, you find that a lot of software developers prefer to create their own thread class and inherit from that class in order to create threads. It gives you a lot more power.
That's cool.
When you create a class that you inherit from, obviously you can add more functionality that you want. But the thread class will just have the base functionality required to run the thread in an object-oriented concept. And if you want to throw stuff in there, you do it.
And that's what C++ is all about, is giving you that ability to be very object-oriented. Windows will provide you some of the functions that allow for multi-threading already, but this will always be more clean if you just make your own thread class and inherit from it, and we'll show you the approach. Yeah. It's pretty smooth.
So there's a few things that we kind of have to get out of the way, Brian, before we actually discuss this, just so that you're not completely caught off guard. So Brian's going to tell me, because I don't know what it is, what the hell is the reinterpret cast operator?
Well, it's if the play is really bad.
The play is bad?
Yeah, and you run out of funding. You can reinterpret the cast.
Oh,
yeah. Zinger! Hey, kid, I'll be here all night.
Yeah, you just definitely cleared out the room, and I was the only one in the room with you.
The reinterpret cast operator converts a data type into a pointer, any kind of data type. So, for example, an int pointer can convert to a character pointer or whichever way. We can force a reference to any data type to become another data type without actually typecasting it. Mm-hmm. It just reinterprets the cast. This is particularly unsafe if you reinterpret Class A into Class B and nothing is similar and you just start using it like it's Class A. Be mindful of using this and only use it when you absolutely have to.
And this is like one of those things like a wrecking ball. In the right hands, a wrecking ball is a tool. But if you gave me a case of beer and a wrecking ball, there would be some horrible things happening. So this is one of those things that if used properly, it's a great tool. But when you have a couple of beers and you use it, it may cause a problem.
They'll also give you the create thread function, which is great. And that's the primary function call for creating threads. You can go to the MSDN for more information from Microsoft, because this is Windows 8. We're kind of in the Windows realm of things. Go see what they have to say about it.
And a D word, Brian, we've kind of seen this. We may have even shown a couple of code samples that use this. Now, it's a very common question that when people are getting into Windows API programming, they say, I see this data type D word, but I have no idea what it is.
Like you might see it in the registry, for example.
Yeah. Yeah, exactly. And Windows created its own, like, remember how we were looking in C, there was a class that standardizes integers. Well, Windows did its own kind of thing, and dword is just an example of that. It's an unsigned 32-bit integer, and in computer science, according to Wikipedia, a word is typically referring to a natural unit of data used by a particular computer design.
Awesome.
So that, when I was trying to think of a way to put this, Wikipedia just got into my brain and sucked it out.
It's almost like some people say like an element or like an atom.
Yeah, right.
Kind of, but it's just like a unit of measure.
So when we convert this out of the 0000001 terms into human terms, a word is 16 bits. So a word is a 16-bit integer. And these are typically unsigned. A D word, which is a D stands for double the size of word, is 32-bit.
That makes a lot more sense.
Yeah. And a quad word, Q word, is a quad word, so it's 32 or 16 times 4, which is 64. That is right, isn't it?
Yeah, probably.
Okay.
I don't know.
Who knows? Oh my goodness, we have some code, Brian.
Now here's an example of how we can use the thread class to make this slick way of doing it. So before we had just a function and we would kind of spawn off that function as a thread and whatever. So now we're going to implement it into a class. So here we have a thread class that we define inside of a namespace WiBit. Just for the sake of keeping things organized, we'll put it inside the WiBit namespace. And in the thread class, we'll define private and public members. In the private members, we have a static dword, which is just a 32-bit integer, when API, start routine. And we'll pass this the LP void type, and that's the void pointer. Then we'll define dword underscore thread ID to have a private member that stores the thread ID and another one for the exit code, and of type handle thread handle. So now in our thread class, we can store those three things at any time and have access to them and manage them however we want. But those are the core elements of a thread that we want to maintain. Publicly accessible is the thread constructor, the virtual destructor of thread.
Right. So the destructor is going to be overwritable.
Yeah, which
just in case your thread spawns memory that you want to manually.
And that goes
clean
back
up
to what we were talking about before. Sometimes when you use somebody else's library or use somebody else's headers or whatever, they might have a memory leak somewhere, but you can't override the destructor, and you're just screwed with the memory leak.
Yeah.
We also have a boolean for if it's running or not. Get thread ID, which will return the thread ID.
And it's returning it as an int, so we're typecasting it back to a more cease-friendly data
absolutely.
type. Yeah.
And we'll get the exit code, where after this runs, we can call get exit code on this object instance and see what that exit code was at any time before we, obviously destroy the object. Then there's an unsigned integer start, which start we'll talk about later. But we have start, stop, and run. Start will return an unsigned integer just like a thread ID does.
Yeah, and it is the thread ID.
And then there's the dispose method.
Yeah, and since we use a handle to access the thread, the dispose method will be used to close that handle. So whenever you're done executing the thread, this class structure is designed for you to call dispose at the end. And of course, as you can see, we have run and stop as virtual. So when you want, the main concept of the thread class will not define the run method, because why? Because you are the one that has to define that. We're just giving you the template to define that.
So thread would never be something that you rework to use as the actual thread that you want to build.
Yes.
This is just a kind of a basic mold of what you want to inherit and extend into what you want it to be.
Yep.
But
So
you'll see it in a minute.
Let's take a look at the implementation, Brian. So in this case, that dword when API, that method that Brian was talking about, start routine, is defined first. Now this is defined as static. And inside of this, we use that reinterpret cast operator to take that PV, that void pointer, and we're going to convert that to a type of the class that it is currently inside of.
Nice.
And we're going to use, since it is a pointer, we're going to use the arrow to execute run, which you guys remember, you saw the run method before. So when this first starts, you can see at the bottom run is not defined. You will define that. But this is just saying, I want you to run as a thread the run method. Then after that, we just have the constructor. The constructor just sets the exit code to -1. Doesn't really do much when it constructs. The destructor doesn't do anything. It's designed for either you to override it to undo what you've done, or if you don't use any massive memory usage, like if you're just using integers and chars and you don't have to clean up after yourself, you can just leave it as it is. Running is going to return a boolean that's going to evoke the get exit code thread function that comes from windows.h. We're going to pass it the handle. We're going to pass it a pointer to the dword exit code. And it's going to return a 1 if it's currently running and a 0 if it's not running. and it's going to value execode using a pointer. After that, we're gonna define the get thread ID, which is going to typecast the D word, which is an unsigned integer, just so that we use more basic data types. So when you get it back, you have it in a standard integer format. For those of you that are Windows freaks and that offends you, sorry. Then with get execode, we're going to call is running. Now what that's basically going to do is it's going to like refresh the status of the thread. Because if we don't do that, then we'll never know what the current status of the thread is. And then we can return the execode if it's done running or not. Start will then create that actual handle by using the create thread function that Brian was talking about before. Now there's a lot of things that go into this, but the only things that you should really, keep in mind here is start routine, which is the function or the method defined at the top. This, which is the current instance of the class that we're working in, and then a pointer to thread ID, because it will then value the thread ID when it creates an ID for the thread. It will use a pointer to set this value and then return back to the user the thread ID.
So just to reiterate that, create thread function takes in the parameters to create the thread handle, and the thread handle doesn't need a lot going on. It just basically needs the start routine, which jumps us over to run, that you can override, this current instance, and the thread ID, a reference to the thread ID. So once it knows what that thread ID is, what it's supposed to do with it, and where it's coming from, that's all you basically need, and it's going to spawn off a thread, just to kind of pound that in there.
And when that thread ID function is called, if you look at the top, that LP void, this is coming in through there. Because you can see that we're actually executing the run on this.
Right.
Which, remember, with open recursion, this is a pointer that represents the current, the memory address of the currently executing instance. There it goes. Jeez. Then we have the dispose method.
See, we're getting you into some crazy
It is only going to get crazier from here on out. The dispose method is going to use the close handle function to then just close the handle, keep everything nice and clean.
Done. And then run and stop are left blank so that you can choose what to do with it. You can choose your own adventure. Awesome. So now we have a thread class that can create a thread for our process.
Oh, absolutely.
Awesome. And it's designed to be inherited and extended for whatever use you want.
Absolutely.
You don't change this. You kind of leave this how it is unless you want other generic functionality. But you inherit this and extend it, but we'll check it out. You'll see it.
And it's easy as 1, 2, 3 to implement. The first thing we're going to do is create our own class to inherit this class that we just showcased. The second one is we're going to override the virtual methods. For example, the run, stop, and the destructor. Then we're going to create an instance and enjoy the ride.
Nice. Let's check it out.
All right.
First, we create our own class to inherit the thread class. The thread class, if you remember, was in WiBit namespace
right.
thread. So you can see our class WiBit thread. We'll just say that that's our own thread, and you can call that whatever you want. This is where we start extending it. WiBit thread extends public WiBit namespace thread. Now we've defined a new class, a user-defined class that we're inheriting from WiBit thread. And there's going to be private and public functions. We have our implementation file that includes this header file. That's basically it. We've now just inherited the thread class. Now that we've done that, we can start building out our declarations. So in the template, we can say we're going to have count, a thread name. And this thread, just to give you a foreshadow, is that very similar to what we were doing before. We're going to spawn a thread, count a little bit, print out that it's ended, check to see how long it ran for. So we've been here before, so don't worry too much about what it does. What we are going to store a count and the thread name. Publicly accessible is the constructor, the destructor, set count, which will set how long count is, set the thread name, which sets how long the thread name is as well.
Or sets what the thread name is. You said sets how long the thread name is.
Whatever. Sorry. So, which will set the thread name as well. And then we can get the thread name, and virtual void run will override the run method that was in the generic thread class that we defined earlier. Then if we go over to the implementation, pretty straightforward. We have our constructor, which sets the thread name to null, our destructor, which deletes the thread name because it's a string pointer.
Right. It's using dynamic memory, guys.
Set the count, which just takes in the parameter of count and stores it as the private member count. Then set the thread name. We've taken the thread name as a string parameter. Because this is dynamically allocated, we first delete our previously allocated memory space. Then we call a new string in the constructor. We pass it the thread name. So now we have newly allocated. We've cleared out the old, newly allocated new string space and store it into the private member thread name. Then we have get thread name, which just returns the thread name pointer, and run.
This is the overridden.
Right.
Yeah.
Now this is where it gets very cool. So this is our virtual run method that we're overriding. And in this case, we're going to implement it just like we had before. We have a for loop which runs for however long count is, however many seconds count is, with 1,000 milliseconds per iteration, and print ending get the thread name, and it'll print out which thread name is ending, and then a new line. And then dispose, call dispose, and dispose whatever else.
Yeah, pretty straightforward.
So we basically have taken the previous way we've implemented the thread and put it in a class structure that's been inherited from our kind of neutral, generic thread class.
Yeah, and all the other, like the actual stuff that makes the thread happen is no longer visible to you because that's all private. At this point, as a software developer, when you're implementing code, once you get past the design, you need to stop caring about how it works and move forward. So why should I care about how this thread happens? The thread class defines that. I just define what the thread does, and that's when Brian and I are talking about abstraction and object-oriented programming. This is a very strong case or example of what that is.
So you want to keep up at that 5,000 level foot and then eventually up to that 10,000 level foot and keep building up your foundation so that you can be cruising at that 10,000
Yes, now the thing is you don't want to start this high because then you actually never excel as a developer. If you don't actually know how to write a thread class and you just know how to use a thread, what good are you? You know, when something goes wrong.
You'd be like a Java programmer or something. I don't know.
No, you'd be the VB programmer. If you're lucky to be a VB programmer. That's not saying very much.
Now we create an instance and enjoy the ride.
Oh, baby, this is so sexy. So we created an instance of WiBit thread. Hit it real quick. Does this animate? Yes. Awesome. I got a nice. Good one. We're going to create an instance of WiBit thread and call it T1, not to be confused with T1000. This is just thread. This is just going to be thread 1.
It would be cool if T2 disposed T1. Okay, I don't know.
That would be awesome.
Or we just change the method name dispose to terminate.
Yeah, we could do that.
All right, never mind.
The first thing to notice at the top, guys, is we're including thread.cpp, which is a thread class that we created in the WiBit thread class, which inherits the thread class, creating an instance called T1. And on the right here is our little command prompt, and it's running on a computer with these little processes running all over the place. When we compile and run this program, we create a new little bubble in this maze of processes. And inside of this bubble, we create an instance of the WiBit thread class. The WiBit thread class, we're going to call the instance, and we're going to run the set thread name method, and we're just going to call it my thread. And we're going to set the count to 5, so that means that this thread will stay alive for 5 seconds. And the code that does these two processes are outlined on the bottom, which we had just gone over. Then we're going to write out to the screen telling the user the thread ID. So when we call t1.start, that's going to return us the unsigned integer that represents the thread ID. So if you look on the command terminal on the right in this particular example, the thread ID is 4658. Then we go into the isRunning loop. So this is just going to sit there and scan. Okay, while you're running, I'm just going to sit here and do nothing. This will wait for 5 seconds. Because after 5 seconds, the thread will terminate. But before it actually terminates, it tells us, I'm ending. Because that's what we told it to do. If you look at the code on the bottom, the run code said, write that you're ending right before you end.
Awesome.
And then dispose of yourself. Once it disposes of itself, then we start getting the end of our program where everything deallocates. And it's like it never even happened. Isn't that beautiful?
That's nice.
Now Brian gets to go over the crazy example.
Listen, what our objective is here is to take in how many threads we want to spawn as a command line argument. In this example, we include IOStream, SStream. For later on, we use OString, and we'll show you that. A standard lib, time.h, so that we can get, what the current time is and look at some time. And then we include some of our own, just like we did before, the thread and WiBit thread. So we have that implement. Now let's do something crazy with this. We prototype the intostring function that returns a string and takes in an integer. And the way this works is you take in a number, we declare a string, s, instance, and then we declare a string stream instance, ostring. We then pipe the int n into ostring just like we would cout. Now, if you go to write an integer to the console by saying left arrow integer, it'll cast convert that into a string and send it out. So in this case, we'll do that same thing, but instead of out to the console as a handle, we're going to do it to the string stream and pipe it over to the string through ostring.
Right, so just like cout would, where it converts your data types and concatenates them, this will do that as well. Now, as I looked at this code, Brian, that
we don't need
that
string S. I know. I was just looking at the same thing, but that's cool. It's just for fun.
We'll squiggle that out.
Yeah. It's cool. We felt a little awkward not using the actual string class. We were like, I know I'm just here with your cousin, but, it's fine. It's cool. Whatever. And then we return ostring.str, and that will return us the string from that stream.
Yes, so this demonstrates how the string stream, which is what stream stands for, uses streams to concatenate using the insertion operator.
It concatenates.
Yes, it concatenates using the insertion operator.
Nice. Then we also have another function. Oosha! That's thread is running. This takes a array pointer to WiBit thread type, and an integer, t-list, and count. And if we look through the for loop inside thread is running, it just iterates through everything in our t-list array of WiBit threads. Mm-hmm. Checks to see if they're running. If they're running, it returns true.
If it finds even one that's running, it doesn't even continue. Once it finds one running, it just fires back.
And that's it. Otherwise, it'll go all the way through and return false.
Yep.
In the main function, we start out by saying srand and then pass it now to seed it. And then later on, we say set count random, and that generates a random number. So like we talked about before in previous things, we first seed it and then call it. So that first line is to seed it. This will take in our argument vector, just like we talked about before. So if we call this executable and we pass 3, in argv, 3 will come in, and we'll say ASCII to integer, ATOI, which is in the standard library, stdlib. We'll do that on arg1, because if you remember, arg0 is the name of the program that we're executing, and arg1 is the first argument. And that will convert it to an integer and store it as thread count, int thread count. Then we declare a new WiBit thread array of size thread count, which is our argument that we passed in.
Now remember, this is using dynamic memory, so the program didn't account for this at compile time. It's creating this at runtime.
Which is awesome.
Yeah.
So now we have 3 WiBit threads in this example, or a thread list array of WiBit threads. That's kind of what we're going to use as our like index or our manager of these different threads.
Right. So these blocks here represent each individual thread in the array.
Right.
Not the threads themselves, but the potential of a thread.
So every element in this array is a new thread instance.
Yep.
Now we move through a for loop up to our thread count size. So from 0 to thread count size. And that will traverse the thread list. Every time we do an iteration of the thread list array, we set the thread name to be thread and then the number of which one we're on. So thread 1, 2, and 3. And then set the count. We'll set it to a random number, 1 through 10. And then we'll start the thread. So as soon as we set these, we're going to be starting the threads.
Yep.
These will create the threads and then attach to the process. Mm-hmm. As you see on the diagram on the right, in the computer processes cloud.
Yeah.
Then we say while call thread is running and pass it the thread list and the thread count. So while thread is running, we're going to keep running through the while loop. Mm-hmm. And if you remember back down in thread is running, the only way it'll return false is if it makes it all the way through the iteration of the array and nothing is running. Mm-hmm. Then it'll return false, kick back.
So in this case, thread 2 kills first. Now, here's the thing that's interesting is thread 1 started first. Thread 2 ended first just because it's random. Its random number just happened to be lower. Then, after some odd span of time, now thread 1 kills itself.
And during this time, we're still moving through this while loop thread is running. Mm-hmm. Because there is still a thread running.
Yep, and that's this, well, not anymore.
Not at all, he just, poof, gone.
He's all gone.
So now thread is running is going to return false.
Right.
That's going to kick back and delete the array thread list and deallocate all of that from memory.
Yep.
And then that disappears, and then we return 0, and poof.
All gone. It's like it never even happened.
I know, it's crazy. It's like being a true Boy Scout. Or a...
What?
Or a Bula Scout.
What the
You never leave more in the woods than when you entered it.
I get it now. Now, Brian, you want to see something really crazy?
Yeah.
All right. Now, this example, we just did 3. Just because if we did more on that animation, it would have killed us to make that animation. If we did 20, look on this left side here.
That's insane.
Check this out. Now, Brian, this is really amazing right here because as that thread loop was going through and scanning and stuff, these threads are just sometimes concurrently starting and concurrently stopping because the computer's running so quickly. If you look down here at the second line where it says ending thread 11 and then right next to it
That's awesome.
is ending thread 11. Now here's the amazing thing, Brian. As the console was writing the characters, it stopped and the next one started before it finished the first one. Like that buffer got flooded with some new data because if you look at the quote that's supposed to be at the end of thread-11, it's at the end on the following line.
That's intense. It's almost like the Stern reactor. the particles go so fast when they collide that the result of the collision happens before the collision actually occurred.
Yeah, right, exactly.
We just bent space and time with the console.
Now, this next example on the right, we're going to do...
Or because we're in Windows, the command prompt.
We're going to do 1,000,000 threads.
Oh, yeah.
So you guys can have fun with that.
Crashing your computer.
You can. Well,
maybe, I don't know.
You won't, because I tested this with like 100 million or something
I'm sure
stupid.
It's fine. It's cool.
But it's fun because you can watch 1,000,000 threads run
just
and
like
see how they all do stuff.
That's awesome.
As they're dying, they'll tell you that they're dying. It's good stuff.
So I need to know. I need to be on the side of the fence that's either the right way to do stuff or the wrong way to do stuff, and there's no in between. So which is the best?
You're either with me or you're against me, Brian. There's no in between.
Well, it depends on the situation. The thread class gives a lot of freedom, a lot of flexibility, and it makes for kind of a robust framework to work with. And it's very object oriented. Mm-hmm. But it's not as simple to implement if you're kind of a sissy.
Yeah, well, if like we were saying in the way beginning, if you have a simple thread, like if you have one program that's going to have just basic threads that you're just going to call a void,
then just get the job
function,
done.
You don't really need to implement whatever, exactly. You know, we prefer the class concept. That's pretty much what you're taught in the field or when you go to school, because you just have so much more control over what you're doing. That's really it.
And this will allow you to start developing, we keep talking about object ecosystems. This will start allowing you to set up those ecosystems and keep, once you create your thread class once, you just inherit it whenever you want it, just keep including it.
Or you inherit it and make another one and inherit that one and just keep the train rolling.
You keep building on your foundation, you keep building your own library of your own style so that you can cruise at that 10,000 feet. But in your own way, not in the way somebody else wants you to, so you don't understand what's happening. You've built that process of you're making the plane fly. And this begin thread example has more restrictions, but it's really simple to implement. Right. So, whatever. Do what you want. So we just went over multi-threading, Brian. That is a very important part of computer science, and you will use this in so many aspects of what you do, whether you're aware of it or not. There are so many things that when you develop software, like for example, like when you're getting into Windows applications, whether it's Unix, Mac, or whatever, when you do something like have a progress bar move, that's multi-threading. Yes.
If you don't do it as multi-threading, then the actual process that is the Windows form won't update until whatever process you're done is done.
Yeah.
So multi-threading is rampant across software engineering.
If multi-threading wasn't available every time you use a program, anytime you ask the program to do something, everything would just lock until it finished doing it, and then you could... it's kind of like older versions of iTunes. We're kind of like that a little bit.
What do you mean older? They're all still like that.
Well,
iTunes is the worst program I've ever used.
You go to double click on something and then start playing a file, but you want to change the folder you're in at the same time.
I used to think that I'm running it in Windows. It's designed for Mac. It runs better in Mac. It has to. And then I use it in Mac, and I'm like, wait, it sucks just as much in Mac. Whatever. Anyways,
have fun. Toodles. Ta-ta for now.
Welcome back to the Programming in C++ tutorial series from WiBit.net. In this video, or this lesson, we're going to be discussing delegates, or delegation of code from one class to another class, which we went over in the introduction to OOP before. But now we're going to actually see this monster in action.
Don't get scared.
Oh, wow. You guys remember this?
Oh, yeah.
How this is when we had a TCP class in a my class, where a client somewhere in no man's land sends a transaction to listener. Listener sends the transaction to process message. Process message is acting as a delegate method that then outsources the work to my class. And then my class takes the message, sends it through the Ninja Star. The Ninja Star does some crazy thing and processes it, inserts it into a database somewhere, and then comes back with a response message. The response message is then sent back to process transaction. And then process transaction then sends the response back to the original TCP client. And this is an example of how a delegate works.
This is also like the examples where you click the button in a GUI event and it calls code somewhere else, or also the example where the kid is holding the remote control and he controls the remote control car.
Yep.
That remote controller is like the delegate function.
Yeah.
So this is where we're going to see it actually, we're going to have the rubber hit the pavement. Let's take a look.
It's no longer an abstract terminology. Right. It's going to actually be a coding programming concept.
Yeah, and it's not even a difficult concept for you anymore.
Right.
Because it's just a function pointer.
Right.
Passed as a parameter.
Wait, you can pass a function as a pointer?
That's it.
I didn't know you could do that.
That's yes.
Why didn't you tell me this? Are you going to save me so much more time if you would have told me this?
Yeah, it's that simple.
Brian.
So you can pass integer as a parameter, you can pass whatever. Now we can just point to a function and pass that as a parameter. That's it. It's awesome.
And when you do this, you unlock a very powerful aspect of not only C++, but software development in general.
Yeah.
Because this allows us to then take functions and pass a whole function as a parameter to another function.
It's awesome. If you see on the bottom, here's the basic syntax of this action. We have a return type, the pointer to the function, and then the data type of the parameters.
Right.
The list of parameters and data types. So for example, we return integer, we have a pointer label function,
right,
and we take in an integer.
And that text function, guys, is arbitrary text. Think of that as integer x. That is just how I'm going to know what the function is, because when I'm passing a function as a parameter, I don't know what the original name is. I just know where it is in memory. Mm-hmm. So I define this function to me as function, but that could be whatever you want it to be.
It's your delegate function label.
Right, or just your function pointer label. This example is not actually a delegate. This is just showing how function pointers work. In this example, if you look at the top, we have two functions. We have integer myFunction1 that takes in an integer and then returns that value plus 10. The second function is the same thing, except for we're returning x times 10. And then we have another function below that, which is acting as sort of the intermediary. This is going to return the integer. It's called exec function. The first parameter, Brian, is a function, not a data type.
That's awesome.
So what we're saying is the function that we're going to call returns an integer, and within my local scope context, I'm going to know of this function as function.
That whole thing is the declaration of the parameter.
Yes.
So that's not 3 parameters, that's not 2 parameters. That whole int star function int in its entirety is a parameter of passing a function as a parameter.
Yes.
But it has to know those data types to understand which function, because we can do overloading.
Right. And then, of course, the parameter list is after that. In this case, we're just passing one integer parameter. The second int x is just a parameter that this exec function will take and then pass to the other function. So if you look, it says return function. Now look how clever this is, guys. When we call the function, we just call it as if it was any other regular function. But in this case, it could be any function that returns an integer and accepts an integer. How beautiful is that?
That's awesome.
Very nice.
It's really cool. If you look down on the main function, we call exec function and we pass it myFunction1 and pass it 10. Now, because this particular implementation of exec function takes in something that returns an integer, we store this as int y. Mm-hmm. Because of the way exec function doesn't necessarily inherently call that, but in this particular case, we're returning an integer from exec function. Then we print y, then do the same thing and call exec function this function too. Now we're calling the same exec function 2 times.
Right.
The first time passing function 1, the second time passing function 2.
Right.
And then we print the result of that as well.
Right. So when you look at the right, you see that when we use function 1 as the parameter, we actually execute the code in function 1 and return 10 plus 10, which is 20. And the second time, it's 10 times 10, which is 100.
That's awesome.
I mean, that's
really cool.
That doesn't excite you, you're in the wrong business, man. Get out of here. This is amazing.
So function pointers are really just pretty straightforward.
Yeah.
Now let's take a look at, maybe you can show us a basic delegation example.
I can do that. Now in this case, we're not using the delegate as we had explained it initially, which is one class calling code or executing code inside of another class. This is going to be a class executing code within the main portion of our code. Now let's take a look at the my class header file on the upper left. We're going to, in our private members, we're going to create a void type, and this is going to be, Brian, a function pointer, like we had just discussed. So this is going to have the 2 parentheses on the outside with the star underscore delegate function, and the paren at the end indicates that this doesn't take any parameters at all.
Now this is the same as we showed before, where we had int star function int x.
Exactly.
But in this case, instead of int, it's void. Instead of star function, it's star underscore delegate function.
Right.
And instead of int x, we have no parameters.
Exactly. And don't overthink this, guys, really, because this syntax confuses people, but don't overthink it. Then in our public members, we're going to have a method that's going to be called connect to delegate. And this is going to be taking in, if you look at the template of the function pointer declared above, it's the same template. It's a void return type, and then in parentheses, it's going to be a pointer, and then no parameters. The left and the right means no parameters. So if that accepted an integer, you would put an integer within those parentheses, but in this case, it doesn't. And then we have a void method here called run. Now, Brian, How the hell do we implement this code?
Well, it's pretty straightforward. Let's look down on the bottom left and we'll see my class run just calls _ delegate function.
Beautiful.
No parameter pass.
Sexy.
So that's effectively calling the delegate function pointer to the function that we passed it.
Yep.
When we pass it to connect to delegate. Connect to delegate's implementation down below takes in void function pointer, and we'll just call it delegate function for our local reference, passing no argument. So we've now seen that syntax before. Void, the pointer label, and the parameters as the input parameter type. And the delegate function private pointer member is stored as the pointer value of what we take in. So all that's doing is just setting our private pointer to the function that we pass into this function. And going back to run, when we call run, it just calls what we set there.
Beautiful. Now, one important thing to note, Brian, is when we execute that run method and we call the _ delegate function, that's executing it within the context of the myClassDriver.cpp file.
Yeah.
Any global variables declared outside of the scope of my class but inside the scope of the main function is accessible. Because even though it looks like you're running the code in my class, you're actually running that code in the pointer that sent you that
Through
method.
the delegate function.
Oh,
it's awesome.
Amazing. Now, if we look at the driver code on the right, we of course include the myClass.cpp. Then we have two local functions to the main function. So these aren't objects, these are local functions. And it's going to be function 1, function 2. And as you can see, we're using the preprocessor macro __func__, which will print the current function name. When we go down to the bottom, we create the instance of myClass C.connect to delegate, sending it function 1.
Smooth.
Now, on the upper left, the delegate function equals function 1.
That's awesome.
So when we do C.run, we execute function 1 inside the main code block.
And then, without reinstantiating my class C, we just say, now C connect to delegate function 2, C run, and now we're running function 2 through that same class instance.
I feel a sense of just comfort going over this code because
Weird. I feel a wetness in my pants.
This is one of those things that's like a lot of developers are scared to look at this, but when you really look at it, this is very simple.
Yeah.
Very simple. Now let's look at another one that's a little more complicated. And before we actually do that, we have to understand that there is a difference between using a function pointer and using a method pointer. And that is because of the scope. Because before the example that we showed, function 1 was inside the scope of the main function, so it naturally acted as a pointer. So Brian, why don't you tell us a little bit about how, using this basic program that's not really functional, how method pointers work?
You can see the myClass declaration at the top. We have a run, which is just going to output run. Very basic. Nothing special about it. Later, in the same syntax that we're used to, which is instead of int star function int x or void star function, no parameters. In this case, because it's a method pointer, we have to declare it within the scope of the class we're referring to.
We're scoping in, exactly.
So in this case, instead of void star function, no parameters, we just simply say void my class.
Right.
RSO, the scope operator, star function.
Right, so this is a pointer that exists inside of my class.
Right.
Remember this. The
Simple.
scope resolution operator defines the scope of the following member.
And that's going to be set to a reference pointer to my class scoped to run. So within my class, the run method, pointer to that run method is what that's going to be tied to.
Yes.
Then we instantiate my class C, and we call C function pointer.
Now, one thing to keep in mind is the syntax with the parentheses around the C.star function is required. And the function, the parentheses on the right are the same as if you were just calling a regular function and passing either parameters or no. I know we've mentioned that a lot of times, but I just want to make sure that we make sure that sticks.
And then we return 0 and exit the program.
So when we do this next delegate example that Brian will tell us in a second, we have to keep in mind that instead of using local functions, now we're going to be calling a function that exists inside of an instance of a class. So it's a different monster. Functionally, it's the same. It's just getting the engine started is different.
So this is conceptually the same as example number 1. It's just for that difference. Here we have delegate class. Delegate class has my method. My method's implementation just prints the name of the function. So here's D object with my method. In the main function, you'll see that we're just going to instantiate delegate class as D. Then we also call my class, and here we pass it, template it as delegate class C.
The reason why we're creating a template is because in order for us to make a pointer to delegate class, we need to be able to know the structure of the data type. So by using the template, this will accept any data type. So whatever instance that your delegate method is inside, that is the data type that's passed within this template parameter here.
So you can see object C that's instantiated has, just like similar we've seen before, in this case we have the delegate function as a private member, which is the function label pointer. Then we have the delegate instance,
right,
which is a delegate instance pointer of a data type.
Yeah, that's just pointing at D.
Right.
In this example, it will anyway.
And the connected delegate, which operates effectively the same as it did before, but in this case, we just have our data type pointer for the instance void, and this is the same format, this void dt : pointer, and then no parameters, just the same that we've seen. It's just that delegate function parameter pointer coming in.
And don't let the fact that there's a template scare you.
Yep.
That DT, all that means is that is a placeholder for the data type. Yep. And remember, the data type is passed as a parameter. So whatever that data type that's passed in, that will be replace it. That will replace it.
So we're just keeping it abstract.
Yes, that way it will work in every circumstance.
And then we have run. And run's implementation, as you see below, calls delegate instance, which is the pointer to the delegate instance. And then the arrow, because we're talking about a pointer to an object, the arrow instead of the dot, the pointer to the delegate function. So so kind of bear with us on this. This is not as bad as it looks. We have our current delegate instance. We're going to make a reference to that. Then we're going to point to, within that, the pointer of the delegate function, which in turn is pointing to some function.
Right, so think of it this way. If you want to go to Brian's house later tonight, the delegate instance is the street, and the function is Brian's house.
Kind of to further illustrate this, you can see the delegate function points to my method. That's where we've tied it together. If you look at if we go back to the driver and you look at the main function, we call C connected delegate, and we pass it delegate class D, which is its instance, the delegate class my method. So we passes the pointer reference to the myMethod function. The myMethod function is what we call in. We didn't know what the data type is, so that's going to come in as that, and the instance as well. Now we've effectively tied the delegate function to myMethod and the delegate instance to the object instance, which is awesome. So now we kind of linked them up.
When it executes the method, it knows which context in order to execute it, and that's D.
Then when we call run, c.run, what that's effectively doing, like we described before, is it's pointing over to the delegate instance, then to the delegate function based on the delegate function pointer. Here we go to the delegate instance, and then within that instance, now that we have that domain of reference, we can then say within that, we're going to point to the delegate function in particular. And that effectively runs my method remotely.
It runs it inside the scope of the code file on the right.
It is awesome.
Beautiful.
Yeah, it's very cool.
Love it.
Now you've effectively taken the delegate concept and we've done it now to do remote code execution in a separate class. So now you're basically golden, up and running, solid with delegates in C++.
Yeah.
Which is awesome. It's pretty exciting.
Very exciting. I mean, so much of software development is based on this concept. Well, in some implementations, you don't see it. It's hidden from you. But on the backside, this is what's actually happening. So when you do open up your, I don't know, whatever program you use, a web browser or something, and you hit a button, that action of you clicking on the button is executing a delegate. Otherwise, you would have to create a brand new inherited instance of some button class all over the place that has independent code things all over the place.
It would be insane.
It's not reusable. Right. It's probably how Netscape was built, and that's why it was so slow, but whatever. That's why they're gone now.
I hope you like the delegates examples. We're going to go over a few more of them in some later lessons. So keep your eyes peeled. Make sure you got these down pat, because we're going to use them later and really try to just kind of tie all these concepts together.
And once we get into the Mac languages, we're going to use them. We get into C#, we're going to use them. I mean, this is a very common concept in software development, so get used to this. Whether you like it or not, you're going to have to know it.
Yep.
Sorry. We're being held captive, and we're recording this against our will in some underground bunker.
From the WiBit.net Fallout Shelter in Lower Montana. Welcome to Programming in C++, the video on properties.
Not bad.
Yeah. In case it's the end of the world and you need to have properties on your methods to save the world, watch this.
In this lesson, we're going to talk about properties. Now, we kind of brushed over properties in the intro series, but in this one, we're going to actually grab this thing by the horns. But before we do, we're going to set this warning, and that is that properties are not natively supported in C++. You have to kind of do some things to do it in native standard C++, not in Borland C++, not in Visual C++, because those are offshoots of C++ that have implemented their own version of this concept.
It's very nice of them. Now, because we're not using one of those, we will be nice as well and build our own property class. And we can kind of keep using that so that we have our own property implementation, just like they did when they kind of upgraded C++.
Yes, and now we're going to build this and sell it for $55 billion trillion.
Because keep in mind, when we talk about ecosystems and we can talk about building and developing your style so you can fly at the 10,000 feet. It's all about when you see these enhancements on language, your job in an object-oriented world is kind of to, whatever language you write in, enhance it to say, how would I want this language to work? Enhance it so that it can work that way.
And if you're forced to write in VB, just quit your job. Because, seriously, that's that. Okay.
Or write a C library and import it into VB.
That's really the only thing. That's the only way you could save yourself. Because you can do that.
It's like a child sneaking cake batter into the closet. It's kind of like you're secretly coding in C and masking it as an executable class, executable library.
Your main sub is 4 lines long. Load DLL, execute DLL, close DLL.
You're where's the source code files for your DLL?
What are you talking about?
I just lost them. I don't know. I had a hard time.
It was some open source thing that I downloaded.
Yeah, I don't even know. Don't even worry about it. But anyway, sorry, the property class, we're going to write our own. You can use it whenever. You can kind of mold it into how you want it to be. But there's a tons of way to do this.
Yeah, you'll see a lot. If you read a documentation, you'll find lots of developers have their own take on this. And no way is right or wrong. Ours is obviously right.
Yes.
And they're wrong, but still.
So never take ours as truth. Just take ours as the coolest way to do something.
It's right. It's the fashionable way. So properties, we had to save these, even though it's a simple concept to understand. It requires higher level understanding of C++ in order to pull this off correctly.
And now that you have that higher level knowledge, we'll show you how to put that higher level knowledge to use.
Right, because we're going to need delegation, operator overloading, and templates in order to do this.
That's it? That's easy.
I think so.
That's cake now.
I think we're going to find that out. And also you have to understand how to write in C++.
Yeah. But cake, now you know how to do that.
Cake? Did you say cake?
The cake is a lie.
So property, just as a review, is an indirect way of accessing fields within a class.
Yeah, basically.
Yeah, so they typically use to retrieve values from an instance and also can be used to calculate values and acts as if it's a field.
And if you don't remember why to use properties, just go back to the Intro to Object-Oriented Programming lesson on properties and you'll know why. So how does it behave? You can either have it read-only, you can have read-write privileges to a field, and it basically is just the setter and getter to interface through instead of having direct access to your private members. Because it's like a chastity belt, kind of, really. It must be able to accept any data type in order to really behave as a proper property.
Mm-hmm.
You don't want it if you really hard line it to be too specific, then you basically just have some method.
Well, but then you also have to have multiple methods, or even have to make a brand new class over and over again.
So now, keep it generic.
We mentioned it has to be able to be read only and write only. There's technically a third way, and that's write only. And even though I've seen that in textbooks, as my experience as a developer, I've never seen a write-only property in my life. Have you?
But I know.
Okay.
But so if you really want to, you can, whatever.
You can add it.
Yeah.
We're not going to show you because we're too cool. Let's take a look at the property header file, Brian. Let's start from the top.
So here's our property class. Class property.
Yes.
The private members are going to be the property, just like we saw before with declaring the
delegates.
The delegates, we have our data type, the function pointer, and then our parameters.
Mm-hmm.
This is going to be our property data type. And because this is we're talking about classes here, we're going to make sure that we scope properly. Our object data type scoped to the function pointer getter method.
Right.
No parameters. It's just a getter.
Right.
Then we have similarly void, because it's a setter, we don't really want to return anything necessarily. Scope in our object data type to the setter method pointer and pass in the parameter our property data type.
Oh, yeah.
So far, so good, so smooth. We just went over the delegates. You're kind of you're really primed to get this.
Right.
You should be solid.
Now, just to put this in context, for anyone that's wishy-washy, on the get method delegate function up here, the object data type would be the my class that we were looking at earlier. And the property data type is, for example, if your property was a string, that's a string. If it's an integer, it's an integer. If it's a custom class that you've made, it's that custom class.
Mm-hmm. And you can see the template up above as the class object data type and the class property data type, right?
As the template for the class.
Yeah. Then there's the object data type pointer. property instance, and that's going to make a reference to the property instance itself.
Mhm.
Then the property data type get, which is just going to be a private get method. Then a void private set method, which takes in the property data type, and that's not publicly accessible.
Now, what is publicly accessible, Brian?
Well, it's read only and read write.
Oh yeah.
Read only takes in a object data type pointer, and then just like we saw in delegates, the property data type, the object data type scope, and a pointer, and the parameters, which are not in this case because it's just read only.
So this will set your property as a read only property.
And then the read write, which is very similar, but in this case, just like you'd expect, void object dt to the pointer, and we're going to take in as a parameter property dt. Then we'll also take in property dt scope into the function pointer.
And if you guys are kind of wondering what this is, on the read only, that's going to be returning the getter method. And on the read write, that's going to be accepting the getter and the setter method. Because if it's read only, you only have to know how to read it.
Yep. And if it's read write, you have to read and write.
Now here's some other cool stuff, Brian. We're going to overload the operator equals.
Nice.
And we're going to be accepting, obviously, the property data type.
Whatever that is.
You say Brian.firstname equals, and then we'll define what that does.
Cool.
Then we're also going to override the data type itself, and that will be returning the value.
Nice.
So we're going to see how this implements in a moment. But we also have an overload here for the insertion and the outsertion, whatever, for the operators. And the reason why we're doing this is because when we're working with streams, we would have to typecast these values, or else C++ won't like it.
Yeah.
So this kind of just helps if you want to just see out or output it to a stream, this does the work for you.
Yep.
And if you want to input it to a stream, this does the work for you as well.
And since that's such a kind of crucial part of C++, you're bound to come across this, so you probably want to implement this as well.
Right. And if you do see circumstances where it doesn't function with other operators, then you could just define the operators here.
Unless the C circumstances is C circumcised. I don't know. Okay, whatever.
I just hit myself in the nose with my wedding ring, and that hurt.
Oh, that sucks. Oh, screw! Like right on the bridge.
Yeah, that's how upset I was at that joke.
Oy vey.
So the implementation,
Yes,
Brian.
chalk it up to the list.
And the implementation, we're going to start off by using a directive here. So we're going to say with a macro, if not defined WiBit property class, then define it, and then create the class. And then at the bottom we have the end if. Now what this is basically doing is if I have a code file and I say include property.cpp 37 times in a row, the first time it actually defines it and the second time it doesn't, or else the compiler will not allow you to compile the program.
Awesome.
Yeah, that's really all I was going to say.
Cool.
Include property.h, Brian.
Let's take a look at our implementation. We have the property read-only. Property is not going to return anything for read-only, and the read-only is going to take in the function reference parameter, which is going to be just the data type, the pointer to getter. We'll just call it getter, and there's no parameters for getter. So you see we have property instance we're going to set to be OB. The getter method we're going to set to getter, and because this is read-only, we're just going to set the setter method to null. Now in the read-write method implementation, it's going to be very similar, but in this case, you see we take in the whatever the data type is pointer. Then we do function pointer parameter, void some object type. We're going to pass it as the function pointer label setter. That takes in a parameter of a property data type. And then we also pass in the getter just like we did before. So we take in the object, the setter, and the getter. The object we're going to store as a property instance, and the getter we store as the getter function pointer. The setter method we're going to store as the setter function pointer. So now we're kind of in this method implementation, we're kind of linking up those function pointers we're passing in to our instance in the private members.
Very well done. Very well done.
Down below, you'll see when we do the get and set, all get effectively does, it returns a call to the property instance, which is like the street, and then point to, because it's a pointer to an object, the point to the function pointer getter method and call it. So this is just like we've seen before. On the set, it's going to be the same thing. We call the property instance, and that property instance is set method, and pass it the value that we've taken in. Easy, just like we've seen before. But now, here's where it gets interesting. Now we're going to do the operator overloading of the equal sign.
Oh, yeah.
That takes in a property data type value. So we keep it generic, we keep it abstract. If the property instance is null, then let's throw an error. We talked about exception handling. We're going to throw the property instance is not set. We've got a problem. We can't We can't do that. We can't say something equal to something.
Yeah, because we're not pointing at an instance to work
Right.
on. We have no concept of where we're doing this.
So you can't. That's not allowed. It's not valid. Also, if the setter method is null, we have no way of setting it, and that's really what we're using the equal operator for, is to be able to set it. So we want to overload that operator so we can call the setter more conveniently and kind of blend it into the C++ language smoother. So if the setter method is null, we're going to throw an exception. Not good. Now, if everything's fine and we haven't broken out of this, we haven't thrown an exception, then we're going to set value.
Which we defined already.
Right.
And we're just going to pass value, which is the parameter passed when we do Brian.name equals, and then whatever Brian's name is the value parameter.
So that set value is actually effectively calling a delegate function to then set the value into the instance of the object that we want to set.
Beautiful. Beautiful.
Nice.
Now recall, Brian. Remember this person class?
Yeah.
Remember this guy where we were doing stuff like making populations for static members and all that kind of crazy stuff. Now, let's completely jack this person up and let's start doing properties. So the first thing you're going to notice is we added a new integer, an unsigned integer called birth date time at the top, which will represent the Unix time that this particular instance was created. And then protected methods, we have an init method, which we will discuss that in a second. That's just basically going to set up the properties. Below we have an unsigned int getAge, which is the getter for getAge. Now, we don't have a field called age. I wonder what that's going to do.
Weird.
I guess we'll have to figure that out later in the next slide. And we define our properties below. Now remember, this is just creating an instance of the property class that we created before. So we have a property instance and we're using the template. So remember the template, the first template parameter is going to be the class in which this is being defined in. So this is the person class. The second one is going to be the data type that the property actually is. So the first name will be a string. In the second example, the last name will be a string and it belongs to person. And the last one, the age is an unsigned integer and it belongs to person.
Now, how smooth is that? That almost looks like it was baked into the language.
Yeah, that looks, it almost looks natural.
Yeah, it almost looks native. It almost looks like it had just intended you to say property, what's the property data type, and what's the property name.
Yep.
And then that's that. But this is we include the property.cpp, so we're now including that class definition.
Yep.
So that's not native to the language. That's just what we just made.
Yeah, exactly. Awesome. Right. So in the implementation file, if you look at the constructors at the top, the two constructors we have is the default constructor, which takes no parameters, and then the other overloaded constructor, which takes the last name and the first name. Both of them now have a method called init, which is defined directly below the second constructor. And in the initialization, it's basically just having one method that does some startup routine so that no matter how many constructors you have, whatever independent thing that they do, they all end up doing the same thing for the properties. So we create the person's birth date. The person's birth date is now. Whenever this second is, they're born. Then we do we set the property. So within the instance of the property, first name, we're going to call the read-write method. The first parameter is this, which remember, Brian, open recursion, we're passing the pointer to the current instance that this is operating within. The next one, we're going to have a pointer reference to the setFirstName method scoped from the person class. The next one is going to be the same thing, except for we're going to be sending the getFirstName method. The first one was set, second one is get. So it's read-writes. We're enabling the setting and getting of this attribute.
And that comes from when we defined the implementation of the property class. We just said the object, the setter, and the getter for read-write.
Mm-hmm. And last name is configured the exact same way, but age is read-only.
Oh.
So that's why we have... so we're only going to pass the current instance and then the getter, which is the getAge method.
Nice. Lastly, we have the getAge method itself. This just returns the current time minus the birth date time, how old this object is.
Measured in seconds.
Yep.
So if you wanted to get how many years old this object was, if it lasted for years, you would divide it by how many seconds are in a year, and there you go.
It's awesome.
84,600, 86,400, one of those two.
Cool.
Now here we go, Brian. Let's actually take this code and let's do something with it.
All right.
How beautiful. Oh my goodness. Huh. When you look at the actual driver code, I mean, how smooth and abstract. Yeah. I mean, talk about abstraction. How abstract is that?
So now our person object has the properties first and last name, and it also has the property age. So let's take a look. So we instantiate person as P. We set, using the equal sign that we overloaded the operator for this, this type. P.firstname is WiBit, P.lastname is .NET, and then we sleep for 5 seconds.
Yep.
Then we print the first name, the last name. So now we've set the first name and last name, and now we're getting the first name and last name just by calling them like that.
Yep.
And also because we overloaded earlier the insertion operators, this knows how to handle that.
Yep.
Concatenates that.
It concatenates. Just make sure it concatenates those as a string out to the command terminal.
So then and then we call p.age, which is our read-only getter property. That will calculate the age on our current time, now that it's 5 seconds later, minus the time that we first instantiated the person object.
And it acts just like a field. You're calling
awesome.
.age, and every time that you call that, it's calculating the value. And
So now it almost
just like
looks
a field.
like, C++ had natively inherited. So now we're really making the language act like we want it to act, which is where we're really getting into some fun stuff.
Now in the upper right, we're going to compile this program just as we normally do, and then we're going to execute the program. And when we execute it, as WiBit is showing here on the left-hand side, we're going to chill for 5 seconds. How was your day, Brian? Was it good?
That's good.
It's good?
Nice.
What'd you have for breakfast? Was it
Nothing.
longer than 5 seconds? And after the 5, and actually notice I'm using the wait symbol from the
Nice.
flowcharts.
Awesome.
So we wait 5 seconds for a time delay, and then at the end of it, WiBit.net is 5 seconds old. How beautiful is that? Now, Brian, tell me what would happen if I tried to set the read-only property.
I think the computer's eye would twitch, and it would probably just fall over.
Well, we can compile this. If you look at the top, the compilation worked just fine.
Interesting.
So it didn't see anything wrong with it during compilation because syntactically there's nothing wrong with that.
But we're not allowed to set age.
Well, let's find out what happens. If we execute the program, then we're going to see the problem. What's going to happen?
It's going to explode. Oh! Now, this is the exception that we threw.
Yep. That manually threw this exception.
Yep. That's awesome.
Yeah, so if you actually accidentally did this within your program, you could catch it and say, "Oh, whoops! I probably shouldn't have done that." And,
or reprompt the user for whatever.
Yeah, and if you try catch this, since we threw the exception, you have the opportunity to recover. Otherwise, it would just crash the program if we didn't try catch this. The program would be gone.
That's awesome.
Properties. So even though they're not native to C++, you can integrate them with C++ as if they were native, and they will behave as they do in many other languages that take advantage of this concept.
Because I do what I want.
And by the way, if you want to use this code, pay royalties, $5 billion per download.
Billion.
Billion! That's a B.
Okay, let's talk property.
Yeah.
We want to make a property class to make it easier for you to use properties in C++.
Yes.
While explaining how properties work in C++.
Yes, and it's something you can take with you to other development projects.
Yes.
Now, we already did a video where we discussed making a property class, but we have some other exercises lined up that will be using this concept. So we want to make sure that we write this for you.
That way you just kind of have it, you know?
Right, so that you can follow along with the other stuff.
And it's fun. Who doesn't like talking about properties and stuff?
Give it a capital P, Brian, since we have a capital P directory.
GIA, girl. GIA.
Yes, we'll do C# Java style.
Property.h. And we want to
Does that say property? Or am I just like dyslexic?
Yeah,
okay, cool.
Okay, now I can't speak.
Use this.
I have audible dyslexia. Wait, where's... Oh, right. Yes.
Having a hard time there. There we go.
Okay. So we've got our implementation file and our header file. The implementation file, of course, is going to include property header. Yeah.
Yeah, and let's do our if define, if not define as well.
All right.
Now, you guys, hopefully, in the introduction to object-oriented, we went over the concept of properties and what they are. We did a video on properties where we discussed the property class at length. So we're not going to be talking about exactly what this is. We're just going to be doing it.
Yep. Because you should know by now.
Yeah, that's what she said. We're just going to be doing it.
Doing it well.
Well, doing it well, yeah. To quote the poet, LL Cool J.
Yeah,
I forgot
I was like Ice-T.
for a
No, it was
second.
Ice-T.
That was LL Cool J.
Yeah, that's right. Okay. Let's start with our header, our blueprint of the class. Now, this is going to be abstract.
Yep.
Just like the delegate class was, because we want it to be flexible and robust. The instance that we're dealing with is going to be whatever that object data type is, and then we're going to have a property data type, whatever we want to set that property to be. And this is for class property.
Nice.
Semicolon. We're going to have privates, and we're going to have things that are public. We're going to overload the insertion and outsertion. So we're going to privately declare a method of data type, property data type, and that's going to be in reference to the object data type scope into a pointer of the getter method.
The getter method.
Or the getter method. Okay, cool, nice. Do you like it? And then we're going to declaring the setter method, and it's going to not have a data type of returning because it's a setter. So in a similar fashion, we're going to make reference to the object in question, and then scope into the setter method, whatever that's going to be. And that's what we're saying here is whatever we want to set this thing to be that we're declaring now. And it will take the property data type.
So these are basically doing delegates, but writing them manually.
Yes. Object data type, pointer, and this is just like the object instance. And in this case, we're going to call it the property instance, but it's the same thing because this whole thing is the property.
Right.
We also want to have we want to declare a get method and have it of data type property data type. So whatever that property data type set to. And then we want to have a setter, and that's just going to be void. And that's going to take in the property data type. Very nice.
Very nice.
Publicly exposed to the public, like Pee Wee Herman, will be read-only, which will be a setter. And that will take the object and the reference to the object innards as the property data type.
Right. So if it's read-only, it needs to know where to get it, and it needs to know what to get, but it does not allow you to set.
Right. So that's the property data type as the return type of object data type scope into its innards. Don't pass any parameters. Okay, so we got read-only. Now we want read-write, then we want write-only. Okay, so we got read-only. Now we want read-write, then we want write-only. So we got read, write, and then after that we're going to do write-only. Yeah? And then, I'm going to do it like that. Then, so similarly, we're going to have to refer to the object data type pointer, and then because it's this is the setter part of it, it doesn't have any return data type. It's just void. Then we scope into the innards, and then property data type. Then after that, so that's the setter, and then the read part. That's the write part. This is the read part. Property.
I'm gonna pop that to the next line or something.
Yeah. Stick it there.
Yeah.
Property data type, and then the object data type innards. That's it. Okay. And then we have void write only, and then write only obviously is going to be just the setter.
Same thing as read only, but the opposite.
Yes. So kind of like this.
Yep, perfect.
Okay, so write only is going to take just those things.
Right. Because it needs to know where to get it and where to set it and nothing else.
That's right. The last couple things we're going to do are going to deal with the operators. It's just all overloading. Overloads. Okay. The first one we're going to define is the operator equals symbol.
Nice.
And what we're going to be passing it is of data type property data type.
You got a little pro-ry.
Yeah, the keyboard's dying a little. Property data type. And then operator property data type.
Nice.
And this is going to be overloading
the data type.
Print.
Awesome.
And what that's going to do...
Now we're going to define this one. It's a special case.
Yes. And all this is going to do is return the getter.
Mm-hmm. Right, so this is when you do instance.property runs this.
Yes, which is awesome.
Right.
Okay, so now the last thing we want to do is tell our friends they can touch our insertion operators.
Nice. Brian's close friends that he gives access to his insertion. You got a little stir, man. You gotta get some sexually transmitted diseases.
Oh, yeah.
Not sexually transmitted...
Regrets.
Yeah. Which I guess kind of go hand in hand.
So we're going to overload insertion, and that's going to be, as usual, the stream.
Mm-hmm.
Reference to, we'll call it stream. And then the property reference, we'll call it P. Yeah, that's cool.
Yes.
So now all we're going to be doing is taking the property data type, casting, P, get. So whatever the P is, it doesn't really know, so we're just going to typecast it to this.
Mm-hmm.
And then we're going to pipe that back to stream.
Right.
That's how that's going to work. And then we just return the stream.
Right, so this is basically just to typecast p.get, and since this is a friend method, it has access to the private methods, which get is private.
Yep. And then we want to overload.
So Brian lets his friends I'm sorry.
Yeah, we get it. We get it. Okay, the operator outsertion. This is when you... No, I don't even know. I don't even know what this is. This is this iStream in this case. Reference to stream, we'll call it, and property P will do the same thing. Cool?
Mm-hmm.
And I'll do this and scroll down. Okay. All right. We want to do a couple things. Our main objective is to be able to say p.set some I don't want to say it. What we capture, some temporary thing that's going to capture, you know, the captured thing, you know, basically. So how we want to say that is of type property data type temp.
Mm-hmm.
We want to take the stream and dump it into this because now this object is of the type whatever that property data type is. So that's a known. So now the stream knows how to handle it when we do the insertion operation to it. Once that happens, we can say pset. We can pass that thing that we've now captured into the setter and return the stream. Cool?
Sure.
And that concludes the blueprint of the property class. Now let's get to the implementation.
Now, just real quick, pop over real fast.
Yeah?
That stream insert into temp, that is making an assumption, and the assumption is that the data type that we're working with already works with the
Insertion
and outsertion operations.
And that if it doesn't naturally, then it's overloaded to be able to be.
Yeah, so
and that we know what it is at this scope.
Right. If you want to take advantage of this functionality on your own custom classes, you have to overload these in your own classes.
Yes.
Mm-hmm.
Because if this thinks it's a string, that's fine. But if it thinks it's a
person,
right, then it doesn't know.
Mm-hmm.
Okay, so now we implement it. Alrighty, now we implement our property class. We want to include the IO stream.
Nice.
Sweet.
Little blip there in the operating system.
Okay, so let's do the read-only.
Right, because we had the three different types of parameters, read-only, write-only, and read-write.
Right? Read, write.
Mm-hmm.
Okay, so for reading, these are all going to be templates.
Save time, baby. Save time.
Oh, we already have it right there? Yeah, awesome. Look at that.
It's all about being lazy and sexy.
There, there.
Nice.
And there.
Cool.
Yeah. Okay. Void. This is the property class. And we want the object data type and the property data type. Scope into function name.
Yep, there
This
you go.
is always going to be the case. We'll do the Andy Warhol way of systemizing our art here. read only. And so in all of these cases, we're going to have an object, whatever the object data type is, pointer to some sort of object.
Mm-hmm.
And then depending on the case, this will take, because this is read only, we're just going to be doing the getter. So the property data type is the return type, the object, DT, scope in, and point to the getter. No params. Okay?
Mm-hmm.
And this could probably be on the same line.
Yeah,
that's okay.
Cool.
And that does that. So that's for read only. And then for write only, it's not that different. So this is write only. And the difference is we're not going to be doing the getter, we're going to want the setter.
Mm-hmm.
And the setter doesn't have a return data type, it's just void. And we scope into the object data type just the same. Point to the setter. And this does take the parameter of type property data type.
Nice.
Yeah. And that's it.
Now, Brian, if I was a read-write method, what would I need?
You would probably be a combination of the two. Actually, I'm going to do write and then, because we kind of do the writes and then the reads.
Yeah, make sure that this fits the template, too, because I forget which order we did it in.
Yep. So this is, so we do the setter and then the getter.
Okay. But it's not read-write only.
Oh, yeah, good point.
I guess maybe technically that's correct, but no.
Okay, so
That's
then
about
got
as
one
ugly
more.
as you in a bikini, that text.
Me in a bikini.
Yeah, it's pretty nasty.
What is with you and your fascination with situations where you can see?
It's actually the opposite of fascination because there's got to be hair all over the place,
so-
like a gorilla.
So we do the setter and then the getter. Right?
Yeah.
Cool. Okay. So that does that.
Whoa!
Nice. That scared the hell out of you, didn't it? You just had like flashbacks to taking acid in 7th grade.
I was doing acid in 7th grade?
Yes.
Wow.
So we're going to be doing two things. We want to interact with three things. The property instance, that's the internal property instance, the internal getter method, and the internal setter method. So we're gonna be dealing with these three things. This is gonna take the object.
Right. Set the pointer.
This is gonna be taking the getter.
Right. Another pointer.
It's read only, so this takes nothing.
Holy sugar
I
monkey.
know. Okay, this one. What do you think it's gonna be?
I don't know, man.
This will always take the object.
An object.
This will always take, well, it's read only, so this takes nothing.
Oh, sugar.
And this takes, surprise, surprise, the setter.
Holy monkey. And this one's got to be a lot different.
So this is read and write. So this is going to be always the object.
On J again.
This is going to take the getter, and this is going to take, since it's both, the setter.
I'll tell you what, Brian, that is the most magnificent code I've ever seen in my life.
Yeah, that was pretty cool. All right, let me pass it over to you.
Okay.
You can complete the implementation
I can
and
do that.
test this thing out.
I can do that. Okay.
Okay, so now we've got read only, read write, and write only. Now we want to do the set, the get, and the operator overload.
Right. Now these are just basically going to be performing the actions of setting, getting, and then executing.
Yep. So let's grab that template.
You got it, buddy. This right here?
Yep, because we're always going to be doing that.
Yes. Okay, so we're going to slap this baby in here.
Yep.
And I guess
And it's going to return a property data type.
Right, so
Because it's a getter.
property data type, and this is going to be
In the property class. Yep. And then that's going to be...
I'm going to do one of these.
Oh, yeah,
jobs here.
perfect.
Yeah.
Flawless.
Do one of these little
Cool.
nut jobs, and this is going to be
So
called
that's gonna
get, right?
So scope into... Yeah, we can do get.
All right.
Okay.
Now, once we're in here,
We want to check some conditions?
yes, we have, and we're going to probably be best to throw some exceptions here. So if we're going to get something, right, we have to know that the getter method is set. And just like we did in the delegate class, we also want to make sure
Do we have any?
that the instance is set, or else this is going to completely fail. So the first thing we'll check, Bri, is the property instance.
Yep.
Is property instance null? If property instance equals null, then I want to throw an exception, right?
Yep.
And if you were going to throw an exception in this case, what would you do?
I would throw a new string that says property instance is not set.
Okay, so like a D's, right?
Yep.
Property instance is not set. And just to be an ass, I'm going to do one of these things.
Okay.
And we're going to be doing a similar thing.
For the property method.
That is correct. And this could be an if or it could be an else if, but
yeah, whatever.
Actually, no, it doesn't have to be an else if. It has to be two different ifs because they both have to be checked.
Well, I guess one would fail.
No, if this was an else if the property instance was set and this was not set, this would never execute.
Oh,
Right?
yeah, true.
So
Yeah.
it has to be like this. So we're going to be checking what the getter method is. If getter method equals null, I did a control C instead of a control V. What do you want to tell the user? Property method
property getter not defined.
Is not defined. I like that wording. Makes me sound smart when I say defined instead of set.
Or
Okay.
you could say cannot set. Yeah, that's fine. Yeah,
Okay.
That's good.
So once we have validated, Brian, that
Then we can
what we need is there.
just pass it along now at
All
this
right.
point.
So now we're going to be calling the delegate by doing a property instance. The property instance is going to be pointing to
You didn't copy it.
your mom. You're right. The keyboard batteries are getting bad, aren't
Yeah,
they?
they are.
It's a stupid Microsoft keyboard.
Yeah.
All right. So property instance pointing to the getter method, and we have to close that off. Remember.
Yep.
And since this is a getter, it will be accepting no params.
Yep.
All right.
Cool.
We've done that, and now
we do the setter.
set, which will be basically
The same thing.
almost the same
But
thing,
not at all.
but not right. But this will be set, right?
Yep.
That will all be the same.
And then
Now, what defines a good setter, Brian?
well, a setter first takes in a parameter.
Uh-huh.
So we want to take the parameter of property data type, and we'll just call it value.
Okay. And
Property data type.
we should also probably
And
do
we'll call
a
it
check.
value.
Oh, yeah, I'm sorry.
It's okay. Yeah, so let's check that we have an instance.
An instance and a
setter
setter,
method.
right, yeah. That's important as well.
Yep.
If the property instance is null, that's
That's
fine.
fine.
If the getter method...
This is the setter, yeah.
If the getter method is
And the
null...
setter.
I'm sorry, I'm stupid. If the setter method is null, property setter is not defined.
Yep.
So there's our two little checks and our little wimpy exception handling that we got.
We want to set the property instance's setter method
Right, that's kind of dumb.
and pass it the value. So
right.
it's the same thing, just replace set with what we're actually trying
Right,
to do.
so we'll pull this out.
So that's going to be a setter, and we're going to pass it the value.
Yep. So setter, method, and value. Okay,
Yep.
and that's going to be calling the delegate.
That works.
Awesome. Okay, now
so
what do
now
we
we
got?
overload the equal operator.
Okay, cool. So it's going to be
So we can say this property equals this.
mm-hmm. And the syntax of that's going to be basically all the way up into the scope operator, or RSO, SRO, whatever you call it.
Yeah. And then operator equal.
Operator equals. And this is going to be
taking in.
taking in the property data type value.
Right, because this is effectively just the set overloaded for the equals.
Exactly. So it's going to be like a D's.
Yes. And because we already exception handled the
Right.
set, we can just
Yep.
call set.
Yep. So we can just do set value.
Done.
Done.
Look at that.
Freaking deal.
Okay, now let's test this.
And as you guys can see in the property.h, the get has been written here. And this is kind of a special case operator, so that's why we put
Right.
that inside of the actual header code instead of the implementation code. So let's get some driver action going on here. Save this as
Property driver.
property driver. That sounds like some 1865 job title.
Sometimes people call this like class test harness. So it'll be like property test harness.cpp. I've seen that a lot, but test harness is too long. Driver is shorter.
Yeah, you'll also hear it called client code, which we
Yeah.
use interchange.
Sometimes.
Client code and driver code is the same
Yeah.
thing. I catch myself using it. Why does that happen?
Now, usually if I'm not doing this to explain it to somebody, I'd probably just call it like ASDF or blah or balls.
Yeah, right.
Balls.cpp. Just as something ridiculous, so I remember to delete it.
I'm the one that's always guilty of making delete me.cpp.
Yeah.
But then the weird thing is I'll write something very valuable in there
Yeah.
that I really need, and I'll be like, what the hell happened?
I deleted it? Why would I delete it? I called it delete me.
I'm so guilty of doing that.
So we include...
now, I believe this pulled in IO
properties.
stream, right?
Yeah,
so
so
we just need property.cpp.
Yep. And then we can use namespace standard if we want.
Right. We'll do that.
Cool. Return nothing.
All right, let's see if I have to clean up any of Brian's messes here again.
Probably not.
G++.
Even again, the last one was flawless.
Okay.
Ooh.
You really this one up. All right, let's start from the top.
Yikes.
Property.h, line 5, error expected identifier before star. Okay, property.h, line 5. Oh, you misspelled property.
Oh, yeah.
Yeah, look at that.
Catch.
Yeah.
One of the things that's really nice about IntelliSense and some of the IDEs
Yeah, right.
instead of Notepad++, which is not bad, but there's probably a lot of typos in this.
Okay, line 6.
Oh, yeah, proper DT. Yep.
Yep, we got the same thing.
That's the
That's probably, yeah.
And those two, too. Oh, and that one, too.
Man,
All 5 of those.
you got a whole epidemic here.
I know.
All right, let's try that again.
Okay, it's getting smaller.
Stream in namespace std.
Oh, okay.
Line 23. All right, so let's see exactly what the error says. Error stream in namespace std does not name a type.
Oh, okay.
Oh, that's because this is supposed to be OStream.
Oh,
you forgot the O.
Yeah,
no problem. No
okay,
problem.
Cool.
All right, property. Okay, that's a lowercase property on
Okay.
line 23. It's
property. Right
it's
there.
supposed to be property
next one,
data
too.
type. Property data type is what that's supposed to
Yeah.
be. And then property data type is supposed to be here as well.
Yep.
Let's try that again. It's getting a little smaller. STD does not name a type on line 29.
Probably something similar.
Line 29, STD : iStream. Stream, STD : 2 colons.
Oh, yeah, there you go.
No double, you didn't scope in right. It's fine. All right, run that again. That's gotten way smaller. Error property data type is not proper. Proper data type has not been declared on line 9. Line in CPP, so it's line 9 here. Proper.
Man, I really didn't like typing that. Why?
Yeah, it's fine. It's all right. All right, we're getting really good now.
Okay.
Did not declare pointer to void on line
cannot.
21,
Yep.
or cannot, line 21.
Oh, proper. There it is.
Oh, good eye.
And that probably happens in a couple spots, so I would just scroll down before you even try it.
All right, so copy property, look for propert.
Yep.
All right.
There's another one. Did you get that one?
Nope. All right.
That highlighted one?
I think we're good. I think we're good with that. So basically, the moral of the story is download the code off the website and don't write this live with us. Property CPP line 51. Actually, you know what?
Property.
You know what? This is actually not a bad thing, guys, because learning how to debug code and like deciphering error messages is a crucial part.
Yes,
so it's actually not a bad thing that this happened. 51, column 12, prototype for proper blah. So CPP line 12, right? Oh, I'm sorry. Where was it? Where was that? Property.cp line 51, column 12. Line 51,
right here.
Column 12. Property data type, property. What was the error message again? It said prototype for property
does not match
set does not match. Let's go back to the .h file. Look at set void This is void. There we go. We have a misrepresentation here.
Absolutely perfect. Okay.
All right.
Nice.
Now we're down to just error. Okay, it looks probably the same thing on line 62. 62.
Yeah, that's also setter.
This
so
is
that's
supposed to be a void. Mm-hmm. All right, now that should take us down to no errors.
Yep.
All right. And for those of you, we did that on purpose, right, Brian?
Oh yeah, of
That's
course.
totally on purpose. Okay, so the way that these properties are designed is they're designed to be used inside of a class. So let's just make a little class here. Class, my class.
Yep.
Okay.
And we'll give it like a field like name.
So like you said, Brian, we'll do a private string. You said you want to call it name?
Yep.
Okay.
And then we'll just want to be able to set the class name and get the class name.
Right. And let's do this private as well.
Okay.
So we'll do void set name.
Yep.
String, and I'll just do the definition here.
Okay. Might as well.
Underscore name
equals,
and then I'll just do str. And then
we'll do a get name.
Void get name. And this is just going to return str, right?
Yep.
Okay. Now in the public sector, in the public job sector, we're going to want to define the properties. So I should just be able to do property, and I need to get the template here, right? So in the property, now the first parameter is going to be the object data type, so it's going to be my class. And the second one's going to be the data type of the property, which is a string. And we'll call this name.
Cool.
And inside of our my class, we're going to have in the constructor, we're going to define what the name does. And what the name is going to, do you want it to be, it's read write, right? So
yep.
Read write. All right, now how do we define read write? What are we passing?
So read write takes the what we're referring to.
Mm-hmm.
So, and then
this.
Yep, and then it takes the setter and then the getter.
Okay, I think, Brian, if memory serves me right, this will be and my class.
Colon set name.
Scope into set name, right?
Mm-hmm.
And then there's also going to be, again, with the get name, I think.
Yep.
Don't hold me accountable to this.
Let's just call it
get and I guess maybe for top down, even though this is not required. I'll put this here because we're going to be calling this on the instance. So we should do that. So that should be name dot. We're setting it as read write. We're passing the instance that we're going to be working with, which is this. Scoping into the setter, scoping into the getter. Let me see if this compiles. And of course it does not. STR was not declared in the scope on line 9. It's under. Oh, stupid. Oh, I'm looking at the freaking setter up there.
Right.
Return underscore name.
Yep. Cool.
In member void get name line 9. Return statement with a value line 9. Oh, look at this. My God.
Oh yeah.
Yeah. Okay.
Doesn't return void.
String that. Okay. Now we have it functioning.
Yes.
So at this point, after we have this little sample class in here, let's create an instance of class. Now remember, Brian, properties are an object-oriented concept, so they have to be encapsulated inside of a class.
Uh-huh.
So we have a my class.
Yep.
C.
Okay.
And then I should just be able to do c.name
equals
WiBit.net.
And then we can print that out.
And then c out.
C.name.
Name, colon, c.name.
That's cool. That's awesome.
Okay, now let's CLS this bad boy. Compile. Wow. What's that about?
That was cool.
What's
There's
that?
probably
No
something
match
wrong
for
with the
operator.
Okay,
what
there's
is
some
that?
Outsertion issue.
Line 22.
All right, let's see what that's doing.
Let me comment this real quick. All right, so it's definitely angry about this.
About outsertion.
Which we did define here. Out defined. I wonder if I were to just do something. Let me see if this works. String s equals c dot name, and then we'll see if we can fix this. Just to make sure that it's getting properly, and it is.
Okay.
So what do we have wrong
with the operator overload for the outsertion?
Yeah, what do we have?
Let's look at our friend definition first.
All right, let me just try to see if it's something stupid with concatenating. It's not. Wow, look at that. Okay,
let's check our header file. Oh, that's not property DT, it's the property class. It was complaining before because it didn't match. It's really just not matching because it was a lowercase p.
Oh, it's an instance of property.
An instance of property, right.
Okay.
Okay.
And syntactically...
And then same thing with the insertion as well.
Syntactically, that was not wrong. So this is property, not property data type.
Right. Yeah.
Okay.
All right, let's try that.
You are a magnificent man. Now let's do a cin so we can say couts. What is your name? Colon cin c dot name and cout c dot name.
That's awesome.
Yeah. See here. Your name is os is c.name.
That's pretty cool.
That's very slick. Look how abstract that is.
Yeah, it's nice.
Talk about abstraction, folks. That's what OOP is all about. Nice. Very nice.
Cool.
Now this is a class that for those of you guys that do C++ for a living, you could actually use this in a variety of situations. It also kind of helps solidify the whole abstraction concept, you know? We're dealing with a property. We're dealing with something that is hidden from the user. The actual ability to set it and get it is hidden, and the actual attribute itself is hidden, but I can interact with it using delegation and using our own overloaded methods of overloading the class itself, overloading a few of the operators like out and in, and just passing set and get methods that can be used on the backside to control access to a private member.
And that's not that bad of an implementation either.
No,
it's pretty clean.
Slick.
Yeah.
I mean, I've seen better, but it's still pretty good.
Yeah.
You know, I guess maybe one way you could improve on this would be to have this kind of stuff defined in a constructor.
Yeah.
But you know, it's good. It works fine for the purposes of what we're trying to do.
Thanks for watching.
So ladies and gentlemen, welcome to the Linked List Project Overview. In this video, we're going to take a couple of lessons here, and we're also going to be adding in some programming videos where we're going to be building a linked list, which is a pretty standard exercise in object-oriented programming.
Absolutely. So this will walk you through the idea of the linked list, what a linked list is, what are you going to use it for, how it functions, how it operates, and then we're going to kind of start going through and building out our class definitions and how to implement it. Yeah. So this is just a wall-to-wall run through of linked lists.
Brian, what is a linked list?
Oftentimes when you create an array, you have to predefine the size of the array. And sometimes that can be a cumbersome thing. You also have to predefine the data type of the array.
Right.
With a linked list, it's a dynamic array, and it can contain an assortment of items that are linked together by memory address references. Mm-hmm. This list can grow and shrink during runtime. So it can adapt itself to having, whatever you need attached to it. It doesn't necessarily all have to contain the same data type. You can design it to contain all the same data type. And it has basic actions such as adding an item, removing an item, retrieving an item, clearing all the items, and how many items are in an array. Yep. So it's a very flexible array, and it's called a linked list. It's very interesting.
But it's an array class that is not like your standard array. So when you think about C++ arrays, when you define an array, you just get consecutive blocks of memory. Mm-hmm. And each time that you say bracket number bracket, It's that many memory blocks away from origin. So if I want to go to the third, I go to the first and then go down 1, 2, 3. There's the third block.
Right.
The difference, like Brian was just saying, that the difference is now we're dealing with objects. That every single time that we want to create a new element, during runtime, my program's just going to go, I'm going to just throw it over here, and then I'm going to just hook this one to this one so that they know where they are.
Oh, it's this kind of object. I need this much space for the next element.
Right.
So your elements are all over the place within memory, and they're tied together through references to the next location, kind of like your file allocation table works on your hard drive.
Right, yeah.
Sort of.
And we're going to be doing the doubly linked list, which means that we will be looking at the next and previous value. So each element will know its parent and its descendant.
Let's take a look at an example of what this looks like.
Yeah, so a linked list will typically just start with a pointer, because it's just like the pointer to the first element.
And if you have no reference to where it starts, how can you ever find it in the first place?
Exactly.
So you have to have something pointing to some beginning. You start somewhere.
Like if you want to go into your house, you open the door. You have to know where the door is to get started.
Right.
In this case, we're going to just create an element, Brian. And when an element is created, in our case, we're doing a two-sided linked list. We have a previous value and a next value. And as you can see from this image, they're both black, which means they're null. Because this is the only item that exists. There's no previous, and there is no next. And also, the first item in a linked list will never have a previous item.
Right.
But it has to conform to the same structure, so that's why it still looks like that. It also looks kind of like a creepy face, like kind of like wake you up in the middle of the night. So, Brian, how do we then add a new item to this list?
Well, we first have to point to this object. So this is an object. We'll just say that this is an element object that we're defining, and an element object can point to the previous element and the next element, and it has data in it. We want to point to that object. So let's create a couple pointers. We're going to point to our original object, and then we will also have a pointer to the new object that we created that we want to add to it. So then we have our original that was in the list, and we have the one that we want to add.
And just like the original one, Brian, when the new one is created, its memory pointers that are built into it are null.
Yes.
So we have to change that.
So now we're going to take our pointer and point to the new object and set that back to the next pointer of the original object. So the previous points to the original, and the next of the original points to the first.
Right.
So see how these are kind of linking together. So you have a previous now and a next. And the orange means that it's pointing to the next, and the white means it's pointing to the previous. Now we go to add another one, and now this next reference, this next pointer, points to the next new object, and that previous one points to this one, and that one's previous one points back to the original.
So you can see now we're building a list.
Yep.
This is beautiful.
So they're all over the place, and how those paths make it there through memory is always something different. They're always going to be allocated in some different space. But these two things point to who's next in the list and who's previous in the list. They always do. Now we're going to add another one, and so on. So now you start seeing all over the place in memory, no matter where randomly they get assigned value.
So you can easily, just from looking at this picture visually, Brian, you can identify who's first and who's last.
Yes.
Because the first one, its previous pointer is null, and the last one, its next pointer is null.
Yes.
And if the first node, if they're both null, it's the only node in the list.
Right. If we're traversing this list and we want to know if this is the first or the last, we can check to see if those are null, because that will always be true. If anything has a null next pointer, there is no next location. Even if there was one, it's now orphaned because we don't have anything that points to it. So it's gone.
Now let's go ahead, Brian, and let's delete the third element in this list.
Okay.
He's going to be gone. So how do we go through this process?
Visually, you can kind of assume that we're just going to take those connectors and link them instead of pointing to this person. So let's take a look.
Well, we first have to travel there because because since this is happening at runtime, we don't actually keep track of where everything is. Every node is responsible for keeping track of the next and previous.
Right. We only will naturally have a pointer to the original object.
Right. That's the only one that we really need to know.
And we know we want to delete the third one.
Yes.
So we traverse to the next. Is this the one we're looking for? No. Is this the one we're looking for? Yes. We want to delete this one. We make a pointer. We grab the previous value, which we know is this, and we tie a pointer to it. Then we grab the next value, and we temporarily grab a pointer to it. So now that we're looking at the memory location of the next value, we want to store that off and assign it to the one that's now going to bridge over it. Or jump it.
Boom.
That now goes to the last object and circumvents that third one that we want to, break free. So we're one at a time, unplugging the wires from the one we want to delete and plugging them into the one before.
There you go.
And we do the same thing. We take this previous pointer and we trace it back up and we attach it to point to the now new previous one.
Now this is cool, Brian, because if you look at that orphan you were talking about, there he is. He is pointing at his friends, but his friends have abandoned him.
Yes. And this is kind of a weird situation. It's kind of an awkward situation if you say that, because the one we want to delete is still hanging on. You know? We're like, hey, buddy, just...
He says, no, don't do this to me.
Don't worry about it, man. It's cool. It's just... And he's gone.
Gone. Done.
Now these two are kind of happily holding hands and just sort of had Red Rosie, the other guy, out of the picture.
Beautiful, Brian.
Kids are so mean.
Now let's say we want to retrieve the value from this last one, Brian. We basically do a very similar process that we did with delete. We go to our head value, and the head value is not index element 2, it's 0, so we're going to fly to the next one. This is 1, okay, let's fly to the next one. Okay, this is the one that I want. We can then extract the value and return it back to whatever code is asking for this value.
So this is a process of traversing each item until you find the item you're looking for, and then pull the value out from there and use it as you will. So it's just a traversion process through these linked lists.
Ladies and gentlemen, thank you for sticking with us. Now we're going to start actually looking at some code to build this fantastical, wonderful, mystical linked list that we just talked about.
Yeah.
Yeah. So what are we going to do, Brian? I don't understand. I'm so scared and confused.
So I want to see this work.
Yes.
I want to see this in action.
Yes.
Enough of these weird-looking little alien smiley face things. Like, I want to see how this looks. I want to figure out how we can put this into code. We're just going to start by building the data type that we're going to use as the node. So all we basically have per element is data, a pointer to the next thing, and a pointer to the previous one, just like we saw.
That's it.
And the class template is what will lay this out, because the class template, as you know, is the blueprint of the object definition. So that's what the class template is going to focus on.
So let's take a look at the actual node. So when we were looking at the alien with the circle and the two freaky eyeballs that were staring at us, this is it in code.
Done.
Now, we're using a struct in order to do this. So we're creating a struct called node, or a structure called node. And inside of it, in this case, we're going to have a data which is just an integer. Okay, we'll change that later. But just to get on a flat basis for primitive data types, we create an integer. So it's going to be storing that smiley face that we saw earlier is an integer. I don't know what integer it is, but
just accept it. Yes. Just deal with it now.
And now, Brian, this is kind of cool. Inside the node itself, we're going to make a reference to an object of its own type.
That's awesome.
So we're creating a node structure pointer to the next link and previous link, which will represent the eyeballs on the freaky alien.
Very cool.
Previous to the next.
What do we need? We need to store the number of items.
Yeah.
We need to store a pointer to the first item, because like we said, if we don't have a pointer to the first item,
the rest of them are gone.
Whatever. Yep. Yeah. There's the good as nothing. We have to initialize a pointer to be able to traverse the list so we can move and find things and delete the whatever. We also have to be able to initialize a pointer to be used when we create new nodes.
Right.
There's one that traverses the list. There's one that can initialize a pointer to go to a new memory space when we add it in.
And then there's one that's constantly pointing at the head.
Exactly. So we've got a few pointers that we need, and we need to be able to store a number of items.
So functionally what we need is we had to be able to add a new item to this list. We have to remove items from this list. We have to retrieve freaky smiley faces from the aliens in this list. We have to be able to kill everybody in the list and just run through and make it awkward for everybody at the same time and just kill them all. Then we have to be able to retrieve the number of items that currently exist in the list. And lastly, we have to be able, in order for any of this to happen, we have to be able to traverse the node structure from head to tail and either add, subtract, delete, whatever.
When you're watching this, think of things that you would also like to add, because these are just whatever we think is,
this basic functions.
Whatever,
this just gets you started.
If you think it's best to have the functionality to be able to remove all odd items,
or
all even number
like
items,
a sort
or
method
whatever,
or something,
just think of things that you would want to add, and think of how you would implement those things as we go through these.
Now, if we take a look at the code here on the right, this is the actual class template. It's funny because we looked at that. It looked like some weird, crazy thing, but this is like, what, 25 lines of code?
Not bad.
There's really not much here.
We have the number of items that are in the list. We have a couple private methods. We have in range, and we pass an integer, and that determines whether it's in the range or not.
Right.
A method to travel to a particular index, and then we pass it that index number. Just like we saw before, we have our head, a pointer to our head node. We have our temporary pointer to create new instances to add to the list, and then we have our visit pointer that we use to traverse the list.
This is the one that just like, he had the most fun job.
Yes, exactly.
He just gets to swim around all day.
He's like the social guy. He's like, hey, what's up, buddy? Hey, how's it going? And he just kind of walks around. Can I get you a drink? What's up?
Hey!
That's the visit pointer, you know. Our public methods are the constructor and destructor, just like we always see in our class definitions. But we have our at, remove, count, get at, a particular location clear, just like the things we defined as the functional requirements of how a linked list is going to operate, and our operator array.
Speaking of operation,
Yeah.
we have an operator overload for the bracket, which you guys array. So we can actually make this behave like an array by saying instance bracket
That's
number.
very cool.
So we'll see how all that works.
That's awesome.
But I mean, as you can see, the return data type is an integer because, as you guys recall, the node data is an integer, and we're passing out an integer, which will be the index that will be taken. So we're gonna walk through the implementation of these in just a little bit.
Welcome to programming in C++. Stay with us. We're getting there. You're going to see it in action soon enough. You can probably taste it already, or smell it, or hear it already, or whatever you're into. We're going to now look at the class implementation. We saw the template of the class. We saw the functional requirements of the class. We kind of talked about the concept of what we want to do. Now we're going to look at the class implementation, the how we're actually going to pull off what these functions do.
Beautiful.
When we execute them.
I couldn't have said it better myself. So, Brian, let's start here with the constructor and the destructor.
Okay. We're all going to lean forward and take a look at this. We include node.h, our node header file. Now we start declaring the class linked list. Just like we saw before, we have the count, the range, travel, head, next, temp, pointer, visit, everything. We've seen this. We're going to focus on the constructor and the destructor. In the constructor, we're going to start the head node to just point to null.
Which
we don't
means
have anything in the list.
It's just not pointing at the address that it's pointing to is nothing.
This tells us if there's any point in time where we want to check to see if this list is empty.
Right.
We can just say, is the head null?
Right.
And if it's null, this list is empty. This count must be 0 if the head is null.
Right.
The count can't be anything else. So, as you can see, we initialize the count to 0 because we initialize the head to nothing. The destructor will execute the clear method.
Wow, the clear method sounds like something like your parents told you about sex or something when you were a kid.
Yeah, right. It's like an acronym for something bad. You know? We'll talk about the clear method later. We also will set the head node pointer back to null, as well as the temp pointer visit pointer, because we don't want to have any leftover little tendrils connecting to anything in memory. We just want to wipe it clear. This will effectively just absolutely deallocate the list.
Right, and also when we do actually go through the clear method, which we'll see in a moment, we actually do deallocate all the memory addresses. So we just, like Brian said, if we have like a lingering, like the head pointer is pointing at memory space that's been deallocated, we just don't want to have a risk of some crash or some memory. Like if another program wants to use that memory space and we're pointing at it, we just don't want to allow a situation to happen.
Yep.
I don't even know. So when we look at how the actual linked list constructor behaves, on the right-hand side, we can see this is our little linked list, little bubbles floating around here. And we're going to take the head node and set that to null, and take the count value and set that equal to 0.
Easy.
Very easy. And then the destructor, if we look on the right-hand side, let's just say we have a count of 10. So we had 10 nodes in the list. Our memory address is pointing at 12. And right now our temporary and visit pointer, they're equal to just some random space. Whatever the last value they looked at, it's looking at. The clear method is going to run through and it's going to kill all the other nodes in the list, and then finally just run through and nullify these pointers.
Smooth.
Very smooth. Of course, Brian gets the fun slot again.
Awesome. I get to add stuff.
I gotta be more aggressive. That's what it is. I'm too passive.
Let's look at the implementation of the add method. We've taken as an argument a number.
Right, which is the data stored in the node.
Right.
Yeah.
Our linked list in this particular case, our nodes have a data type of integer. Let's take a look at the first condition. Like we talked about before, if the head pointer is null, the list is empty. We want to keep in mind we're adding to the list. So now we're adding to an empty list in this condition. First, we want to create a new node, and we set that to the head. Now the head's a pointer, so that head pointer is now going to be pointing to the newly allocated node struct in memory. The data element in the head node is going to be set to the argument we pass, which is the number. The next link is going to be set to null because there's nothing next yet. And every time we add it to the end of the list. So that will always be adding null. And because this is an empty list, there is no previous link.
Right. So the head is not null, but the pointers both are null.
Yes. So the head is really just the entry point to the initial node.
Now let's just say we have a list that has 3 other values, and then we want to add a value to the end, Brian. How do we accomplish this?
Okay. This is basically our else condition. And we'll walk through this. Just like we've seen before, each one of these elements point to the next one until the end, where the pointer to the next one is null, and the previous ones point all the way back to the first one until it's null, which means it's the first one. So in the else condition, The else meaning that the head is not null.
A list does exist. Oh, here's that floozy visit pointer.
So here's Mr. Social Butterfly.
So wait, the visit pointer is giving head? Is that what that says?
So the visit pointer first points at head because that's the first known. If it's empty, that's going to point to null, whatever, and we would have gone into the if condition. So we know it's not null. We don't know how many's in there, so we just go into the entry point. Then we say, while the visitor pointer's next link, so while what the visitor pointer is pointing to, the node that represents, its next link is not null, then we set the next link to its value. So we just keep moving to the next one until we get to a situation like in the end, when next link is null.
And this is called the traverse loop.
Yep.
So we're just literally traveling through the entire list. So as you can see, as Brian's moving through here, we went from the head node to the next node. Now we're going to the next pointer, which is pointing at this one. Then we go to the next pointer, which is pointing at nothing. So now we know when we create a new node, we attach it to this one.
Yes. We keep that last node's memory space just remembered. It's the visit pointer is just going to keep it as, you can see it's XO3, memory position 3 as far as these purposes go. We'll just remember that. Now we use the temp pointer. The temp pointer is going to be stored as a new node. So we instantiate a new node and we link that memory address to temp pointer. Then we set the data to num, just like we saw in the original condition. The next link also is going to be null.
Yeah.
This will always be the case when we create new ones. But the previous link will be set to the visit pointer, because that was stored as the last one. So now we have our backwards link, and that effectively jumps us to that last element, that last node.
And so we go, hey, visit pointer,
So
where are you pointing? I'm pointing right here.
Now we have our new one that we're adding linked up to the one that was last. Now that last one still has its next pointer set to null. So we want to be able to pass through that, so we set that to the value of temp pointer, because temp pointer is set to the one we just instantiated.
Right, because the temp pointer just made the new one, so
we basically, just like we did with removing, we just unplug the wire and take it from the temp pointer and plug it into the next one, and now we've effectively just linked them all up.
Goodness gracious, Brian.
Now we increment the count because we just added, and then we return our count.
How beautiful is that? Pretty smooth, huh?
Yeah, it's very smooth.
Nice.
Awesome.
So next we have the in-range method.
You got a lame one.
I got a lame one again.
Do you want me to do this one? You can do the next one?
I don't know if we have any more fun ones anymore.
Get at. Get at's a lot better than...
Your mom's get at.
How about you do both of them?
Maybe I can do both of them.
All right, let's do that.
In the in-range method, what we're going to be doing is accepting an integer. Now, this integer has no relationship to the data stored inside the nodes. It's basically just testing to see if this specific index value is valid. And as you can see from the first if condition, it will also accept negative numbers. In the situation where we don't have a list at all, so that means head is equal to null, no matter what integer we pass, we're going to get an exception because the list is empty. So we can't, no matter what number it is, it's not valid. The next one is that the index value is greater than the length of the list, so we're going beyond the bounds of the array. There's the other exception. Anything else is fair. So if we send a negative number, so for example, if we have a list of 2, we have 0 and 1, and we want to send -1, what that's going to do is it's going to take the index plus that, so it's going to be -1 plus the count, so if it's 2, that'll be 1. Then it will return the last element in the list, -2, we'll get the second to last in the list, and it will basically just test to see whatever number is valid.
I like it.
I like it a lot. So the next one, and then we have the get_at method, which, foreshadowing, is also going to be leached on for the operator overload later. Very sexy. What we're going to do here is we're just going to accept an index value, and we're going to just travel to that index value and return the data in that index value. Now, you can see that there is a reference to another method. Now, you
can see when it returns the visit pointer's data.
Right.
Now, we don't see that happening, but we'll look at that. But that visit pointer is kind of globally available within this object.
Right, which we define, if you look on the left-hand side, as one of the private members in the class. So we have the travel to index method, which will accept the integer that was basically just passed a get_at. And what this will do is the first thing it's going to do is it's going to call in_range to test to see if that number is a valid index. Then if it passes that test, just like we did before when we were adding, we're going to set the visit pointer to the first value. And then we're going to just iterate through the loop until we find the index that we want. And then once we reach that index, the visit pointer then equals the value of that index. So if we're traveling to the third element in the list, the second that I equals that index, the third element in the list, then the visit pointer equals that value. And if it travels the whole way without hitting something, we then will return an exception.
And that's really what that visit pointer is intended to do. That visit pointer is supposed to just kind of go mingle around, and wherever it leaves off,
Right.
we go look back to see where it left off.
You can almost look at it like a read-write head on a hard drive.
Yeah.
It's the actual mechanism that goes and retrieves the data for something else.
And then we look at the position where it stopped.
Right, and start reading from there.
Yep.
Precisely. So that's basically how those two work. The get at sets the pointer and then returns the value within that pointer.
Now we'll take a look at remove at. Remove at, similar to get at, will take an index value, the index position that we want to remove. This also uses the travel to index method, so you can kind of start to see these things build on top of each other. So let's walk through and see how this works. If the index is 0, then we know we're talking about the head reference. The temp pointer is going to point to the head's next link, and we're going to delete the head. So we basically just say, temporarily get the next in the list so we don't lose contact with the rest of it, chop the head off, and then that next in line is now the general.
Nice.
If the temp pointer is not equal to null, if that temp pointer is something, because if that next link is null, that means it's the end of the list, and the list is now empty. Mm-hmm. But so long as that's not the case, then we'll set its previous link to null to keep it clean, to make sure that that's now officiated as the general, as the first in the list.
It's given its hat in the cane
exactly.
or whatever. That's like the ceremony. You are now the leader of the list.
And then the head value is going to be equal to that temp pointer.
Beautiful.
So that head value is now, bridge that connection back. It's always about making sure that we kind of unplug the wires, plug them into the new thing, and kind of do that process. Make sure we cover our bases and don't let anything lingering around, any extra connections. In the else condition, this is where the index value is not equal to 0. So now we're not talking about the head, we're talking about some other value. So we do want to know if this value is valid. Well, when we call that traveled index method, you might remember we also, inside that traveled index method, had a method that tests whether it's in range. So that will also check to make sure that that's a valid value. So we don't have to do that again. That's kind of taken care of for us. So we'll travel to that index. And travel to index, if you remember, we'll always set that visit pointer to be wherever it traveled to.
Right.
Now we set the temp pointer to the previous link of the visitor pointer. That way we have the one before the one we want to delete. Then we set the temp pointer's next link, because a temp pointer is a node struct. So we set its next link to be the visit pointer's next link.
Yep.
So now we've effectively set it to the previous one, and we've set its next one to the one after, circumventing the one we want to delete.
So you're severing off the one you're trying to remove.
And this gets us into that awkward situation we talked about before.
Yeah. Guys?
That almost Fleetwood Mac kind of situation.
Hey guys, where are you going?
Why are you... What are you...
I'm still holding on to you. Why did you just let go of me?
Now the temp pointer is going to be set to be equal to the visit pointer's next link.
So that just kind of finishes it all off.
Yeah. So now we're done with the other connection. Now we're going to set the next connection starting with the next link. If the temp pointer now, which is the next link of the one we were originally looking at the index, if the temp pointer is not null, if it's not the end of the list, then we're going to set its previous link to be the visitor pointer's previous link. So we're going to kind of attach it backwards now. Now once we're done with that, we've now effectively done both directions. And we can delete the visit pointer. Then we decrement the count to keep it accurate, which is just a number, and that's it.
In this list of methods, we're going to be retrieving the count, which is just going to return the integer, the private value count. Then the clear...
Wait, how does that work? I'm a little confused.
It's madness. It's basically shut up. Then the next one is the clear method, right? The
Lysol, extract, abstinence, and
regret. Yeah, there you go. It's like one of those 1990s like mom,
like in
mother
Dare.
and drunk driving
like
things.
Dare and Mad and...
So in this method, what we're going to do is while the count is greater than 0, we're just going to start running through and bang, bang, delete. From top to bottom, we're going to kill everybody at the list. So when we hard code that 0 in there, every time that we just call this, we're killing the top, all the way until every single one is dead. Then we set the node the head node equal to null.
And because we are dealing with integers, there's no, deleting them. Like once that's removed, that's removed.
Right. So if you were to do something like create your own data type, you probably just in the destructor clean up that. I don't want to be responsible for cleaning up your
Right.
So write your classes nicely. So next we have the smooth operator, Brian. The smooth operator. We've already seen the get at method in what?
Nothing.
Is that what happens in that song?
Isn't that Sade? Sade?
I haven't heard. I have no idea. This method leverages the functionality in the get method. You done?
Yes.
All right. This method, overload, leverages the functionality in the get at method. So when the index is then passed in the brackets, which we'll see later, we call the get at method, passing that index value as the value that we're going to get, and then we return the integer that is in that location.
You don't say.
How about that? In this video, we're going to talk about templating the linked list class because we have a fundamental problem, Brian. We can only store integers.
Yeah.
How useful is that? Not very.
No, not really.
No, not very. So if we template this class, we can make it handle any data type that we want.
Any data type
Any
in
type
the world.
in the entire galaxy. So if you wanted to make a car class, you want to have a list of cars, great. Have a list of Brians.
Whatever you want.
I don't know why you want to have more than one Brian, but let's say that you
Whatever
did.
you're into.
Whatever you're into. Whatever variation of Brian's beard you want, you can have a list of all of them. Just as we templated functions before, Brian, we didn't mention this because we secretly wanted to just show it here in the secret material. You can also template a class just like you template a function.
Awesome.
So in here we have the template, class, the data type, the class name, and the class code. And that's just the basic outline of how this works. So let's take a look at the code on the left, Brian. Now, the first thing that you'll notice is we removed the node.h and we implanted the node inside of our private members. Now, the reason why we did that is because the data that it's going to be containing
is unknown data type.
Yes, so it has to be templated, so we're going to just kind of throw it inside of our class.
Ooh.
Beautiful.
Now you can see all the references of the data type. Since this is not a known, we need to keep all of these tied in this class definition here. You can see when we add something, we pass that data type. When we return a get@, we're returning that data type.
Right.
When we do the operator overload, that's going to be of this templated data type. To keep it flexible, keep it fresh, keep it clean.
Beautiful. Beautiful. Now, if we take a look at the before and after, Brian, like this is like before the makeover and after the makeover. And the before, although it looks a little more convoluted, but once you learn the syntax, and we've gone over this in the other video, it's not that bad, really.
Right. The only difference is before we had int, now we have template, class data type, data type.
Right. So,
and then when we call linked list, we also, we've seen this before. We've seen this 1,000 times. It's no big deal. The functionality inside, at least for this, is identical. The implementation code itself is the same.
You can see now in the get@ method, when we return visitor pointer data, we're returning whatever the data type is. So it could be a string, it could be a whatever. It doesn't matter. Isn't that beautiful?
That's awesome.
That's beautiful. How about that?
Isn't that something?
Isn't that something? So you can see here that nothing's changed in the constructor and destructor other than how they're defined because we have to have the template parameter.
And we've seen this 1,000 times.
1,000 billion trillion times.
You wipe out int, you swap it out with more abstract form.
Beautiful.
Now let's look at add.
Now add functionally is the same as well.
Yes.
All that we're doing is we're accepting the new data type,
yes.
or the generic data type.
But once we accept it, we don't declare it again in the implementation. It's just the parameter we take in changes, and the templating of all of these methods.
And it's literally the same code because it's not object specific. Yeah, it's beautiful. Very nice.
It still returns an integer because
it returns the count. These two methods are also functionally the same, just that the definition or the template parameter is added.
That's how easy it is.
Yeah.
So you're kind of seeing a pattern here. There's not a whole lot we had to do other than just getting used to that. I know it looks freaky the first time you see it. The first time you see that template, class, data type, void, void you're used to, but in the case of get@ DT again, linked list, and you see the DT in the angle, it's kind of confusing. Like, I understand it, I get it. Once you familiarize yourself with that, it's really not freaky. That's all basically can just get swapped out with whatever you're returning that method as,
And it unlocks a very powerful feature of C++ as well.
And it's so easy to implement.
Very easy.
All this stuff, like when we went through all this with the integer, we're going through the methods and you're like, oh, this is easy. Oh, that's easy. Like, so is this. It's no different.
And
what do you know?
Yeah.
This is the same thing.
It's the same thing except for the template parameters have been updated.
It's awesome.
And the remove add is okay. This is a lot different. Wait.
No, it's void. It takes an integer. Oh, it's exactly the same.
Damn it.
Well, how about that?
I hate you, Brian. No. Now here's where it gets.
All right. Well, what else we got?
An implementation. How nice. So here
now we're already at the driver.
Yeah,
that was it.
Other
than just changing how we declare it, the idea that it's now abstract, the idea that it's now a template. We didn't change a single line of code in the implementation itself.
Right.
That's crazy.
Just the declarations.
Awesome.
Yeah.
Very cool.
So in this programming example, what we're doing is we're pulling in time.h and stdlib, and we're also pulling in our linked list so that we can do random numbers and all that kind of fun stuff. So in this example, what we're doing is we're creating a linked list, and the integer the data type we're going to use is integer, which is functionally the same that we did before. Mm-hmm. We're going to fill it up with a array of random values. So we're going to have, since, we could select how big we want it, how small we want it during runtime. So during runtime, we decide
how big the list.
At most, I want 20, but it can be less than that if you want.
That's awesome.
So from there, we have a random amount, And then each one of the values is a random number inside that random amount, and then we print that out. Now here's the sexy thing. List, bracket, I, bracket.
That's awesome.
So it acts and behaves just like an array, but it's a linked list. And if you wanted it to do, to make more sexiness to this, all you had to do was create
set at.
We'll create like operators. So you can do like a compare less than, compare greater than.
A plus, a minus. Whatever.
Yeah, but
the equals, so you can,
Yeah, so functionally, this is all that you would need, but, I mean, you could make it sexier.
Yeah.
But this is pretty sexy.
It is. Now, here we really switch it up. Now, this time, instead of an integer, we use a character.
That's crazy.
Look at that. That's awesome.
Yeah, so the same thing here.
Just add a character to the position it is, and moving on. Awesome.
Beautiful.
And we'll really change it up here this time and make a...
string!
Nice.
Now this one, remember the string,
yeah.
So we're creating we're taking in an integer and we're converting that to a string and storing that in the list. So
using our
you can see std : string as the template parameter. So you could literally, if you really wanted to get crazy, make an array of linked lists. Or make a linked list of linked lists that have linked lists inside of the linked lists.
Nice.
You could actually do that.
That's
here.
awesome.
It's beautiful.
And like we were talking about before, if we wanted to do some other, strange thing with it, we could write a function that says, like, remove odd numbers.
Right.
So in this case, we just traverse through the list. If it's I mod 2 is 1, that means it's an odd number. And then we just say remove that index.
Beautiful.
And then go to restart, use a go to label, and just keep, going and going and going and going.
As long as the data types have overloads for greater than, less than, equal to, you can have a generic sort function. You could just pass the linked list and it will sort the linked list.
Awesome.
Beautiful. Hey, Brian.
Yeah?
You know what'll be fun as hell?
Not having to reinitialize the size of an array every time I need one.
That would be really cool.
Yeah,
you know what else would be really cool?
What's that?
Like if we just had like an array that we could just throw stuff at it during runtime. No initializing, no destroying. I can make it whatever data type that I want. Now, wouldn't that be the sexiest thing you could possibly imagine?
Although I can't imagine a circumstance where you'd ever need that, it would be really exciting.
It must be all that time, the Mac development that you've been doing that's made you think in one way. There's only one way to do it, and it can't possibly happen another way.
So the word of the day, linked lists.
Linked list. One of the greatest exercises in algorithm analysis that anybody's ever created, because it's a very functional concept, and it's all over software development in languages that, matter. Okay, we're going to be doing a linked list. So we're going to be saving as on our little desktop, C++, and we're going to make a directory called linked list.
Yep. So we want our header and our implementation to start with.
Yes. Now you guys recall, hopefully, if we're appending this correctly in the video hierarchy, we went over a slide presentation of what a linked list is, how it works, and the code for it. Mm-hmm. So Brian and I are basically just going to be writing our own linked list program because we're going to be using this in other examples that we're going to be doing. So we want to make sure that you've seen it happen. There's nothing hidden behind the scenes and all that stuff.
Yeah, and writing a linked list class really kind of goes over a lot of concepts, and it's kind of a nice project to really drive home. I know when we go through this in the coursework, it can get kind of intensive, mm-hmm. and sometimes it's better to see it in a way where you can write a bit, test it in the driver, come back, write a bit, explain it, talk through it, test it in the driver.
Yep.
So after we get through this, it'll be second nature for you to be able to just knock out a linked list.
Yeah, and also use this code for you.
Yeah,
if
absolutely.
If it works for something that you're doing, I mean, that's kind of what we're here for, So let's kind of start here at the linked list .h file, Brian.
Okay.
And we kind of already went in depth in the video series about what we're doing, how we're doing it. So we're not going to be explaining too much here. We're just going to be doing it. And if we do explain stuff, we're going to try to keep it as short as we can.
So we want this class to be called the linked list class, and it's going to take in a generic data type.
Okay, so we're going to be templating the class then, right?
Yep.
All right, I got the...
So we'll block out the class,
yeah,
and then we'll template the class.
All right, and we do this by this template, and then we're just going to do something like
class and DT
we'll
for
call
data
it data type. Right, okay. And we're going to be functioning with private and public members, and I got to spell private correctly. Pivot.
So the first thing we want to think about is whenever you're building a class, you want to think what's the core fundamentals that this class is supposed to be kind of based on? Like, what's the seed of the class? And in this case, kind of one of the core primitive pieces is going to be a node.
Right, exactly.
Because, as you recall, the linked list is a series of nodes that point to the next node in the list by its memory address and string all these nodes together.
Yep, and each node contains 2 pointers and 1 value. It encapsulates the value that you're actually storing.
Right.
Wonderful. So how do we do this, Brian?
So let's do a structure. A struct.
A struct.
We'll call it node.
Node.
And
we can define this inside of our private. I mean, this is perfectly legal syntax to define the...
Yeah.
That just means, Brian, that this is only accessible inside the scope of the linked list class.
Implementation,
right? So if I have class something else down here, it can't make a node data type or structure because it's stuck here. And that's the way we want it.
So the node's data is of whatever data type we're templating out.
Right.
And we'll just call it data. Because that is kind of like the... Whatever that is kind of what we're storing in there. We want it to be generic. We want to be able to have this a list of integers or a list of blah, 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 blahs. Yeah, a list of whatever you want to make it.
A list of linked lists?
Yeah. A list of whatever custom class definition that you want. A list of persons. A list of whatever you want.
Yeah.
And then the other 2 things that we want to do is we want to have, and this gets a little funny, but we want 2 nodes that are going to be the pointers to the next link and to the previous link.
Yeah, so we're creating an instance of a struct of its own type inside itself, which is also legal.
Just a little trippy.
But see, this isn't completely out of the ordinary because when we did stuff with like the W string lab, we were making instances of W strings and returning those back to things that were expecting W strings.
And it makes sense too. Well, because the previous and next links, what are they pointing to? Other things with previous next links and data types. I mean, it's what else do you do?
Yeah.
So okay, so we want to we also want to be able to store how many nodes that this contains.
Okay.
So count, perfect.
I did see outs.
And then we probably want a couple checks. Like one, we might want to find out if something's in range. So like if somebody says, I want array element like 50, and I only got 10, man. What do you want from me?
Right, yeah.
We want to have something come back and determine whether or not it's in range.
Well, that's going to be a void, I think, right? Sorry about that.
So we're gonna do a test to see whether it's in range or not. This actually isn't going to return a Boolean value. It's instead going to throw an exception up, and then you can handle that exception however you feel is best fit.
Right. So we're not making any assumptions for you.
Yep. Then the next thing we want to do is travel to index. So that's going to kind of just
travel.
Yeah, we're gonna have like a pointer that's kind of our traveling pointer, and this is gonna move that.
He's the social butterfly of the group.
Yeah. So now let's define like that traveling pointer and stuff. We're gonna have our head pointer.
Okay.
So it's gonna be a node that head.
Yeah.
So that's gonna be our starting one.
Right.
We're gonna have another one that's just a temp pointer that we're just gonna use for
like creating new
shifting
instances,
stuff around and moving, shifting things and whatever.
Is it just called TEMP?
We'll just do temp PTR
like that.
Yeah, that's good. And then the last one will be our visit pointer, which is kind of like our like current cursor, so to speak.
Yeah, he's our social butterfly.
Yeah, exactly.
And the travel to index is going to be manipulating this pointer value as it traverses through.
Yep. To that index location.
Yep.
Okay, so now let's take a look at what's going to be externally facing that we'll put in our public section.
Our pubic section, correct. Yeah.
Obviously, we want our default constructor.
We do? Why?
Because we want to be able to construct it.
Why? Why would we? Ah! Okay. Why would we want to do that, Brian?
So that it exists? I don't know.
Oh, okay.
We just do it. And then we have a destructor. We don't have any overrides. We don't really want to initialize a linked list with a list or anything like that. So we're not going to worry about that. We'll just have a default that kind of...
You can write your own that does that.
Yeah, sure.
Yeah.
We want to be able to add.
Okay.
And that's going to take in a data type of whatever we want.
Right, from the template, correct?
Yep. And then we're going to remove add a location.
Right, yeah.
And that's going to take an integer as the index.
Nice, very nice.
And then we want count that returns an integer.
Oh, cool. So like this.
Yep. So...
And I'm guessing, Brian, that's just going to return underscore count here.
Probably. It's likely. We want, like a get at. Because we have a remove at and add. We kind of want to retrieve stuff from the list. That would be helpful, wouldn't it?
It's going to return a data type.
Yeah, it's going to return the data type that we templated.
And get at this index.
Yes.
Okay.
Exactly. And if you want, you can override, never mind. No, it's good. Okay. And then we want to clear the list.
Okay.
That doesn't return anything, obviously.
Right.
And then, let's overload the operator so we have
Sexy.
that bracket thing to make it like
Sexy.
function like a list. Yeah. Now we did this before. We did this on the
string.
Yeah, the string class. Yeah. So that'll be cool.
Is that it?
Yeah, that's it.
What?
So that's our blueprint.
We just did that like in 2
seconds,
minutes. What the
I know.
hell?
It's ridiculous.
All right, let's just do a quick check for syntax. So we'll do include linked list. So we don't have the CPP written yet, so we'll do the .h file. I'm going to do a little start run action, CMD action here, CD, desktop, CD,
C++ awesomeness.
C++ awesomeness, linked list, G++, linked list driver, -o, linked list driver.exe. Oh. All right, so we got line 11, two or more data types in this declaration of count.
What? No.
What?
How does that even make any sense? Does the struct need a semicolon? Yeah, struct needs a semicolon.
It does?
Yeah.
Oh,
man.
well, maybe that'll take care of that. All right, sorry about that, ladies and gentlemen. I'll be damned. Well, that is precisely what did it. So, if not define WiBit linked list.
Cool.
Right?
Yep.
All right. Then we want to define
yeah.
WiBit linked list, and then we want to end if, and then Brian's going to help me figure out what the hell I'm going to put between these two things.
All right, so let's include linked list header naturally.
Now, why would we want to do something so crazy like that?
Because it's the header.
Okay. I'm going to have to take your word on that one. Include linked list.h.
And let's take the same approach we took last time where we basically just copy and paste the header into here.
Magnificent. So let's do...
we'll do our privates first.
You want to do privates first?
Let's do let's do constructors, constructor destructor,
yeah,
and then
go.
two privates and then the rest.
You, sir, are a damn genius. Okay, so if we do this...
Okay.
We're going to have to scope in, right? So it's going to be one of these jobbies where...
Actually, let's just copy all of them first.
Damn it, Brian. I already got started here, okay? Jeez. All right. Sorry about that little...
All right, and then the two private ones?
These little guys here?
Yeah, uh-huh.
All right, these little fellas are going to go here, okay.
And then
what
go
else?
back.
Yeah.
And then go do the public ones, the rest of the public ones.
This isn't so bad. This is actually a pretty small little class we got here.
Yeah, it's nice.
All right.
Okay.
Now, of course, it doesn't have all the functionality you would want.
You can select all those and move them.
Okay, how do I do that?
Shift tab.
Shift tab. Shift
One more time.
Tab.
Yeah, look at that.
One more time. Okay.
One more time.
I'm gonna pretend like I didn't hear that.
Daft Punk? You don't like Daft Punk? The funk.
Not that song. Not that song.
All right. Well, Daft Punk doesn't like you either.
A friend of mine went to a NoFX concert recently.
Oh.
Did you know that NoFX was still around?
Really?
I had no idea.
Are skateboards still around?
I had no idea that NoFX was still around and actually functioning as a band.
Oh, wait, don't do that because it's like our placeholder for knowing if we've been playing.
All right, how about if I leave it right here?
Sweet. All right.
That's kind of like going to see Poison. Oh, wait, wait.
Okay, I would go see Poison if
liked
list. I like that too.
Yeah. I might go.
Yeah,
see
I'll go
Poison.
see Poison. That'd be pretty awesome.
A little. What is it? CC. What was his name? The guitar player. CC, pick up that guitar and talk to me.
Okay.
All right.
So
now we're back to business, Brian. Let's do this.
All right. So the first one is going to return a template data type.
Oh, you know what? You're right. I got to template these, don't I?
Oh yeah.
Oh, actually, whatever.
Fine. We'll just class data type
Like that.
Sweet.
Yeah. If you want, you can do it like this to save lines.
Yeah.
Syntactically,
let's do it.
whatever. I'll do
Cool.
it like that. So.
All right. And basically, we want to null out the head because
So-
this is the constructor. The head's not really going to be pointing anywhere.
Yep.
And we count to 0 because nothing's in the list.
Right.
So pretty straightforward.
When I'm typing count, my hand wants to type C out.
That's funny.
Yeah. Okay, cool. So now
Okay.
we have the destructor.
Yep.
Okay.
And so in the destructor, we'll put in a comment to say we're going to clear it.
Okay.
We don't
cool.
have that built yet.
All right. So why don't we just do
So
this?
we'll just say clear.
Since we know that's
Yeah,
how
yeah.
it's going to function,
Yep.
we'll just do that.
And then we want to null out the header,
Okay.
and we want to null out the temp pointer and the visitor pointer, just to make sure like all of our pointers are just nulled out.
Okay. So the null and then visit. pointer.
Visit PTR, yeah, and then temp PTR, I think it was.
Is it TEMP?
MP, yep.
PTR equals null. Okay,
Yep.
I can live with that.
Okay, and then we say that's it. So now we want to basically go through this list in the order that we don't have any dependencies, kind of like we talked before.
Right.
So now I'm going to close my eyes and think about which ones don't have dependencies.
Does InRange kind of have a little thing going?
So InRange does not have any dependencies, so let's implement that one next.
All right, so InRange index, I guess,
Yep,
right?
index, absolutely.
All right, so Brian, if you were going to write an InRange method...
So if the index is less than 0, obviously that's not in range.
Okay, so you want to do something like if index is less than 0...
So we could take a different approach, kind of like we did before, and we could say, instead of saying like it's not in range, we could really say it's equal to the index plus our count. And that does the same thing we did before, where basically we work our way backwards from the right. So if it's -3, it's third from the end. You know what I mean?
Yep.
So then we want to just do some exception handling, basically. And we say if the head is null, if head equals null, or if index is still less than 0.
Let's run those two separately. That way we have two different exceptions that are caught.
Okay.
So if head equals null, we have one exception.
Okay, that's fine.
Throw new std
right. That makes
string.
sense. I'm with you now. Yep.
What is this going to be?
So this is going to be the list contains no items.
Which is one type of exception.
Right.
Okay.
And then we'll do a else if the index is less than 0.
Okay.
And this is basically going to be out of range. We could probably do this, or if it's greater than index is out of range. We can probably say if the index is less than 0, or if the index is greater than equal to the count.
Or index is greater than or equal to
the
count, like that?
Yep, so it's outside of the bounds, and then range instead of rancy.
Where's this?
Index is out of rancy.
Isn't that correct?
That might be when you fart. It's a little rancy.
That's Rancid, Brian. Rancid. Wasn't that a band too, Rancid?
Yeah, it was.
Yeah, hold on a second. Rancid. Images.
Wait, the band has an official site.
Ah, look at that!
It's funny.
Rancid. Look how cool looking this guy
Oh,
is.
yeah. Let the dominoes fall.
Dominoes fall. Nice.
I play dominoes with an old man in the park.
I think Rancid was a punk band. If memory serves me right.
I don't know. I've never listened to Rancid.
I knew of them. Anyways, okay, well, what's the next?
I was more on the Grateful Dead side of the spectrum.
Yeah, well, that's kind of dumb for its own reasons.
Yeah, fair enough.
Travel to index. Can we do that?
Well, we have in range.
Yeah.
So we know if it's in range or not. Yeah.
Okay.
Let's do it.
And this one, I'm assuming, is going to take in index as well.
Yes, absolutely.
Okay.
Okay. So here we go.
Here we go.
First, we call in range on index to make sure that so it basically just validates the index, and if it's not valid, then it bubbles up an exception, and there you go.
Yep. So it just kind of gets all the failure points out right away. Okay. Now, if it is within range, Brian, what do we do?
Now, then the visitor pointer is going to equal the head.
Visit PTR equals head, right?
Yeah, uh-huh.
Okay. So we're starting at the beginning.
Yes. And then we set, we'll just make I, and I. We'll make it 1. We'll start with 1. And we'll say, if the index is not equal to 0.
If index does not equal to 0, block it off?
Yep, block it off.
Okay.
And then we'll say, so we already did the in range.
Mm-hmm.
We just want to make sure that it's not 0 in particular.
Okay.
Otherwise, it's just going to be the head. We don't actually have to travel, you know.
Right, yeah, don't waste the time if we don't have to.
Exactly.
Right.
And then while the visitor pointer's next link is not null.
So while
visit pointer,
and this is a pointer, so we have to use the arrow.
Yep. And then next
link, like this,
yep,
does not equal null.
Right. So long as there is a valid next link, so long as it's not null, we can move to the next one.
Okay.
So that means there's still some more road we keep on walking. So we'll block that off.
So now our friend, our social butterfly is going to do what?
That's now going to be set to that next link.
So that's going to equal
that.
the pointer that it's got inside of its own self that points to the next value.
That's awesome.
So he's just like swimming around, just like flying through the list until he finds that number.
Who's next? Hey, how's it going? Who's next? Hey, how's it going?
Oh, now this is going to the end. Now, is there
Yeah, we block it off.
right? Oh yeah,
Yeah.
like this. And I guess that's where that I comes in handy, right?
Yeah. So if the I,
Like right down here.
yep. So if I is index, if I equals to index, so that's the location we're looking for.
Yep.
Then break.
Break.
And increment I.
What? That's crazy.
So we go until we hit the index, or if it's not, if we hit an all, we hit the end of the line. And really, our count. Hopefully, that should never happen. Hopefully, we'll always break before we hit not equal null.
Man.
Because the index is in range, it should, in theory, count should be valid. We should break before we ever hit that point.
Yep.
Anyway. Okay. So after this, after that.
Right here.
So we just want to say if the visit pointer that we have now is null, then we throw an exception. Otherwise, we've moved there. We're good to go.
So if for whatever reason some goes down, we're throwing an exception.
Yes.
And we're going to say throw new std string, right?
Uh-huh. Yep.
And what do you want this string to say?
Like unable to find index.
Cool. Unable to find index. That's good enough for me.
Yeah, cool. Done.
All right. So at this point then, Brian, if this passes this test, then we have successfully set the visit PTR
Absolutely, yeah.
to the index that we want it to be on. Okay. Now, what do we got next, Brian?
Next we have,
Can we do add?
we can do remove at.
Okay, remove at. So let me grab my template stuff here for remove at void link list. Wait. Void link list that. Void. Did I do that already? No way. Okay, I don't remember doing that.
Oh, weird. Okay, so remove at's going to take integer, which is index again.
Okay. Okay.
Okie dokie. So we want to say, basically, if the index is 0, we want to handle it a little differently because we're dealing with what the head's pointing to.
Okay.
Else, we do something else, basically.
Okay.
And then after that, we want a decrement count. We'll just get that out of the way.
Like this?
Yep, because we removed one.
Right. So if it's the head pointer, Brian, what do we do?
Okay, let's think this through. So if it's the head pointer, we first want to set the temporary pointer to the head next link. Because if we just delete head or point head somewhere else, we lose that next link. So we want to hang on to that for a second.
Right.
And then we delete head. Because we do want to manage our memory.
Delete head.
Yep.
As opposed to, which would also be nice
Oh,
as well.
Yeah, you're good at that. So long as that temp pointer is not null. Oh, you got pert for some reason. That's why IntelliSense is nice. I like IntelliSense.
We're getting there, Brian. We are
getting there.
So as long as the temp PTR, if temp PTR
It's
equals...
not null.
Oh, not equal to null.
Yep.
Okay.
So long as it's valid,
Mm-hmm.
then let's set the temp pointer's previous link to null.
Temp pointer.
Because that would have been pointing back to the
Right.
head.
Previous, previous link equals null. Right?
Okay.
Because it's pointing at memory that's been deallocated.
Right.
So.
And then basically the head now just points to the temp pointer.
Okay, so now this is give head. So we take head, and head is going to point. Now, guys, we're not like swapping values here. We're actually swapping memory addresses.
Right. We're pointing to different things. We're like remembering where this address space was and pointing to that one now.
So this is not like I'm setting head equal to this value, and now we have two copies of something.
Right.
No, this is just random memory that's been allocated that we're just pointing at. Yeah.
Yep. We're just preserving the address and setting something else to have that address.
Yep.
Okay, so now in the case that we're not dealing with the head,
Okay.
we want to first travel to the index.
Travel to index, right?
Yep.
Okay.
Okay, so now our visit pointer is now over there, right? Mm-hmm. Now let's make the temp pointer equal to the visit pointer's previous link. Because, as you know, we're effectively now going to be deleting our visit pointer, right?
Right.
So we want to preserve the previous link. We also want to preserve the next link. So the temp pointer becomes the previous link. Now the temp pointer's next link becomes the visitor pointer's next link. And so now that temp pointer basically is just bridge that gap.
Right. So visit pointer next like this.
Yeah.
Okay.
So it's not too bad. Okay, so now the temp pointer equals
the
visit pointer's next link.
So temp pointer is going to equal the visit pointer's next link. Like that?
The temp pointer now points to the visit pointer's next link. Now the thing to remember is setting the temp pointer to something doesn't mean the temp pointer now equals that thing.
Right. It equals the memory address of
at
that
this
thing.
point in time, right?
Right.
So when we say temp pointer equals the visitor pointer's previous link, temp now has moved over there and set its next link to something else. Now we've moved over to the next one, and we're going to set its previous thing. Okay, so let's make a space before that line just to kind of like distinguish that as
which line?
Just add a space in there. Yep, just to kind of distinguish. Now the temp pointer is doing something else. So now after this, we'd basically want to say if the temp pointer is not null, because then we don't know what the next link is going on.
Right. So we're looking at next. So if temp pointer is not pointing at the end of list, is basically what that says.
Yep. Then we want to say that temp pointer, that node that we're pointing at now, we want to set its previous link to the visit pointer's previous link. So now that's bridging the next after the visit to the one before the visit. Yeah. So now we've made that bridge all the way back.
Which we outlined in the video that we did before.
Yep. So now after this, we just delete the visit pointer.
Sorry, buddy.
You're out of here.
Goodbye.
Yep.
Goodbye.
And that's it. We're done.
All right, Brian. Now, what is the next method we're going to attempt to
Let's do the add next before we go too far.
All right. So add. Where's add? Right here.
Yep.
All right. So we can do blah blah and okay. Talk to me, Brian. What's the variable name going to be coming into this method?
Data.
Okay. For lack of a better word, that's perfect.
The first thing we want to check is if the head is null. That means our list is empty.
Right. Yeah, no items in the list.
So we're going to have kind of two conditions. One in the case where the list is empty, and one in the case where we want to add to a list.
So if head equals null, then that means that we're dealing with a list that has no items.
Right.
And then in this condition, we're dealing with a list that has previous items.
And then after that, we increment count and return count.
Right. So this is going to be underscore counts. Like that.
Yep.
And then we're going to return to the user just counts.
Exactly. Yep.
Yeah.
That's it. Okay, so now in the case where head is null, it's pretty easy.
Right.
We just say head equals new node.
Dynamic memory.
Yeah, we create a new space.
A new structure.
Of new structure node.
Uh-huh.
And then we set head data to data.
Okay, cool.
And then we want to set the next and previous links to null because that's all, this is all we have. There is no next, there is no previous.
Next link is null. And yeah, like Brian said, since we're just adding one, there's only one item in the list. This is it, and there's no point of giving it an extra previous link.
Okay, so now let's go to the case where the list is not empty.
That sounds good.
And we're going to say the visit pointer should point to the head.
Right. Visit
so that we have, we always kind of start that way and then traverse.
Right. Now remember, this is just pointing at the memory space where head is located.
Right. Yep. Now what we basically want to do is we want to basically traverse to the end of the list.
Okay.
So while the visit pointer's next link is not null.
Well, visit pointer next link does not equal null.
Then we want to just set the visit pointer to be the visit pointer's next link.
Okay. So
just move the visitor pointer right along.
Yep. So we're just traversing through the list all the way up until we get to the last item. Okay, cool.
Okay. After this, we want to set our temporary pointer to be we want to allocate a new space.
Okay, cool. So this is going to be a new node.
Yep.
Equals new node, like that. Okay.
Yep. And then our temp pointer's data will be the data that we pass in.
So temp pointer data equals data. All right.
Okay.
Since there is no next link because we're adding to the end, we're going to set the next link of this new node
to be null.
So if I do the temp pointer, which is our new node that we just created, this is going to be next link is going to equal nothing because it's the last item in the list.
And then the previous, that temp pointer's previous link will be the visit pointer because that's what we traversed to.
Right. So then we have that equals, what is this going to equal?
The visit pointer? Because that was the end of the list.
Yep. Okay.
And then the visit pointer's next link will now tie to our new last one, and that completes the...
It ain't no more.
That completes the circle of life, so to speak.
Yeah. The next link equals the memory space
of the temp pointer.
Of the temporary pointer.
That's awesome.
Done.
It's pretty smooth.
Deal.
So let's keep moving right along.
All right. What do we got next, Brian?
We got the tough ones. We got count and clear.
Oh man. All right. So let's scroll down. All right. We got count. Want to do count first?
Yep.
All right. Hold on. I gotta brace myself for this one. What are we doing?
We're returning.
Yeah.
Count.
Oh, man. Man.
Oh.
All right. Can we do get at or clear? Which one are we doing now?
Whatever you want. We can do get at.
Yeah. Let's do some get at action.
Okay.
Here.
So all get at's basically gonna do. Oh yeah, that's right. We got to make sure we template these.
Yeah.
Okay, so get at is basically going to traverse to the index that we want.
Mm-hmm.
So that parameter we're taking in is index as well.
Right. So we'll be doing something crazy here, like index, and then we'll
travel to index, and then we're going to return that visit pointer's data.
Okay. Visit PTR. Data.
That's it.
Like that?
Done.
Holy monkey!
And then the return type is DT, so...
Right. So whatever the data type is what we return. Very nice.
Pretty cool.
All right, so we got some clear action here.
We want to kind of start at the end and just delete we just want to delete all the way back and then blow out the head.
Okay. Now how would we accomplish this?
So while count is greater than 0, so while we still have something in our list.
Oh, that's cool. So while... underscore count, which is our private member, is greater than 0,
yep,
right?
And then count equals 0. Just kidding.
Program
right now.
Remove that, right?
Remove that 0, yeah.
So we're just going to keep chopping off the top until we got nothing left.
Hack it down and then set the head to null.
Nice. Very exciting, Brian.
Okay, now for the last one. This is the fun one. And then we'll get into testing this thing out in the driver.
All right, this is going to be the hardest one.
Operator over the... Yeah, right. Okay, so all we want to do is when we pass an index into those brackets, we just want to get at that index.
Oh man!
And return whatever that returns to us. Awesome.
Is that it?
That's it.
Golly, man! All right, let's make sure this thing compiles real fast. So let's just take this to CPP. Let's test our luck. Yeah! Whoa! All right, let's look at the top. Invalid use of template name linked list without an argument list on line 6.
Did we not include template linked list.h?
Yeah, you know what we didn't do? And this is totally my fault, guys. Don't we have to do...
Oh, yeah, DT. I
think that's what we have to do, right?
Yeah, it is. No big deal. That happens.
Sorry, guys. Sorry. I'm so sorry. Sorry.
And that's sometimes where an IDE kind of becomes useful.
Yeah.
Because it'll kind of stop you know, when you're using a text editor.
There's nothing in your way for making a horrible mistake like that.
But everything is fixable.
Okay. In member function int that add visit pointer was not a visit pert.
That happens.
Visit PRT. And that's going to be PTR. That should put us in the green, huh?
Beautiful.
Hey! Sweet. All right, we're going to take a quick break, and we're going to come back and test this thing. Okay, guys, so now let's just do a quick test, Brian. So, I guess a simple one would be just testing with some integers, and then we could also test with our own data, like or a string, or we could import the delegate, whatever. We could do stuff like linked list,
like a linked list of delegates.
The list of delegates, you know, linked list, and this will just make this an integer. My inted or just my list, whatever.
Yeah, that's fine.
My list. Okay.
My list does it good.
For ni equals 0. while I is less than 10 I plus plus, and I should just be able to do, right? My list dot add.
Absolutely, and just throw it in there. Yep.
Okay, now if I do a cout my list dot counts, what will this do?
There you go. See out again.
I know. What is that? Jeez.
Muscle memory.
Your face is muscle memory. I don't know what that means. Linked list dot exe. Hey!
Look at that.
Very nice. Very nice. Okay.
So now let's loop through it again, and then we'll see out the result of our operator overload.
Nice. So something like this. See out my list sub I.
Yep.
And line. And we should just get 0 through 10, right?
Yeah. Cool.
Oh, or 0 through 9.
Yeah, right.
So let's do something really dumb, Brian. Let us print this out and then do another one here where we delete everything that is even. What do you think? Or do you have a more fun example?
Yeah, let's do a string one. Let's get rid of all this stuff, and we'll add 3 strings, and we'll delete like a banana or something.
All right, you got it. String.
Okay.
My list. So the first thing we'll do.
So we'll add an apple, a banana, and a carrot.
Apple.
Or a clementine.
What is it with you and fruits? Can we have an example that you make that is not fruit related?
How about?
No, it's too late now. We've already gone down the road. I mean, you gotta wait for the next run.
Oh man.
Apple, banana, and what?
Clementine.
How the f do you spell that?
CLEM. ENTINE. I guess that looks about right. I don't know.
Nah, whatever.
Who cares?
Who cares?
Okay, and then after this, let's remove.
Well, hold on. Let's just make sure we can print the list out.
Okay.
For int I equals 0, while I is less than my list dot count, my list dot counts.
Yeah.
I plus plus, sort of, maybe, whatever. Who knows? Who's keeping track?
There we go.
If I do a cout and I do a my list sub I and line, this time instead of numbers I should get strings.
Yeah.
Assuming that this works properly, and I think it will, and it does! Woohoo! Okay, Brian, now let's delete some stuff.
So my list remove at 1.
Remove at 1 is going to do what, Brian?
You should delete banana.
Okay, so
Banana.
we should see apple and clementine. Hey! Not too bad, huh?
It's a cool linked list.
Very cool, and
There
we're gonna be using this as like the basis for a stack and queue example here coming up. Basic Windows Graphical User Interface Programming. We're going to be using the Win32 API in this lesson.
In C++.
In C++. How beautiful is that?
No graphical editor, no WYSIWYG, no anything. Just, you've always wanted to know how this works. You've always wanted to know, how do I just drag this thing on there and it works? I see these crazy code files somewhere, but I don't know how to make a window just pop up from code. We're going to show you. It's going to be awesome.
Yes, pretend like it is 1995. Windows 95 just came out. This is...
And you're like, whoa, they have a start button.
Yeah, this is hot off the press.
Crazy.
Hot off the press. Windows 95. Windows 95. Look how far you've come, everybody. You're awesome.
Yeah.
Look at what you've accomplished from beginning to right now. You're actually now at a point where you're creating Windows applications.
That's pretty intense.
That's very intense.
What do we need to know first? We're going to be using information defined in Windows.h to build a dialog window. And I know maybe later we'll kind of get into some Trolltech stuff or Qt or, Linux GUI stuff down the road. But for now, maybe we could make this argument. People who are more familiar with Linux are probably more likely to have the aptitude to figure this kind of stuff out than people who use Windows. So let's show it to people who use Windows.
Yeah, let's
sorry,
do
Linux users. Sorry, Mac users. Sorry, OS2 Warp users. Sorry, Commodore 64 users.
Commodore 64.
I don't know.
I would love to see the guy that has his Commodore 64 ramped up to be able to watch this on there with the 64K
it's probably the same
RAM.
guy who's like, when are they going to do the TCL TK videos?
Hey, I actually want to do a TCL TK
I know, I do
series.
too, but who writes a GUI interface? Do you know what I mean?
TCL?
Yeah, exactly.
Yeah, you're right.
Because
It's
there's
that
no,
guy,
I mean, that's like some, that's pounding it out. Well, and we know somebody who wrote a 3D Rubik's Cube solver GUI application in TK.
Oh my goodness.
Which is funny.
Wow.
Anyway. Which is impressive. It's extremely impressive.
Now, other things that we have to know is we're going to take a look at some structures, data types, and functions that come along with Windows.h. Now, for those of you that are thinking that you're smart and you're all great. Yeah, these do work in C. We understand that, but we're just going to be showcasing this as C++.
So we're going to take a little walk around the block through Windows.h just so we kind of get a sense of the territory.
Yeah. So let's start off first by defining, and you see this everywhere in Win32 API, is what is an HWND data type? It's a handle to a window in the Windows operating system. So the H stands for handle, and the WND stands for window.
That just blew my mind.
Handle to a window. Very nice. The earlier Windows developers were awesome, I gotta say. So Brian, what is an MSG structure?
It's just a structure that stores message information that goes to and from applications. Mm-hmm. So it's just a structure that keeps things like the window handle that we talked about before, the message itself, which is just an integer.
Right, like a message code,
integer,
right?
It's just a code, the message. And then a couple parameters, a high and low parameter, and the time, which is stored as a D word, which is the 32-bit unsigned integer, and then just a point, which is PT. That's just going to be just the cursor.
Right. So if you wanted to do something, if your mouse hovers over something, you can calculate its position. Mm-hmm. This pointer will help you with that. Another one here is the WND class EX, which is an instance of a structure that contains information about the dialog window, and this is passed to the register class EX function, which we'll go over in a moment. So just to breeze through these, now there is a link up top to the documentation if you want to read this yourself. We're just going to give you the quick. So here we have the size of, which is the size of the integer, and this is typically calculated using the size of function that we are accustomed to in C. This uint is the style. Now there's a whole bunch of different styles that you can have concatenated with a pipe delimiter. So things like drop shadow, no close,
mod, emo, goth,
right.
Whatever.
The documentation link is below, so if you want to look at this in more detail. WinProc is a pointer to the Windows procedure, which is a very important concept which we will discuss in a moment, but just be excited about this because WinProc is awesome. This allocates any extra bytes to the structure here and here. In most cases, you'll see this at 0 or null because it's not very common for people to use these. And then here is the handle to the instance that contains the Windows procedure that we had defined above. Starting to look a little bit like the delegates that we were talking about, huh?
Yeah, a little delegate. Looks a little like a bastard in a box reporter. Looks like
this shows Brian and I didn't invent this. This came before us, whether we want to admit that or not. This H icon is a resource.
I don't get it.
It's like you and I, we think we're smart, but we're not because it came before us. So this will have the handle to an icon. If you want to have an application icon, a handle to a cursor. Now these are typically embedded inside executables, and you'll see their usage in a moment. HBrush is a data type that just basically stores a color, so it's like a resource handle to a Windows background brush color. So this is a pointer. It's a C string that is basically a reference to a Windows menu. Next we have the reference to a Windows class, which we'll see this in action in a moment. And here is the small icon. So we defined the large icon before, and this defines the small icon in the same exact way. WinMain, Brian.
Weird. Win main and not main. That's crazy. Usually we always see main as the entry point, but in a GUI Windows API application, win main is the entry point.
Yes, at least in Win32 API.
Right. Now it works just like the main, just like we've been using. Don't be afraid. Don't worry.
I'm scared.
It's really a clever way to kind of take control of how our program's going to be executing so we can launch these things properly.
Right.
It's very cool.
Because there are things that this is patched that only something above it could understand.
Yeah, it's awesome. Yeah. Very cool. It's very clever. So that's why we got this win main. And it takes parameters, this instance, the previous instance, and those are just 8 instance types. That is the current application is this instance. Previous instance is a previous application. Then we have a command line argument as a type LPSTR. It's just command line text passed. Doesn't include the XE name. It's just a list of parameters, list of arguments. And then we have integer win show, and this controls how the window is shown. And we'll take a look at this later.
The register class X function. Well, this is like X, I think, is for extra or extended.
Or exciting.
Or exciting.
Or extravagant.
Exciting. Extravagant. Now, this prepares a window for the create window function. And what this does is that win pointer that we were looking at that had stuff like the icon and all that, that's passed by a pointer to this. And then it returns a true or false value if this is prepared. Okay, this is registered. Everything in here checks out. Now you can go ahead and do your stuff. So if it's false, it will return false to the win main. If not, it will continue with the application.
And just for a concept of this, you can kind of think of this sort of like there's Windows needs to kind of have a registry of where everything is. Windows needs to know what windows exist and where so that it knows how to manage things like, what's in the start bar or what's where, what's in the, whatever it needs to do with managing how these things display. So it needs to have these in a registry. This will register your class into that registry.
The load icon function is used to set the icon that we had discussed in the structure before. And it will take an H instance, which is just basically a handle to some executable. And if it's set as null, then it will just use the system default icons. And then the next one is a string that was just the name of the icon that's located inside of the resource. Now on the right hand side, if you look at those constants, those actually map to integers. So we will use some of these later on, but those are, you recognize these, the error icon, the question, the shield, the warning, the application icon. Those are all standard Win32 icons.
Yeah. Load cursor works the same way. So we take in the instance and the cursor name, and that basically is just, let's say we have an instance to a DLL, and then inside that DLL we have a bunch of cursors that are stored as resources in there. Mm-hmm. We just pass the cursor name. Now if we leave H instance as default as null, we just pass null as the H instance, that's going to default us to our just default system32 DLL, basically. And inside that, we have some constants that have access to common resources that you might recognize, like app starting, the arrow, which is just a standard arrow, the crosshair, the hand.
Talk to the hand.
The help, question mark, if you want a question mark.
Hourglass, vertical arrow.
Yeah, the wait one you'd probably use. Wait and arrow is probably two you're going to use the most.
Now, create window, Brian. This is where the magic starts to happen.
Oh.
And create window, this is going to return to us a handle to a window, which is what the handle window handle data type represents. Yes. Now let's walk through this here real quick. So this first one that we're going to look at here, the first parameter we're going to look at, specifies the Windows class name, which is basically some predefined strings that will kind of map this control to its format.
So we can declare this class name. We declare what class this window is going to be, and this window will create with that class name so long as we register this window with that class name. So what will happen is after we create the window, we register this window and it kind of registers that class and ties the two together. You can just kind of call this whatever you need to so that you have some sort of reference to the window that you're creating.
But there are a lot of predefined ones which we'll look at.
Yes.
And next is the Windows title text. So the title bar on the window. Just make it say whatever you want. Or the next parameter is a D word or a double word. That's going to be accepting some style parameters. And, we have WS, minimize, maximize box, minimize box, size box. For more information, visit the link above. If you can read the orange text on the orange box. Now the X and the Y here, horizontal position and vertical position.
Nice, easy.
Now what do we do?
Width and height.
So that's the width of the window, the height of the window. Now here, this is interesting. This is the handle to the parent process or the parent window. In the case of, if we're creating a new dialog window that doesn't belong to another window, we actually will pass the desktop handle.
That's awesome.
So the window belongs to the desktop.
So it's almost like the desktop is the master window.
Yeah, exactly.
So to speak.
Right. And then whatever windows come up are attached to that, and whatever windows are spawned by the other ones belong to the window that spawned it. Pretty cool.
Yeah.
Now, if we do specify a menu, we set this here, but we're not going to be doing that in this video. And here we're going to do the handle of the actual application. Now, you'll see later on in this tutorial, when we see the win main, this is passed in by win main. So this is just the application that owns the window. And then last, we just have some parameter that's just some optional value that is always null in all the documentation you read. So cool. We're not going to waste time with that.
Then we have show window. Show window sets a window state. This allows a window to be minimized, force minimized, hidden, where it's kind of neither and there's nothing on the taskbar, maximized, show maximized, so that's activated and maximized. These parameters are the handle to the actual window and the integer value, which sets this, and these constants that we kind of went over are all constant integers.
Right.
So if you know what the integer values are, or if you want to try some other ones that you find in the documentation in the link, that's cool too. But it's just the handle to the window and what you want to do with the window, how you want to show it. Pretty straightforward.
Beautiful. Now let's start talking about messages. Now when you do something to a window, like your mouse hovers over the window, or you click a button, or whatever, it creates messages. And the messages pass to your Windows procedure function that we'll take a look at here shortly. Now just as a basic fundamental, this kind of creates like a run loop within your program. So as this thing is listening, it's listening for a close, and if it doesn't close, then it continuously processes messages, and you can handle the types that you want and ignore the ones that you don't want, or default, process ones that you don't want to handle. And this will be taking in the message structure that we looked at earlier. This will also be taking in the handle to the window, as well as if you want to kind of filter the range, the lowest value that you want to read and the highest that you want to read. So if you don't want it to react to every single type of thing, like if you're not monitoring the mouse movement, then you filter out that range. So you only look at the range that you're looking for the specific messages that you're trying to process.
So you can get some level of efficiency in there.
Yes.
And we can translate the message. This is an interesting thing. This converts the message struct into a character message. So it takes the message structure as a parameter, and it basically just kind of blows out that... Yeah, exactly, yeah. It sort of just blows out that message structure into what it needs to be dispatched.
Right.
So then when we dispatch it, we can only dispatch it once it's been translated and kind of like properly puffed up. Then we can dispatch it, and it sends a message to the Windows procedure. And the parameter that takes is also the message itself. And that's, the pointer to the structure containing message.
Windows procedure, that fella we've been alluding to this whole time. Now, the Windows procedure is a function that is attached to a window, and it's executed by the dispatch message function. Now, every single window must have a Windows procedure. Now, that doesn't mean that you have 5,000 Windows procedures in your program, because you can actually use the same Windows procedure in all of the Windows for your application. But when things are happening in the window, sending messages, it needs to have a place to send those messages. So what we have here is the handle to the window. So the window that is sending the message, the message number, or like the code, whatever, that's being sent by the window, and then some additional parameters about the window. And we're going to take a look at these in just a moment on how functionally these are used.
And lastly, we have the post quit message. This tells the system that a thread is requested to exit or terminate. It just takes the exit code value, and it will set the application exit code before it terminates. Lastly,
the default Windows procedure. Now, before we had the Windows procedure, we're handling custom things. In this case, let's just say we have a message type that we just want to handle the basic way. So if you had some close procedure where you had a text editor and someone hit close, you check, oh, this isn't the most updated version. You ask the user, do you want to save? Well, let's just say you don't care. You could just say handle it the default way, and it will just close it in the default way, as opposed to having some other way of managing it. And this accepts the exact same parameters as the Windows procedure. Are we done yet?
Holy make it stop. Alright, so it's a lot to go over. We understand. Stand up, stretch your legs, shake your arms out, get your blood moving. Jacks. Yes. This walk around the block is why it's so difficult to understand every time you go to look at the code for how the GUI stuff works in C++, and you're like, what the that? I don't know. It's because you haven't had this walk around the block. So now that you're properly whorish to dig into GUI application stuff, you've walked around the block. Now we know how to understand how to make basic Windows applications with a GUI work in C++.
Right, with the Win32 API.
Yeah. So now let's jump in.
This is a full code example. Take this code, put it in a text editor, compile it with G++. You will actually have a window open. Now, Brian and I want to walk you through this application from top to bottom. This is all the code that you need to have a window pop up, huh? Pretty
awesome.
cool.
Yeah.
Not bad at all.
Let's do it.
Now, down here is that win main, which is the main function for the window. Remember that. So in the win main, we're getting a bunch of stuff and doing things. Now, we define our handle, Brian.
And the message.
In the message. And that structure that contains information.
Yeah.
Yeah. And that structure is going to be valued here. And if you look at the right, this is the actual structure as referenced by the Microsoft MSDN documentation. So you can see some stuff like the H instance is the H instance that's passed to us by the Win API. So that is the application that is controlling this window. And then we have the class name, which is a generic Windows application. Then the Windows procedure, Brian, that function above, which we'll talk about in a second, is being passed. Now remember, since it's not within a class, we can just pass the function name.
Nice, yep.
You know, because we've already went all through that stuff already. Yeah. Then we got some other stuff, like the default icons that we're using and the background color.
Right. What the cursor is going to be, whatever. Yeah. Cool. You got it.
You got this.
And now we're going to attempt to register this class, and we're going to pass it the pointer reference to our Windows class that we just instantiated and filled all that information out for. And if we're not able to register it, we're going to return 0 and kick out of the program. So if we can register and register successfully, then we can kind of continue on and we're able to create the window once it's registered.
Right, so as Brian just alluded to, next we're going to set the Windows handle. So the Windows handle, HWND, is going to equal the response to the create Windows function. And just like if you look at the class name for the struct Windows app, this one is also going to have the class name of Windows app.
And that class name must match.
Yes, you are correct. Absolutely. Then we have the title text, which is going to be my Windows application, followed by some other stuff like and then
Overlapped window.
Then next we have where we're starting it, the default XY position on the screen starting from the upper left corner.
And that's going to be the default position. So we're going to use the constant default. So we could say 0, 0, start at the top left, or kind of figure out the screen size and whatever.
Yeah,
blah, blah,
right.
Blah. We're just going to start at the default position.
Yeah.
We're not crazy.
Yeah, we're not crazy. And then it's going to be 640 width, 480 height, and we're attaching it to the desktop handle.
Nice.
How sexy is that? And then, of course, we're also going to be passing in some other stuff, including the actual application that is going to be controlling this window. Which
is this instance.
This instance.
Next,
window.
We'll show the window.
Yeah.
And this is going to pass the window handle and Unster still. That basically just shows how the window is going to be shown. Whatever. Then we go into a while loop.
This is like the run loop.
Yes.
The message loop.
Right. So this is the application running effectively. Mm-hmm. While get message, so we're basically just sitting there constantly polling for messages to come from the window. Get message, get message, get message, get message. While we're getting something, we're going to get the message, translate it, which puffs out the message itself, because you can see we're passing a reference to messages. Puffs out, translate message, puffs out that message struct, and then dispatch the message. We're going to keep doing that over and over and over and over. Translate, dispatch, translate, dispatch, translate, dispatch.
Now, that only happens when you're having messages occur.
Right.
So if you have a window and your mouse cursor is not on it, that actual get message function will just sit there and wait. So the while function isn't polling, it's waiting for a response.
Right.
And then once those responses come in, then it's going to process them.
Then it goes back and waits and goes back and waits and goes back and waits.
If you want to have a little fun, put a cout statement down there, or a printf statement, and then take your mouse and drag it over the screen, and it'll go like all over the place. It's kind of cool looking. So let's go see where all this craziness gets processed. This madness, all this weird, insane stuff goes to the Windows procedure, which, remember, Brian, every window must connect to a Windows procedure.
The Windows procedure takes the window handle, the message, and high-low param, which we don't have to worry about right now. And we're going to call a switch on the message. So depending on what the message is that we take in, we're going to handle it in a certain way. In this case, we're going to switch on WM_destroy. That's a message type saying that we're basically wanting to quit this process, this window. We're going to then call post quit message, pass it an execute of 0, and then break. And the default parameter is just going to say return default Windows procedure. So if it's not destroy, that's the only case we're handling, we're just going to say do whatever the default Windows procedure is.
Mm-hmm. Yeah. And that's it. That's a basic program. So on the right-hand side, we have our Windows simulation.
Our South Park Windows simulation.
We have a command terminal, and we use G++ to compile GUI.cpp into GUI.exe. We execute it. We get a window.
That's a nice looking window.
It's beautiful, and it's 640 width, 480 height, and it just has the title with the close, maximize, and minimize. Kind of cool.
Nice.
Not bad. Now, I know that this might not be enough for some of you guys because, okay, you can make a window happen. What do you freaking do? Now do something with it. How do I do stuff like put controls on the window?
Right, like make a button.
Yeah, like a button. We will show you how to do that.
It's a little button.
Right now. All right. This application on the right is what this code on the left will produce.
Interesting.
Yes. So, Brian, let's just kind of go over the fundamental differences between these two, and then we'll see what the outcome is.
These are very similar. You can see right away, if we look in WinMain, we have our WinCL object, and that's got the H instance, Windows app, style, the icon, the cursor, whatever. We've kind of been down that road before. So we make all of our definitions, our stylistic definitions, just like we have in the window. Now, the difference is, once we go down, we see we have the create window, which goes to the window handle. But then below that, we have another create window, which goes to the handle win button.
And what is that first parameter, Brian?
Button.
It's a button.
Yes. So that's the window class. So everything that you create is basically creating a window. But the class that we call will return back a handle to a different type of object. Mm-hmm. And in this case, because we asked for a button, we're basically getting a button to work with. And that H instance is so that the window handle is the same object data type for the button as well as for the window, which is crazy. They're both
You
handles.
mean the HWND.
Yeah.
You said H instance.
Oh, I'm sorry.
Another thing to look at is if you look at the way top, we have a define. So we have a constant defined as 999, and it's ID button.
Interesting.
Now, in the olden days, there were no automatic ways for us to manage these. So we actually had to set our controls with numbers so we could identify which ones they were. So also, if you go back down to the create window function, you'll see that the parameter that is third from the last is a typecast value. We're sending that value 999 in, coming from the preprocessor directive.
Nice.
You can also see that we're starting this in position 10 from the left, or pixel 10. Then we're going to go down 200 pixels, 600 and whatever width. I don't have my glasses on.
30 height.
Yes, and then the HWND is the window that we're going to attach this to.
Yep.
Fantastic.
So as before, we called it the parent handle was the desktop. Now the parent handle is going to be the parent window.
Beautiful. My Windows application, when we show the window, we get a window.
I know, it's awesome.
That's ridiculous.
It's very cool.
Now, Brian, what this program is intended to do, all right, now we didn't want to just show, we want to actually show you some action so that if those of you that are curious, you can take this and run with it and you could make little baby Windows applications. So we want to show this window being clicked and our application responding to that click. So let's go up to the Windows procedure and do a quick walk through how this is going to respond to that user clicking on it.
When we click on the button, that's going to generate a message. That message is going to be processed by Windows procedure. Windows procedure is going to take the message. We're going to switch on the message, just like we did when we looked for WM destroy. We still have that case. That's still going to be the post quit message call. But in this case, we also have WM command. When we switch on WM command, we're then going to look at the arguments. The first argument is going to be the high word and then the low word. The high word is a function that takes in a parameter that returns if that argument type is button clicked, then we check the lower parameter. So we kind of have what happened and then what it happened to exactly. So then we switch on the low word and pass it in the other parameter to try to figure out what it happened to. In this, we do a case on ID button, which we've already stored as 999 and attached as that button. So that button object instance has an ID of 999.
Right.
Now we're going to do a switch case on that. So if this is the button that was clicked, we're going to pop up a message box that's going to say, thanks for the click, buddy. I don't know why all computers are Canadian in our mind. Anyway.
Because they always look so happy. That's what it is. So. The title bar is going to say, my app, and then we're going to have an OK button, and we're going to have a icon that has a you should be scared thing. Now, this message box function is predefined in Windows.h, and it will just create a basic dialog box that allows you to click OK.
Yep.
You know, so it's a kind of a quick way to throw a window up in your program just to kind of like give the user some information.
But at least this kind of shows you the basic structure of an event. So let's see what happens when we click on it.
All right. Let me get my mouse cursor.
All right. Got it.
Boom!
Oh, nice.
Sucker.
That's awesome.
And then when we click OK, the program exits. Or the program doesn't exit, but it goes back. It sends the control back to the other window. Now, you guys, I mean, come on. This is cool.
It's pretty awesome. So now when you jump into these like Swing and .NET, Visual, Microsoft Fried Chicken, whatever you get into, whatever suits your fancy, at least now you'll have some sort of frame of reference.
Yep. Yeah, because, I mean, this is literally taking a Windows application and building it from the start. Back the way that our grandfathers in the 1990s once would handle these processes. Beautiful. Ladies and gentlemen, now that we have gone through our C++ material, we're going to start talking about object-oriented design. Now, this is, I don't want to say that this is a common thing that you'll see in C code, but this is kind of something that Brian and I really like to showcase to people that are learning C, because you can sort of treat C as if it were Java in a way, as if it were C#, and kind of use it in that object-oriented realm that a lot of the more modern programming languages use nowadays. You know, C++ uses the main function concept to create instances and objects and stuff like that. What we would like to do is use the main function to create a main class that uses the main method.
Right. What we're basically doing is preparing you for the next generation of languages, basically. And we're going to literally walk you through how they arrived at the needs of those languages.
Right.
It's very cool.
And like the template for how this all came about.
And this will help you understand things like C# and Java a lot better. It's going to make that transition way easier, and you're going to come at it with a very grounded, strong foundation. It's going to make all the difference in the world.
And if you have an IDE, right? If you build your own C++ IDE and you make a template for this design, you would not even know you were in C++ if you did it sexy enough.
That's because you're the best
around. Nothing's going to ever get me down. You're the best. As we discussed earlier, C++ is a bolt-on language, right?
Right.
So C++ does not conform to the main class concept as modern languages
It's
do.
not a native object-oriented programming language.
It's slammed and drilled on Just like Objective-C, which we'll be talking about after this.
Most modern object-oriented programming languages don't behave the same as C++. Well, we can create an environment that makes it mimic modern languages. Using object-oriented design will also allow you to work in a more object-oriented environment.
Yeah, it's more pure.
Yes. It keeps you always thinking in terms of objects.
Right.
So you're never abandoning, you're starting on an object, you're moving to an object, you're always thinking in terms of objects.
Mm-hmm. So when working in our object-oriented design structure, our object-oriented design will consist of 3 files. We're going to have a main class.h file, which defines the template for our main class.
Uno.
Then we're going to have the main class CPP, which implements our main class.
Dos.
And this will be declaring our global items, so all of our includes will be going in the main class.cpp file. And then the launcher,
Tres.
yes, will be main.cpp. Now, the only thing that main.cpp will do is it will just create an instance of main class, and you will be working in the main class. So main.cpp means nothing to you. It's just a bridge to get you to where you want to go.
Just like Kevin said, main.cpp is just a bridge to get you to where you want to go. We're talking about the main class as a object, not as an entry point necessarily. Mm-hmm. The main.cpp will have the entry point that gets you started in the main class. Mm-hmm. Then we have other supporting classes, like supporting class 1, 2, 3, 4. And those supporting classes can then be referenced from the main class in the main function.
Right, so you're swimming up and working in the bubbles. You're not confined to this little box of a main. Now you're actually working in a more pure object-oriented setting.
So you could even destroy your main class and jump to some other thing once you get up and running.
If you really wanted to,
yeah,
sure, why
you
not?
could spawn off into other things and then just kill the main class, and now you're just like a little bubble on its own floating around doing some weird making little agents and stuff. Let's look at the main class header file. We want to define a template for main class. We're going to define method prototypes, fields, properties, and any new property that's needed by the main method now can be defined here. At the very least, this will define the main prototype. So we have that as a starting point. So let's take a look.
Wow.
Or private and public.
Very complicated.
Whatever. Yes. And we have the main class constructor does its thing, and then we have the declaration of main. And it takes an int and a string array, just like we're used to seeing.
But this is not the main function. This is the main method. Oh,
and it's a void.
Sexy!
This isn't returning anything to the operating system.
Yeah,
it's not
that's
returning
true.
an integer to anything, it's void.
So in the main class.cpp file, this will contain our class implementation. So at the very least, its responsibility is to define the main method implementation. We also want to use this to put all of our includes and globals so that they're accessible to the entire program. So remember that includes have a hierarchical, how the f*** do you say that word?
Hierarchical.
Have a hierarchical effect. So when something is defined above something else, it is active for everything below, but not above. So if you want stuff to be available to your whole program, you just include it here. So use this method to program and not the main function inside the main CPP file. And again, like we said, this will allow you to work in a completely object-oriented environment. Here's the implementation code for my main class.cpp. As you can see in this example, we're including iostream, time.h, using namespace std, and we're also including our property CPP file that we created in the previous video. And lastly, and this should be last on the list, the main class.h file, which will be importing the template for this class. So instead of programming in our main function, we're going to program in this function.
Nice.
Very
and
sexy. This method.
Whatever. I know it gets confusing.
Yeah.
Don't kill yourself over it. So the main CPP will collect all the arguments as a string array instead of a character array.
Yeah.
That's one difference. Also, it'll create an instance of the main class, and it will call the main method within the main class. So we include mainClass.cpp.
Sexy.
Easy. And now we want to just implement a getArgs, the return to string pointer, and it takes the argc and argv, just like we're used to seeing, the argument vector and the argument count. And args is going to be a new allocation of string, the size of argument count, iterate through that, and we store all those off into our args, and we return it. Easy, no big deal. So now, don't worry about it.
Well, we just converted the argument vector character array into a string. So now that adds to the object-orientedness because we're no longer working with primitive data types. Now we're working with an object that will be containing our
That's awesome.
Our parameters.
Yep.
So you could do something weird like one argument dot length. Wow, craziness.
Now here's the main. Now this is lowercase main. So this is our main function.
Yeah.
And that is just like we're used to seeing it. Returns 0, starts int main, argc, argv, constant character pointer. Now you can see we instantiate the main class in a main instance pointer, and it's a new main class dynamically allocated. Then, in our main instance, since it's a pointer, we use the little arrows. We call our main method, and we just pass right on over argc and getargs, which will pass our string pointer. And then we delete the main instance when we're done.
Beautiful.
Return 0. Very clean, very nice.
If you write using this convention, you have a similar setup as Java and C#. Now let's kind of use this to demonstrate an object-oriented operation, Brian. Now, a very common usage of a structure like this is doing graphical designing. And we're going to just this isn't a real UI framework. We're just going to make a fake UI framework that just has a button and we click the button. But it's more of a concept base than it is an actual base. And later on when we get into other languages, we're actually going to be using this.
Cool.
But this is just to kind of understand how this all integrates and why it's important to think in these terms. So we're going to create a instance of an object called UI button, which we'll define in a moment. We're going to use this to simulate a button click, and that button click is going to execute a delegate that exists inside of our main class. So we will be able to have multiple buttons where each one of them share the same delegate.
That's awesome.
And then inside of that delegate, we will know which button is clicked because, here's the kicker, we're going to pass a pointer to the button that was clicked. So you can access all the members of the button that just sent you data.
In the future, you will be very familiar with this concept.
I like that. That's beautiful.
All right, let's just rock and roll through this. Here's what we're going to do. UI button header, UI button implementation, creates a UI button object.
Yep.
And within that object, there will be a click event.
Right. Now, it's a method, but we're going to treat this as an event. Exactly.
This is then related to the main.cpp, which instantiates our main class. That's how all these kind of are tied together.
Right.
In the main class, it comes from the main class header, main class CPP.
And inside the main class, Brian, we have a method called onClick.
Interesting.
I wonder what's about to happen here.
Ooh.
So our main method is going to create 2 instances of UI button.
Nice.
So you could just imagine that this is a cancel button and an OK button, just conceptually.
Now we have 2 instances. Now the instances each of them have just a default click reference.
Mm-hmm.
Now we want to set those clicks to be different actions. We get onClick, we send the onClick delegate, attach it to the UI button, and that ties back to the onClick method in our main class.
So every time that we click, so if we click this button, we're going to then activate this object instance. This object instance is going to call the click method, which is the click event. The click event, in turn, is going to call the delegate that exists inside the main class.
Nice.
Passing the pointer where it came from. So inside of the onClick, I can say the OK button was clicked because the pointer that I received is the pointer to the button that has the text OK on it.
That's awesome.
Isn't that sexy?
Isn't that something?
Isn't that something?
That's cool.
Now let's, Brian, explain. Here is the actual template file, or the header file for the UI button. How the does this work?
Well, we've seen something like this before. Now, in this case, we have string the text, and the text is going to be what's going to be on the button.
Yeah.
We have an initialize. We have a onClick delegate template.
Now, if you notice, the template has a UI button pointer.
Right.
Yeah.
Then we have the delegate instance itself. Publicly accessible, we have the constructor for the UI button. Then we have connect to onClick receiver, which we've seen something like this before. And this is in a template form. And we also have set text, get text. We have a click method, and we have the text property. And we've seen properties implemented. So all of this, we're kind of seeing an aggregation of all these concepts we've gone over before. So if you get a little stuck in any of these, just jump back to previous videos. Not a big deal. That's what they're there for. Now let's look at the implementation of the UI button.
Implementation.
In the constructor, we initialize, and we set the delegate instance and the onClick delegate to null.
Right. Remember, the initialize method we're using to set the properties.
Right.
So in this case, we're calling the read-write method inside the text property, passing this, which is the current instance of the main class, or whatever class is executing in, because it's templated. We're also passing this, the method that we're passing as a delegate is the set text and the get text.
Right. So now we have that text as a property. Very cool. Declare the implementation for a connect to onClick receiver. And just like we've seen before, we've taken the delegate instance, and then we take in the delegate function. And we just store that as, I don't know, the delegate instance and the onClick delegate, which is the pointer to the delegate function.
The only thing to keep in mind here is that the delegate that we're using for the click action must be void, and it also must be able to accept a pointer to a UI button.
Right. And we also have the set and get. We've seen this a bunch. Set just sets the text. Get returns text value, which is our set and get properties for the text property. Mm-hmm. And then we have the click action.
Boom.
Now, this will check to see if there's a delegate instance and if there's a onClick delegate. And if there isn't, it will just return
Yeah, that
Just nothing, just kick out of there, doesn't do anything, whatever. Just for safety. So if any of those aren't, now if both of those are set and we're good to go, then we go to the delegate instance, we jump over to the delegate, unclick delegate pointer, and execute passing this object.
Do we pass the actual button as a parameter? Now, that little check all there is when you do get into UI programming and you put a button on a form, the program doesn't crash when you click the button. Because the delegate's not set.
Yes.
When you click the button, it just does nothing. So if this was a real button class, it would functionally do the same thing. Every time I click, nothing happens unless a delegate's been set, in which case I turn control over to the delegate. Once the delegate is done executing, I will continue the code within this program itself. Let's take a look at the main class.h. Ooh. So we can see that here we have 3 private members that are UI buttons. Now, remember the template? We're passing main class because that's the instance or the object type that we're calling this within. We're declaring button 1, my button 1, my button 2, my button 3. So those are our 3 conceptual buttons that we've created.
Cool.
We have a main class constructor, which does nothing, but looks nice. Then we just have the template for the main method and the template for the on-click method, which will act as our event. And this, just like we showed in the template in the UI class, this will be accepting a UI button. And again, we're templating it with my class because that's the class in which this is being evoked from.
Cool.
So, and the main class.cpp, we had the same stuff from before. We have IOStream using namespace std. We're pulling in property.cpp. And that, in the hierarchical thing, UI button requires that because it has a property. Yep. So we have that UI button.cpp and then the main class.h, which requires everything north of that. Inside of this, we're going to evoke the connect to on-click receiver for all 3 buttons.
And this is effectively just plugging those wires up. We're just kind of connecting the stereo.
Yes. And that method on the way bottom that says on-click, every one of those buttons, when they're clicked, will then run that code within this instance of main class.
Very cool.
Before we evoke the button to send the control back to this instance, we're going to set the text. Now, we've had the property here. We have my button 1.text equals my button 1, 2, and 3. That way on the bottom, when you see that code, when the button is clicked, we can say the cout clicked text, so we can tell which button had sent that response or that
text. And this will effectively simulate clicking the first button, then clicking the third, and then clicking the second.
Right. Then lastly, we just have the main.cpp, which is exactly the same as the one that we saw before. All that we're doing is we have the get arg to convert the character vector into a string array, creating the instance of main class, and then evoking the main method in the main class, which gets everything started.
And then deletes it.
That's pretty awesome.
Yeah.
But what I want to see, Brian, is I want you to show me visually how this happens. Because as sexy as that code was, I need more.
First, we include the main class.cpp. That gets us started. That's what calls the lowercase main function and kind of includes the entry point. Now we have the main class. That also includes the definition of the UI button, the property. We included all those in that order. Now we have all the concepts of those, the definitions of those, and the entry point. Here we execute the main function that will create a main instance and execute the main method in the main instance. Did you get all that? All right.
Very nice,
cool.
Brian.
Here we point over to the new instance of the main class. The main class then contains main method and the onClick method. Here we see the template for the main class. It has the 3 buttons like we saw before, and it has the onClick. These are the UI buttons, which is included from the definition before.
Ooh.
Here's the instantiation of these 3. So considering how and when we are instantiating and invoking things, we are first instantiating the main class and then from there jumping into the buttons. So we have to kind of go from the entry point into the main class, from the main class connected over to the main buttons to the clicks.
Mm-hmm.
So everything kind of ties together. We always have wires connecting one object to the next, and we kind of link these things together and establish how this will all be built out. However we build it out, there will be a path from any B to F to A to D to whatever we're getting to. This is the class template for the UI button.h, and that shows the blueprint of what the button definition is. You can see just like we saw before. There's a connect to onClick receiver, the setter, the getter for the text value, the click method. Inside of these objects, these will be represented, the delegate instance in the text will be represented as these 2 rectangles. Here we have the text property. That'll be represented by the orange text property icon. And here we call the main instance's main method.
Beautiful.
So this is what starts the program off. This is what gets it kicking
so
into gear.
before we actually did anything, we built our universe, and then we swum into it. That's
Yes.
what just happened.
Just like in Mario Brothers, we just...
Do 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 do.
Nice. First, we want to connect the on-click receivers to each of the buttons. So here, button 1, we're connecting to on-click, button 2, and button 3. Now we've effectively set all of those. Now you can see they're all orange. We've tied all of those to the on-click. Then we set text, set the text, set the text.
Beautiful.
Now we've got my button 1, 2, and 3.
Beautiful.
Then we execute button 1 click, and that calls it from the main class. That calls the on-click method of the main class, and it prints out click button text property. You see it print out to the console up above. Then we call my button 3. We go over to that instance, call click. Click calls the delegate function. That prints out the click button's text property. So now you can see, then we click 2, and that prints 2. So you can see the console now printed 1, 3, 2.
Very, very, very nice, Brian.
Nice.
Now we have to go through the death. Now let me explain the death. Since you get the fun, let me at least get the
I
killing.
can be the Grim Reaper.
Yes. So as you can see from this code, after the last button click has been evoked, now we're going to start murdering things. Because the destructors will then start doing their thing. So then the buttons are dying, and then in turns, the destructor inside the property is killing it. The destructor inside of the my button is killing it. Then once all of those are dead, the calling class that had once been the leader of this universe is going to start dying as well. So he
And
dies.
then it will go supernova. No,
Yes.
No. Just kidding.
And then we just have a big, vast vacuum of space. Nothing is left except we can put more input and create another outer space.
Nice.
So I guess that's what a black hole is. It's like the input for like a new universe. In a nutshell, we created our object-oriented environment, we swum around in it, and we worked in it, and it wasn't that bad at all.
All in a nutshell.
So
Look at me. I'm in a nutshell.
You are. How did I get in this nutshell? When we go into the next languages, guys, we're going to start swimming around this universe. And this is kind of that introduction. We're also going to be doing some supplementary material where we're going to be writing code in this framework. Now again, you might not see this everywhere you go, but this is the next bridge to the next level that you will be achieving in your journey at becoming the greatest software developer in the galaxy. Operator overloading, Brian.
Yes.
We're going to overload some operators.
Yes.
Now this is a concept that we have discussed previously.
Yes.
Now we're going to actually show how it works.
Yeah.
Yes. So an overview, Brian. What is operator overloading?
Operator overloading is when you add two things together, subtract two things together that use that operator. The operator might be a plus, a minus, or whatever. So you have an instance 1 and an instance 2, you add them together and it equals something else.
Wow.
Well, the C++ language knows how to add two integers, or an integer and a long, or whatever the case is. But it doesn't know how to add your own custom data types.
Very interesting,
Yes.
Brian. Very interesting. So if we wanted to do something like this,
Yes.
we have two objects, and we could just say, just for the sake of argument, that these are inherited from the dessert object, and then we have a cupcake and a cookie.
Nice.
And they're both comparable data types.
Right.
So I have my cupcake and my cookie, and when I add them together, it equals a delicious yum yum.
Yes.
I mean, that sounds like a really good dessert right there.
So, of course, the cupcake and the cookie can be anything that you make it to with any collection of data types, any collection of variables, and whatever else however you design that class.
Right. And when we
But
do...
how do we add them together?
Right.
That's the question.
We have to figure out how that's actually going to happen.
Yeah.
Now, just before we get started, here's a list of very common overloads that you can use. You see simple stuff like add, subtract, multiply, divide, plus, equals, insertion, and, caret, new.
Whatever. Tons of stuff.
All kinds of stuff. Some of these we haven't even discussed. You know, and some of these we'll also be just using later, just at random, just because we're cool like that. So before we get started, let's kind of take a look here at something that we know. Now, we know that when we want to send a variable as a pointer to a function, in this case, we're using C. We then put an and symbol in front of that value to send the pointer reference to the receiving function below, where in the prototype and the code implementation, we define that value as a pointer. So int star z,
Right.
star z equals local x plus local y.
So passing by reference instead of by value, passing by reference will pass a pointer. And we have to take it in knowing that this is a pointer, otherwise we'll basically typecast that pointer as the variable itself,
And
as the object itself.
we can cause troubles.
Yes.
But C++ allows a more sexier way to do a very similar thing, and that is using the end in the prototype and the implementation, Brian. How does this work? What happens?
Keeps it consistent. So in this case, instead of the pointer in the prototype and in the implementation, you have the ampersand symbol to denote that we're passing by reference. And when you call the function, you just pass the parameters like you normally would.
Yeah, you don't have to put an and symbol.
Clean,
you know, if you just pass it,
yeah.
And the receiving code will get it. And if you look at the output on the right, when we compile and run the program, we actually do affect the value of C in that function add two numbers. Now, another really cool implementation of this is creating a constant. So below, if you look at the add two numbers now, instead of having int x and int y and whatever, we have constant int and x, constant int and y, and then int and local z. And then at the bottom we have local z equals local x plus y, which functionally does the same thing. But the beauty of doing something like this, Brian, is like, let's just say instead of int x and int y, we had person x and person y. If we don't want to pass a copy, which will put overhead on our system resources, we can literally pass the reference to that memory or to that object, and then by declaring constant, allow them to use it, but not change it.
Mm-hmm. That's one of the dangers of passing by reference is the calling code won't always anticipate that the object that's being passed in will be changed.
Yep.
And that can be a very dangerous thing.
Very true.
So this is a great level of protection to where you can have your cheesecake and eat it too.
And another cool thing is, when we use pointers to access members of objects, we use the arrow syntax. Well, by using this method, we can use the dot syntax and treat it as if it was just a regular variable within that scope.
That's awesome.
So now that we know that,
all right,
let's get on operator overloading, Brian. This is where Brian's expertise comes in.
Here we have a header template. It's exciting.
I'm excited.
You have the return type, and then the keyword operator, and then the operator itself. So this is the operator we want to overload, and what data type it's going to be returning.
Yeah.
And then we pass in parameters.
Interesting.
Yeah.
Oh my goodness.
Let's take a
What
look.
is this?
So because we're talking about cupcakes and cookies and cheesecakes and things, we'll have a treat class.
Ooh.
The common denominator in treats is sugar.
Yeah.
So we declare sugar. Sugar is going to be some value that we can measure in each of the treats. And we can get sugar, and we can set sugar in the constructor. The operator overloader, you see treat operator plus. Treat is going to be the return type. So it returns a type of itself. Operator keyword and the plus, we're overloading the plus symbol. We're overloading the plus symbol in the circumstance that we pass it in a treat data type.
Mm-hmm.
Or we overload it with the int data type as well.
Mm-hmm.
So we can either overload the operator plus with a treat or with an integer.
Mm-hmm.
Now in treat's case, like we talked about before, we don't necessarily want the implementation of the operator overload to modify the treat itself, but we also don't want a copy of it over there either for unnecessary reasons. That's why we declare the constant treat ampersand. It passes it by reference so we don't have a copy, but it's also a little more protective.
Beautiful.
Smooth.
And also on the top, Brian, we put some syntax here for if not defined treat header, then define it. And that will protect us against multiple includes of this code file.
Very cool. Here's the implementation template now. When we go to implement this function, it's very similar. We have the return type, and then the class name, the RSO, the operator we overload, just like you'd expect. It's nothing strange. Just remember to keep that operator keyword in there preceding the operator itself. And then our code block.
Beautiful. So it's just like a regular method.
Yeah.
Crazy.
The only difference is that you just say operator and then the operator symbol.
Wow.
That's the only difference.
Sexy.
Yeah. Here's what our implementation looks like. When we overload the operator plus while taking in the treat object type, all we do is we take it in as value param. We call the getSugar method, which returns the sugar as an integer, and we add that integer to the getSugar of our current instance. So you pass in another instance, and you add it with the sugar from ourself, and you return that. And that returns it. Now you see that we're returning the treat constructor.
Right.
While adding those.
Right.
So we add those as a number. And we're calling actually the next, we're calling the second constructor.
Yeah, so by calling the constructor directly by saying treat, we're passing back a new instance of a treat that contains the amount of sugar of both of the objects that were just compared.
And if you look at the last one, the operator overload for integer as a parameter, it will just simply add that value with the amount of sugar in our current object and also pass it into a constructor and return a new treat object.
Beautiful. Doesn't get any better than that.
And that's all you need to overload, how you're going to add these two things together. We are choosing the concept of when we add these two things together, we're choosing sugar to be that thing that we add together.
Right.
Because it has to be something. Mm-hmm. Now, if it was characters and we concatenate them together or whatever, we can decide what that is. If this object had a title, we can concatenate those two titles. But in this case, we choose to do it on sugar. And we choose this to be an integer operation. Beautiful, Brian.
Very well said. Now here is the actual code driver that will put into practice those two things that we just went over, the overload. We take a look and we create an instance of treat called Cupcake, and we call the constructor directly. Now we haven't shown the syntax before, but this is another way of calling the constructor to create a new instance of Cupcake, and it works the same way that it did back in the implementation file that we just looked at just a second ago. So a new instance of Cupcake that has 50, measurements of sugar.
Right.
50 units of sugar. And then we have a treat cookie that it has a lot more. I don't know why a cookie would have more than a cupcake, but maybe it's a really, really small cupcake and a really big cookie. We don't know these things.
Yeah.
This is secret. Abstraction.
This is just on a need-to-know basis.
Yeah.
This is not something we need to know.
We're just calorie counting, Brian. We don't care about the size.
I'm not a baker for cooking.
We create a new treat, Brian, called Delicious Yum Yum.
Yes.
Where we combine these. So cupcake, which is a treat object, and a cookie, which is also a treat object, are then added together. We create a new Delicious Yum Yum. And then we present to the user that Delicious Yum Yum dot, call the getSugar method, to tell them that we have 350 units of sugar.
Very nice.
Now let's walk through this, Brian. Let's kind of take the WiBit.net line by line approach here. We pull in the template for the treat.
Now we have the concept of a treat, the concept of sugar.
I know that a treat only has sugar and nothing else. The next we create our two instances of we have a cupcake that has 50 units of sugar and a cookie that has 300 units of sugar. Then we come down here to create our Delicious Yum Yum, and we do this by adding these two values together because, Brian, that's what the operator overload told us to do. Remember in Terminator 2 when John Connor was like, "Why did you do that?" And then he said,
"'Cause you told me to."
Exactly. So right here, what we're doing is, why did you add the sugar together, Brian?
Because you told me to.
Exactly. And then we got the getSugar method to retrieve the sugar that is now a part of the Delicious Yum Yum instance. Beautiful, right?
Yep.
So then we compile and run it.
Just like you'd expect.
350 is the output.
Easy. You got it.
Now, you want to see something really crazy?
Yep, sure.
You can call the operator overload as a method, just like any other method.
That's awesome.
That's all that it functionally is. The plus just kind of abstracts you from this. So this is what you're really calling when you call the plus operator. So we just do cupcake plus operator plus, which is the name of the method that we define in the implementation, passing the parameter as a cookie. So you can see how this operation works. Cupcake is on the left, plus cookie on the right.
Now go back to the other way.
Huh? Nice.
Awesome.
Okay. Now,
we can also overload, when we displayed the value, we said delicious yum yum dot get sugar, and we took that integer and printed it out to the console. We don't have to do that. We can also overload
the stream operators.
Outsertion and insertion operators. We can also overload those, because that's a common thing to overload as well. And that way we can just say, C out, arrow,
delicious yum
yum.
Yep,
and it'll print that units of sugar.
Yep.
This is not really intuitive. This is slightly different than other operator overloading.
Right.
This is kind of a freak case because this kind of comes from the stream objects.
Right.
And it's actually was a globally declared friend function to the stream class.
Yeah, concepts we haven't even explored.
Yeah. But we'll get there in a couple videos.
Right.
And you'll be able to implement this before
and you'll be much happier to wait because you will learn a lot more along the way. And then if you were to show it here, you would say, I have no fucking idea what this is.
But I mean, we're not going to show you everything at once. We're not whores.
No.
Hello, everybody. Welcome to a quick lab on writing an integer wrapper class. So this is going to be similar to the string class, but we're going to do it for integer and numbers to make it easier to interact with integers. Our primary data element is actually going to be a long. Once you see how we kind of integrate this, everything will expose itself in an integer form.
Yeah, so in languages like Java, for example, there are many instances of what they call non-mutable instances. And Java will have something like an integer or a double that is set during the construction phase, but and even the string class in Java is non-mutable. That just basically means that as long as the instance exists, it equals one thing, and you manage that one thing. And if you want it to change its value, you have to construct a new instance and a new instance pointer. So, and all of that it really does is it just kind of encapsulates some value, kind of like what we did with the WiBit string. But this is just a little more simplistic, and it just kind of like introduces you more to the, I guess, the Java way of doing things. Because what we did with the W string was mutable, meaning we could do a dot clear.
Right, we could set it.
We can change the value. In this case, that won't be the case. So,
right.
All right, Brian, let's talk about the .h file. And
you could think of something being non-mutable as being disposable.
Yeah, there you go. Yeah.
So it's kind of like you make it and you can't reconfigure it. It's just once you make it, you use it and then you dispose it and then you move on.
No recycling.
So now let's get our trusty Notepad++ out. I'm having deja vu. Save the file as whatever we're going to call it. So this we're going to do an integer wrapper class. So let's call this integer header.
Yep.
Okay, so the class is going to be called also integer.
Interesting. Very interesting, Brian.
Okay, we're going to have some privates.
Some private?
And we're going to have some publics.
How do you even pronounce that? Puvliv?
Puvliv. I am Boris Puvliv.
Perfect.
Okay, so like I said, we're going to have a long pointer. And that's internal, and we'll just say I, because this is ultimately an integer.
Right, so that's just like the char star in the WiBit string class, this is what we are encapsulating inside of this class.
Yes. We want a default constructor. That's here. We want, most importantly, different kind of constructors for taking in what we're going to translate into be an integer.
Mm-hmm.
So the most common one will probably be an integer that we'll take in. And then the next one will be a long. And lastly, we want to be able to take a string and at least attempt to parse this into an integer. And we'll see how that goes.
And those of you guys that are proactive, write another constructor that takes in its own type of an integer, which would be the copy constructor. So have fun with that.
Oh, yeah. Oh, yeah, good point.
Yeah.
So that would look something like this.
It would be a constant integer and.
Kind of like that.
Yeah, but...
Oh, yeah, constant.
Const.
Right.
Flawless.
Just a hint. Okay, and our destructor, naturally. We're going to have a couple static methods on this class. So we can do like integer : parseInt, and that returns an integer and takes in a string, but doesn't necessarily instantiate a new integer object instance.
Mm-hmm.
So that'll be static. It'll return an integer. We'll call it parseInt, and we'll pass it a string.
Nice, Brian. And then those of you guys that are proactive, overload this to take a W string.
Oh, yeah, good point. We're going to do another static method. And this will be two binary string. So it'll take in an integer or long, and it will give you back a binary representation in a string.
Oh, yeah. So we're going to actually be doing a binary algorithm. This is awesome.
Yeah, that's always fun. If you're a nerd. So it'll be two binary string. And that's going to take a long.
Nice.
A long, tall Sally. And then we got one last one. And binary is cool. But what's even cooler?
Nice. Hex?
Yeah, alright. I was like, wait, what are you saying nice for? I don't even know. I didn't say anything.
Here's one thing, guys, that's kind of interesting. The way that this is designed, so we're taking in long as a parameter here. We're not taking in int. Well, that's because int can impersonate long, but long can't impersonate int. So if you really want to get nitpicky, you can overload that, like we did with the constructor, although that's not really necessary. So I just wanted to point that out. That's why we're not having an int overload.
So back off.
Yeah. As
be more constructive with your feedback when you're criticizing my friend.
Or as Axl Rose would say, back off, bitch.
Back off, bitch! That's good. That's good.
I tried.
Okay, we also want to be able to...
my testicles are too big to sound like him.
We want to get probably not enough Botox. We want to get different types of representations. Now, the nice thing about storing this as long is we could give you the long value,
right,
or the double value, or the integer value, or whatever kind of value.
Or a string value.
Yeah.
What's craziness, Brian?
I know. So let's do, we want to return the integer value. We want to be able to return the long value. And we want to return the double value. Okay. And then maybe, what do you think, to string?
Yeah, why not? That way we can get the string value. So if you want to, like, maybe append the number to a string, you could get the string value and append it. Yeah.
And then maybe to binary string.
Nice. So the instance level binary string.
Right. So this will be kind of like what we have up above, not upstairs. Up above than the
well,
static.
Upstairs, that works. Because, like, look at this. You got little stairs going up.
But yeah, but like Evan said, on the instance level. So 2 binary string, and then we'll do one more to hex string.
Mm-hmm. No, those will be just binary string.
All right.
Yeah, because the 2 will be the class level. See?
We could call it string.
That's fine. Just leave it. Just leave that.
Okay.
Now there's one of the exercises that we're trying to get across here is to kind of do this the Java way. Now I know we're not going to be going to Java next. But, for those of you that are uninterested in Objective-C, you may just jump right into the Java language. Now Java lacks a very important, well, I don't want to say that because Java programmers like this, but Java lacks
Speed.
a comprehensive
Charisma.
operator overloading structure. So
Usefulness? Sorry, I'm done.
Okay. So in this case, we're just going to be defining the like an equals method, but we're not going to be defining the operator overload.
Right.
But you can do that on your own.
Right.
So anyways.
So equals will obviously return a boolean.
Mm-hmm.
And we'll just let it take a long, we'll let it take an int, we'll let it take an integer data type.
So we can take
if Amish people were programmers, they would probably program in Java and Fortran.
Nice. More Fortran than Java, probably.
Okay, Java's like the Mennonite language, and Fortran is like the Amish language. Okay, so that concludes our header. Now we want to implement this blueprint in our implementation file.
Very nice. So, you know, Brian, the first thing that I would do if I were you...
Yeah, I save the file?
Well, besides that, I would do the if define, if not define.
Oh, yeah.
And while Brian's getting that infrastructure set up, basically all that we're going to do is just kind of define all the different pieces that we're going to do. We'll just kind of go from top to bottom, starting with the constructors, and we'll go through and we'll just define all the things that don't need stuff, or we can just do that. That's fine. If not define. Nice.
Define WiBit integer class. And if.
Nice.
Okay. I threw all this shit in there.
Now, none of these methods are going to be very long. They're all going to be pretty simple.
Yeah,
so if you want to,
there's a lot of piggybacking.
Also do a little include the before we include the .h file, Brian. There's a couple of C++.
Like IOStream?
Yeah, IOStream.
Sweet.
We're going to do SStream as well.
Oh, yeah.
And then we're going to also piggyback on some C
wait.
functionality.
I want
Right.
stream.
We're going to piggyback on some C functionality by doing stdio.h and stdlib.h. And some those of you guys that follow the C videos will know that we're going to be using those to do conversions.
What was the other one?
Lib? stdlib?
Oh, yeah.
Nice. And we're also going to be including, of course, integer.h. Very cool, Brian.
.h.
Nice.
Okay.
Integer. Constructor. This is going to be crazy, Brian. So we'll scope in, and really all that this method is going to do is, and it's going to be kind of similar with the other ones, is we're just going to, whatever the private well, yeah, there you go. We'll just make that equal to a new long. So we've just created a just a little semicolon, since that's a primitive data type. So now we have a new long instance, and after this, on the next line, we can do star underscore I. So now we're setting the value of that pointer to 0. So if you just call that, it just equals 0. And since this is a non-mutable, you'd have to kill it for it to equal something else. But whatever. We don't make the rules here. So we're going to do basically the exact same thing with integer, right, Brian?
Yep.
Except for we're going to be doing crazy stuff like...
Like what?
Like, well, we're going to be doing... Yes.
And this will be, what do you want to call this?
Init value. Seems good.
Yeah, that's good.
And we'll just typecast that into a long. Yeah, very nice.
Cool.
And then the exact same thing, except for no typecasting, with the next fella down. Very awesome.
Initial value.
Cool.
All right.
All the construction is done.
Oh, the string.
And now with the Now with the string,
Probably
we're gonna be calling something else. So we'll just kind of come back to that. But you can see in the destructor, since we're using dynamic memory, all that we're going to be doing is removing that memory. So we'll delete underscore I.
Easy.
Cool.
Nice.
Easy breezy.
Yeah, we'll come back.
Beautiful.
So this one here, we just want to say, baby, come back. All right.
All right, now, so just to kind of keep moving along here, in order for us to do the integer constructor that takes in a string,
we need to do static parseInt.
We're going to have to define the implementation for the parseInt method,
right?
Which really does nothing more than take in a string and returns its integer equivalent. And we're piggybacking on C here, right? So we can really simplify this.
All right.
So, Brian, if you were to do this, how would you do it?
I'd probably ATOI it.
Nice.
Which means ASCII to integer it.
Right. But remember, string did not exist in C, so what do we have to do?
We have to C-string it?
Yes.
Oh, no.
No. See, yeah, that's right. That's not a WiBit string. Cool. So now we can define the integer constructor that takes in a string.
Cool. Now you want to go? Okay, I'll go back. Baby, come back. Alrighty.
Cool. Get your scope in. Of course.
But of course, yes.
And give std string a name, and we'll call that init value as well.
Okay.
So we're going to be doing the same thing with creating a new memory space for I.
Alrighty.
But then star I is going to equal what, Brian?
Probably, I'm probably going to want to call parseInt.
Yes.
And pass it the initial value.
Yeah.
Alright.
Now, one thing, we don't have to do it, but just for consistency, we can typecast it to long. Although, I think syntactically that's the same. So now we're on what? If we scroll down a bit.
Now to binary string.
Alright. Now, before we get into the more complicated ones, we can start doing the getters.
Okay.
Let's go write some of the getters, Brian.
Okay.
So down below we have the double value, right? Now, or I'm sorry, let's skip this one because that's got a little meat to it.
We're beelining for the getters.
Int. We'll do that. So let's scope in.
Oh yeah, this one's gonna be tough.
Oh, this is gonna be really hard.
Wait, can I guess this one?
No. Stop. What are you doing? Stop. No, that's actually wrong.
Hold on, time out.
Oh, that's also actually wrong. You're missing one thing. I was gonna do the Jeopardy theme song. Just do the int scope in first, and then that method is done.
Yeah. Nope. Wrong. Right.
Sexy. Now the long value, Brian. Now I don't even know if even the most ridiculous scientist in the world can figure this one out.
This one's gonna be tough. Return.
Okay. Well, we'll see. We'll see when testing comes.
Double? Same with double?
No. Double is going to be really hard.
Oh, yeah?
Okay, so let's well, if you, the spelling is the most complicated part.
It actually is kind of tough because I can't spell the
Yes.
same way. Okay, so we got that. We want to plonk typecast it.
Very sexy. Now, if what do we got next? 2-string?
Yep.
Now, if I was to do something 2-string, Brian, we already know how to do this because we've learned how to do this in the videos that we, the slide videos, and we're going to be using and leveraging some of the functionality built into the string class to do this. Now, how would you do this?
I'd probably scope in to the standard library.
Yeah,
and I would define
a
string.
Nice.
I'll call this an out, since it's going to go out, we're going to call it an output string.
Mm-hmm.
And then we're going to pipe to this string.
Yeah, stream it in.
This, which is this instance.
Right.
And we'll get the long value representation of it. Now, obviously, we could just as well get, whatever, but...
Yep.
We're cool, so...
Now, we're also using open recursion, guys, so we're actually calling this... Now, you don't have to do that, but we're just doing this just to expose you to it. Just because we're cool like that. And now all we have to do is return something. And what is that?
We just have to return string value. So this O string obviously is not really what we want to kick back.
Mm-hmm.
We want to kick back the string value of it.
Absolutely. Very nice, Brian. Very nice. Now, we have a couple of other methods here that are kind of dependent on...
The binary string conversion,
yeah.
string conversion. Okay, so we jump to the equals, then we'll do that last?
Yeah, we can do... Because the equals are going to be real stupid easy.
Okay.
And they're basically going to... Just like we did before, they're going to kind of piggyback on one another.
Alright, so we're going to do the equals.
Right. And this is going to be real hard. I mean, this is going to be crazy, crazy, crazy.
So we basically just want to return the result of whether or not the value in I...
Mm-hmm.
is equivalent to whatever this gets passed in.
Right. Awesome.
Done.
That's crazy, Brian. Now, the overload that takes an integer, how would you do that?
Actually, there's a couple ways you could do it, but you could just call equals.
Right, because that's already defined.
Yeah. So it's basically whether or not this... Oh, we need a value. Whether or not this equal to... equals, and we pass in.
Well, you don't even have to.
We can just pass it.
You don't even have to do the I equals or the dollar equals because that's already defined in the method above it. So all that we're doing right now is we're just going to call the equals overload.
Oh yeah, good point. Okay, but I think I still have to typecast it too long, otherwise I won't know where to go.
Okay, so that looks like it should work.
Yeah.
Then lastly, we have an equals that takes in its own type, which is a integer with a capital I.
We'll scope in equals integer type value.
And that'll be a reference, integer reference. Very nice. Now, can we possibly piggyback on something else here?
Well, we do. We can get the long value from it.
Right.
So we can say equals value, and then its long value.
Oh, baby!
Nice.
Holy crap, that's ridiculous.
Look at it go. Okay, so now let's get to the trickery.
Yep. Now let's do some crazy stuff, Brian.
All right.
Now, we have discussed the conversion to binary before. We're going to actually write our own binary conversion algorithm.
I'm excited.
Now, as you guys recall, remember we were doing this by hand in the Introduction to Programming video series?
Right.
Well, now we're going to kind of mimic that, but instead of doing it as a division, which was kind of... We did that to kind of simplify the process, because we weren't fully confident that everyone knew what the hell modulus was. So we're going to be using the modulus method, which is just a derivative of what we taught before. So the first thing we're going to do, Brian, is if the number that is passed, so define a parameter. So if that value equals 0, return quote 0 quote.
Well, that makes sense.
Yeah.
We'll just be done with it. And
yeah, we're not going to waste the time going through the algorithm for one stupid little number.
Okay.
And now we're just going to make like a little temporary string and maybe return string because that's what we're using it
that
for.
Works.
Right. Perfect. Yeah, we'll set that equal to blank because we're going to be appending values to this. So,
Okay.
Brian, you know, and I know the algorithm to do a binary conversion.
But of course.
What is the thing that we have to kind of account for as we're looping through this algorithm?
We have to account for the fact that it's backwards.
Well, there's that. But remember when we were doing the Introduction to Programming series, we divided until we hit what number?
0.
Exactly.
Right.
So we have to make sure that the value that we're currently working on is greater than
okay,
0.
I'm with you. Okay. That was like when a teacher asks a really bad leading question.
That
And
was.
the students are like, what is the person asking? Like, it's a mouse.
I thought that.
I don't understand.
I thought that was a perfcly clear question.
And the teacher's like, no, it's not a mouse. It's a ALU processor unit. And you're like, okay, so while the number, and when I say number, I mean
value.
the value.
Well,
Yeah.
you wrote what you spoke.
Yes. It is a number. Okay.
I do that when I'm teaching all the time.
So while the value is greater than 0,
Yep.
we want to do something. We want to the first thing we always want to do is test to see like where we're at, what are we dealing with, and what should we do.
Right.
So in this case, if the number
Or the value.
stack mother mod 2,
Right. Now before you continue,
yeah.
what is this asking, Brian?
So this is asking whether or not the value mod 2 is 1, so that it's not an even number, basically.
Right. So remember when we were doing this manually, we would let's say we were trying to get the binary value of 5. We would do 5 divided by 2, which equaled 2.5.
Right.
Well, that's what this case is.
And
because
we know
there is a remainder. So that means that is a 1.
And right, because the rightmost is always going to be it's 0, 1, and then so on 2, 3, whatever.
So then once we get this condition, now what?
The only case that you're going to have 1 all the way to the right is for an odd number.
Right. Exactly. So what do we do?
Want the rightmost character to be a 1.
Or we want the leftmost character because remember binary pops backwards.
Right. So the return string is actually going to be 1
Right.
plus the return string.
Exactly. So we're appending to the left of the string. So
the first time that the first time that we append return string will be blank.
Right.
So the first instance that this happens, the rightmost digit will be
1.
the number 1, denoting that it's odd.
Mm-hmm.
Okay. Otherwise, we do a 0.
Mm-hmm. And that's it, folks. That's a very basic conversion to binary algorithm.
Right. And then the next, we want to set up the value for the next iteration, so we're not kind of like just spinning our wheels here. And we basically, as we explained before, we just half the value.
Yeah, and just bring the tab even with the else to denote.
Oh yeah, perfect.
Yeah, that doesn't belong to else, so we don't want to. Yeah.
When we're done with this, then we just return string.
Very cool.
Nice.
Very, very nice.
Okay. So now let's pound through the hex string.
That's what she said. So when we're doing the hex string, Brian, we're going to be kind of leveraging some functionality that C already gives us. Because, again, we don't have to. Why reinvent the wheel, right?
Yeah.
So then define your parameter there. So that's long. You make it number or value or whatever you feel comfortable with. So I guess
I like misspelling it so well.
Now this may be a little controversial, kind of, sort of, maybe, but since we're kind of piggybacking on C, we have to define a string of a size.
Okay.
So we could calculate the size of the string we want based on the incoming number, but we're not doing that. We're just going to basically say that the largest hex string that you can retrieve from here is 256 characters long.
Which would be ridiculously big.
Yeah, but there may be circumstances where you need longer, so you can modify this, or you could just manually change this number, whatever.
True. So we're going to have a temporary string that's going to be, like Kevin said, basically 560 characters wide.
And now, Brian, C does give us a function that we can use to do this, and what is that?
Printf.
Very nice. You guys remember this
also known as sprint.
The first parameter is what we're putting it into.
Yep. Destination.
Right, and then the format string.
Formatting, capital X.
Yep, and then the value. Holy crap!
Oh,
that is insanely ridiculous.
Okay, so now, that's a char star, so we want to take that and put it into a string, like a standard string.
Yep.
And then we'll call that, return string seems to be our convention of late. So it's going to be a string, and then passed in the string constructor will be the temp string char star.
Nice.
Okay, and then we'll wipe our ass.
Yep.
And then why can't I spell return to save my life? return string. But I can type return and return string.
You can't type string either.
Yeah, okay. Alright. Okay. So now we have our static methods to hex string and to binary string done.
Yes, yes.
And
so what do
those
we have
will
left?
help us. Well, those will help us with two other ones that
Right.
we got in here somewhere.
What are they?
So we have those two. We have our getters, and we just want to have our getters to get the binary string.
Holy monkey! And I bet you in 1,000 years you couldn't figure this one out.
So we scope in. All right. No.
No idea what you're doing, but I still know that you can't spell return to save your life.
We're going to return a binary string in the form of a string. So what do we do?
I don't know.
To binary?
To bring Bruno? To bonsai? To bonsai string!
Hi.
But we want to do that passing it a parameter because that one takes a parameter.
Okay.
Nice. Now the same thing for hex string.
All right. Well, that's easy enough.
See, once again, another example of how each time we bubble up, it simplifies things more and more.
Oh,
Is
yeah.
there anything we don't have defined?
One more, I think. One more.
I think we have
I thought we
everything.
had a something that's like a string in a parameter somewhere. Nope, that's
know.
implemented. That's implemented.
I think we got them all, dude.
Okay, cool, awesome.
You want to try to do a little compile and
No, not really.
see what kind of errors we got going on here?
Let's just assume it's fine.
I'm
Good
sure.
Good enough for NASA. Let's send it.
Hey,
on
don't
foot.
say that about NASA. Don't talk bad about NASA.
I'm not talking about it. Mad about it now. So let's make a driver file. Let's call this integer. They call me integer driver.
Nice.
We'll include. We don't really need to include anything, do we?
We don't have to. We can just include integer.cpp.
That'd be nice.
Yeah, because that does pull in IOStream. Although you could pull in IOStream and it shouldn't matter. It should be all good.
Okay.
And it would be kind of a really fun exercise for this, Brian.
What's that?
Let's create a for loop that
Okay.
goes from 0 to 255.
I'm listening.
And for each iteration, create a new instance of an integer and see out the numerical, the binary, and hex value on one string.
All right.
Sound fun?
Sounds like you're getting freaky with the cheese whiz.
I am. I swear it's crazy with the cheese whiz, man. I swear.
So we'll create a new.
You got two eyes.
So do you?
Just call that something else.
I got. You got two eyes too.
That has to be called something else.
Yeah.
Because the iterator is also called I. Nice.
Actually, you got four eyes.
I do have four eyes. And you have a ponytail.
Like some sort of freaky hippie. Oh.
Having a slow day.
Today. So all we want to do is we want to print out.
Well, first let's do number dot was it long value?
Okay.
Paren, then maybe do like a space or a tab or something or that. And now let's do the binary string.
Okay.
The instance level binary string. Holy monkey!
That's so easy.
And then how about hex string with a space or a tab or a comma or something in between?
Oh yeah, that makes sense. End line.
Yeah,
Okay, how's that?
Let's fix
Cool?
that so it's on the same screen. Very, very nice. Oh, look
Like
at
that.
Sweet. Let's see what it does.
Let's watch this not compile. Integer driver. Our output's gonna be integer driver dot exe. Oh, boo. Integer CPP. Static oh, I left static in there. Well, just call me Mr. Butterfingers.
What line number did it say? 47?
We're missing a colon.
Yeah. One of Brian's common problems with his life.
Okay, we got missing a colon.
Integer driver line 2.
I probably missed a semicolon.
Using namespace std.
Oh yeah, look at that. Should be abusing namespace std. Okay, cool. Woohoo!
Wow!
That was awesome.
Wow.
That was like fireworks. That was like Katy Perry.
Although I guess that should be less than or equal to 255. Because the last number should be FF.
Alright, let's try it
Or
again.
do less 256. 256.
You sure you want the equals?
No, I want 256. There we go. Now we should end on FF. Hey! There we go.
Nice.
Not too shabby.
Zeros to ones. Very cool.
Brian?
Yeah.
This video is going to be exciting.
This will rock your world,
Yes.
man. It'll rock your world.
If this video is half as exciting, we were as excited as we were developing it, this is going to be a huge success. Now what we want to do is we want to create a delegate class. The delegate class is basically a way of encapsulating a delegate. So when we took a look at delegates in our delegate code, we were doing it kind of the manual, the hard way. We want to put a little bit more effort into designing a class so that when we want to implement delegates in other classes, it simplifies the transfer of that data.
Mm-hmm. Some of the topics we wanted to cover in this are templates and delegation.
And object-oriented design.
Absolutely.
So the first thing that we're going to get started with is, let's just build our quick object-oriented design model, and then we'll get into designing our class. So as you recall, the object-oriented design model, the way that we implement it, is going to require 3 files: a header file for the main class, a implementation file for the main class, and a driver code file that will instantiate the main class.
Mm-hmm.
So the first thing we'll do is we'll create 1, 2, 3 text documents. The first one here, and we'll save this on the desktop. C++ awesomeness.
Delegate header?
Let's put this in its own folder. So we'll put we'll start doing it the Java way.
Nice.
We'll have a delegate folder. And inside the delegate folder, we're going to have main class.h. And then this is going to be save as main class.cpp. And then this one will be called file save as main class driver.cpp. And in main class.h, it's going to be pretty simple, right, Brian?
Yep.
What are we going to do?
Well, the main class one is just going to have public void main.
All right, so we're just defining a main class. And inside the main class, we're going to create a public access to void main.
And naturally, that'll take a int and a string array. You can do a string array.
Int string array. And I'm going to change things up a little bit and make this static so we don't have to actually instantiate this.
Cool. And then we're also going to end up using...
Actually, you know what? I'm not going to do that. Forget about that.
Yeah, forget about it. And we want a private one.
Yeah?
That's going to be our thread delegate.
Oh, nice.
That'll take in a string.
So, guys, this is going to be what we're going to be passing as a delegate when we implement the example.
Mm-hmm.
So there's our main class.h. Now, main class.cpp is going to be defining these. Now, we're just going to kind of do kind of a basic. We're not going to fully implement this,
right.
but we'll just do an include IOStream.
And the namespace standard. Your muscle memory will learn to type these 2 lines very fast.
Using namespace std. And then we'll do a include main class.h. And then we'll start defining our methods. So we'll do a void main class
scope2
scope into main int argument
C
counts string
args v or args s.
We'll do it the Java way and call it args.
Cool.
That'll be that, and then we'll do a quick implementation here where we'll just do int main class.
You got the args.
Oh yeah,
right.
I'm sorry. Oh my god, I so wrote it the Java way.
I know, it's funny.
Wow, good call, man. All right, sorry, this is C++, kids. So main class, and this will be thread delegate, and this takes an integer. Oh, I'm sorry, this takes in a string.
Yep, string stir.
And we're not going to implement this. We're just going to return 0.
Yep, or just return a string length.
Just 0. I don't care. And this one we'll just do couts. Hey, buddy. So here's our object-oriented design. Hey, buddy. Plus a little bit extra. So inside of our main class driver, we're going to be writing one function that will pull in the arguments and convert them to a string, and then we're going to pass those into the main class. So we will include main class
CPP.
And we'll create a string pointer get args, and this will come in with int argument counts, constant char star argument vector, and this little fella is going to be
vector array.
Good call. String pointer args is going to equal a new string of size argument count, so we're just creating a new dynamic array.
Yeah.
For int I equals zibby, while I is less than argument count, I plus plus, and args sub I will
be the same as arg vector I.
Argument vector sub I. So what we've done is we've just converted the constant char star array to a string array.
Yep.
To kind of make it more object oriented and abstract our way out of C.
And then we just want to return args.
Oh yeah, good call.
Otherwise, we'll have done it for nice.
Returning args.
Args.
And then the main function will have
same arguments.
The same arguments. But in this case, we're going to create an instance of main class.
Yeah. And that creates a little bubble.
That is our little bubble. And we'll just do
pointer, main
instance. We don't have to do it as a pointer, do we? We can just do it like that, can't we?
Cool.
Main instance. Main instance dot main, right? And then this is going to take argument counts, and it's going to take the result of this and argument counts and argument vector.
Yeah.
All right, now let's see if this runs, and then we'll kind of do a quick
semicolon.
Overview. I don't need no stinking semicolon.
And we want to return a number.
No, we don't. Brian, stop.
Quit it.
Stop it. Desktop, C++, delegates, G++, G++, G equals, main class driver, -o, main class driver, .exe, line 8 on main driver, CPP, oh, I forgot my semicolon here.
Oh, yeah.
Okay.
Cool.
All right, so if I run this, it should just say, hey, buddy. Now I'm going to do a quick overview, and then I'm going to turn it over to Brian to take us into the other layer of this, which is going to be the delegate class. But as we discussed in the object-oriented design, if we've discussed that or not, if not, we'll get to it. We just created a main class so that everything that we do is in an object-oriented setting. And all that we're using this code file for is for creating a string array of our arguments, and then passing that to an instance of main class, calling the main method. So in effect, this is where our code is actually. This is the entry point.
Yes.
In our object-oriented
That's our new
land.
object-oriented entry point.
Right. So I'm going to pass the puck to Brian, and he will start to discuss the delegate class.
Okie dokie. Here we go. So we are going to start implementing the delegate class.
Mm-hmm.
We don't want to define this class to be of a specific type.
Right.
Because if we're using a delegate, we don't know what that function we're going to be tying it to is going to return.
Well, we don't know what class instance we're working with. So we have to make sure that it can accept anything.
Right.
And how do we do that, Brian?
Template.
Well,
that's
okay.
right. I said it. Template.
Now, how do you template a class?
Well, by templating a class.
Oh, I don't know. I'm scared.
Template class.
Uh-huh.
And then we'll call it object DT.
Right.
And then the returning class will be a class return DT data type.
Mm-hmm.
And then for parameters, let's get freaky and call it like param DT.
Okay.
So we have an object data type, a return data type, parameter data type.
Right. And now what that is, guys, the object data type, and you'll see this when we implement it later, but it's going to be the instance where the delegate resides.
Right.
The return data type is going to be the data type that delegate returns, and the param data type is going to be the type of the input into that delegate. That way, it could accept any data type, it can return any data type, and it can be any data type.
It's awesome. It's quite generic, I'd say. The class, we're just going to call it the delegate class.
Uh-huh. Nice. Don't forget your semicolon.
Yeah, I know. I forget that often. We're going to have some things that are private. We're going to have some things that are public. It's going to be a fiasco. So now we basically want to wire up the return data type where our object is going to reside, as well as define where exactly in memory our object exists.
So to put it in simpler terms than that,
so we want to tie
we're going to store a pointer to the method, and then a pointer to the instance where that method resides,
and take the parameters.
Yeah.
So our return data type.
So the method returns the return data type
of, and then this refers to a method that's scoped into the object, and the method name.
And you guys remember this from method pointers. We discussed this already in the delegate video.
And it takes the parameters, param data type.
Right. So don't think of this as anything complicated. This is storing a pointer to the method that we're going to reference.
Right.
Oh no, the return data, that's just defining a prototype. The return data type is what it returns. So if it returns an int, that'll be an int. A string, that'll be a string.
Now we tie the object data type pointer to a particular
instance. Yeah.
Of delegate instance.
Right, so you guys can kind of see.
So now once we declare that exists.
We're just storing a pointer to the instance where our delegate resides. So the object data type is where it is.
Right, but that's not a set yet. So that's just kind of declaring where it will be.
Then the one above that is what inside of this are we going to access.
Right. We want a constructor. So that's obviously going to be called delegate.
Yeah, and there's our default constructor.
And we want a constructor that takes in parameters. So delegate.
Now don't get scared with this, guys. Just follow it.
Okay,
you know this.
This is taking the first parameter that's going to be passed as the object instance. The second one is going to be the method pointer. That's going to be return dt, pointing to the innards of object dt.
The innards. Nice. I like that description.
Param dt, trails at the end. Okay.
Awesome.
And that's all encapsulated in this.
Yep.
So so that sets up our constructor and our default constructor. Now we want to be able to set the delegate instance.
Right.
So this object up here, we actually want to set that instance to some instance of something.
Yes, and also if you call the default, like this is kind of set up so if you call the default constructor, like let's just say, for example, Brian, you wanted your delegate to change its instance during the program execution.
Right.
You can use these functions or these methods inside to say, now look at this instance, now look at this instance.
Right.
So it allows you to kind of override everything.
So it doesn't return anything because it's a setter. And we're going to set delegate instance. And all that needs is the object.
The pointer to the instance, correct.
Right, the object pointer. We also want to set the delegate method to basically tie that together if we want to change it, like Kevin was saying a minute ago. We're going to call that in the constructor as well as later if we want to move it around and shift what we're pointing at. So this will set the delegate method, and it's going to take in the return data type, the object innards.
You got a little onjack going on there. That looks like some kind of a drug, doesn't it?
Onjack?
Dude, I'm so on onjack right now.
Oh, yeah. It's like a drug of the future.
Yeah. Param doctor.
Come on.
Somebody call the doctor.
Okay.
Isn't that a Poison song? No, that's Dr. Love.
Yeah.
Yeah. They call me Dr. Love.
And then we're going to do an operator overload.
Yes.
This gets a little freaky.
This is the cool part, though. This is what's going to implement the abstraction layer. So, implement it, and then we'll kind of go over it.
So we're going to overload the parens.
Yep.
The parens are generally used when you call a function.
Right.
And it's going to take param data type.
Right. Now, what we're going to be doing here, if you guys can kind of see where this is going, we're going to be able to set an instance, and we're going to be able to set a method inside of that specific instance, and we're going to be able to use this delegate encapsulator or wrapper, whatever, to call that method as if it was just a regular function inside of our program.
It's pretty
Very,
crazy.
very nice.
That will make the delegate process far easier in C++. So just to review, when we define this return data type, we could say that this is similar to saying int, and then when we declare this, we say that passes right along as the return type.
Right.
That gets passed from here.
Yes, because when we template, we're passing the data type as a parameter.
Right. And then this, if you take it not in parentheses, is going to be the name of the function, the delegate method, because that's what we're pointing to. Inside of this object, point to the delegate method,
right,
and pass these parameters.
Now
just like you would normally define a method in a class.
Now, when we say underscore delegate method, Brian, that is nothing more than our label for it, because we don't know what the name of the method is going to be. So we want to call it something that we know.
Something generic.
And the reason why we will be able to access it no matter what it's called is because it's coming in as an address. So we're pointing to something that we will call delegate method, but that class can call it Brian's butt. It doesn't matter, you know?
So now that we have the blueprint laid out, we've solved the problem, figured out generally how we're going to approach this to awkward fascination. So now we're going to build our implementation for this class.
Our what?
Our implementation.
What do you call it for C++? Is it our complementation? Is that what you would call it?
As always, if we have not defined the WiBit Delegate Class, let's call it WiBit Delegate, then let's define it.
Now you're actually writing an Objective-C. Put in the @ symbols. Nice.
Okay, so if we have not defined this, then we'll define it.
Yep.
And if.
Nice.
Okie dokie. We want to include IOStream.
Not by doing that well. It kind of goes, sort of.
That was weird.
That was very weird.
And then
it's kind of, I'm actually kind of scared.
Actually, that would be kind of a cooler way to do those.
Yeah, it would be.
I like that.
You know, you could make a preprocessor directive that can probably do that.
The preprocessor director of pound?
Well, no, but you should be able to write like a preprocessor macro that would swap that out for you if you really, really wanted to do it that way.
Interesting.
Yeah.
So we're going to include that. We're also going to include.
Yeah.
What is it? What we just made? Delegate.
Delegate. See, I knew it. I knew the answer before you said it.
Okay. This implementation is going to be obviously similarly structured to our blueprint.
It's going to look kind of complicated, guys, but we're going to try to speak to it as if, you know, to simplify it as much as possible.
All right, so let's just walk just walk line by line.
And don't look too deep into it. Just look at it for what it is.
So we know that we're going to be templating the data types.
Right.
So we're going to, just like we talked about a minute ago, like these could be int, they could be string, they could be whatever.
Right.
So we're going to make a template class, the objects data type.
Right. Just like we did in the class, it should be the exact same text that we put at the top of the class.
Return data type. And the parameters data type. Yeah. Then we're going to implement our default constructor.
Right. So what we're doing is we're templating the method at this point. So we put the template code above the method declaration, and the method declaration will then contain the parameters, just like this.
And that keeps us all linked together. And we scope into delegate.
Now, real quick, stop real fast, Brian.
Yeah.
So, just in case you guys didn't quite get this in the delegate video, this is this is what the name of the method is, right? Inside of the
scope,
delegate class.
The class name.
Now, I'm sorry. This is the class. This is the method. I'm sorry. This is as if you. This is kind of the same thing as if you were going to. I was. If you're trying to do something like this, int my function int. That's the same thing, but since we're templating, our parameters are this.
Right.
Right? So in this, we'll just say that when I call an instance of delegate, I'm going to reference the one that has this template, and I'm going to pass as a parameter these three values. That's it. Just wanted to tie those together.
Awesome. To implement our default constructor, we want to null both the delegate method and the delegate instance. And we do that in a really weird way. No. Delegate instance.
Does it piss you off that Objective-C calls it nil?
Yeah, I don't like that. I don't like yes and no. I like true and false.
Yes and no, I know. It's so... Man. Sorry.
Oh well. We're going to do another templated constructor. This is the constructor that's not default. It's the one that has parameters. So to pass the parameters, we say data type, object, DT, pointer, delegate, instance. Yeah?
And since this takes two parameters, right?
Yes.
Since C++ will ignore white space for viewability, Brian, let's just knock... we can do it that way too, yeah.
You want to put this down too?
Yeah, just C++ ignores the white space, guys, so this is legal syntax.
Return of type, return data type, object to pass, reference to the pointer of the delegate method. Object.
Right. Onject. What is it with... You really want to take this onject drug.
I hate to admit it, but I type on a Mac keyboard a lot during the day.
Oh my god.
I know. And you have to, like, contort your fingers in very tiny ways to type on it.
Everything about Mac is tiny.
Yeah.
It's for little people.
Including the members of the people who use Mac. Okay. And then we pass the parameters.
You got an extra...
Yep. We don't want that there. We want curlies. Okay. The difference is, all we're going to do here is we're going to take... I feel like I'm missing something.
There's something missing.
Yeah.
What is it?
This here... No, I think that's okay.
That's fine.
No, okay.
Yeah.
All right, just checking. I just had that feeling, you know? Okay, so all we're basically going to do is we're going to take this delegate method, tie it to our private internal delegate method, which we defined in the header. No big deal, right here.
And that's just a label, Brian. That's just the same thing as saying, like, char star or something.
Don't let it hurt you, man. It's just a label.
Yep.
Now we're going to wire the delegate instance to the delegate instance. So let's take the delegate method, tie it to the internal delegate method.
Right.
Take the delegate instance, wire it to the internal delegate instance.
Now keep in mind, folks, these are all pointers. So by setting that equal to that, we're just pointing our pointer to something.
Yes. Okay, so now we want to do the set delegate instance and set delegate method methods.
Which I'm sure are very complicated.
Yeah. Okay, so as always, we're gonna keep it abstract. You know we're gonna use that. Void class is delegate.
Delegate.
So that's the name of the class.
Mm-hmm.
And these are the...
You can probably just copy this line up here if you want to save some time.
That's cool. There you go. Okay, so we're going to void that, scope in, and declare the following method. Set delegate instance.
Nice. You got a little delegate issue there.
Don't we all?
Now again, don't be afraid on how Brian's doing this. This is just taking advantage of white space to make it more readable. Otherwise, it'd be going off the screen. If you just remove those new lines, it'll just be one long continuous line.
Yeah. We're going to take in one parameter. That's going to be the delegate instance. Because that's all we need to take in to set the delegate instance.
That is correct.
So to take in the delegate instance, just like we did before, we want of this type, this object is what we're going to call it here.
Beautiful.
And however you want to pass it in is however you want to pass it in. Probably don't need an extra space for that, so we'll bump it up. We'll pump up the jam.
Pump the jam. Oh my god. Why did I just say that?
Isn't it amazing how much our brain can memorize?
Yeah, it's
phenomenal.
Weird.
In this case, it's really similar to our constructor where we take in a delegate instance to delegate method. In this case, we're only just setting our delegate instance. Okay. Last but not least, this is the home stretch of implementing this like crazy awesome, you know,
we should have two more. We have the operator as well.
So we got two more in what I'd call this is a Kevin special. This is the type of thing Kevin makes, which is slightly stylistically different with what I tend to make. He makes things that take it up a notch so that you're working at a higher and higher like altitude.
So what would you do differently?
I'd probably just sit there waiting for be like, hey Kevin, do you have a class?
Do you have a class I can use?
Yeah.
I remember those days.
Yeah. And you'd be like, yeah, hold on.
Yeah, hold on
just include this. Okay, thanks.
Just awesome. Pull in this DLL, done deal.
Be like, it also does this, this, and this. I'm like, oh, so I don't have to do anything anymore? I'm done. Awesome. Okay, so this is the class. So here we go.
This should be a void, right? Because aren't we going to set the delegate method? Yeah. Cool, you got it.
Well, so this is going to be the return. Whoa.
No.
I knew that.
Yeah, you're doing the wrong one. Yeah.
Okay.
That one's after this.
This is a setter.
Yeah.
Where am I? What day is it today? I don't know.
You're in space, baby.
I don't even care.
David
All
Bowie
I know
style.
is David Bowie sitting on my lap, and it's kind of creeping me out. So this is very similar to the last one. The only difference being that we're going to be setting the delegate method instead. So, yeah, we take this just like we did in the constructor. And we wire up the method so the internals is equal to what we get passed in.
Right. Do we have a match on parens here? Just want to double check. Yeah, okay, we do.
Sweet.
It just went off screen, so I lost sight of it.
Wicked cool.
Yeah.
Man, wicked cool.
So now we have to override the operator.
Okay. Now this is last but not least.
Mm-hmm.
First, we have to declare our template.
Mm-hmm.
And then, now this is where we get to have a return data type.
A retro.
Delegate. I'm going to copy that from up here.
What is on BJ?
I can't.
What is this?
I'm typing it.
Now you're putting sexual things in here, Brian. What is an on BJ?
It's an event.
Should I ask your girlfriend what an on BJ is?
It's an event handle. That's what it is. And it is not a delegate function.
Well, it is a delegated action because you're not doing it yourself, right? You're not like...
It is not a delegated action. Okay. Return delegate.
So wait, you're giving yourself a BJ? Is
exactly.
That
Marilyn Manson style. Marilyn Manson style.
Awesome.
All we're going to do is take in the params.
You know, where I grew up, there was a restaurant called BJ's on the Water. And it was like the guy that owned the place was named like BJ, and it was on the water, so it was BJ's on the Water.
In the case that the delegate method is null, we have a problem. Because what we're doing here is I'll show you what we want to do and you'll see it. We want to return the result of delegate instance pointing at the location in which we can execute the delegate. There's going to be a typo in here, I guarantee it. Method. And pass it the param.
Mm-hmm.
That's what we want to do. Now the problem is if the delegate method is null, we have an issue.
Yeah, we'll have a crash if that's the case.
So let's prevent. Now, generally speaking, in these labs and in our lessons in general, we're pretty bad about exception handling.
Yeah, we're pretty terrible.
And we aren't like that in real life, I assure you.
Yeah. Well,
but for the sake of teaching, it just consumes time for us to kind of go off on sidewalls of every way of handling exceptions.
Right. And also, it is also fairly common practice to handle exceptions at a much higher level. The thing about languages like C++ is there aren't like default exceptions that happen like in Java and C# that you can account for. So that's the reason why we're lazy is because we do work in the higher level languages where it's easier to handle.
But we will, but maybe we'll get around to doing a series just on exception handling and how to stabilize and debug your code.
Right.
But that'll be, that's down the road.
So in this case, Brian is checking to see is the method valued. And if the method is not valued, we can't functionally do this. So then we're going to throw an exception.
We're going to throw a fit.
And it's going to be caught at the higher level. So if you put this in try-catch blocks, you'll be able to catch this.
Okay, so now I'm going to turn it over to Kevin to test this out in the driver so that he can deal with all of my typos.
Right. Just to kind of reiterate what this is, don't get confused. This is really the same thing as saying, I'm going to return, and let's say I have a class called my class. And this is an instance of a class. Dot my method. Passing it param.
Yes.
This is the same thing, but the difference is since we're dealing with pointers, it's just syntactically different.
Yes.
So that's it.
Cool.
Don't be scared.
All right. On to the driver.
Now that we have the delegate header written and the delegate implementation written, we're going to kind of abstract out of this into the driver, which, as you guys remember, since we're using object-oriented design, let me just kind of, so that we have the hierarchy in proper order. Since Since we're using the object-oriented design concept, we're going to have the main class.h, the main class.cpp, and the main class driver, which we're not going to be working in. We're going to be actually working at this level, although hierarchically speaking, this is the bottom level. But anyways, let's include Brian's delegate class, and we should just pull it in here, right?
And hope like hell. Up one.
Above main class?
Sure.
All right.
And hope like hell that it compiles properly.
Yeah. Delegate.cpp. And now I get to deal with all of Brian's mistakes. Holy shit! No way!
Nice.
No syntax errors. That's awesome. Impressive. Holy crap. Okay.
Doesn't mean the program works.
So now let's kind of take a look at what we're doing here. Now, if you look back here in the main class driver, we're creating an instance of main class. And the main class instance is called main. So as you guys remember with the recursive, the open recursion, inside the context of my class, I can refer to myself as this. So when we start making a delegate, so we're going to pass this as a delegate. And our delegate class is going to know where this resides because it resides here inside of me. And this is going to be the name. So let's kind of do a quick example of how we can just make this work.
So first we want to make an instance of the delegate class.
Okay. So delegate class.
And we want to tell it we just call it delegate.
Okay. That's right, delegate.
And we want to give it the different data types.
Okay, so the first one, if we go back here and take a look, what is the template? The first one is the data type that the method resides in. Well, we're inside of the main class, so that's where this method is going to reside. If I had another instance of another type, this would be that type, like a string or whatever.
And next is the return data type.
So
thread delegate returns an integer.
Right, so this is going to be what our method returns. So as you can see here, this method is going to return an integer, so that's my return data type.
And now we want to know that the parameter data type. What are we passing into it?
Right. So you can see again here, the parameter data type is going to be what is passed in as a parameter into my delegate. And you can see down here, our delegate is using a string. So if I do this, that is the basic lineup of the template parameter.
And we'll call the object D.
Okay.
Or
for delegate.
Yeah, sure. Maybe just throw a space in there, not that it matters.
D.
Cool.
All right, now we're going to do an example where we don't use the constructor, but we can also do an example where we use the constructor.
Okay.
All right, so now D dot, what are we doing, Brian?
Well, we first want to set the delegate instance, and then we want to set the method. So to set the delegate instance, this is the instance.
Right.
Just like Kevin was saying a minute ago. Now we want to set the delegate method. And that delegate method is going to be a reference to the class and then the function. Right.
So it's going to be kind of it's going to be like this. Now remember, this is the method method pointer that we discussed before. So it's going to be inside of main class. So we're going to scope into main class, and the main class method that we're going to be referencing is this method right here.
Right. And that's it. So now we can basically call D as if it's let's change the name of D to like delegated func. Delafunk.
Delafunk?
Yep. Just so it looks more like a function.
Well, you don't like the D function?
Nah. Okay.
So watch this, guys. Watch this. Now, what we're going to get here first is we're going to get nothing, and that's fine.
Yeah, we're just going to get 0.
This is just an example. Let's run this, and then Brian and I will explain exactly what we're doing. Okay? So we got 0. You could make an argument that in this particular case, why don't you just call the thread delegate? Well, this is not a practical implementation of a delegate.
Naturally.
It's an example of a delegate.
It's the simplest example that we could possibly boil down.
And we're going to use this class to build on other more practical examples. So what we're doing, guys, we're creating an instance of delegate called delafunction, setting the instance to the current instance that we're within, setting the method that we're going to be using inside of this class from this class scoped into, and then the name of the method. And now, since we overloaded the parentheses operator, I can just call the instance as if it's a function inside of my class.
It's really cool.
Right, so if I have a class that is expecting a delegate data type, so remember the example that we used before, which was, I don't know, the TCP example. Well, if you made a TCP listener class, and you had a on message arrived, delegate or action or event, you can have a default method, but if somebody passes in a delegate, when a message arrives, it will run within the context of my class.
Right.
So this is really, really, really cool.
Awesome.
Now, just to kind of complete this.
And that doesn't have to be in this class, obviously. I mean, we passed this,
Mm-hmm.
but it definitely does not have to be in this class. Most of the time, it won't be.
Absolutely. So to kind of complete what we're trying to achieve here is all I'm going to do is return the length of the string that was passed. So just to kind of follow where this goes, right? We have this stored, we have this stored. When I call delegate func, just to kind of follow where this logic drops, when we call this, Brian, when we call the instance and we pass these, watch what happens. I go back here, it drops into this code.
Yes.
And it checks, and we should probably also do a,
instance?
Oh, yeah. We should probably also add another exception here. Since, this is class-based, we want to make sure that the delegate instance is not null as well. If delegate instance is null, delegate instance cannot be null.
Cool.
So what it will do is it will check, do I have an instance pointer? Well, according to this code, I do, because I sent this here. Do I have a method pointer? Well, according to my implementation, I do, because I pointed that here. Okay, I passed the 2 tests. Now I'm going to call this, pass the param, and what does that do, Brian? That jumps into the scope of here from that back-end class.
Right.
How cool is that? Now, Brian had another example he wanted to go. Brian had another example he wanted to go over.
Right, so I just want to show how easy this is. Let's say you want to make another, and just keep imagining that this can be in any class. Mm-hmm. Let's say we go back and we put this back to return 0.
Mm-hmm.
And I don't want to go too far on this, so we won't make it very complicated. We want to make a new method in the main class and call it length. Mm-hmm. Yeah?
Mm-hmm.
And then we say string, stir. We take in a string. Just like the other thing, we say return. Cool?
Mm-hmm.
Okay. So now we have a whole different, we've got a whole different method that we want to implement.
Mm-hmm.
And we want to call this as a delegate, not directly. Because we want to be able to, however, we want to be able to call that remotely from another class.
Mm-hmm.
For a multitude of reasons. All we have to do is when we set the delegate method, what we can also do is just set it again. Actually, I'm going to put this below here. We can set this again, and we can just say string. So now we've rewired the delegate method.
Right.
We don't have to change the instance because it's still in the same instance.
Right.
So we call that.
Now do a different string.
It's still delegate function.
Right. That way we'll get 2 different lengths. And maybe also, Brian, kind of go back down to mine and make it return 0 again.
I did.
Oh, you did? Okay. Cool.
Okay, so the first one should return 0, and the next one should say, I'm not your buddy, guy.
I ain't your guy, buddy.
Okay. Nope, not that. That's Control S. Where are we at here? Okay. So, will this work? Will it work quite as easily? We'll find out.
You have to scope it in, Brian, and you have to put it in the header file. Go back to main.h.
Oh, yeah, because we're not. Oh, yeah.
We're doing object-oriented design.
Okay,
so,
yeah, so naturally. Okay.
Yeah.
Because we're in a class, we just want to say length string. There we go.
Yeah, that should be it.
Easy enough.
What do you think this is? C#?
Okay.
Hey, buddy!
So now we've effectively reassigned our delegate method to another delegate, another method, just like that. We just set it, use it, done, good to go. It's very cool.
So the next thing I want to try, Brian, is let's delete our private methods. And this will kind of show you guys how abstract this really is, because we were working within the confines of our own class. Well, what if we want to pull in another class that we want to send as a delegate? Now, if we go to our C++ awesomeness, I think we have like a person class we can use, right?
Yeah.
So we can pull in person.cpp. Why did I right click on that? I can type that myself. We're gonna import that person class that we used before. And the first thing we're gonna do is just kind of include it here. And for those of you that are paying close attention to this, yeah, we kind of f***ed up and we're editing this back together. So if you see some code like disappear on the screen, it was Brian's doing. Person.cpp. All right, might as well be honest about it because that's not going to be a clean cut.
Yeah, that's fine.
So we pull that in, right, Brian? Now we're going to do a person P, and I'll do this as a pointer, and this is going to equal a new instance of person.
All right,
Right?
now let's. Okay.
All right, now what do you want to do? Make a delegate?
Yeah, let's make a delegate.
Make a delegate.
Delegate.
Now, okay, the object data type is person. Remember how we were working in the main class context before? Now we're working in the person class. The return type, we're going to be doing a void, and the parameter type is going to be a string.
Yep.
And we'll call this set name, or set...
Yeah, that's good. Set name.
Set name. Set name dot set delegate instance. Come on, Kevin. Set delegate instance, and this is going to be what, Brian?
P.
The instance P.
Yep.
Set name dot set delegate
To by reference.
Set delegate method. Right. What are we going to do here?
Reference to person scope in to set first name.
Nice, nice. You guys remember the set first name method in the person class. So now we've abstracted ourselves out, and now we're going to be setting another class instance instead of our own class instance. Right. And what we're going to be doing, Brian, is we're going to be setting the first name.
So now what we have to do is just call set name like it's a function. Give it the name, and we've set the name. We've set through a delegate the name of P. Right.
So that delegate called code that's inside of this class.
Right. And that's not right. It's crazy.
It's beautiful. So now if I do P get first name like that.
Uh-huh.
By reference, we should have WiBit.net on the screen.
Absolutely. And we will. And we shall.
So we'll do a compibble. For those of you that speak Kevinese, that's compile. Now, I hope that you appreciate the power that we just showed you, as Brian gives the little golf clap. So instead of using our own instance, Brian, we're using person, and we're sending the pointer to person back to the delegate's setting this, and I'm retrieving it. So the delegate is the one in control here. That's
very
pretty cool.
Yeah.
Yeah.
I like it.
I guess that's it, huh?
Yeah.
All right.
Adios.
In this lab, guys, we're going to be building a stack using object-oriented concepts.
Yeah.
And the object-oriented concept is going to be a class. Yeah!
So at this point, you should know what a stack is. You should know what a class is. You should have already built a linked list on your own.
Yeah.
You should be pretty golden by this point. So you should be perfectly up to speed for what we're about to do.
Absolutely.
And if you're not, then go watch that other stuff and get up to speed.
All right, so for our class, we'll just call this, what do you want to call it? Just stack, right?
Yeah, it's called stack.
So we'll save this.
How about W stack?
All right, W stack. So we'll make a directory here called W stack. And inside of here, we're going to create a file called, what is it?
WStack.
H. And then WStack.cpp. And WStack driver.cpp, and in my little command terminal here, I'll call this WStack. Awesome.
Cool.
All right, so in the WStack.h, Brian.
All right, so the stack, what the stack includes will be of some undetermined data type.
I wonder why we would do something so crazy like that.
So that we can keep it generic.
So just like the linked list, right?
Yeah. So this will be just class DT. We'll just call it DT.
All right, just like we did in the other thing.
Yep. And then it'll be our WStack class.
Like a this?
Like a that.
All right, okay. Private.
Well, we want so our private usually always contains our core element, like our primary core element.
What we're encapsulating.
Yeah. So what we're going to be encapsulating is essentially a linked list of our generic data type, and we'll call it the stack.
Okay, linked. Come on, Kevin. Linked list of our generic data type called the stack, like that.
Right.
And then for public or public, what? All right, what do we got?
So our externally facing methods for this class are going to be something to determine whether or not this is empty. So it'll return a true or false for it is empty. Yep.
If it is empty.
Perfect.
Okay.
And then we want to get the depth.
Okay.
So it'll just return an integer.
And we'll do an unsigned integer because the depth will never be negative.
Fair enough. Why not? And then we're also going to do a we want to you remember in a stack we can push the stack and pop the stack.
Mm-hmm.
So if we push the stack, we want to return the new size, which will also be an unsigned int.
Mm-hmm.
So this will be push stack, and that data type is going to be whatever that data type is.
So what we're slapping on the top of the stack.
And then we want, like I said, we want to pop it, and that will
Right.
return the data type. We're going to pop the stack. So we go
Right.
push. You got push start. It should be push stack.
No, you're wrong. Just don't question me. Now, you guys remember that with the actual functionality of a stack, we're not accessing individual elements because we don't care. We're just sticking stuff on top. And remember, with the stack, Brian, it's going to be the most recently added is going to be the most... Well, it's going to be the first one taken off. It's going to, oh, right? No, it's last in, first out.
Right.
Right. So the most recently one added is the first one that we pull out. Pull out. And anyways, over here on the CPP file, Brian, let's talk. I'm going to do my if define, if not define, and you can talk about stuff.
So that's going to, we'll call it like WiBit stat class.
You have something fun to talk about while I do this?
Well, since this is based on the linked list,
Right.
this is going to be contingent on our linked list project.
You are correct, sir.
So we want to first include our linked list
Right.
class.
And we, within the local context of this, if we go to our
directory,
our desktop, and we're actually within the scope, of this directory here. So if I want to access the linked list,
we got to go back one.
Right, I can copy the code and put it here, but why? If I can just go up one and in here, and those of you guys familiar with the syntax, you'll see that ..// means go up one directory.
The ... is actually a link to the parent folder.
Yeah, it's
a hidden shortcut to the parent.
It's
folder.
a hidden folder that every folder contains that takes you to its parent folder. And then the folder name is linked list, right?
Yep. And then linked list. No,
you're right. It's a directory.
And then linked list.cpp.
Very cool, Brian.
Cool. All right. And then the next thing we want to include is obviously our header.
Right.
And the reason why we do this after we call the other one is because our header refers to a linked list class.
Yeah, and it's typically, although, we'll make the mistake, other people will. I mean, I don't want to say mistake. That's kind of strong, but for the most part, we find that C++ developers find it bad practice to include code files in .h files. That you can know that if it ends in a .cpp extension, it will be what's consuming, and .h files will not be consuming.
Yeah.
That's not a strict rule, but it's sort of common. Anyways.
Whatever. Okay, so let's get our methods from our header.
Let's do that.
And we'll build out our implementation file.
Yeah. So we're going to copy these, Brian, right?
Yeah.
So I can do a little copy action, a little paste action.
Yep. So these are going to be templated.
Oh, I'm sorry. I got to do it the Brian way. We got to do a little select shift tab.
Nice. Look at that.
And
template class DT.
Class data type is going to be these, and then
we'll probably put it on the same line. For each
then
of
it's
these if
going
you
to
want to
be
get crazy.
I like a these, and then bool, and then W stack. Don't
DT.
forget it this time. Like that, right?
Yep.
All right. So let's do. Let me just do a quick. I'm sorry, Brian. Let me just do this.
Perfect.
Just knock this out. Get
Makes
this out of
sense,
the way. So we'll stick that there.
What you got?
Stick.
Does it work like that?
Nope. It works like that.
There you go.
Like that and like that.
Yeah.
Is empty. Talk to me.
Okay. Is empty is pretty straightforward. We just
Okay.
want to say if
Okay.
the stack
Okay. So if underscore the stack
dot count. Remember, because we had a count method we put in there
on the linked list.
on the
correct.
linked list,
Yep.
right? If that's 0,
Right.
then just return true because
Nice.
it's empty.
Right.
If the count's 0, it's
Yeah.
empty.
Perfect.
And then return false.
Okay.
Cool.
Return false.
Moving on.
If it fails this condition,
Yeah.
it will then
That's all we
enter
want to
that
know. Nothing
condition.
simple. It's
Yep.
just a matter of building out.
Now you see how simple all this gets, Brian. Once we start abstracting out, so we build one class.
Absolutely.
Then this class
It's
consumes.
that low level that's kind of,
Yep.
it's like the string class. Like that's something you have to
Yeah.
your way through. you
Yeah.
know? The integer class, that's something Okay, so depth, we just
Okay.
want to return count from the stack.
I don't believe you.
I know, it's crazy.
All right. Well, I will anyways.
So we're just connecting all the wires, basically.
Like that, right?
Yep.
Okay. So then push.
Push stack. We just want to return
Okay.
the stack
Underscore the stack
dot
dot
add
add
And then your data type coming in, it's like an item.
Item like that?
Item, yeah.
Okay.
So we'll just add an item.
Like that?
That's it.
What the hell, dude?
Because the stack, that linked list will naturally add to the end of the list.
Right. Mm-hmm.
Natural, that's how it works. That's how we designed it. So we know that if we just add to it, it's just going to slam it on the end. Slam it. And that's all we're doing when we're pushing a stack is just adding that item on the end.
Yeah, exactly. So when we're popping a stack, what are we doing?
So now popping a stack's a little different. A popping stack's not as easy, but it's not difficult either.
Mm-hmm.
If the depth,
Uh-huh.
which is basically just the count, but
If the depth
if depth is less than or equal to 0,
less than or equal to 0,
which it shouldn't ever be,
right?
we'll just throw an exception saying, unable to pop an empty stack.
All right. If the depth of the stack is less than or equal to 0, we're throwing an exception.
Yep.
Throw new std string. And what is it going to say?
We'll just say
Stack empty?
stack empty on it. Yeah, stack empty.
Stack is empty. Sorry, pal. Sorry about your luck. Don't remove those. Yeah, cool. All right.
Okay. All right. And then now we want to fetch the location.
Okay.
We want to set a fetch location.
Like an index of where the last index is, right? You want to call it fetch? Do you have another name or just fetch?
Let's just call it last index.
Last index.
Yep.
That's going to equal what?
It's going to be the depth minus 1.
Nice. Like that.
Yep.
Okay.
We're gonna make a return item
Right.
of the data type.
So it's going to be return.
Because when we pop it, we return this item, but then we want to make sure we delete at the end.
Right.
So what we're basically going to do is return this thing at this last index,
Right.
and then delete it, and then return.
So like that. So
Yep.
last index.
And then we want to remove that last index. So the stack.remove add.
Oh. Because we're popping it. We're not giving it to the user. We're actually killing this thing.
Yep. And then now that we've held it in that little return item, we can return that.
Right. You have a little temporary pointer or temporary value that stores that.
Yep. And now we just return that return item.
Return item. Holy crap. Is that really all we got to do?
That's really all we got to do.
Holy crap. Let me zoom out real quick and take a look. All right. I'm going to get rid of my little spaces here. I got a little extra space. All right. Cool. So
Let's see if it compiles.
that was a lot simpler than I thought.
Yeah.
So let's go ahead and test the driver. Okay, we'll do an include stdio. I'm sorry.
IO
What language am I using?
I don't
here?
know. Depends on the day, I guess.
IO stream.
stdlib we can include.
Namespace std. Yeah, we could do weird stuff like that, but we're not. Int main. All right. Return 0. All right. So we want to create an instance of a W stack.
Right. So we first want to include our
Oh yeah. We got to do all that stuff first. So include.
Now we're in
Objective C, of course. Include wstack.cpp, like that.
Exactly.
So we're going to create an instance of wstack. And what data type do you want to make?
I don't know if you want a semicolon up there.
You're correct.
But if you want it,
Your face
cool.
doesn't
I don't
want
think it actually hurt anything.
It probably will. What data type do you want to make our stack, Brian?
Let's just do an integer. Why not?
All right.
And we'll call it
My
the
stack.
New York stack of mind.
All right. So now let's just see if that runs. All right. So we do a little G++.
Nope. W.
Whoa.
Directory /
Whoops. Okay. Let's try that again. G++. What was it again?
W string.
W stack.
Abstract. I mean.
-ow stack dot driver exe. Wow.
Cool.
Not bad, huh? Okay, so should we just start adding? Just maybe loop through and add some stuff?
Yeah.
All right.
You can just randomly generate a number. Well, let's just add it. Let's not even loop. Let's just add some crap and pop it. Let's just add like the number 5, 6, and 7.
Okay.
So we won't even bother with the loop.
My stack dot add
Push.
No, push, sorry.
Push stack.
Push stack
5.
5
5, 7, 30.
5 7 30. And let's see out the depth.
Yep. Stack depth.
All right, let's see what that does.
Okay.
All right, W stack driver.
Cool.
3.
Look at
All right, now what are we gonna do?
that. Let's pop the stack.
Okay.
Well, let's print out a pop stack twice.
Okay, so this will be
After,
pop.
You can just do it after this,
Oh,
and then we'll do the def again.
Sorry. So we'll put that at the end, and we'll do a
pop stack, and then one more time.
Like that?
Yep, perfect.
So we should
Flawless.
get 30 and 7,
Yes.
right?
Yep.
Okay, 3 is the length. Okay, that's confusing.
All right, let's add some.
Well,
Let's add some descriptors. We should all, yeah.
we can do one of these jobbies. That was correct, I swear. So that equals that,
Right.
and then that.
And then what we really want to do too is for every time we pop the stack, because of the way we're using exception handling now, we really want to say if the stack is not empty.
That's true. Yeah.
So that'll test our is empty too.
All right. Let's see if we can get that exception to blow up.
Okay, let's do that then.
We'll do this.
Let's do this first. Okay.
So we do. So depth is 3, pop stack 30. Okay, and that is correct. Now, what Brian is saying is we do something crazy like a this, right? So I'm going to pop this again, and we're not going to have an error just yet, but we're going to have an error if we do this again. So here is the compiled. Here's this. So now the depth is equal to 0.
Right. So now if we do it one more time,
I wonder.
the list will be empty, and it's going to not be so happy.
So if we do something like this. Holy monkey, we got a crash, baby. So you guys remember, and we'll test the other method in a second, but we can do something like try, right? And then we're going to try this code. And if this code fails us, right?
Yep.
We can then throw it into a catch, which will then have a string pointer, ex. And we should be able to do cout ex dash star ex.
Yep.
I like this. So I think that should catch the exception. And instead of crashing the program, because before we had like a Windows pop-up that said, "Whoa, this thing blew up."
Right.
Now we have a little stack is empty. Now, like Brian was saying, and
Now we could also have that try surround the entire list of output if we wanted to.
Yes, we could. You want to do that?
Sure.
All right, nice. All right, so let's blow this thing out and let's take this thing up. So we do this. So this is just to like protect our entire program, right?
And then if we want to, we can just have we can surround each pop stack with an if, but this will catch it. So
yeah. So now let's crash the program again. Oh, stack is empty.
cool.
Now Brian gave us another fun little thing. So we can also do like he said, like if
My stack.
if my stack
Actually, if not, my stack
right
is empty.
if not dot is empty. So this should prevent that exception from catching. And there you go.
So because we're doing exception handling by throwing the errors, generally speaking, when you write code, you always do want to do checks like this.
Yeah.
And classes, if they're well designed, won't just fail and not return anything.
Mm-hmm.
You do want them to return an exception, so you do want to test to make sure that whatever you're going to do is valid. So
Right.
you don't just want to blindly be popping stacks like there's no tomorrow,
Mm-hmm.
and then if it doesn't return anything, you just keep on popping stacks.
Right.
You really only want to be calling that when you know that there's something to pop.
Right.
So it's perfectly reasonable to want to check to make sure it's empty before you pop the stack every
Right.
time you do it.
Right.
So we should probably even put this before every one, just so you know.
Right.
I'm not going
Right.
to do that because it's just obviously a test to make sure this works. But
Yeah. So like
in practice,
an example of this would be like if you wrote, I don't know, some network software that was using some values in a stack. Usually each item in a stack will fire or trigger some sort of process flow.
yes.
So before you actually get into the process flow, the first thing you do is check, is there a value waiting for me? If
Right.
yes, get
And
the value.
is that value valid?
Yeah, get the value and then,
Yeah.
then send it through my process flow.
So,
That should be.
yep, and you'll get there.
All right, Brian, naturally the next progression from a stack is what?
A queue.
Nice.
Now the queue is the bank line situation. So this is first in, first out, FIFO.
Yeah.
Yeah.
Yeah,
This is like a fridge in a restaurant. Like you put food in, the oldest food you want to use first.
right. This is the data structure that's more relatable to humans because
Yes.
we see first in, first out in most aspects of our lives.
You go to buy a coffee. I got here first. Serve me next.
Yes, exactly right. Okay, so in our WQ directory, we'll make a WQ.h.
Yep.
And then a WQ.cpp, and then a WQ driver.cpp, and then my shell or terminal or DOS prompt, whatever. We'll go to WQ. Nice. All right, Brian, let's just start from the top, the .h file.
Okay, there's not a lot going on, just like the stack.
Right?
Yeah, it's going to be templated, just like the stack is. And the class is going to be the WQ class.
Right. All right, so class WQ. QUEV. What do we got for private?
Okay, no, the private's going to be the same linked list. And we'll call it a linked list of our generic data type. And we'll call it the Q.
The Q.
Instead of the stack. Yeah, I like that. Let's do that.
I like that. All right.
All right, and the publicly accessible will be similar to the stack, is empty, and it's going to return a Boolean. So it determines whether or not the list is empty or not.
Okay.
We're also going to have depth, like we had before, so it'll be another unsigned integer.
Okay.
And then now instead of push stack, we're going to have push Q.
Okay, so push is going to be int?
Yep. It's also going to return the size, the depth.
Right. Push Q, and that's going to be DT?
Yep, exactly.
Okay.
And then we're going to pop Q, which returns DT.
Right, so DT.
So it's just like push stack and pop stack, but in this case, when we push to the Q, it goes last, and when we pop the Q, it takes the front of the line.
Right.
Instead of the end of the line. That's basically the difference.
Okay. So if not defined, WiBit Q, then define.
And if.
And if. Okay.
All right. Now we know right off the bat that we're going to include the linked list project.
Okay. So we did this before, right,
Yep.
guys? //
So the parent directory, the linked list directory, and then linked list CPP.
Okay.
Okay. And then we're going to include obviously our header file as well.
Right. Include WQEV.h.
Yep.
Okay.
All right. And now let's copy the
Yes.
methods from our header file.
Yeah. Yeah. Okay.
Okay, so now this is templated.
Okay.
It's generic.
All right. I'm gonna just start since I only have like two of them to work with here. So this is
gonna
gonna be
double paste going on.
All right.
And then the last one.
So this is gonna be bool. And this
end.
is gonna be sorry. So this will be like that.
Yep.
Bool.
So that'll be bool WQ, and then we pass in the data type.
So
and then we pass in the data type.
Copy that.
And then we pass in the data type.
And copy that.
And then we pass in the data type.
And then we do that. Sorry about that. And then that.
Yeah.
And that. Okay.
Right. Now we're done. That's it.
Is empty.
Is empty if the Q count is 0, underscore the Q dot count is 0, then we return true.
Okay.
And then return false.
Holy crap.
And then for depth, we just return count.
I can't type today. Return false.
Cool.
For depth,
we just return the Q's count.
The Q dot count. Okay.
Cool.
And
push Q or return the Q add.
So this is going to be data type. What do we call this? Item?
Item. Yep.
Okay.
So we're going to return the result of the Q.add item.
Okay, so return the result of the Q.add item.
Yep.
Okay.
Done. Okay, now we pop it.
This is going to be hard.
So if for some weird reason the depth is less than or equal to 0, which it should never be, really, considering how the class is laid out.
So less than or equal to? Or
less than or equal to, because we can't pop an empty Q.
Okay.
Then we throw an exception. We throw a new string, unable to pop empty Q.
Okay. Unable to pop empty Q. Okay.
Okay. And maybe a period, not that that matters.
exclamation point, Brian. This is an exception.
Oh, yeah.
So
There you go.
this is an exceptional circumstance. All right, what do we got?
Okay. And then also later on, right now we're throwing a string. We could define an exception class.
Yeah, an exception instance, right.
You know, and then that exception class could have things, that instance of the exception class could have things like a message and like severity.
I think in C++ it's the what method
right,
that has the message. Yeah.
So anyway, so we want to first create the item we're going to return, and that's going to be of type data type.
Okay.
So our return item is going to be the queue at position 0.
Okay. Because we're taking from the top, right?
Yeah. We always take from the beginning.
Right. So, oh my god. Okay, the queue sub-0.
Yep. Sub-0.
Right. Sub-0 wins.
And then we remove at position 0 from the queue.
Like
so we
that?
so we get the item at the beginning, and we remove the beginning, and then we return that return item.
Is that it?
That's it.
Holy crap.
I know, it's pretty crazy, huh?
Let's see
All
if
right, so we've just implemented a queue. Done.
Include IO.
Move along, folks. Nothing to see here.
So we're going to do an include IO stream, then a using namespace std. I spelled space incorrectly. Name space. There we go. All right, Brian. What is a good, fun way of demonstrating a queue?
Well, you know what would be cool?
What's that?
We could include the person class,
Okay.
and then we can make a queue of people.
Okay, let's do it. So like people that are like waiting for the bank.
Yeah.
Yeah. Okay. So in order to do this,
Let's see where that's sitting. I don't know if it's out in the open or if it's in a subfolder.
it should be here. So it's just going to be .. person.cpp.
Okay, cool. Let's
So
do it.
we could do include .. person.cpp, and this will be a type person. So let's
That's
make
cool.
sure that this actually
Compiles.
G++ WQ driver -OWQ driver.exe. WQ was not declared in the scope.
Cool.
Driver line 6. Driver line WQ. Oh, I didn't include it. I'm so stupid.
Oh yeah.
Yeah.
That's funny.
Include.
Oh my god, how funny! How funny! That's so funny.
Like that, right?
Yep.
All right, let's see what that does now. Okay, cool.
Hey, cool.
So Brian wants to make a bunch of people.
Yeah.
All right. So in order to do this, Brian, let's just kind of like.
So you can say my queue add. We'll like name them. You know what I mean?
All right. So now I think. Let me go back in time here. Let me pull in the H file here. So we do have constructors. So let me see. Can we do this, Brian? Can we do myqueue.add? I don't know if this is going to work. So let's just see. Person.
Bill Mill.
Yeah, our buddy Bill Mill from C. Let's see if we can do if this is legal syntax.
And his last name first.
No member name. Oh, it's not add. It's push.
Oh yeah,
It's push.
Push Q.
Q.
Maybe we should have called it add, but we wanted to make sure that
now
it's the pushing and popping language that we want to make sure that
it's
you know.
Add is technically incorrect when you're talking about that. It looks like it works. So what we're doing, Brian, is we're just calling the constructor, which should return us a new instance, right? So we're adding Bill Mill to the queue. And who else are we going to add? And I think it is last name, right? Nah, I guess I'm not going to know until I open this. This is why we got to write our documentation better. Last name, first name.
Okay,
so
cool.
Mill Bill, that's correct.
All right. So what about Melinda Jefferson?
Jefferson, you're going to have to help me with Melinda.
MEL.
INDA. Nice. Okay, Melinda Jefferson.
And how about WiBit? WiBit the frog. The frog is his last name.
Are you sure?
Yep.
Is it Da Frog?
Sure.
Nah, I don't know.
I like that. That's like 90s, like Bugs Bunny going like, yo.
Like that?
Yep.
All right, so these are the 3 people in our queue.
Cool.
And they're in the line to do what? What are they in line to do?
They're in line to get served.
They're in line to get served.
So let's say while the queue is not empty, while not empty, we will display this person has been served.
But let's also make it so that we're interacting. So let's just do a little cin action. When we're ready, to serve someone. That way they have to wait until I put something on the keyboard. So first off, we got now during a typical work day at the Brian and Kevin restaurant, no matter what time of day it is, we will work while somebody is in our line, right?
Yep. But as soon as that line's empty, we're like,
we shut down for the day. So we should be able to do while my queue depth. Or is that, while not is empty, we can do that too.
That's what it's there for.
Yeah, while not is empty. So right now we have what they call in software development the glorious, infamous, infinite loop situation.
Yeah.
So when you get caught in this situation, your program is pretty much screwed. A little Control-C action will take care of that. Oh, all right. So let's do. So we're gonna know who this person is. So current person equals, and this is gonna be my queue dot pops queue, right?
Yep.
So we can do a cout like this person is ready. So like current person dot get first name. Current person dot get last name is ready.
Dot.
Yep. And let's just see what this buys us.
And then do you want to do an input after that?
We will. Yeah.
Okay.
Let's just run through this real quick and just see how this functions. So you can see. Okay, Bill Mill is ready. So, and again, this is in order. So we're adding Bill Mill first. So Bill Mill gets in line first, and then all right. So now that they're ready, they gotta wait for us to get ready. All right. So now, what do you want to do, Brian?
Let's say cin order up.
So
and then we type yes, and then they've been served.
Okay. So then we got a little
not like in a dance-off sort of way either.
String user input, and we'll just set that equal to blank. So we'll do a little. You want to do cout order up like a question mark?
Yep. Mm-hmm.
Okay.
So that's like asking us if our order's up.
Right. And then we'll cin user input. And if the...
and so we want to declare that user input somewhere, obviously.
It's up here.
Oh, yeah. Okay, wow.
If user input
I just zoned out,
equals yes. Or...
Yeah, that's perfect. Why not? Let's do it.
How about because what if we push something else, then it will still function. It will still go to the next person. So what we want to do is we want to have a loop here that says while
user input is not equal to yes.
We can do that. User input does not equal yes, like that. Good job.
This is not necessarily good practice, by the way, but
this is the best practice ever. I don't know what Brian is talking about here. Brian's just being dumb. Okay, so then while it doesn't equal that, we'll just keep asking for input.
So we should say order up inside of the while loop.
Yep.
And then after user input, we'll make a new line.
Oh, we don't have to because the new line will be captured.
Oh, yeah, because we... Yep. Okay. Yep.
Perfect. And then we'll set the value back to blank. That way it doesn't equal yes in the next iteration. Want to try that?
Yeah. Looks good.
All right, so 11...
Whoops. Just forgot a semicolon, probably.
Why is it going back here? Oh, I put a colon instead of a semicolon. That'll do it sometimes. Let me, little clean action here. All right. Bill Mill, order up.
Nope.
Order up.
Yeah, that's ready.
No! Yes. Hey, Melina Jefferson comes up.
Yeah, we're ready.
Nope.
Oh.
Nope.
How about now?
I don't
How about
like her shoes.
How about now?
Order up, that's right, because we didn't use get line.
Nice.
Yes. Ribbit the Frog is ready.
Yeah, he's orders
right.
up.
Yeah, he's orders up. Oh, we're done for the day. We're going home.
Close up shop.
Yep. All right, Brian. What are we going to try to accomplish with this video?
We're basically going to make a thread class that uses the delegate class we made before.
Mm-hmm.
So the thread class is just kind of will be a convenient thread object that will allow us to easily implement threading in a C++ program.
Right, so we're basically going to encapsulate a thread inside of a class. Now, the way that we taught before, Brian, was to create a thread class and inherit from that thread class for your own purposes.
Mm-hmm.
Now, that is kind of the Java-friendly way of doing it. And the thread class concept is a little more in lockstep with how
C# folks.
C# does it. And all that we're really trying to do is expose you to different ways that you can accomplish the same task. Because no way is right or wrong.
All right, there's 1,000 ways to skin a cat.
Yeah, or there's 1,000 ways to do something less gross than skinning a cat. So, alright. So we're going to make a little directory here called thread, because our class is going to be called thread. Thread.h.
Nice.
And we're going to do thread.cpp.
Of course.
And to demonstrate delegates, we're going to be doing object-oriented design, so I'm going to need a header file. Or we could just work out of the header file. Screw it. We'll just do it the way we've been doing it. So here we'll do main class.h, main class.cpp, and lastly will be the driver. This is going to be thread driver.cpp. So, Brian.
All right.
What is a fantastical way to get started?
The best place to start, obviously, is by laying out the blueprint of the thread class.
Okay, and now how in the world will we accomplish something
We
so
go to the
crazy?
thread header.
Okay, all right, we'll
start there
here now.
Okay. This is templated.
Okay.
It's generic. And we're gonna have a data type of the object.
Okay.
And we're also gonna have a data type of the parameters in some cases.
Look familiar?
And this is kind of the same structure we set up as Kevin's implying with the delegate class.
So private members, Brian, let's go.
Well, the core pieces is going to be the thread ID.
Mm-hmm.
So let's start there. It's going to be a D word.
Right.
Thread ID.
Which is an unsigned, was it unsigned 32-bit integer, a
Yeah.
double word.
Yep.
Right? Thread ID?
I always thought it was dong word, but
You would.
just kidding. Underscore thread ID.
Okay.
And then we want an exit code, which is also a D word.
Nice, because we're working in Windows here.
Yep.
Exit code?
Yep. And then we want a handle of the thread's handle.
Mm-hmm. You want to handle my thread?
Yep.
Thread handle, okay.
And then we want to know whether or not it's running currently. So we'll just, this is Boolean is perfect. Also, we want to do we want to declare a static private method.
Right. Mm-hmm. And all that this is going to be doing is doing the Windows launch procedure using the reinterpret cast operator stuff that we did before. And this is going to be static, so this doesn't go with the instance. This stays back with the class.
So you can actually probably put it above the other stuff if you wanted to, but
I'm not going to be that
that's
cool.
fine.
D-word. We're using when API, and then the method's going to be called start routine.
Sorry, Unix folks.
Yeah, sorry guys. LP void is going to be the input data type. So it's going to be a void pointer.
Then we want, so the meat, we always think about what's in the private is like the core element of what we're building this around.
Mm-hmm.
And in this case, our core element is the thread delegate.
Okay. A delegate.
Yep, and it's going to be the object data type, the void,
Okay.
and the parameter data type. And for how to use this, look at the delegate class, or go back and watch the delegate how-to.
And you're going to need that because we're going to be using that code here.
Oh,
now,
yeah.
remember, this is the object data type is the class type that the delegate is residing inside.
Yep.
Void every single, and this is pretty much standard across every language, every single thread method or function usually always returns void. So
Yep.
we're making that assumption here. And the param is if you're going to pass a parameter to your thread,
Yep.
which not all languages allow.
Yeah.
But we're going to do it because we're awesome.
And then, okay, so then we want to define our parameters.
Okay.
So we'll do param data type,
Okay.
and we'll just call it underscore param.
All right. Okay. That way we can encapsulate the parameter.
Yep.
Okay.
And then we want some other private methods are going to be init and run. So
Okay.
and they'll be voids.
So a void, init, I wonder what that's going to be.
to initialize, and this is just to like kick off to run the thread.
We're going to be using all kinds of crazy stuff in this
Yeah.
one. We're going to be really driving this together.
And then we want to do another thing where we basically, and this is just kind of for consistency's sake, we'll say void set running, and it's gonna set the running variable, and that'll take a Boolean value.
Okay.
And then we will also want another one to determine whether or not it's running, and that will return a bool. And it does seem a little redundant that we have our running variable, and then we're also doing like a set and a get for that. That's private, but the thing is probably won't do anything complicated in this example, but you may want to have other elements of verification before setting and getting whether or not this is running. There might be a couple other things you want to determine first.
Right, and we're also, guys, we're going to be using some properties here in a minute. So that is running.
We'll tie.
I'm going to take a guess. Is going to respond back the value of
Right.
running, and we're just setting it private because we want people to use the property and not the method.
Yes. Okay, so then the last two that are private is get exit code and get thread ID, and those are going to be returning integers.
Okay, get exit code. Whoopsie daisy. Get exit code
And get thread ID.
and get thread ID. So get thread ID. Okay.
All right, now we're on to our public methods.
So the public members.
We want a constructor
Okay.
and a default and one that has an overload.
Okay, so it's going to be
Just thread.
like that.
Yep. And
Okay.
then the next one is thread that takes in delegate,
Okay.
but it's going to be a delegate cast of types object, void, and param dt because it's
Right, like this here.
templated right. And that in its entirety is the
Right, so
data type.
you can make a delegate and you can pass the delegate here into the thread class that you
Right.
want to execute.
And what that's basically going to do is just when it instantiates, it'll connect to delegate.
Mhm.
That
Right.
delegate that you pass in. We're gonna have a virtual method, which is gonna be the destructor, so that people can like make it better when they inherit this and do what they want with it.
Right.
And then
right. Yeah, you're right.
and then we want to have one that connects us to the delegate, so it'll be a void. It doesn't return anything. It'll be connect to delegate, and that will link this up.
And I'm guessing this is going to take
Absolutely.
this, right?
Yep.
Yeah, so if you just called the default constructor, this would allow you to like swap the delegate in and out, all that kind of crazy stuff.
And then we want to start this, and that will return an unsigned integer.
Okay, so it'll probably return the thread ID, right?
Yep.
Unsigned integer start, like that?
Start, and then we pass in the parameter data type,
Okay.
whatever that parameter is going to be.
Parameter data type?
Yep. And although that's only one value for the parameter, you can always pass in a list because it's generic,
Yeah, or like a struct or a class,
right,
yeah.
whatever you want.
Mhm.
So we start that, and then we want to have a dispose, so we can dispose and kind of like close out the thread.
Right.
Yeah, that doesn't return anything.
Dispose. Nice.
Okay, now that's it for the externally facing public methods.
Mhm.
Now we're gonna have 3 properties.
Holy crap.
Do you know what those 3 are gonna be?
I have no idea, Brian. Maybe you can help me out. Now we're gonna
Are you lying?
we're gonna
I think you're
delegate
lying. I
this.
think you know what they are.
This is inside of the thread class, and it's gonna be what, a Boolean?
Yep.
For the first one, and what is
Yep.
it gonna be called?
Running.
So we can do instance.running, and that will return whether it's running or not.
Yep. And then the next one is gonna be the exit code and the thread ID.
So this will be exit code will be integer.
Yep.
Exit code, and the holy crap! How does that happen? That happens to me all the time. I don't understand what I do to make that happen. And thread ID,
Yep.
and that should be.
That's it. So that's our blueprint.
Yep. Now let's just real quick before we continue. Will this include? Well,
We'll just
yeah,
keep-
why not?
All right.
I'm not gonna let this happen, Brian. I'm not gonna let this happen. Never again. All right, can we get this to compile? G++ thread driver -o thread driver exe. D word does not
Oh yeah, so
Windows.h.
That's fine.
So
We're just not there yet.
Okay.
Okay, so let's go to our implementation.
Okay. If not defined, what do we call this? Thread class?
WiBit thread class?
WiBit thread
class. That's fine.
Then
define. And if.
Okay.
Okay. And then right off the bat, we'll just include Windows.h.
Okay.
Include thread.h.
Include Windows.
And then we can test the driver.
Include thread.h. Okay.
And then we can go to the driver and then include thread.cpp.
Do what? I'm sorry.
Just to make sure it compiles, we can go to the driver.
Yeah. Okay, yeah, I got you. I got you.
Yeah. Just to make sure it checks out.
Yep.
It probably will.
Line 12, error delegate. Okay, we didn't bring in the delegate class. No big deal. So
okay,
we
so
go
now in thread CPP.
Yep. We're going to do before this, include / delegate / delegate.cpp. Oh, we got to bring in the properties class too. Nice. Yeah. Very nice. Okay. No biggie.
So that should be property.
And I don't know why, but we made that lowercase.
Yeah.
Whatever.
We can change it right now.
Yeah.
Whatever.
Other code is depending on it, so I'm not going to...
Yeah, fair enough.
Property? Did I spell it wrong?
Or
did we not put property in the directory?
Or do you need to do property before delegate? Maybe that doesn't matter. I don't know.
I don't think delegate used property, but let's try that. Although this does complain about thread.h, so this is not going to work. Maybe we just didn't put it in its own directory. Do we have a property directory? Oh, we have a capital. We do a capital. Man.
I just saw you type it.
I thought that we didn't do it capital.
I didn't think so either. Oh,
whatever. So that means back over here we have to change these to capitals too. Whoopsie daisy.
Maybe we went through and made it consistent and then whatever.
Or maybe just the file name was capital.
Yeah, I don't know.
Hey!
Cool.
Okay.
All
right, Brian. So in the CPP file, if you want to kind of continue on...
Yeah, so we'll just start cracking up the implementation.
All right. Do you want to do the driver? Oh, not the driver. The constructors first?
Yeah, let's just do the constructors.
All right. So now these are going to be templated.
Do you want to just paste everything in there first at once?
Yeah, sure. So we can do those.
Then we'll do the private ones.
Then we'll do the private methods, which are these little fellers here.
And then don't
we have that static.
Yeah, the start routine.
Yeah,
floating out there.
We'll stick. So we'll do one of these jobbies. We'll stick that there.
Put that above it.
Yeah, put that above it. So that way it stays all nice and pretty. Okay, good. Okay. Then we'll go to these guys here.
Actually, the destructors should probably be with the constructors.
You are correct, sir. You are so correct. It's not even funny. So we'll take this little guy, that little feller, and put that little feller up there.
And then,
what's up? Did I miss something?
Properties?
The properties should be set in the init method.
Okay.
Those are just data types. Those aren't...
All right, that's fine.
We're good. Those aren't methods. So,
okay, so let's do... let's actually just get started with init.
All right. And before I get too far along, Brian, I'm going to...
Yeah. I know we want to template this all out. Yeah, that's fine.
I don't think I have to declare that virtual again. We'll see. And that doesn't have to be static. And run... This is the tedious part of C++.
It could be worse, though.
It could be. And that is the beauty of the higher level languages, is if you do generic objects, that stuff is just so built in nowadays that,
That's great.
So what do we got? You said init, right?
Yep, let's start with init.
Okay, so this is going to be that. This will be called, what is it called? Thread.
And then object data type, and then parameter data type.
It is a little bit redundant when you look at this, but I see why, kind of. But anyway, okay.
And then we scope, and then we go from there, and then scope into init.
Like a D's.
Like that. All right. So right off the bat,
okay.
As soon as we run init, we want to set running to be false, because obviously running is not going to be running at this point. We just initialized it.
Right. Running equals false. Okay.
Yep. And then we set the exit code to -1, because
Right, so that means it never exited before, right?
And now we want to set the properties. So the running property will be read only.
Read only.
And then we're going to pass it this, which is the object we're talking about, the class scope we're talking about. Then the reference to the thread, and that's going to be exactly
of this type of thread,
right?
Scope in
to is running,
which we'll define in a bit.
Right. So maybe we should not do that yet.
We've already started.
Okay.
So then we have running, and then what's next?
Exit code.
Exit code is going to be, what is the method? Get exit code.
Get exit code.
Okay. And then we have another property,
which is thread ID.
Thread ID, and this is just get thread ID.
Yep.
Okay, get thread ID. And that's what init does. It just kind of initializes everything on first run.
Okay, so now let's do is running, and we'll just implement that one next.
This one's probably going to be really hard.
Yeah.
Now remember, we're going to have to do a little scope action here, and I'll just do that little thing. Where's is running? Where is
that scopes to the class?
There it is. Okay, is running.
Okay, and is running just returns running.
Oh, okay, that's no big deal. Return running, which is a private field that we are keeping track of.
Now let's do set running.
Okay.
Which is just above it.
Set running. Bool running status. I don't know.
There you go. And then that's just going to say running is equal to running status.
Right.
So we just kind of link those up.
Yep.
So that gives us this running. The next one we want to do is exit code.
Get exit code?
Yep.
All right, let's go ahead. Get exit code. What is that going to do?
So we want to say if it's running.
Oh, this is like actually work. Okay, so
if is running, then we don't have an exit code that's like that. So we just want to return -1.
Okay, because it hasn't exited.
Right.
Nice. Okay.
Okay, so now we're going to call get exit code thread, which is a function that comes with the Windows API.
Mm-hmm.
And we're going to pass it the thread handle, our internal private thread handle.
Okay.
And by reference, the exit code.
Okay. Exit code.
By reference? Yeah, I guess so.
Yep. Because what
it'll affect it.
It's going to actually change this value on return.
Okay, so then we just return typecast as an integer, the exit code.
Okay. Like that.
Yep, just with an underscore because it's the internal one.
Did I just do coke? Exit coke? Holy
Cokey.
crap. All right, underscore exit code.
All right, so that gets exit code. And the last one for our properties is the get thread ID.
All right, let's do that.
Okay.
What is that?
So that just returns.
Yeah.
Typecast as an integer, the thread ID.
Like this?
That's exactly it.
Oh my goodness. I'm gonna do a little action here to save a little bit of space.
All right.
What's next?
Okay, so let's just kind of go up to the top and work our way down. Now that we kind of got those.
So we're coming to the top now, as you had stated before.
Okay.
Okay.
All right. So let's do our default constructor.
All right.
So we just want to scope in there.
Done.
And we just call in it. Now that we've implemented it.
That's it?
That's it.
Nice.
Okay, so now let's do our overloaded one.
Let's do that. So we have two parameters that are coming in.
Right, and that is going to be the thread delegate.
Oh, wait, never mind.
Yep.
That's right.
So, and then that will be, we'll just call it thread delegate.
Right, like this?
Yep. A little space in there when you're done.
All right.
Okay, and all we're basically going to do is say our internal thread delegate.
Okay, so it's going to be, what is it?
Underscore thread delegate is going to be equal to that thread delegate that we come in with the constructor.
Okay.
So it just kind of
makes a copy.
And then we call init.
Are you sure?
Yeah, I'm sure.
You're crazy. Wait, does it ./init? All right, sorry.
Okay, now let's go to init to see what that actually does, just so we can kind of take a look.
Okay.
Yep, so that's it.
Yeah.
It calls it's running, calls get execute, calls thread ID. Now let's implement the destructor.
Okay.
Now the
knowing that the destructor is virtual, so that can be overridden when if you inherit from here.
Right. The destructor is basically going to call dispose. So let's just call dispose, and then we'll go implement dispose really quickly.
Okay, dispose?
Yep. And we'll kind of shoot and ladder down there and implement dispose.
Okay.
Okay, and dispose is going to be using the Windows API, and it's going to be calling just one function out of it.
Okay.
And it's going to be calling close handle. And then we just pass as a parameter our thread handle.
Okay.
And that will take care of closing out that thread,
Mm-hmm.
and we'll dispose the thread.
Right. Yeah. So like the reference counting that's happening on the runtime level,
Mm-hmm.
just the same thing as closing a file,
Yep.
sort of.
Okay, so let's go back to the top.
All right.
And let's move down here. So we got our default constructor.
Yep.
We got our
overload done.
Yep. Okay.
Destructor.
So let's do start routine.
Let's do start routine.
Okay. This
Right.
is the part that gets a little weird.
Well, this is like the meat and bones of it all.
Right.
So we got the D word. We're using WinAPI.
Yep. And we'll call
This
that, what do you want to call that? Pointer value? PV?
I don't care. You tell me.
Pointer value?
PV like that.
Sure. Yeah, that works.
That's common.
Okay. So this gets a little more cryptic looking.
Yeah, which we've seen this sort of.
Yep.
So what are we going to do first, Brian?
We're going to do reinterpret cast. INTERPRET. Reinterpret.
Okay, there we go.
Hey, it's bold.
Nice.
And then that's going to be of type thread pointer, right?
Thread pointer.
And then we're going to pass as a parameter
Okay.
that pointer value.
PV.
Yep.
Well, that's not really passing as a parameter. We're forcing the cast.
Oh, right.
Yeah.
I gotcha.
And then once we force the pointer to cast the change to what we want, we access inside of that pointer
The set running method.
set running method.
And we set it to true.
True.
Right. So we're kind of using the Windows API to access that thread and then access the system that is making a reference to that thread. Is that a way to explain it?
Sure.
Whatever.
So
now we just run it.
the first thing that we want to do is we're going to lock it basically by saying it is running, right?
Yeah.
Set
And then
running
it's
method.
done running.
It's not set running method. It's set running.
Right.
You said set running method.
Oh, I'm sorry.
No, it's not your fault. I actually typed verbatim what
Yeah.
you said, and I really shouldn't have
That's
done
funny.
that. So in between these
We'll just
two
run it.
actions, so set running, run. Once it stops running, false, not running.
Yep.
Okay. Awesome.
And then we return 0.
What? Why do we want to do that?
Okay. Now the next thing we want to implement is whatever we haven't implemented next.
All right, let's go. Let me copy this little guy. All right, next we got init, which is done. Run, which is not done. But I think run is easy, right?
Yeah.
Okay, what does run do?
We just call the thread delegate, and we surround it in parentheses so that we're kind of like the evaluation of, and then we pass a parameter.
And that's going to be the param that we
Right.
set.
Yep, our internal parameter.
Okay. Is that it?
And that's it.
Holy
so we're
monkey.
really just we're evaluating that thread delegate, basically. Okay, what's next? So we got set running.
So if you guys are kind of watching this from a high level, like up here, whereas this little fella is calling this little fella, which is calling this little fella, which is calling the method that you've locked into that
Right.
encapsulated thread delegate or
Yep.
delegate. Okay.
So we got run.
We
That's
got run.
good. We got set running. We got is running.
Okay. We have get execode.
Yep.
We have get thread. We have connect to delegate.
All right, and now we need start.
Start.
Actually, connect to delegate, and that's the next one. Sorry, I didn't notice that was. I almost skipped right over that.
And connect to delegate, we're just going to be doing what, Brian?
So this takes in a parameter, a delegate, and we'll call that thread delegate.
Okay.
And then all that does really is just we set our internal thread delegate to be equal to that thread delegate.
So underscore thread delegate equals thread delegate.
That's it. That's all we do to connect it up.
Not too bad.
Okay, now we're on to start.
Start. What is start going to do, Brian?
It's going to start it.
How did you figure that one out?
I just blew your mind, didn't I?
You blew something. Now, what is this param data type? What are we going to call that?
Param.
Param. That sounds generic. I like it.
Okay, so now our internal parameter is going to be stored as that because we like to store that internally for the other things that use it.
Right. So that equals
param.
That.
Yep.
Right.
So we're just kind of internalizing that, not in an emotional way, just internalizing it. And then our thread handle is now going to be equal to. And here's where it gets interesting.
Thread handle equals.
We're going to call the WinAPI again, and we're going to call create thread.
Like that?
Yep. And we're going to pass it null. And you can look up the WinAPI.
Yeah, we've already went over this before as well.
So we're going to call null. 0.
Right.
Start routine.
Right.
And then this. 0.
Like that.
Yep.
Okay.
And also a reference to the thread ID. Underscore thread ID, the internal one.
Like that.
Yep, that's it.
All right.
Okay, so now that establishes our thread handle, and that one's often created, and while our thread handle is pointing to that, that is where it is. We want to sleep for like 10 milliseconds.
Okay. And that just gives our application a moment to get started.
Yep.
If you don't do this, see, here's the thing. Computers are so fast nowadays, right? That if you don't allow this little sleep to happen, we could fall into a situation where this executes so fast that the computer doesn't have an opportunity to recognize the thread is there, and it will just end the program.
Okay, so now we just return typecast as an unsigned integer now. Our thread ID.
Okay.
Our internal thread ID.
Like that.
Yep. That's it.
That's it?
That kicks it off.
Nice. We got
that
down
may
here.
Be the end of it.
Dispose. Is that it?
Cool. Hey.
All right, let's see if we can get a little compile action here.
Nice.
What the hell?
That's awesome.
No way.
Okay, so now let's go to
let's do our object-oriented design setup here real quick. Now, those of you guys that have been following along know how simple this is, so we're just going to simplify it by
yep, that's all it is. It's always the same.
And now when we get into our main class.cpp, that's where it kind of gets a little hairy, like Brian's face.
So let's kind of our thread driver is going to get a little different. So actually, let's just get that thing.
And we've already kind of gone over this before,
this object-oriented call of main.
Yeah, so we've explained this.
Right.
So you should know what this is.
So that just kind of ties those together.
Yep, and we create the arguments, we create the instance, we delete the instance, and we're actually working in this level here.
So we're going to want to include IOStream, because we love that library.
We do, it's awesome. Include IOStream.
Yep.
Okay.
And we'll use namespace standard, like we always do.
Namespace std, because Brian, never mind.
And now we're going to include property, delegate, and then thread.
All right, so // property property.cpp.
Yep, and then delegate.
Delegate. Sorry. Yep. So delegate, right?
Yep, and then just thread, which is in where we are. So.
Okay, thread.h.
CPP.
CPP, of course.
All right, and then now we're going to include our main class header.
Right. Nice.
So that links everything back together. Now, in the driver we had set up before, we made those includes in the same way. Now we're just kind of moving those over to our main class implementation. to kind of make this object oriented.
Yeah, and as you can see here, we're also going to be building a method here called thread delegate.
Right.
And we're going to be doing that over in the main class, that's file. But I guess first we have to define the main class, don't we?
So let's, it's going to be void, the main class, and then we scope into main.
Okay.
And then in argc and argv,
Yep.
or args plural, doesn't matter.
Well, it's no longer argv. We're going to do it hardcore style.
Okay.
We're doing
Args.
Java style. Okay.
Okay. And then, so that's that. And then we also want to make a, the thread, we want to implement that thread delegate method.
All right, and that should be pretty simple, right?
Yeah. So we'll just scope in.
What do you want to call this string?
str.
All right.
And let's just like sleep for like 2 seconds. So it'll be 2,000 milliseconds.
Yep. So, or 2 times 1,000 for those of you that want to be more
cool about
crazy.
it.
Yeah.
And then we'll just output the string that we pass in.
Like that?
Yep.
Not too bad. Now
Okay.
let's see where we are at this point. In the thread driver, which we've modified, we should be able to run that. And cool, not so bad. And then we do thread driver.exe. So far, so good, ladies
Cool.
and gents.
All right.
So let's go back here and let's continue on.
So let's test this thing out.
All right, we want to create an instance of delegate, right?
Yeah. So let's make my delegate.
Okay. Delegate.
And it'll be main class, obviously.
It's sitting inside of an instance of main class. It's going to be returning a void, and the input parameter is going to be a string called myDelegate.
Yep.
Which we've used this before. What
And then,
now?
so now we want to set the delegate instance. So myDelegate, set delegate instance. And we're going to set it to this.
Right.
Because that's where it's residing.
And in the thread driver, we create an instance of main class, right? So there's this. Okay.
Okay. And then we want to set the delegate method.
All right. So set delegate method
to be a reference of.
It's
the thread delegate, but we have to scope in.
Right.
So main class thread delegate.
Main class thread delegate. Okay.
Yep. Okay. So now that just set up your delegate.
Right.
So now we'll make a thread object.
We'll do that. So far, no crash.
Right. So now we'll set up a thread class.
Okay.
Thread object, and it's the main class in the string type.
Right. So this is the class that it resides within, which is the main class, and the parameter, which is going to be a string.
And then we'll call it my thread.
Okay.
And then we pass in my delegate as a parameter.
Or we can just call the constructor like this.
Right.
Right. So this is just calling the constructor.
The overloaded constructor on my thread.
Which is this little fella right here. We're just passing in the delegate. Of course, we could have called connect the delegate just as easily, but we're not because we're cool. All right. Do we have a functional? Yes, we do.
Cool. Should we just start the thread?
Sure.
All right.
Starting the thread, Brian.
Okay, so we just want to say that my thread started.
Whoa.
But the thing is because it's a thread, our program will just end and that thread will just kind of finish. So we don't actually want to do that necessarily. We want to continue running our program until that thread has been completed.
What do I got here? No start? What do we call? I thought we had a start method. My thread dot start.
I think you need to pass it a parameter.
Oh.
You need to pass it the string.
Okay, what are we passing it? Test string.
WiBit is awesome. I don't know.
That's even better. Shameful plug.
WiBit.net is awesome.
Now, what Brian was just saying, check this out. All right, let's not be stupid. Okay, Brian was saying, all right, we compile and we run this. Watch what happens. It just ends. Right. That thread actually did execute, but the program ended so quickly.
Yeah, it was like, hey, that's nice. See you. Bye. I gotta go.
So how do we prevent that from happening?
So we just want to say while my thread running.
Okay.
And then just leave like an open. We don't have to do anything. Just while it's running.
That's the
property. But like but now that we've implemented those properties, you have to admit that's kind of cool because it's not like running pren. It doesn't save you much, but it does kind of like it's clean. It's nice.
Oh yeah, very nice. So now we should be. So look at that. It's waiting. Boom!
Nice. That's awesome.
Very, very, very cool. So we have successfully encapsulated inside of a thread our own delegate using all of our own classes that we've made ourselves from scratch.
It's pretty cool.
This is awesome.
It is.
This is really, really cool.
Yeah.
Welcome back to the WiBit.net C++ lab video series. What we're going to be doing in this is very, very exciting. So, you know how we've written the delegate class, Brian, right? We've also written something crazy like a thread class, right?
Oh, yeah.
So now we're going to kind of take advantage of that to create a class that will do a timed event.
Why wouldn't we?
Which is very functional. I mean, think about how many times, you want to write a piece of software that maybe every 20 seconds do this.
Right.
Or every 15 seconds do this.
That makes sense.
Or every 20 seconds do this, every 15 seconds do this, and if this goes off like this, then every 20 seconds do this. I mean, there's a lot of timed events in software
There's a lot of
development.
doing this you can do.
Yes, precisely. So what we're going to do is write code that will allow you to do something awesome just like that.
Okay, so our objective is to write a timer.
Yes, timer.
This is going to be
we're not competing with time.h here.
Marty, what is the time?
Now, some of you guys may kind of argue with how we did this, but, we're going to be using pointers, but you guys, if you want to rewrite this using references, you can. It may be a little better that way, but we're going to use pointers just because we're awesome.
All right.
So, Brian, what are we going to do first with the timer class?
Okay, we want to declare a class, and this is going to be a generic class.
Yes. Yes.
So our class data type, we'll just call, we just call it DT.
Yeah, why not?
And then our class will be the timer class. Pretty straightforward, yeah?
Yep, we're done, right?
Yep. Okay, so as you know, we have privates and we have publics.
Right, so we're going to basically set a few fields. The first one's going to be enabled, which will be Boolean. Now, this is just one thing that we're going to be able to set and check this value, to either make the timer enabled or make it not enabled.
Cool.
Next one we'll do is an unsigned long, which will be the interval. So we'll call that underscore interval.
Makes sense.
Now, that's just the reason why it's unsigned is because you can't have negative timed events.
Or can you?
Well, not in this universe.
What get you? Or can you?
So this one, which is what we're going to use a pointer for, and again, if you want to use a reference, feel free to do so. We're going to make a delegate. So as you can see, we're probably going to be pulling in our delegate class in a moment. And this one's going to be pulling in the data type, and it's going to be returning a void, and the parameter is going to be a timer pointer.
Cool.
And we'll just call this underscore timed delegate.
Nice.
Very nice.
I like.
So now let's make a hidden thread.
Okay.
And this is going to be of timer, so we'll just call this timer. And it's also going to be accepting a timer pointer.
Nice.
And we'll just call that underscore timer thread.
Timer thread.
Very nice.
Now
we're also going to have a few other. We're going to define some methods.
Oh
here.
yeah.
So we're going to do a void run.
All right. So these are private.
Yes. And this will be taking in the timer with the data type as it passes the parameter.
Sweet.
And that's coming in as a pointer.
Nice.
Now we'll do a void init, which will just kind of be what runs when the constructor runs, which we've been using that in some of these examples to set up the properties.
This is old hat for you guys. Old hat.
And we're also going to be setting a void that's set enabled, which is a private setter method. You can already see that we're already starting to set up a properties, maybe? I don't know.
Oh, yeah.
We'll see. And the next one will be another one that will be set interval.
Set interval.
Very nice. And this will be taking an unsigned long.
That's what she said.
And then next we're going to be doing an unsigned long get interval. So we're defining private setters and getters.
Interesting.
Brian. This is craziness. Craziness.
All right. And then we also want to get the whether it's enabled and running.
Yeah. Well, yes, if it's running, which will be coming from the I think the delegate or the thread. I forget which one. We'll find out in a moment whether it's enabled.
All right. So that's our internal private methods.
Right. So now we want to be able to create an instance, Brian.
So we want our default constructor. We want our not default constructor that takes in Delegate.
Yep, a delegate with a few parameters. It's going to be DT.
The data type.
It's going to return void and take in a timer pointer, which is, as you can see up there, where the delegate is defined previously.
Don't you mean up there?
Up there. And yes, very nice, very nice.
Okay.
And how about a method for setting a delegate?
So
let's just
that makes
say
sense.
you call the default constructor, or you want to change the delegate that you're using. Why not? Makes sense.
Oh yeah. So that's our template data type,
Mm-hmm.
our void,
Which is the return data type,
and then our timer.
the
points.
parameter data type.
Right. Okay.
So as you guys can see, the timer, the delegate is going to be accepting as a parameter the timer pointer itself. So you can do stuff like, if this happens, disable timer, because you will be pointing to that memory address.
Right.
It's pretty cool.
Now we got some property.
Capital P. Yes. Yes.
A lot of these are going to be. Let's see. We got. I don't know. Let's make quattro of them.
Right. So the first template parameter is going to be the class that it's inside, and it's not a timer class. It is a timer. Timer. Never mind. Doesn't that look weird written down? No, stop it. Look at it. That looks so wrong.
It's like Timir.
Wow. I didn't realize it looked that weird.
Timir.
Anyways, I'm sorry.
We're huffing nitrous oxide.
My brain is broken.
Okay. So let's see. The first property, whether or not it's enabled.
All right. That's going to be
the Boolean.
deal.
Enabled. We'll just call it that.
Cool.
Sweet. Done deal.
What's the next one, Brian?
The next one? I don't know. You tell me.
Interval?
Okay.
Unsigned long?
That's what she said.
Oh, yeah.
Interval. Okay.
In her dreams. Next one will be running.
Okay.
And the last one is going to be timed event, which will be taking.
Interesting.
Now this is going to be an interesting thing. We haven't done this yet. We're going to be passing inside of the template parameter a template parameter.
Nice.
So to prevent a conflict. Now watch this, Brian. Don't just do another greater than sign. Don't do a space. Go back. What does that look like to you?
Oh, weird.
So we can't have that because C++ will interpret that as a stream operator.
Yeah.
So we have to have a space there
That's
so that
hilarious.
it's properly interpreted.
That's hilarious.
Yes, yes. And that'll be the timed event.
And that's a very good the more you knows.
Mm-hmm. The more you know. So now, Brian, as you have so gloriously written this wonderful header file,
Oh, yeah.
let me find all of your f***ups real quick,
Okay.
because I know that if Brian touches it, it's got to be broken.
Yeah.
Just kidding, Brian.
I'm flawless.
So we'll do timerdriver.cpp, and we'll just kind of do a little include. Ooh, let me a little.
It's just a tiny include.
That's what she's. Ooh. IO stream.
Wait, is that at the joke or?
No, that was at your joke. That was your little tiny stream. Brian has a tiny stream. At least that's what the girls in college said. I don't know.
It's like spaghetti thing.
I can't spell return either.
It's tough, isn't it?
It's funny when you're trying to type it fast. It's
like,
really hard.
It's like
All right, so this will be another include.
Yep. Timer.h.
Yep. Timer.h. So this is our little timer class. Now let's see if we can get a little.
Oh, actually, we need some other
Like what?
like property delegate and thread.
Oh yeah, that's a good point.
Yeah.
Otherwise, this
That's
is going
why
to break.
I said it.
All right, so I got you. So if we do a little
Yeah.
CPP action,
Yeah.
we can just do a little save as to timer.cpp.
Okie dokie.
If not defined, then what is this? WiBit
Timer class.
timer class. Then define.
It's like a flower.
And if. Okay, so you said there were some includes, right?
Yep.
All right, so what are we doing here? Include what?
Property.
So this is going to be ..
Property.
property slash
Property.
property.cpp. Right. Next.
And then delegate. ..
delegate /
And you guys should have all
Delegate.
these at this point.
Yes, hopefully. And what else we got?
Then the thread delegate.
Okay.
Include .. thread delegate, capital T and D.
thread/thread.cpp.
Cool.
Is that it?
Yeah.
And then below that, include timer.h.
Perfect.
Right?
Look at that.
So now we should be able to test to see if this thing will compile.
Yeah.
Desktop.
Hopefully it does.
C++ awesomeness. Timer G++ timer driver -o timer driver .exe.
Cool.
All right.
Look at that.
All right.
That's because I'm awesome.
You are awesome, Brian. Now, what are we going to do? There's also probably a few things that we're going to want to leverage.
Like time.
Some things like time.h. So let's go include time.h, which comes with the compiler.
Yeah.
Now, we have to do a bunch of stuff like
Okay,
template and
so
stuff.
all right. Do you want to grab the methods from here?
Yeah, let's do the, since a lot of these are kind of dependent on one another. Let's you know what, screw it. We'll just grab all these and we'll just write them
Right now. Right here.
We'll grab
Right
these
now.
are methods here as well.
Yep.
All right.
A private.
Yeah.
Cool.
Yeah. Yes. Okay, so we also have a constructor here. What does the...
You can just drop that in all of them real quick.
Okay, we can do that.
Should we just get our scoping out of the way?
Yeah. You want to tell us a funny story while we do this, Brian?
A man walks into the bar.
Yeah.
And he says, "Hey, can I have a shot of whiskey?"
Mm-hmm. You know what? Your time is up.
Yeah.
Anyways,
I
the
don't know.
default constructor. Now, we're going to have to be templating these as well. So we're going to be doing the template, and the template, I think, is class DT, right?
Yep.
So let me just go ahead and stick these on here as well. That's what she said. I really hope that
It's like Speed Racer copy and paster.
Yeah. All right.
They invent a faster copy and paste.
All right. So now we have the
They
templates.
invent a keyboard that automatically pastes when you copy. That doesn't even make any sense.
Yeah, that's probably the worst idea I've ever heard in my life.
Okay, default constructor.
Now, the problem with defining the default constructor is that it depends on the init method.
All right, well, let's go to init.
So, is there anything in init? I think init should be fine, right?
Yep.
All right. So let's build the init method.
Okay, so on init, we want to set the properties first.
Okay, so we do
The
that
first
by
one is enabled. It's going to be read-write.
enabled, which is read-write. Okay.
And then we're coming from this instance.
Okay, so that's going to be this.
And then timer set enabled is the
Writes.
it's the method we're looking for.
Set enabled.
Yep.
Okay.
And then timer get enabled for the writing.
Okay.
I mean, for the reading. So then we want to do reference to timer get enabled.
Okay.
So that's the read and the write.
Like that?
Yep.
Except for duh.
Perfect.
Okay.
Flawless.
And then the next
All right,
one's
so
going
this
to be...
one's going to be interval.
Same thing? Read-write?
Yep. Set interval, get interval.
Okay. Set interval and then get interval. We're setting and getting.
Cool.
All right.
All right, and then the next one is running.
Okay.
That returns whether or not we're running. Hence the name running.
Running is going to be just the getter, right?
Yeah,
So
it's just read. Yep, read only.
Read
Only.
only.
That'll
Because we're not going to be setting that. It's just going to be... What is
that'd
it?
be ridiculous.
What is that going to be?
It's going to be get.
Yeah.
No, I'm sorry. That's is running.
Is running. Like that.
Oh, yeah.
Okay.
Okay, and then the last one is the timed event. Remember that freaky deaky one?
Is that read only as well?
That's write only.
Write only.
Right.
Very cool. Write only, and that's going to be what? Set.
Set delegate.
Which we have not defined yet.
No.
It's going to be down here, but we haven't defined the set. These setters and getters as well. So
we've already
get over. Get over
and
yourself.
instead of running, it's going to be called timed event.
Okay. Oh yeah, good call. Like that.
And then okay, so because it's in it, it's not enabled yet. We want to set enabled to false.
There you go.
Right off the bat. Done and done. Wait.
Enabled equals false.
Okay, not so done and done. Now we're done and done. Okay. So now we want to run the delegate.
We're going to create the instance. Create a delegate instance.
Right. So to do that, we create the instance.
So we're going to make an instance of delegate.
Yep.
And then the first template parameter is going to be the class that we're inside. Second one's going to be what it's going to return. And then the last one's going to be the parameter, right? Which will be a timer pointer, which is the way we're doing it.
And we'll call that
run delegate.
Cool.
Run delegate.
Okay.
Run.
So now we want to set the delegate instance, and then we want to set the delegate method.
Okay.
So first, the instance.
All right. So set delegate instance,
Which of course
is going to be
our current instance.
Yes. Nice.
And then we want to set the delegate method.
We can do that.
And we haven't implemented the method this is actually going to be setting.
Mm-hmm.
It's run.
Right, which we'll do in a moment.
So
and run's got to be scoped in.
So reference and then scope in.
Okay.
Cool. Okay, and then the last piece here is so when we said, can we do this one first? Not so much, but it's okay. So then the last thing is we're going to call on the timer thread.
Mm-hmm.
We're going to call our internal timer thread. We're going to connect to the delegate.
Right.
This run delegate we've now built.
So this variable here.
Yep.
We're going to timer thread dot connect to delegate, and that's going to be what? Run delegate.
Run delegate.
Run. See, I really want to do a Forrest Gump joke here. Run delegate. Run. Jedi. You know what? That's one of the best movies of all time.
It is.
I love that
good.
movie, and I love how you did the parody for the intro to computer programming for that. That's
good.
That's amazing. Brian, the graphic artist, ladies and gentlemen.
Life is like a box of programming.
What?
I don't know.
So it's like a box of programming.
Whatever.
So now, as you guys can tell,
It's my brain. I'll do what I want.
as we've written the init method, we've also noticed that there are some methods here that this is dependent on.
Oh yeah, we need to.
Let's just go ahead and define those. So
Yeah,
let's start
let's
with the set enabled, which I just noticed a syntax error, Brian.
Oh.
Yes. Look at this. Look at this. Look at this.
Oh, screw.
Didn't we make this mistake once before?
Yeah, we always make this mistake.
Yeah, this is
It's
kind of
an easy one to make.
Yeah, very easy. Even for wonderful professionals like us. Yes, the greatest programmers in the galaxy.
And sometimes that's why it's good for you to see, like, not flawless programming, but realistic programming. You know, that's really what we want to show you.
Yeah, because you're going to be sitting at your cubicle writing an application.
And you're going to be like, I'm the stupidest person. Like, I'm not cut out for this.
But you are.
Yeah,
you are fine. Amazing. So set enabled, Brian. Let's do this. So this is going to be taking in a bool. What do you want to call the parameter?
Enabled?
Enabled? I can do that.
All right.
Now, what kind of a crazy, wacky thing are we going to be doing here?
Okay. If we are enabled...
Right. So it's been previously enabled, right?
So if our internal enabled is set to true, so if our internal enabled equals the parameter enabled, we should just return and be done with it, because there's nothing to change.
Right. Okay. So if that equals the backend value, which is this, right?
So if they're both enabled, we don't really need to enable it again.
Right.
They're both enabled. So we just return. Just kick out of here.
Then we have another condition, Brian. And what is that condition?
If we're enabled internally, but we're saying that we don't want to be enabled...
Well, wrong. It's the opposite. If we're saying we don't want to be enabled...
That's exactly what I said.
I thought you said if we're not enabled.
If we're enabled internally...
Oh, sorry.
And we're asking to not be enabled.
Okay. Sorry.
Whatever.
Jackass. All right.
Then we want to basically become not enabled.
So we're going to set...
We're going to set our internal enabled...
Right.
To be equal to... Which is going to be false.
Right.
But we'll just pass it in as the parameter we get in.
Right.
And then we want to say, while we're running, we want to just kind of like finish up our business, you know?
Okay, so then we'll do, and you'll see how this works, because we have a variable in the here called enabled, and we're gonna in the run method is gonna be consistently looking at this to see if we're running. So once it finishes,
should we be running?
Iteration,
should we be running? Should we be running?
Right. So this is gonna set the value and wait to see while it is running. We're just gonna hang out for a second.
Right.
So this will be the underscore timer
because
thread.
when we set enabled to be false, it might take.
Yeah, it'll
take longer than jumping to the next line of code to.
Right. Yeah. So we want to give it time to slow down. So while that running is true, which is that property that we set, then we're just going to sleep
For 10 milliseconds.
Yeah, and the reason
Very
why we're
fast.
going to do that is because if we keep this as an infinite loop and we don't add a sleep,
They might block it out.
you'll start to see that the CPU and the CPU usage will start to go up because we're actually iterating through a loop really, really, really
Right.
fast with no controls.
Right.
So this is just to try. 10 milliseconds is in human times. It's pretty quick. And then once we've gotten to a situation where we're not running,
Yep, and we'll just
Done.
kick out of here.
right?
Okay, so now we want to, so in the other remaining condition, we still want to set enabled, our internal enabled to be the parameter that we pass in.
All right. So we're going to be doing this. Okay.
Yep. And then, because we return, we don't really have to say an else.
Right.
And then, in this condition, we just say our timer thread and we just kick it off. We start it.
Dot start
Right.
this.
Because that would mean that we are wanting to be enabled in this case.
Okay. And the timer thread, as you recall, is a thread instance, which we've already written. So there we go.
Cool.
So we're just going to basically be popping off a thread.
Alright, do you want to do set interval next?
What's another? Is set interval yes. Set interval.
all right.
That's another one of the setters that is dependent on. Okay, so set interval, and what do you want to call the parameter? Interval?
Yeah, let's call it interval. That works.
All right, what is this going to be?
Okay, so this is, all we're going to do is our internal interval is going to be equal to...
Like that?
Yep, that's it. We're
All
done.
right.
Moving on.
Difficult.
All right, let's do get interval. Get interval. It's just going to return our internal interval,
Okay, cool.
as you would imagine.
Right, so just to save some lines, we'll just do one of these jobbies. Return interval.
Definitely better at typing return than I am.
I certainly am, although my first few attempts were not so good, but
True.
whatever. Is running.
Okay, that's just going to return the timer thread, our
Okay.
internal timer thread,
Right, and the internal timer thread is going to be
underscore timer thread.
this guy here.
Yep. And then it's running property.
Right. We're actually piggybacking on the thread class in our own class. Not too shabby.
Okay, and then get enabled.
Okay, get enabled is going to be crazy, right?
Yeah, that's going to return whether or not we're enabled.
Enabled? Like that.
There we go.
Okay.
Cool. All right.
So what other methods are left?
We got like run. We got a couple of them.
We got a couple?
Yep.
All right.
All right.
After these messages.
We'll be right back.
What do we got, Brian?
Okay. So now let's implement run, because that's kind of a. Actually,
right.
let's sweep from the top again.
All right, so back to timer.
Yeah.
The timer
Yeah.
default param.
Yeah. Okay. So now we kind of go back to where we started, and we were like, oh, we need a init.
Right.
So now we can implement init. All right, we're done.
Cool. Yes.
Okay, so now the timer with the parameter that gets passed in.
Right.
So that parameter that gets passed in, let's call it like delegate.
Okay.
That's what it is.
Delegate.
Yep. And the difference between this and the default constructor is just the fact that we're going to set the delegate and then initialize it.
Right. So we got this time delegate here.
Yep.
So that is going to equal a copy of this, right?
You are incorrect.
No.
We already made a function to do this, so
Okay.
we just haven't implemented it yet.
Oh, okay.
So we'll just call it set delegate, and we'll pass it in the delegate.
So set delegate passing this, which, like Brian mentioned, we have not written yet.
And then we'll just call init.
Okay.
And now we'll implement set delegate.
So as you guys can see, we're using a init kind of like every constructor has to do these functions. So anything that's like outside of the ordinary, do it here, and then do a follow-up
Right.
sweep of everything
Right.
that's consistent here.
Yep, and set all the properties and everything.
You said there was a set
It's at the top. Yep, the next one.
delegate. Yeah.
Okay, so
Yeah.
then the set delegate is going to take in, obviously, the delegate as a parameter.
Right, okay.
And this is the one where we set our internal time delegate to be the delegate, like you
All
were
right.
doing a second ago.
So
no,
this-
the time.
Oh,
Yeah.
time
You
delegate
got it.
is going to equal the delegate.
That's it. That's all it does. We're just
Making a
setting that
copy.
delegate. We're just
Making-
making that connection
Making copies.
without copying properly.
Making copies. Making copies. All right, what's next?
All right. So what do we have left?
I don't know. You're the one that's in charge
I
of
don't
this
know. Oh,
whole thing.
run. We got
Run.
run. I think that's the last one.
Yeah, run, timer, run. All right, so what do you want to call the pointer timer, Brian?
How about T,
I can do that.
like iced tea or Mr. T?
Or T-Bone,
Yeah.
for those of you guys that watch Seinfeld. Okay.
Yeah, I didn't get that one.
That was what George wanted his nickname to be, T-Bone. But somebody else got T-bone and he didn't. Anyways, we were talking run. Now this is the actual meat and potatoes of the whole thing.
Yeah.
This is going to be kind of keeping an eye on the intervals, and once an interval has passed, we're going to call the delegate, and then once that delegate has then finished executing, we're going to fall back into the loop that is counting. So let's talk, Brian.
All right. So the first thing we want to know is, what was our last runtime?
Okay. And we're going to be measuring this in, I don't know, milliseconds, because we want to make it so that you can pass milliseconds instead of whole seconds.
Oh yeah, it's more precise.
Yeah, okay. So what do we got?
So we want to clock. Yeah, exactly. We want to clock
that comes
T.
from time.h.
Yep, and that's
Last run time.
Yep. And
So
that then equals
what is that going to equal, Brian?
the default clock constructor.
Okay. Which we went over before in the C video.
Oh yeah, you should know this. You know this, girl.
Clock,
you know this.
Clock function, which is
Okay,
going to be setting that.
so long as we're enabled.
Right. So while we are enabled.
Yep. We're going to do the following.
Now hold on. Before you continue, Brian.
Okay.
Let's go to the set enabled. So when this set's enabled to false,
Yes.
you see how this little
Will
fella
no longer be running.
is monitoring that. So once
Yep.
this iteration is complete and that's false,
It'll kick.
done.
Yep.
Anyways, let's go.
Okay, so while
Okay.
the clock's value subtracted from the last runtime.
So while the current time in milliseconds
Yes.
minus
When we started before we entered into this while loop.
precisely.
So long as that is less than the interval,
Okay.
we're basically safe to keep running.
Okay.
And that's how the interval's going to dictate the range to be able to tell this to stop kicking.
Right. So this is just going to be basically hanging and just counting.
So if we're not enabled, we want to just kick.
Right.
You know,
So
it's kind of another faster fail-safe to
right.
jerk out instead of waiting to the next interval.
Yeah. So if we have, let's say, a time interval where every 45 minutes do this.
Right.
Well, I don't want to wait 45 minutes to know that I'm over.
Oh yeah, we just want to.
So this is while it's waiting, it will say, oh, in between this 45-minute interval and this one, someone requested a stop. So we're gonna get out of here. Get out of here.
And then we'll just like sleep for 50 because this is kind of the same case as before. We don't want to just be sitting there like churning, as fast as we can,
chunking CPU for no reason at all.
Exactly.
So now, Brian, once we get to this code right here, the condition has occurred where it has not been disabled and the time interval has tripped.
Yes.
What do we do?
Well, so we basically want to reset the last runtime.
Okay. Mm-hmm.
And then we want to call the times delegate.
Right. And I'm going to put this above here. This should be more accurate. So this will be the times delegate. And we're going to be passing it to T, which is a pointer.
Yes.
And now remember, this is the delegate. Remember we wrote this where we overloaded this. So then this is going to execute the delegate, and then we're going to reset the clock once we're done.
Yep. Okay, I think that's it for our implementation.
All right, let's see if we can get a compilation
All right. Okay.
So now let's execute this and see that we don't have any errors. Nice. And let's just real quick.
Flawless victory.
To prevent us from having to make multiple classes, Brian, which we can do to drive this program, let's do a little object-oriented design model so we can create the main class and work within the confines of that.
Okay.
So those of you guys that remember how we do all this, and I'm just gonna...
How we do it.
This is how we do it. Let's do a main class.
That was so bad. It was like, it's like, oh.
Now I'm going to spare some of your time and just throw some code in here. So we're going to have a class called main class. And in our private members, we're going to have a void, which is, we're going to call this on timed event. And this is going to be our timer. When our timer kicks, it will run this on whatever interval that we set. And this will be accepting a pointer to the timer instance. And this instance is inside of main class. Now, like I said before, if you guys want to be, change things around, make this a reference pointer, make it more C++y and less CE, fine, have fun. We're also going to be defining a private member called count, which we'll be using, and of course, our main method.
Nice.
So we'll save this little
Pretty
fella.
Self-explanatory.
Yeah. We're going to build the class that will kind of facilitate all of our code. And before we do that, inside of the timer driver.cpp, I'm just going to kind of inject some code here. And the reason why I'm not going to explain this is because we've done this 100 times already.
1,000 times already.
Including main.cpp.
Yeah.
We're going to be doing the conversion of arguments, make an instance of main class, run the main method, sending it the argument count, the string list, and then deleting the instance. So
all in the name of being able to. I think we already have a timer driver.
Yeah, no, but we need to do a main class.cpp.
Isn't that what we just...
Nope, that was the timer driver.cpp that we just did. Now we want to do the main class.cpp.
I'm having deja vu.
So we'll just kind of include
IO
stream.
That'd be cool.
And then, I don't know, include, although I don't know if we really need to do this, but I'm going to do it anyway. stdio.h. Actually, yes, I am going to be using this because I'm going to be doing some stuff that's crazy. Using namespace, not napspace. Although
Napster space.
Napspace sounds pretty good right now.
Nappy space.
Using namespace std, and then we'll do a little include timer.cpp, and then lastly we'll do a little include action for
on our
main class.h. And the reason why we included timer before main class is because we're using that timer class as a parameter.
All right, so this is all in the sake of being able to say void main class main.
Mm-hmm.
So now we have our object-oriented main method.
Exactly.
Instead of our program's main function.
Argument count, string args, doing it Java style, or doggy style, or Wu-Tang style, whatever. And then down here we got the void main class, and then this is going to be that on-timed event.
Oh yeah, on-timed event.
And this will be taking in a timer instance from the main class. That's the class that it's going to be inside of.
Now
it's going to be a pointer, and the name is going to be T.
Now seeing delegates used in like different ways is extremely important before we get into Objective-C.
Yeah, well, and even C++.
Objective-C and C++ too, absolutely.
Yeah.
But once you go into Objective-C, and C# for that matter, Java or the rest of them, this becomes very commonplace very quickly.
Mm-hmm.
And if you're not very comfortable with it, if you don't really have this picture in your mind solidified, everything can start to look very backwards and upside down to you.
Yeah.
So if that happens, just kind of come back to this point and just really focus on like delegates, focus on these labs, and just focus on like keep doing exercises that implements delegates in like a more simple, simplistic, boiled down form.
Right.
To really get that drilled in, you know?
Absolutely. And Brian made some very, very good points. Now to just kind of roll through this, Brian, how would we
instantiate our timer class?
Yes. So the first thing that we'll do, Brian, is make a delegate instance, right? Now this is going to be the delegate that we want to execute when our time event has lapsed, right?
Right.
So we're going to be calling our delegate class, which was already included here in timer.cpp, as you guys recall.
Yep.
And we had that protection, the if defined, if not defined.
This is like remember previously on the first Prince of Bel-Air?
Yeah, right.
When we included our delegate class.
So to kind of demonstrate, that if defined, not defined, if I were to just include this baby right here, that would not cause
any
a problem.
Yep.
So I'm gonna remove that, but it's just to kind of demonstrate the if defined, if not defined.
Okay, so we're in the instance that the method we're looking at is in the main class.
Right.
We're returning void.
Right.
And the parameter we're passing is going to be a timer.
Right. And the timer is also templated.
Yes.
So the timer requires the class that it's going to be within,
which is the main class.
Which is main class.
And that's going to be a pointer.
Right. And remember here, we're gonna put spaces around these since we're kind of what I typically
we're treading lightly.
What I typically do, and I don't know, Brian does this. He may or may not. Whenever I do a template parameter inside of a template parameter, I always put spaces in between these two.
I don't always.
Whether you need to or not. It's just kind of a convention that I find simpler. Because, like, if we weren't...
It's easier to read, too.
If we weren't passing this again, we would have a conflict.
Right.
This would be interpreted as an operator, and it's not an operator. So, we can just call this my delegate, or timed delegate.
Yeah, that'd be good.
And the timed delegate, we can call the constructor. Now, again, we've gone over multiple ways that we can call the constructor.
Right.
But in this case, we're just going to put the two parentheses like this. So the timed delegate, the delegate instance is this.
Yes.
And the delegate method is going to be inside the main class.
Yes. We're going to refer to.
Right, and that method's going to be called?
On-timed event. So that's connecting that on-timed event that we have in our main class and wiring that back up into the delegate.
Right. So now we've taken this method here, and we've encapsulated it in this here.
Exactly.
Now let's make sure that before we get on our high horse here,
that's a perfectly precise way to describe that.
So now that I've taken this and put it in a little box,
I can do what I want with it.
I can send it anywhere I want.
Oh, yeah.
Anybody can use it.
Yep. And we can use that on-timed event to do whatever we want to do with it.
And that's precise. You know, Brian, I like your foreshadowing. That's precisely what we're going to do. Now that we've created the instance of the delegate, as we so gloriously described,
now we want to
create
an instance of our timer, and then we hook the delegate to the timer.
All right.
And whenever the timer fires, it fires the delegate, and then our on-timed event kicks off.
Holy monkey poo, Brian!
I know, it's pretty cool.
So now, as you recall, in the timer.h class,
it's generic.
Templated.
Yep.
So when we template this, we are going to be sending the class in which this is being executed inside, which we've done this 100 times. You guys know this. But we'll just call this my timer.
Sure.
And as you guys also recall, we created 2 overloads for the constructor.
One that passes in a delegate.
One that will take a delegate. One that will be just doing nothing.
Yep.
But it has a set, so if you want to run this, you can set the delegate. We're going to be calling the overload that will take in.
Why wouldn't we?
The delegate.
Yeah.
So timed delegate.
Yep.
Right?
Perfect.
Let me just make sure that runs before we get all on our high horse about how great we are.
I never get on a high horse. I like donkeys.
Sure you don't, Brian. So now, check this out. Now we can do crazy stuff like
cool. Access the properties.
Right.
Nice.
So let's have this thing go off. Let's just do a test one, like every 1 second, right?
Okay.
So 1 second is going to be 1,000 milliseconds. So now that we've set this, and I'm going to skip ahead and I'm going to kind of show you something. So let's do like a little while loop here.
Okay.
So while my timer dot enabled.
All right.
So while this thing is actually running, let's just kind of like chill. I don't know. Maybe let's sleep for like, 10 milliseconds or something. So if we run this code, it shouldn't actually do anything at all.
Let's see.
Timer driver.exe. It doesn't, because we forgot to do one fundamental thing.
Enable it?
Enable equals true. Now we're not going to really see anything, so let's do a little see out action. Hey, buddy.
Nice.
So our program is going to execute every 1 second and say, hey, buddy.
Do you want to put an end line? Doesn't matter. Who cares? You're good. We'll just wrap around the screen.
But I'm going to do it this way because I'm awesome.
Sweet.
So now 0 Mississippi 1, 0 Mississippi 1, Mississippi 1, Mississippi. Every 1 second, this executes.
1 1,000, 2 1,000.
Right.
3, no, it's too fast. Mississippi's too slow. 1,000's too fast. You have to like say both 1,000 and Mississippi at the same time in your mind.
Mississippi, yeah. Now our program is set on an infinite loop. This will never stop because there's never a condition to end this.
Except for...
So I'm going to Control-C this.
That is a condition to end it.
Right. Now, that's one of the reasons why we passed this timer. And again, you can make this a reference. We made it a pointer. Let's just say that there's a condition that's met. And then once that condition is met, we want to end this program.
Right.
So let's kind of just do something stupid. So let's kind of just do something stupid, like let's use the printf function, and let's print the pointer instance. And this is kind of a stupid example, but it's kind of cool. So what I'm going to do is I'm going to retrieve the memory address of T.
Oh, nice.
Just to kind of prove that we're getting that. And then we'll see out that count. Remember we set that counts private value.
Yeah, I remember that.
Inside of our main.h, right, our main class.h right here.
Yep.
So we're gonna set see out that out, and let's also, before we call enable, set it to 0. Count equals 0.
Okay, cool.
So then once we print count to this,
then we'll increment it.
Right. count ++.
All right. Well, it's going to run forever. Do you want to do anything to stop it?
Well, now that we have some sort of a condition that we can test for, and remember now, no matter what context this is being called in, so let's just say we have 50 timers running.
Right.
All of them are calling them within the context of main class. So the second that this condition is hit, everybody should be affected.
Yes.
So in that case, let's just say after we do run this process 20 times run. Right?
Okay.
Is that
perfect.
cool?
Yeah.
So like if
count. Sweet.
equals 20.
Sure. Yeah, it's perfect.
Now how do we stop this? We can like return, but that doesn't actually stop this.
Well, we want to set enable to be false now.
We do, but how do I do that?
Well, we got timer passed as a parameter.
Okay, so we do have the actual timer instance that is calling this being
so
passed.
we can do with it. It's
so
pretty cool.
Since this is a pointer, we can access the members like this.
Yeah, with the arrow.
And we can access the property enabled.
And just set it to false.
Yeah, exactly
That's
like
awesome.
we would with a dot.
That's pretty cool.
Now, to just kind of save us some time, let's make this every half a second.
All right.
So what this should do is, and we'll just watch what it does. What do we got? Line 28, no matching operator for equals. Line 28.
Let's just do greater than.
Oh, C out. C out.
Oh yeah, that makes sense.
And you know what? You're right, because that could actually cause a problem. So let's do greater than or equal to 20. Because when I said if we have 10 different timers hitting this,
yeah, I know. Right?
That's actually going to
hop and jump.
That's still going to be an infinite
away
loop.
from an infinite loop.
Nice. Okay. So now that we have that, let's timer driver.exe. Look at that.
Hey, cool.
You can see the memory pointer address on the left is always the same. Right. Now we're counting. So what will this get to?
20?
15, 16, 17, 18, 19. Second that it equal 20.
Nice.
It was done and over with.
That's awesome.
Yeah.
Round of applause for the timer class. Round of applause.
So one thing to keep in mind as we do Brian's famous impression of the Jerry Springer's final thought, we did a lot of repetition in the C++ labs.
We did. Yeah, we did.
And Brian, why did we do that?
The biggest thing in learning programming is to put the time into just writing the code and seeing people write code.
Mm-hmm.
Now, if you can't write in C++, the best way is to just sit with us and go through writing code.
Yeah, exactly.
And we also don't want you to have a complex. We don't want you to be scared. Mm-hmm. You know, like, programming is something that you can learn to do, and you can learn to do it well. And you're going to have your own badass style of doing it.
Right.
So getting the exposure to seeing us just march through it, you know, and like, it's not necessarily pretty. It's not necessarily always exciting. Sometimes it is. And when it's exciting, it's very exciting.
Yeah.
You know, like the string class and the integer class. Like, we want you to see how you just go through and really, like, polish out those objects and just work your way through them and do all of the overloads and kind of do your due diligence and just kind of get it implemented in there.
Right. Now, when you...
And even those, we're doing simple forms to just kind of get you kick-started. But at least you kind of get, you know, you kind of get to put in that time.
Now, when you guys graduate to, let's say, C#, for example, you're going to notice that C# has a class very similar to this. And it actually is, this is kind of a mock-up mimic of what that is. So that when you get to C# and you see this kind of stuff, you're like, oh, I've written this from scratch.
Right.
So now I know how to interact with this class just because I've opened up the hood and I've seen the wires, you know?
And not only this, but you're going to see the same kind of thing with the string class.
Yep.
You're going to see the same thing with the console, the integer. You're going to see a lot of the stuff that we've been doing. We've been trying to write these classes in these labs so that they kind of mock the higher level languages. So you're just like, you're just
you see where it
jumping
came from.
in and knowing exactly how all of those wires are connected because you yourself went through and connected the wires.
Now, assuming that this is the last lab video, we'll see you guys in Objective-C.
Nice.